Hey there everyone, Ramesh here, back again with another new brand course on Spring Boot 3. In this course, you will learn everything about Spring Boot from the scratch. This course is going to be a 15-hour course, and in this course, I am going to cover everything about Spring Boot from the scratch. We'll begin with Spring Boot fundamentals and why to use Spring Boot over a Spring framework, and then we'll build the REST APIs using Spring Boot. We will build the REST APIs using Spring Boot that connect with the PostgreSQL database, MySQL database. Next, we will learn how to build the web applications using Spring Boot and Thymeleaf. Next, we will build the full stack web applications using Spring Boot and React.js. Next, we will also see how to containerize the Spring Boot application using Docker. Next, we will learn 25 plus annotations in Spring Boot. Okay, I am going to cover everything about Spring Boot in 15 hours. Well, if you don't have any knowledge on Spring Boot, then don't worry, I am going to cover everything about Spring Boot from the scratch. This course I especially designed for beginners who want to learn the Spring Boot from the scratch. Okay, so without further ado, let us kickstart this course with what is Spring Boot. Hi everyone, welcome back. In this lecture, let's understand what is Spring Boot. Well, before understanding about Spring Boot, let's first understand what is a problem using Spring Framework and what problem the Spring Boot addresses. Well, as we know that Spring Framework is very popular Java framework for building web applications as well as enterprise applications. So Spring is very popular for several reasons, like Spring provides a dependency injection and it provides powerful transaction management capabilities, and Spring provides a good integration with other frameworks such as Hibernate, Struts, etc. And Spring Framework provides Spring MVC framework for building web applications. Alright, so Spring is very popular for these reasons. Now let's understand what is the problem using Spring Framework and how Spring Boot addresses that problem. Well, basically, Spring based applications have a lot of configurations. For example, whenever we develop Spring MVC web application using Spring MVC, then we need to configure component scan, dispatcher servlet, view resolver, and among other things. And whenever we use Hibernate in a same Spring MVC application, then we need to configure data source, entity manager or session factory, and transaction manager among other things. And when we use cache or message queue or NoSQL database in the same Spring MVC application, then we need to configure cache, message queue, NoSQL database related configurations, isn't it? So basically, we need to configure a lot of stuff in a Spring based applications. Now let's understand this configuration in action. Well, here I have created Spring MVC Hibernate CRUD web application using Spring Framework. Next, let's explore this project and let's try to understand what is the problem with this project and how Spring Boot addresses that problem. So let's go with pom.xml file. So in a pom.xml file, we have configured a lot of dependencies. For example, we have configured Spring MVC related dependencies, Hibernate related dependencies, and the UI technology related dependencies, and the database related dependencies. Okay, so we have basically configured a lot of dependencies and we have managed the version of all these dependencies manually. Okay, next, if you go to the configuration package, so here we have configured the dispatcher servlet. Next, we have used Hibernate, so we have configured the different Spring beans for Hibernate. For example, here we have configured the session factory Spring bean. Here we have configured data source Spring bean. Here we have configured transaction manager Spring bean. Next, if you go to web-MVC config class, here we have configured Spring bean for view resolver. Okay, now let's understand the problems with this project. Well, whenever we develop one more Spring MVC Hibernate project, then we need to configure the same configuration. For example, we need to configure session factory Spring bean, data source Spring bean, Hibernate transaction manager Spring bean, and view resolver Spring bean, and dispatcher servlet, and we need to configure all these dependencies, right? So whenever we create a new project, that is Spring MVC Hibernate new project, then we need to basically configure all these Spring beans, right? So this is basically a problem. We don't have to configure the same things again and again. Okay, so there should be an automated process, isn't it? So the solution, like, why not we automate this configuration? So whenever we create a new Spring MVC Hibernate project, then this configuration will be automatically configured for that project. So this is what the Spring Boot addresses the problem. So Spring Boot will automatically provides this configuration whenever we add a particular jar dependency in a our pom.xml file. So Spring Boot will automatically configure these Spring Beans whenever it will find a jar dependency in a pom.xml file. So this is the first problem the Spring Boot addresses. Second problem is, so if we use Spring Framework without Spring Boot, then we need to explicitly configure the server and we need to deploy a Spring application in that server. For example, let's say we want to use Tomcat server to deploy this Spring based application. Then we need to download the Tomcat server from the internet and we need to set up that Tomcat server in IDE, and then we can able to deploy Spring application in that Tomcat server, isn't it? So this is a manual process. So this problem also Spring Boot addresses. Okay, so Spring Boot provides embedded Tomcat server to quickly deploy Spring based applications. We don't have to manually set up the Tomcat server. So this is the second problem the Spring Boot addresses. Next problem is, if you go to pom.xml file and if you look at the dependencies over here, we have added a lot of dependencies. For example, we have added Spring MVC related dependencies, Hibernate related dependencies, UI technology related dependencies, and database related dependencies. And we have manually managed the version of all these dependencies over here. So this is a pain for developers to manually manage the compatible versions of all these framework related dependencies, right? So this is problem also the Spring Boot addresses. Okay, so Spring Boot provides a starter dependencies that will internally manage the versions of all the framework related dependencies. Okay, so let me quickly recap. Spring Boot will automatically configure these common Spring Beans whenever it will find a jar dependency in a pom.xml file. Next, Spring Boot provides embedded Tomcat server to quickly deploy Spring based application. Next, Spring Boot provides a set of starter dependencies that we can quickly use to manage the dependencies and its compatible versions. Well, in upcoming lectures, we'll see how Spring Boot provides automatic configuration and how Spring Boot provides embedded Tomcat server and how Spring Boot provides starter dependencies. Okay, just try to understand what is the problem with Spring Framework and what problem the Spring Boot addresses. Well, Spring team developed Spring Boot on top of Spring Framework to quickly create and bootstrap Spring based applications. Okay, so Spring Boot is not a different framework. Spring Boot is an extension of Spring Framework and it addresses different problems of Spring Framework. Okay, and the main goal of Spring Boot is to quickly create Spring based applications without requiring developers to write the same boilerplate configuration again and again. Well, Spring Boot takes an opinionated approach for the configuration. For example, whenever we add a Spring Boot starter web dependency, then Spring Boot assumes that we are trying to create a Spring MVC project. So Spring Boot will configure all the Spring Beans related to Spring MVC. Next, Spring Boot provides important features like Spring Boot starters, Spring Boot auto configuration, externalized configuration, Spring Boot actuator, and easy to use embedded servlet container support. Okay, so in next lecture we'll see all these features in detail. Okay, I hope you understood what is Spring Boot and what problem the Spring Boot addresses. Okay, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we pretty much understood what is Spring Boot. Well, Spring Boot is a opinionated framework that helps developers to build Spring based applications quickly and easily. The main goal of Spring Boot is quickly create a Spring based applications without requiring developers to write the same boilerplate configuration again and again. Okay, and Spring Boot is developed on top of Spring Framework to address different problems. In this lecture, let's understand Spring Boot provided important features such as Spring Boot starters, Spring Boot auto configuration, externalized configuration, Spring Boot actuator, easy to use embedded servlet container support. So let's understand these Spring Boot features in detail. Let's take a look into Spring Boot starters. Well, Spring Boot starters are pre-configured with the most commonly used library dependencies, so you don't have to search for compatible library versions and configure them manually. For example, Spring Boot provides Spring Boot starter data JPA starter module. So this module includes all the dependencies required to use Spring Data JPA along with Hibernate library dependencies, as Hibernate is the most commonly used JPA implementation. Well, Spring Boot provides Spring Boot starter data JPA starter module, and this module will internally pull all the Spring Data JPA and Hibernate related dependencies from the internet, and it will internally manage the compatible versions of all these dependencies. Okay, next one more example is Spring Boot Starter Web Dependency. So Spring Boot provides Spring Boot Starter Web Dependency to develop the Spring MVC application. And this starter dependency will internally pull all the commonly used libraries while developing Spring MVC applications such as Spring Web MVC, JSON, Validation API, and Tomcat. Okay, so this is awesome, right? So instead of adding all the Spring MVC related dependencies such as Spring Web MVC, JSON, Validation API, and Tomcat, we can simply use this single Spring Boot Starter Web dependency. This dependency will internally pull all these dependencies and it will manage the versions of all these dependencies, right? For example, if you go to the project Spring MVC Hibernate Crude Web App, so this project was developed using Spring Framework. And if you go to pom.xml file, so here we have added a lot of Spring MVC and Hibernate related dependencies, and we have manually managed the versions of all these dependencies. Okay, so basically the problem with this approach is we need to manually take care of managing the compatible versions of all these dependencies. Okay, so Spring Boot provides a starter dependencies to automatically manage the compatible versions of all these dependencies. So just remember, Spring Boot starters are pre-configured with most commonly used library dependencies. So you don't have to search for a compatible library versions and configure them manually. Spring Boot starters will take care of managing the compatible versions of all the dependencies. Next, let us take a look into Spring Boot auto configuration feature. Well, Spring Boot auto configuration attempts to automatically configure Spring application based on the jar dependencies that you have added to the project. Well, basically Spring based applications have a lot of configurations. For example, whenever you develop a Spring MVC application using Spring Framework, then you need to manually configure the dispatcher servlet, view resolver, and if you use Hibernate in that Spring MVC application, then again you need to configure the data source, entity manager, and transaction manager as well, right? For example, here we have Spring MVC Hibernate Crude web application developed using Spring Framework, and the problem with this application is that I have to configure a lot of stuff, like we have to configure the session factory bin, we have to configure data source and transaction manager bin, and we have to configure the view resolver bin, we have to configure the dispatcher servlet. Alright, so basically we have to provide a lot of configuration, isn't it? Next, let us say we want to create one more new Spring MVC Hibernate Crude web application. Then we have to provide the same configuration again, isn't it? So instead of configuring the same configuration again and again, why not we automate this configuration? So this is what the Spring Boot auto configuration feature provides a solution. Okay, so Spring Boot will automatically configure all these Spring beans whenever we add a jar dependency in a pom.xml file. For example, Spring Boot provides a lot of starter dependencies. The commonly used ones are Spring Boot Starter Web and Spring Boot Starter Data JPA. So let's say we add Spring Boot Starter Web jar dependencies to our Spring Boot project. Then Spring Boot assumes that you are trying to build a Spring MVC based application, and it tries to automatically register Spring beans like dispatcher servlet and view resolver if it is not already registered. Next, one more example is like, let's say if we add Spring Boot Starter Data JPA starter dependency to our project, then Spring Boot automatically configure the Hibernate related Spring beans such as data source, session factory, and transaction manager. Right, so this is awesome, right? We just have to add the starter dependency to our project. Spring Boot will take care of automatically configuring the related Spring beans. Okay, so Spring Boot auto configuration attempts to automatically configure Spring application based on the jar dependencies that you have added to the project. Alright, so this is how the Spring Boot auto configuration works. Next feature is externalized configuration. Well, Spring Boot provides good support to externalize the configuration. For example, typically we deploy Spring applications in different environments such as production environment, testing environment, UAT environment, or development environment, right? So in order to deploy Spring application in different environments, so we have to externalize the configuration based on the environments, right? So Spring Boot provides a good support to externalize the configurations based on the different environments. Next feature is Spring Boot Actuator. Well, Spring Boot Actuator provides a wide variety of production-ready features without requiring developers to write much code. It means Spring Boot Actuator provides out-of-the-box REST endpoints as a production-ready features. Like we can use Spring Boot Actuator provided REST APIs to view the application bin configuration details. We can use Spring Boot Actuator REST APIs to view the application URL mappings, environment details and configuration parameter values. We can also use Spring Boot Actuator REST endpoints to view the registered health check metrics as well. Okay, so Spring Boot Actuator basically offers a lot of REST endpoints that we can use as a production ready features. Next feature is easy to use embedded servlet container support. Well, traditionally, in order to deploy the web application, we were building the WAR file and then we were deploying that WAR file in external servers such as Tomcat server. But by using Spring Boot, you can create a jar file out of the Spring application and then you can deploy that jar file in a embedded servlet container. Well, let's understand this feature with an example. So here in a IntelliJ IDEA, I have created a Spring MVC Hibernate CRUD web application using Spring framework. Next, in order to deploy this Spring Hibernate project in a Tomcat server, then what we have to do is we have to download the Tomcat server from the internet, and then we need to set up that Tomcat server in the IntelliJ IDEA, and then we can able to deploy this project in the Tomcat server. So this is the manual process, right? But using Spring Boot, what we can do is we can simply create a jar file out of the Spring Boot application and we can simply deploy that jar file in a embedded Tomcat server. So these are the important Spring Boot features, and we are going to explore these features a lot throughout this course. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create and set up Spring Boot project in IntelliJ IDEA. Well, first we will create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. Well, let's head over to the browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a website or a web tool that we can use to quickly create and bootstrap Spring based applications. Now let's go and let's fill up the project information over here. Well, here we have two types of project, Maven project and Gradle project. We are going to use Maven project, so let's keep Maven project as selected over here. And here we have three kinds of JVM languages, Java, Kotlin, Groovy. We are going to use Java, so let's keep Java as selected over here. Next, we are going to use Spring Boot version 3, so let's select Spring Boot 3.0.0 milestone 4. So this is the latest version of Spring Boot as of now. Next, let's fill up the project metadata over here. So let's give group as net.javaguides. Well, you can give any group that you want. Next, artifact. Let's give artifact as Spring Boot REST API. Next, let's give project name as Spring Boot REST API, and then description demo project for Spring Boot REST API, and then packaging name as net.javaguides.spring boot, and then packaging as a jar, and then Java version 17. Well, remember, whenever you choose Spring Boot version 3, then you have to choose Java version 17 or later. Next, let's go ahead and let's select the dependencies. We'll go ahead and click on add dependencies over here, and here just type web. Well, Spring Boot provides Spring Boot starter web dependency that we can use to develop the RESTful web services, and this dependency internally provides Apache Tomcat as a default embedded container so that we can able to run our Spring Boot application in a development environment. Alright, so let's go and let's select Spring Web Starter dependency. Well, as of now, let's keep this single Spring Web Starter dependency. If any dependency is required, we will add in our upcoming lectures. Next, let's go ahead and let's click on generate button to generate this Spring Boot project as a zip file on local machine. And you can able to see here our Spring Boot application is downloaded as a zip file over here. Next, let's go and let's open in a folder and let's unzip this folder. Alright, now we have Spring Boot REST API project in place. Next, we are going to import this project in IntelliJ IDEA. Let's open IntelliJ IDEA, and in IntelliJ IDEA you can see a couple of options: new project, open, get from, VCS. Well, we are going to open the existing project in IntelliJ IDEA. For that, let's go ahead and let's click on this open option over here and go to the location where your Spring Boot application is present. In my case, it is in downloads folder. So go ahead and select the project and click on open. Now this will open Spring Boot project in IntelliJ IDEA. Alright, perfect. Next, if you can see the SRC folder, within that we have main folder, and within the main folder we have Java and resources. Within a Java folder we keep all the development related source code, and within a resource folder we keep all the static resources as well as UI related resources and all the application level configuration in a application.properties file. And here we have test folder, within that we keep all the JUnit test cases. Next we have pom.xml file. It contains all the Maven dependencies and Maven plugins. Now let's go ahead and let's explore more about this Spring Boot Starter Web dependency. Well, Spring Boot provides Spring Boot Starter Web dependency to develop the RESTful web services as well as Spring MUC web applications. And this Spring Boot Starter Web dependency, it internally provides all the required dependencies to develop the RESTful web services. Along with that, this dependency also provides Apache Tomcat as a embedded default container. For example, if we dive into this dependency internally provides Spring Boot Starter JSON dependency, Spring Boot Starter Tomcat dependency. Okay, apart from that, it will provide all the Spring related dependencies like Spring Web dependency, Spring Web MUC dependency. It means that this single dependency will gather all the required dependencies to develop the Spring MUC RESTful web services. Along with that, it will also provide a default embedded Tomcat server. Okay, we don't have to configure the external Tomcat server to deploy our Spring Boot application. This dependency internally provide embedded Tomcat server so that we can quickly deploy our Spring Boot application in our local development environment. Alright, great. Now let's go and let's quickly run our Spring Boot application and let's see how it works. So go to the main entry point class. So this is basically our Spring Boot main entry point class. It has a main method. Alright, so typically in Java programs we have a main method and the execution of the Java program starts from main method, right? So similarly in Spring Boot we have a main method and the execution of the Spring Boot application starts from here. Okay, so we can simply use this main method to start our Spring Boot application. So go ahead and run the Spring Boot application by using this entry point class. And notice here in a console our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Well, let me recap what we have done in this lecture. We have created and set up Spring Boot project in IntelliJ IDEA, and we quickly gone through the project structure and we have explored about Spring Boot Starter Web dependency, and we ran our Spring Boot application and our Spring Boot application is successfully running in an embedded Tomcat server on port 8080. In upcoming lectures, we are going to develop the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a simple Spring Boot Hello World REST API. Well, creating REST APIs using Spring Boot is very simple. Alright, so let's head over to the IntelliJ IDEA and let's quickly create a simple Spring Boot REST API. Well, go to the main package over here, and within that, let's quickly create one more package and let's call it as controller. Well, within a controller package, we keep all the Spring MUC controllers. Now let's go ahead and let's create a Spring MUC controller. Well, right click on the controller package, new, and then choose Java class, and let's give class name as a Hello World Controller. Well, notice here the naming convention for the Java class, Hello World Controller. Well, whenever we create a Spring MUC controller, we always use controller as a suffix for this class name. And here Hello World is nothing but a resource followed by controller is the suffix for this resource. Okay, so this is the Hello World controller. Some of the developers also use the naming convention like Hello World resource. But in typical Spring MUC projects, we use the naming convention like Hello World controller. Okay, we always use controller string as a suffix for a controller name. Okay, now we have Hello World controller. Go ahead and hit enter. Now we have created a Java class. Let's make this Java class as a Spring MUC controller by using @controller annotation. Well, let's go ahead and let's annotate this class with @controller annotation. And notice here @controller annotation is a stereotype annotation from org.springframework.stereotype package. So let's go ahead and let's select this annotation over here. Well, whenever we develop the RESTful web services using Spring MUC, all the REST APIs return a JSON to the client, right? So in order to convert a Java object into JSON, we have to use @responseBody annotation. So let me go ahead and let me use @responseBody annotation over here. Well, whenever we develop the RESTful web services using Spring MUC, we always use these two annotations, isn't it? We use @controller annotation to make this controller class as a Spring MUC controller, and we use @responseBody annotation to convert a response from Java object to JSON, and that JSON will be again returned into HTTP response. Well, as we know that whenever we develop the RESTful web services using Spring MUC, we have to create a controller class and we have to annotate this controller class with these two annotations, isn't it? Spring team thought like, why not we create a shortcut single annotation. It internally uses these two annotations, right? So Spring team released at rest controller annotation. It internally uses these two annotations. For example, let me remove these two annotations, and here let me use at rest controller annotation over here. Well, Spring 4.0 released this at rest controller annotation, and this annotation is a combination of at controller and at response body annotation. For example, if we dive into the source code of this at rest controller annotation, here you can able to see this annotation is annotated with at controller annotation as well as at response body annotation. Okay, so at rest controller annotation is nothing but it is a combination of controller and response body annotation. Well, instead of using these two annotations, we can use the shortcut single annotation, that is at rest controller annotation. Alright, perfect. Let's go back to hello world controller. Now we have annotated our hello world controller class with the at rest controller annotation. Okay, just remember, whenever you want to develop RESTful web services using Spring MVC, you have to annotate a class with the at rest controller annotation. Now this class becomes a Spring MVC REST controller. Within this REST controller, we can create the REST APIs. Now within a hello world controller, let's go ahead and let's create the REST API. So creating a REST API is pretty simple. We just have to create a method, and we use Spring annotations to make that method as a REST API. Okay, perfect. So here just type the method public, and let's give return type of the method as a string, and let's give method name as hello world. Perfect. And let's return some string, something like hello world. Now we have created simple Java method. Let's make this Java method as a REST API using Spring annotation. Well, this is going to be a HTTP GET request, right? So let's go ahead and let's use at GET mapping annotation to handle HTTP GET request. Well, basically we use at GET mapping annotation to map incoming HTTP GET request to this method. Okay, and next let's go and let's configure the URL for this REST API. So here let's pass the URI something like hello -world. Perfect. So whenever a client want to access this REST API, then client have to use this URL. For example, http://localhost:8080/hello world. Perfect. So whenever a client want to access this REST API, then client have to use this URL. Alright, perfect. So let me copy this URL. Now let's go ahead and let's run the Spring Boot application, and let's see how this REST API works. So let me stop the existing server and let me start the Spring Boot application again. And look at here, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Well, this is the GET REST API, so we can access this REST API using browser. So let's go to a browser. In a new tab, just paste this URL, that is http://localhost:8080/hello world, and hit enter, and there we go. You can able to see the client got a response from the REST API. And if you can see the REST API, this REST API returns hello world string, isn't it? And you can see in the browser the client got hello world in a response. It means that we have successfully developed Spring Boot Hello World REST API, and it is working as expected. Well, creating the REST APIs using Spring Boot is very simple. We just have to create a Spring MVC controller, and we need to annotate it with at rest controller annotation. And within a controller, we need to create the Java methods, and we need to annotate it with appropriate HTTP annotations. For example, this annotation is used to handle HTTP GET request. So there are a couple of annotations like at post mapping annotation, at put mapping annotation, at delete mapping annotation. So these annotations we use to handle a different HTTP request like HTTP GET request, post request, delete request, put request, isn't it? Well, we'll see how we can use all these annotations in upcoming lectures. In next lecture, we'll create a Spring Boot REST API. It returns a Java bean as a JSON to the client. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a Spring Boot REST API that returns Java bean as a JSON to the client. Well, let's go to IntelliJ IDEA. In previous lecture, we have created a simple Spring Boot Hello World REST API, and this REST API returns a Hello World string to the client. Well, in real-time projects, we create the REST APIs that returns a JSON to the client, right? So in this lecture, we will see how to create a simple Spring Boot REST API that returns a Java bean as a JSON to the client. Well, it's pretty simple. Just follow the steps that I'm going to implement in this lecture. So first step is we need to create a Java bean. So go to main package and let's quickly create a new package and let's call it as bean. And within a bean package, let's create a Java class. Let's call it as student. And let's go and let's define instance variables for this student class. So let's have a private string student first name and then private string student last name, and also let's add a id to this student class. So let's say private int id. So this is a student id, this is a first name, this is a last name. Alright, perfect. Next, let's go ahead and let's create a parameterized constructor for this student class. Well, in order to create a constructor, right click on this class, generate, and then constructor, and select all the fields and then click on OK. Now we have created a parameterized constructor for this student class. Next, let's go ahead and let's also create a getter setter methods for these instance variables. So in order to create a getter setter methods, right click on the class, generate, and choose getter and setter, and select all the fields and click on OK. Now we have created getter setter methods for these instance variables. Alright, perfect. Now we have created student as a Java bean, and whenever we develop the REST API, we use this student Java bean as a response, and then Spring MVC will convert this Java bean, Java object into a JSON, and it will send that JSON back to the client. So this is the first step, that is we have created a student Java bean. Second step is we need to create a Spring MVC controller. We'll go to controller package, right click on it, new, and then choose Java class, and let's give controller name as student controller. And let's go and let's annotate this class with @REST_controller annotation to make this class as a Spring MVC REST controller. This is the second step, that is we have created student controller class. Third step is we need to create the Spring Boot REST API that returns Java bean as a JSON to the client. Well, creating REST API using Spring Boot is very simple. We just have to create a Java method, and we need to annotate that Java method with the Spring annotations. Alright, so here within a student controller, let's create a Java method first. Let's type public, and let's give return type of the method as student, and let's give method name as get student, and then let's create a student object over here, student equal to new student, and let's pass a value to the constructor, id as a 1, and then name as first name as let's say Ramesh, and then last name let's say Padhare. Perfect. Now we have created student object. Next, let's return this student object. Perfect. Now we have created a simple Java method. It returns a student object. Next, let's go ahead and let's make this Java method as a REST API using Spring annotation. Well, this method is going to be handle HTTP GET request. Hence, we are going to use @GET mapping annotation over here. We use @GET mapping annotation to map incoming HTTP GET request with this method. Next, let's go and let's configure the URL for this REST API. So here we just need to pass the URL. For example, let's say student. Well, whenever client want to call this REST API, then client have to use this URL. For example, HTTP localhost :8080 followed by the URI, that is student. Alright, so whenever client want to call this REST API, then client have to use this URL. Next, let's go ahead and let's run the Spring Boot application, and let us test this REST API. So let me start the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Well, let me copy this URL to access this REST API, and we can use a browser to make HTTP GET request. So in a new tab, just paste this URL and hit enter, and there we go. The client got a response in a JSON format. Alright, so this is how we develop the Spring Boot REST API that returns Java bean as a JSON to the client. Alright, perfect. Now let me recap what we have done in this lecture. First, we have created student Java bean. Next, we have created student controller, and within a student controller we have created a REST API that returns a student object as a JSON to the client. Alright, it's pretty simple, isn't it? In next lecture, we'll see how to create a Spring Boot REST API that returns a list as a JSON to the client. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a Spring Boot REST API that returns a list as a JSON to the client. Well, let's go to IntelliJ IDEA. And in previous lecture, we have created a REST API that returns a student object as a JSON to the client. In this lecture, we will write a REST API that returns a list of students as a JSON to the client. So go to student controller class, and within a student controller class, we are going to write the REST API. So here, let's first create the Java method that returns a list of students, and then we'll make that Java method as a REST API by using Spring annotations. So here just type public and then return type of the method as a list of type student. Alright, and next let's give method name as get students. Let me first create a list of type student, and let's call it as students equal to new array list. And next let's add a student to this list. So here students dot add student and then new student. Let's give ID as a 1 and then first name Ramesh and then last name Padatari. Next let's add one more student, students dot add and then new student, and let's pass value to this constructor, ID as a 2 and then first name let's say Umesh and last name let's say Padatari. Perfect. Next let's go ahead and let's add one more student. Let's say student dot, let's call add method and then new student, and let's pass value to the constructor, ID as a 3 and then first name let's say Ram and then last name let's say Jadhav. Next let's add one more student, students dot add and then new student, and let's give ID as a 4 and then first name as a Sanjay and let's give last name as a Pawar. Perfect. Now we have added 4 students to the students list. Next let's return this students object. Perfect. Now we have created a simple get students Java method. It returns a list of students. Next let's make this get students method as a REST API by using Spring annotation. Let's go ahead and let's annotate this method with @getMapping annotation. Well, we use @getMapping annotation to map the incoming HTTP GET request to this method, and this method should return a list of students as a JSON to the client. Next let's configure the URL for this REST API. So here let's pass students. So this is going to be a students because this REST API returns a list of students. So whenever a client want to call this REST API, then client have to use this URL. For example, localhost :8080/students. Alright, perfect. Now let's go and let's run our Spring Boot application and let us test this REST API. So let me start the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. So let me copy this URL, and this REST API is going to handle HTTP GET request. So we can make a GET request from the browser. So let's go to browser, and in a new tab just paste this URL and hit enter, and there we go. You can able to see the client got a response that is a list of students in a JSON format. This is how we create a Spring Boot REST API that returns a list in a JSON format. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Boot REST API with path variable. Well, sometime client sends a request and the URL contains a path variable. Well, in this lecture, I want to show you how to create a REST API that handles a path variable in a request. Okay, so basically Spring provides @path variable annotation to handle a path variables in a request URL. Alright, so let's go ahead and let's create a Spring Boot REST API that handles a path variable in a request URL. So let me go to IntelliJ IDEA over here and go to student controller, And here let me write the Spring Boot REST API that handles path variable in a request URL. So here let me write the comment Spring Boot REST API with path variable. Next, let's create a method and let's make that method as a REST API. So just type public and then let's use student as a return type of the method, and let's use method name as student path variable. Alright, and let's pass student ID as a method parameter, integer ID. Perfect. Next, let's return a new student and let's pass this ID as a parameter, and let's use first name as Ramesh and last name as Padthare. Perfect. So if you can notice here, we are passing this ID dynamically to this student. Okay, now we have created a method. Now let's make this method as a REST API by using Spring annotation. So here we are going to use add get mapping annotation to map incoming HTTP GET request to this method. Next, let's configure the URL for this REST API. Within a double quote, students / within a curly braces, student ID. Well, notice here the ID. So this ID is called URI template variable. Okay, for example, let me write the comment over here. So this ID is called URI template variable. Alright, and sometimes client sends a request something like this. For example, let me copy paste over here and then let's pass the path variable 1. So 1 is nothing but here student ID, and whenever client sends request with URL like this, then this 1 value will be stored in this URI template variable. Okay, now we need to bind the value of this URI template variable into the method argument ID. So in order to bind the value from this URI template variable to this method argument, what we can do is we can use add path variable annotation. So let me use add path variable annotation. Okay, perfect. So whenever you want to bind a value of this URI template variable to method argument, then we have to use add path variable annotation. Okay, and sometimes we may give the method argument variable name something like this. For example, let's say student ID. Okay, and you can able to see here URI template variable name is ID, but the method argument name is student ID. Both are different, right? So in this case, what you can do is you can just pass a URI template variable name to this add path variable annotation. Then only we can able to bind the value of URI template variable into this student ID. Otherwise, it will give exception. Remember, whenever you have the same variable name, that is URI template variable name and method argument, then you don't have to pass this ID. Okay, otherwise you need to pass this URI template variable to bind a value from this URI template variable to method argument. Okay, next you can pass this student ID over here. Alright, great. Next, let's go and let's run the Spring Boot application and let's see how this REST API works. So let me stop the existing server. Let me start the Spring Boot application. And there we go, our Spring Boot application is up and running. Next, let me copy this URL. Well, this is the get REST API, so we can access this REST API from the browser. So let's go to browser and let me paste this URL in a new tab and hit enter, and there we go. You can able to see the ID is dynamically assigned to this student ID. Okay, if I pass here 2, then this will give a response as a ID 2. Okay, so this is how basically client sends a request with a URL like this, and this URL contains a path variable, and in order to get the value of this path variable, we have to use add path variable annotation. Well, we can also pass a multiple path variables in a URL. For example, consider this is the URL and here we have passed student ID as a path variable. Next, we can also pass student post name as a path variable as well as student last name as a path variable. Alright, and next here we need to change the URL along with the ID. We need to also have a URI template variable, that is post name, post hyphen name, and then similarly last hyphen name. Alright, so this is the basically naming convention that typically we use whenever we have a variable that contains two words. Okay, next, in order to bind a value of these two template variables, we have to use add path variable annotation. So here, let me first pass the method argument to this method, string first name and then string last name. Okay, next let's use add path variable annotation to bind the value of this URI template variable to this method argument, and we need to pass this URI template variable name to this add path variable annotation. Okay, perfect. Next, let's do it for last name as well. So let's use add path variable annotation and then within a braces just pass this URI template variable name. Okay, and next let's remove this hardcode and let's pass first name, and let's also remove this hardcode value and let's pass last name. Okay, this is how we write a REST API to handle multiple path variables in a request URL. Alright, great. Next, let's run our Spring Boot application and let's test this REST API. So let me stop the existing server. Let me start the Spring Boot application. Alright, and let's go to browser, and here along with student ID, let's also pass first name and last name. So let me give admin as a first name and administrator as a last name. Okay, and hit enter, and there we go. You can able to see ID 1, first name admin, last name administrator. So let me pass some different values. Student ID 2, first name Umesh, last name Padatare, and there we go. You can able to see we got a response and these values are updated in a response. Alright, so this is how we create a Spring Boot REST API. It handles a path variables in a request URL. Alright, great. In next lecture, we will see how to create a REST API that handles a query parameters in a request URL. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Boot REST API with request parameter. Well, sometime a client sends a request. The request URL contains a query parameters, right? So in this lecture, we'll see how to use add request parameter notation to extract query parameters from the request URL. So let's go to IntelliJ IDEA and let's quickly create the REST API that handles query parameters in a request URL. So within a student controller, let me write the REST API over here. So let me first write the comment Spring Boot REST API with request param. Well, sometimes client sends a request something like this. For example, let me first construct the URL. Consider in a request URL, we got the URL something like this, localhost 8080/students and then question mark ID equal to 1. So this is basically called a query parameter. Okay, now let's go and let's write the REST API to handle this kind of request URLs. So let me create the method first, public, and let's give return type of the method as a student, and let's give method name something like student request variable. Alright, and let's pass ID as a method argument, integer ID. Next, let's return a new student and then pass ID dynamically, and let's give first name as Ramesh and let's give last name as Padatare. Perfect. Now we have created a method. Let's make this method as a REST API by using Spring annotations. So here let me use add get mapping annotation. Well, we use add get mapping annotation to map incoming HTTP GET request to this method. Next, let's configure the URL. So let's give URL something like this, students and then query. Well, we have already a students a URL we have configured for this REST API, right? So the REST API URL should be unique. That's why I am using query over here, and here also we need to pass / query to this URL. Okay, great. Now whenever client sends a request with a URL like this, then we need to get the query parameter from the URL by using @request_param annotation. Okay, so basically we need to bind the value of this query parameter to this method argument, and in order to do that we can use @request_param annotation. Okay, perfect. Next, let's go and let's run our Spring Boot application and let's see how this REST API works. So let me start the Spring Boot application, and there we go, our Spring Boot application is up and running. Next, let's copy this URL. Well, this REST API handles HTTP GET request, so we can use a browser to call this REST API. So let me go to browser, and in a new tab just paste this URL and hit enter, and there we go. You can able to see the REST API return the JSON, and you can able to see the ID is dynamically updated. If you pass 2 here, then we get ID 2. Okay, it means that the REST API that we have created to handle query parameters in a request URL is working as expected. Now let's see how we can handle multiple query parameters in a request URL. For example, let's say if client sends a request with the URL localhost 8080/student/query and then ID equal to 1 as a query parameter. After that, let's say one more query parameter, for example post name equal to Ramesh, and let's give one more query parameter, let's say last name equal to Padhare. Okay, next here we also need to pass the method argument. For example, string first name and then string last name. Alright, and in order to extract the value from these query parameters, we have to use @request_param annotation. Perfect. Next, let's remove this hardcode value and let's pass post name, and here also let's remove this hardcode value and let's pass last name. Okay, now we have created a REST API that handles a multiple query parameters in a request URL. Right, next let's run our Spring Boot application and let's see how this REST API works. So let me start the Spring Boot application. Alright, and let's go to browser. Here let me create the proper URL, ID equal to 2 and then ampersand post name equal to Ramesh ampersand last name equal to Padhare. Hit enter, and there we go. You can able to see client got the response, and in a response you can able to see post name Ramesh, last name Padhare, ID 2. So if I change the query parameter values over here, for example last name let's say Jadhav and post name let's say Ram and ID let's give 1 and hit enter, and there we go. In a response you can able to see the query parameter values are successfully updated. Alright, it means that the REST API that we have created to handle multiple query parameters in a request URL is working as expected. Alright, so this is how basically you write a Spring Boot REST API to handle query parameters in a request URL. Now you might be wondering what is the difference between @path variable annotation and @request_param annotation. Well, path variable annotation is used to bind the value of URI template variable into method argument, and we use @request_param annotation to extract the value of query parameters in a request URL. Alright, so this is the main difference. I hope you understood how to create a Spring Boot REST API that handles a multiple query parameters in a request URL. Alright, great. I will see you in the next lecture. Well, so far we have built a simple REST APIs without using any database. Okay, now we are going to build a real-time REST APIs for employee management system project using Spring Boot, Spring Data JPA, Hibernate and PostgreSQL database. Well, PostgreSQL database is one of the widely used database in a production. That's why we are going to use PostgreSQL database in this project. In upcoming projects we are going to also use MySQL database as well. Okay, in this project we are going to use 3-layer architecture: controller layer, service layer and repository layer. At a database level we are going to use PostgreSQL database, and controller layer basically holds the REST APIs and that will handle all the requests that comes from the client. Next, service layer basically holds the business logic of the application. Next, repository layer holds the database related logic and it is responsible to talk with the database. And in this tutorial we are going to use Postman client to test the REST APIs. And in this project we are going to use the latest version of Spring Boot, Hibernate, Spring Data JPA, PostgreSQL database, Maven, Java. Okay, we are going to use the latest version of all the tools and technology. Without further ado, let us start creating the Spring Boot application. Hi everyone, welcome back. In this lecture, we are going to create and set up Spring Boot project in IntelliJ IDEA. Well, first we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So let us first go ahead and create a Spring Boot project using Spring Initializer. Well, here I am in a Chrome browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a tool that we can use to quickly create a Spring based application. So here, let us fill up the project information. So here we have different types of projects. So let us select Maven over here, and here we have different JVM languages, Java, Kotlin, Groovy. So let us keep Java as selected over here. Next, let us choose Spring Boot version. Well, here you can see by default 3.1.0 is selected, but whenever you create a Spring Boot project, then that time the Spring Boot version may be different. And let us keep the default one selected as it is, because this is a stable and latest release of Spring Boot. Next, let us fill up the project metadata over here. So let us give group as net.javaguides. You can give any group that you want. Next, artifact. So let us give artifact as EMS backend. So here we are developing employee management system. That's why the name EMS and then backend. Next, project name is same as artifact. Next, let us give description as demo project for Spring Boot employee management system. Next, package net.javaguides.ems. Packaging, let us keep jar as selected. Next, Java version 17. Well, remember, whenever you choose Spring Boot 3, then make sure that you choose Java version 17 or later. Next, let us go ahead and let us add the dependencies. So go ahead and click on add dependencies over here, and here just type web. Well, we use Spring Web dependency to build web applications as well as RESTful web services, and this Spring Web dependency internally provides Apache Tomcat as a default embedded container. Alright, so whenever you want to develop the Spring Boot RESTful web services, then make sure that you choose Spring Boot starter web dependency. Next, let us go ahead and let us select Spring Data JPA dependency. Well, we are going to use Spring Data JPA dependency to develop the persistence layer or the repository layer, and Spring Data JPA internally uses Hibernate as a JPA provider, and Spring Data JPA, it reduces a lot of boilerplate code that is required to develop the repository layer. So let us go ahead and select Spring Data JPA over here. Next, let us add a PostgreSQL JDBC driver dependency. Well, PostgreSQL driver is a JDBC and R2 JDBC driver that allow Java programs to connect to a PostgreSQL database using standard database independent Java code. Next, let us add a Lombok annotation. So here just type Lombok. So Lombok is a annotation based library which helps to reduce the boilerplate code. So let us select Lombok dependency over here. So as of now, let us keep these 4 dependencies for this Spring Boot application. And next, go ahead and click on generate button over here. So this will generate the Spring Boot application as a zip file, and it will download it in a file system. Okay, next let us go ahead and let us open this zip file in a folder. Alright, next let us go ahead and let us unzip this zip file. Perfect. Next, let's open the IntelliJ IDEA over here, and here you can see we have 3 options: new project, open, get from VCS. So we are going to open the existing Maven project. So let us click on open button, and next go to the location where your Spring Boot application is present. So in my case, it is in download folder, and here let me select EMS backend project, click on open. Now we have opened Spring Boot application in IntelliJ IDEA. Well, let me recap what we have done in this lecture. We have created Spring Boot project using Spring Initializer, and then we have imported that project in IntelliJ IDEA. In next lecture, we will configure PostgreSQL database in our Spring Boot application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will configure PostgreSQL database in our Spring Boot application. Well, in order to connect our Spring Boot application with the PostgreSQL database, we have to configure the PostgreSQL database details in a Spring Boot application. So let's go to our Spring Boot application, go to application.properties file. So before configuring PostgreSQL database details over here, let's first create a PostgreSQL database. So let us head over to pgadmin4. This is the console to connect to the PostgreSQL server. So here right click, create a database. Let's give a database name as EMS. EMS stands for Employee Management System. So let us keep default and click on save. This will create a EMS database in a PostgreSQL server. Okay, next let's configure this EMS database in our Spring Boot application. So let's go back to IntelliJ IDEA, go to application.properties file. Here let us type the property spring.datasource.url. Next let us give the JDBC URL, JDBC colon PostgreSQL localhost. Well, the PostgreSQL server is running on localhost, local machine, that's why localhost, and the default port 5432 followed by the database name. So this is the JDBC URL to connect our Spring Boot application with the PostgreSQL database. Next, configure the username spring.datasource.username Postgres. Next, similarly, let's configure the PostgreSQL database password spring.datasource.password Postgres. Well, in my case, the username and password are same, so make sure that whatever the username and password you have given while installing the PostgreSQL database, you have to mention over here. Alright, next let's configure one more property spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful. This property basically tells Hibernate to automatically create the database tables. Okay, so we don't have to manually create the database tables. Hibernate will automatically generate the database tables based on the JPA entities. In next lecture, we will create a employee JPA entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create an employee JPA entity. So let's go to our project in IntelliJ IDEA. And here, before creating the employee JPA entity, let's quickly create a packaging structure for our Spring Boot application. So go to base package over here, right click, new, and then choose package. Let's give package name as entity. Next, let us create one more new package. Let's call it as controller. Within a controller package, we keep all the Spring MUC controllers, and within the entity package, we keep all the JPA entities. Next, let's create one more package. Let's call it as repository. Within a repository package, we keep all the Spring Data JPA repositories. Next, let's create one more package. Let's call it as service. Within a service package, we keep all the interface and classes that are related to service layer. Next, let's create one more package. Let's call it as DTO. Within DTO package, we keep all the DTO classes. Next, let us create one more package. Let's call it as exception. Within exception package, we keep all the custom exceptions. Alright, so as of now, let us keep these packages. Next, go to entity package, right click on it, new, and then choose Java class. Let us give class name as employee. Alright, next, let us go ahead and let us add the instance variables to this class. So here, private long ID, and then private string first name, and then private string last name, and then private string email. Perfect. Next, let us go ahead and let us use Lombok connotations to reduce the boilerplate code. So here let us use add getter Lombok connotation to generate a getter methods for these instance variables. Next, let us use add setter Lombok connotation to generate a setter methods for these instance variables. Next, let us use add no argument constructor annotation to create a no argument constructor. Next, let us use add all args constructor to create a parameterized constructor. Okay, now we have created employee Pojo class. Let us make this employee class as a JPA entity by using JPA annotations. So let us annotate this class with add entity annotation from jakarta.persistence package. Well, we use add entity annotation to specify a class as a JPA entity. Next, let us annotate this class with add table annotation from jakarta.persistence package. Well, we use add table annotation to specify the table details. So here let us use name attribute to specify the table name. So let us give table name as employees. Perfect. Next, let us configure the primary key for this employee entity. So here let us annotate the ID field with @id annotation. So make sure that you choose ID annotation from Jakarta.persistence package. Next, let us configure the primary key generation strategy. For that, let us use @generated_value annotation. And next, @generated_value annotation has a strategy attribute. So here let us configure the primary key generation type. So here let us use identity. So this identity primary key generation strategy basically uses database auto increment feature to automatically increment the primary key. Okay. Next, let us use @column annotation to map a database table column with a class field. For example, here let us have a column mapping for this first name field. So let us annotate this first name field with @column annotation from Jakarta.persistence package, and let us give the column name first_name. So this column name will be mapped with the first name field. Okay, perfect. Well, if we don't specify @column annotation, then by default JPA will give the column name as field name. Okay, but the column name like first_name makes sense. That's why here we are using @column annotation to explicitly configure the column name for this field. Okay, perfect. Next, let us annotate last name field with @column annotation, and let's give column name as last_name. Next, let us annotate email field with @column annotation, and let us give a column name as email_id. Next, let us make this email_id column as a not null by using nullable equal to false attribute, and we can also make this email as a unique by using unique equal to true. Alright, now we have created employee JP entity. Next, let us run our Spring Boot application and let us see whether Hibernate will automatically create this employees table in a database or not. So let's go to main point class over here. From here, let us rerun the Spring Boot application. Next, let us go to the pgadmin4 and let us see whether the employees table is created in a PostgreSQL database or not. So let us head over to pgadmin4 here and go to EMS database, refresh, and go to schemas. Within a schemas, go to public, and within a public, go to tables, and within a tables, you can see employees table is successfully created. Next, right click on employees table and click on view data, and notice here the employees table has a column ID, email ID, first name and last name. Okay, it means Hibernate successfully created employees table in a PostgreSQL database. In next lecture, we will create a employee repository for this employee entity. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created employee JP entity. In this lecture, we are going to create employee repository. So let's go to our project in IntelliJ IDEA and go to repository package over here. Right click on repository package, new, and then choose Java class. Select interface. Let us give interface name as employee repository. Next, let us extend this employee repository interface from JPA repository interface and make sure that you choose JP repository interface from org.springframework.data.jpa.repository package. Well, notice here JP repository is a generic interface, so we have to pass two parameters. First parameter is the type of the entity, second parameter is the type of the primary key. So let us select JPA repository over here and let us pass the parameters. First parameter as a type of the entity, in our case employee entity. Next, let us pass the type of the primary key, that is long. Well, if you go to employee JP entity, you can see here we have given the type to the primary key ID as a long. So this long data type we are passing to JP repository as a second parameter. Okay, perfect. Well, once our employee repository interface extends JP repository interface, then this employee repository will get a CRUD methods to perform CRUD database operations on this employee JP entity. Alright, so if you go to JP repository interface source code, you can see JP repository interface provides these methods, and again JP repository interface extends list CRUD repository interface, and list CRUD repository interface provides all these methods, and this list CRUD repository method internally extends CRUD repository interface, and this CRUD repository interface exposes CRUD methods to perform CRUD database operations. Alright, it means this JPA repository will inherit all the methods from all the extended interfaces. And again, Spring Data JPA will provide the implementation for this JPA repository interface. For example, if you click on this, you will get the implementation classes, and here simple JPA repository is a class that implements all the methods of JPA repository interface and its child interfaces. So just click on simple JPA repository class over here, and you can see simple JPA repository class implements JPA repository implementation interface, and this interface internally extends JPA repository interface. It means simple JPA repository indirectly implements JPA repository interface and its methods. Alright, and if you can notice here, simple JPA repository class, it is already annotated with add repository annotation, so we don't have to annotate our repository interface with add repository annotation. For example, if you go to employee repository, we don't have to annotate this employee repository interface with add repository annotation, because the implementation class, that is simple JPA repository class, is already annotated with add repository annotation. And here one more important point is simple JPA repository class annotated with add transactional annotation. It means all the methods in a simple JPA repository class are by default transactional. We don't have to use again add transactional annotation in a service layer to make the methods as a transactional. Okay, for example, if you just scroll down, you can see delete by ID method is a transactional because it is annotated with add transactional annotation, and delete method is a transactional because it is annotated with add transactional annotation. Alright, so all the public methods in a simple JPA repository class are transactional, so we don't have to again use add transactional annotation to make these methods transactional. Alright, just remember these couple of important points, like simple JPA repository is a class that implements JPA repository interface, and simple JPA repository class, it is already annotated with add repository annotation, so we don't have to again annotate our repository interfaces with add repository annotation. And simple JPA repository class is annotated with add transactional annotation, so all the methods, all the public methods in a simple JPA repositories are by default transactional. We don't have to again make those methods transactional by using add transactional annotation. Alright, perfect. So let me recap what we have done in this lecture. We have created employee repository interface that extends JPA repository interface. So this employee repository will get CRUD methods to perform CRUD database operations on employee JPA entity. In next lecture, we will create an employee DTO and employee mapper classes. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create an employee DTO and employee mapper classes. So let's go to our project in IntelliJ IDEA and go to DTO package over here. Right click on DTO package, new, and then choose Java class. Let's give class name as employee DTO. Perfect. Next, let us define the instance variables for this class. So here private long ID, and then private string first name, and then private string last name, and then private string email. Next, let us annotate this class with add getter lombok annotation to generate the getter methods for these instance variables. Next, let us use add setter lombok annotation to generate the setter methods for these instance variables. Next, let us use add no argument constructor and add all argument constructor annotations to create a constructors for this class. Well, we use the employee DTO class to transfer the data between client and server. So when we build the RESTful web services, we'll use this employee DTO as a response for REST APIs. Next, let us create an employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. So whenever we build the RESTful services, then we have to convert employee DTO into employee JP entity and employee JP entity into employee DTO, right? So instead of writing the same logic in all the classes, let's create a mapper class and let's keep the common logic. So here what we'll do, we'll create a new package and let's call it as mapper. Let's create a class. Let's give a class name as employee mapper, And next let us create a static method, public static. Let's give return type as employee DTO, and let's give method name as map to employee DTO, and let us pass employee JP entity as a parameter to this method. And next here return new employee DTO, and let us pass the values to the constructor. So let us get all the values from employee JP entity and let us set those values to the employee DTO. So here employee dot get ID, and then employee dot get first name, employee dot get last name, employee dot get email. Perfect. Now we have created map to employee DTO method. It will map employee JP entity into employee DTO. Similarly, let's create one more method that will map employee DTO to employee JP entity. So here public static, let us give employee JP entity as a return type. Next let us give method name as map to employee, and let us pass employee DTO as a parameter to this method. Next return object. So let us construct the object of employee JP entity, and here employee DTO dot get ID, employee DTO dot get first name, employee DTO dot get last name, employee DTO dot get email. Alright, perfect. Now we have created map to employee static method. It convert employee DTO into employee JP entity. Alright, perfect. So let me recap what we have done in this lecture. We have created employee DTO class to transfer the data between client and server, and next we have created employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. Alright, great. In next lecture onwards, we will start building the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will build add employee REST API. Well, let us take a look into the development steps. First, we will create the service layer. Well, if you can see here, the controller layer is depends on service layer, and the service layer is depends on a repository layer, and we basically create the REST APIs in a controller layer, right? So controller layer is depends on service layer. So let us first create the service layer. Well, we have already created the repository layer, so we don't have to write any methods in a repository layer as of now. So let us first create the service layer, and then we'll build the REST API in a controller layer. Okay, so create the service layer, like we'll create an employee service interface, and then we create an employee service IMPL class that implements employee service interface. Next we'll build the add employee REST API in a controller layer, and next we'll test this add employee REST API using Postman client. Okay, so let us go to our project in IntelliJ and here let us first create the service layer. So go to service package, right click on it, new, and then choose Java class, select interface. Let us give interface name as employee service. Within employee service interface, let us define the method. So let us give method return type as employee DTO. Let us give method name as create employee, and let us pass employee DTO as a parameter to this method. Perfect. Next, let us create employee service IMPL class that implements this interface and its methods. Next, go to service package, right click on this package, new, and then choose package. Let's give package as IMPL. IMPL stands for implementation. So right click on IMPL package, new, and then choose Java class. Let's give class name as employee service IMPL. Perfect. Next, this class implements employee service interface. And next, go ahead and mouse over on this class, and here you will get the option to implement the methods like the link. So go ahead and click on this implement methods link over here and select the method that you want to implement. Click on OK. Perfect. Next, let us annotate this class with @service annotation, and make sure that you choose service annotation from org.springframework.stereo.package. Well, this annotation tells Spring container to create the Spring Bean for this class. Next, let us implement create employee method. Well, before implementing this method, let us first inject the dependencies. So here, private employee repository. Well, we are going to use constructor based dependency injection to inject the dependencies, and instead of creating the constructor manually, let us use Lombok annotation. So let us annotate this class with @all argument constructor annotation. Okay, now we have injected employee repository as a dependency. Next, let us implement create employee method. So go to create employee method, and within this create employee method, first we need to convert employee DTO into employee JP entity, because we need to store the employee entity into database, isn't it? So here let's say employee equal to, let us call employee mapper class to map employee DTO to employee JP entity. So here employee mapper, it has map to employee method and then pass employee DTO. Okay, now we have converted employee DTO to employee JP entity. Next, let us save this employee JP entity into database. So for that, let us call employee repository. It has a save method and then pass employee JP entity object. Perfect. Next, this save method return the saved employee object. So let us get into a local variable. So here employee, and let us give a variable name as saved employee. Next, we need to return saved employee object back to the client. So here let us convert saved employee JP entity into employee DTO. So here let us remove this null and let us type employee mapper. It has map to employee DTO, and let us pass saved employee. Perfect. Now we have implemented create employee method. Next, go to controller package over here. Right click on controller package, new, and then choose Java class. Let us give class name as employee controller. Next, let us annotate this employee controller class with @REST controller annotation. Well, once we annotate a class with @REST controller annotation, then this class becomes a Spring MUC REST controllers, and this class is capable to handle HTTP requests. Next, let us annotate this class with one more annotation, that is @request_mapping annotation. Well, here we are using @request_mapping annotation to define the base URL for all the REST APIs that we are going to build within this controller. So here let us give the base URL /API/employees. Okay, perfect. Next, within this employee controller, let us first inject the dependencies. So private employee service, and instead of creating the constructor manually, let us annotate this class with @argument constructor annotation. Okay. Next, let us build add employee REST API. So here let me write the comment, build add employee REST API. Well, creating a REST API using Spring Boot is very simple. First, we need to create a method, and then we'll make that method as a REST API by using Spring annotations. So here let's first create a method, public, and let's go return type of the method as a response entity. So response entity is a generic class. We have to pass the type. So here let us pass employee DTO as a type. Next, let us give method name as create employee, and let us pass employee DTO as a parameter to this method. And next, here let us call employee service. It has create employee method, and then pass employee DTO object as a parameter to this method. And this create employee method returns a saved employee. So here employee DTO, and let us give the variable name as saved employee. Next, let us have return statement, return object of response entity. So let us pass value to the constructor. So first value as saved employee, second value as HTTP status code. So here just type HTTP status dot created. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @postMapping annotation. Well, we use @postMapping annotation to map the incoming HTTP post request to this method. Next, let us use one more annotation here, that is @requestBody annotation. Well, this @requestBody annotation will extract the JSON from the HTTP request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have created add employee REST API. Next, let us run our Spring Boot application, and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to the Postman client over here, and here let me create a new request. Let us choose HTTP post method, and let us enter the request URL HTTP localhost 8080/API/employees, and next go to the body, select raw, select content type JSON, and within a body we need to pass the JSON object. So here let's create a JSON object. So first name, let us give first name as Ramesh, and then last name, let us give last name as Padtari, and then email, let us give email as ramesh@gmail.com. Well, if you can go to our project in IntelliJ IDEA and go to create employee REST API, and here you can see employee DTO, and if you go inside employee DTO, and this employee DTO class has the fields first name, last name, email, and if you go to Postman client, and if you can notice the JSON over here, the attributes name like first name, last name, email. So whenever you pass the JSON in the request, make sure that the JSON attributes should be same as the DTO class fields, because we are using @request_body annotation here to extract the JSON and convert that JSON into employee DTO Java class object. And in order to convert a JSON into Java object, the JSON attributes and Java object fields should be same. Okay, perfect. Next, let's go to Postman client over here. Next, go ahead and click on send button, and there we go. We got a response of the REST API, and if you can notice here the status 201 created and the saved employee object in the response. We have successfully built add employee REST API. In next lecture, we will build get single employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get employee REST API. So let's go to our project in IntelliJ IDEA, and let us first change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let's go to employee service interface over here. Within this interface, let us define the get employee by ID method. So here, let us give employee DTO as a return type of the method, and let us give method name as get employee by ID, and let us pass employee ID as a parameter to this method. Perfect. Now we have defined get employee by ID method in a employee service interface. Next, let us implement this method in employee service IMPL class. So let us go to employee service IMPL class over here, and just mouse over on this class, and here we have implement methods link. So go ahead and click on this link over here, and then select the method that we want to implement. Next, click on OK. Perfect. So here we can implement the get employee by ID method. Well, before implementing this method, let's go ahead and let's first create one custom exception. Well, whenever an employee with a given ID is not exist in database, then we have to throw the custom exception, isn't it? So let us go ahead and let us first create the custom exception. So go to exception package, right click, new, and choose Java class. Let us give exception name as resource not found exception. Perfect. Next, let us extend this class from runtime exception, and then let us create a parameterized constructor public resource not found exception, and then let us pass message as a parameter. Alright, and here let us call super keyword to pass this message to the super class constructor. Next, let us annotate this class with @response status annotation, and let us specify the HTTP status. So here let us use HTTP status not found. Well, if employee with a given ID is not exist in database, then we will throw this resource not found exception, and then Spring Boot will catch this exception, and it will get the error message from the exception, and it will send the error message along with the HTTP status to the client. Next, let us go back to employee service IMPL class over here. Next, let us implement this get employee by ID method. So here let me maximize this. So within a get employee by ID method, let us call employee repository. It has find by ID method, and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and just pass employee ID. Next, optional has or else through method. So here let us call or else throw method over here, and notice here or else throw method returns a employee object, and or else throw method takes supplier as a functional interface, and we have to pass the lambda expression implementation of this supplier functional interface. So let us call this or else throw method over here, and let us create the lambda expression. So here lambda symbol, and then new resource not found exception, and let us pass the message employee is not exists with a given ID. Alright, and let us pass the ID dynamically over here, that is employee ID. Perfect. Next, let me maximize this a bit. Next, you can see the typo here exists, so let me correct it. Employee is not exist with a given ID, and then employee ID. Next, let me also break this statement. Perfect. So this or else throw method returns an employee object. So here let us take the result of this or else throw method in a local variable of type employee. Perfect. Next, if you can notice here, get employee by ID method returns an employee DTO. So let us convert this employee JP entity into employee DTO. So go to return statement, remove this null, and let us call employee mapper over here. It has a map to employee DTO method, and then pass employee JP entity object. Perfect. Now we have implemented get employee by ID method in a employee service IMPL class. Next, let us create the REST API that will internally call this get employee by ID method. So here let me minimize this and go to employee controller over here, and within employee controller let us build get employee by ID REST API. So here let me write the comment build get employee REST API. Well, creating a REST API using Spring Boot is very simple. We just need to create a method, and then we will convert that method into REST API by using Spring annotations. So here let us first create a method public, and then response entity as a return type. Response entity is a generic, so let us pass employee DTO as a type, and next let us give method name as get employee by ID. Next, let us pass employee ID as a parameter to this method. Within this get employee by ID method, let us call employee service. It has get employee by ID method, and then pass employee ID. Perfect. So this get employee by ID method returns employee DTO. So here let us take the result of this method in a local variable of type employee DTO. Perfect. Next, let us have a return statement. Return response entity. It has a OK method, and next let us pass employee DTO as a parameter to this method. Perfect. Now we have created get employee by ID method. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map the incoming HTTP GET request to this method. Next, let us pass the ID. Well, this ID is basically called a URI template variable. Next, we need to bind the value of this URI template variable to this method argument. So in order to do that, we have to use add path variable annotation. So here let us use add path variable annotation, and we need to also pass the URI template variable name here, that is ID. So notice here the URI template variable name is ID and the method argument name is employee ID. So both the variable names are different. That's why we have to pass the URI template variable name to the path variable annotation. Then only the path variable annotation will bind the value of this URI template variable to this method argument. Okay, perfect. Now we have created get employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here and let us create a new request. And here let us choose HTTP GET method and let us enter the request URL HTTP localhost 8080/API/employees and then /1, and here we have passed employee ID 1. Okay, next click on send button, and there we go. You can see the response. The REST API returned the response, and the response contains the employee object in a JSON format and the status 200 OK. It means we have successfully built get employee REST API. In next lecture, we are going to build get all employees REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get all employees REST API. So let's go to our project in IntelliJ IDEA over here. And first, we'll change the service layer and then we'll change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give a return type of the method as list of employee DTO. Next, let us give method name as get all employees. Alright, now we have created get all employees method in our employee service interface. Next, let us implement this method in our employee service IMPL class. Let us head over to employee service IMPL class over here and just mouse over on this class. Click on this implement methods link. Next, let us select the method that you want to implement. Click on OK. Alright, now let us go ahead and let us implement this get all employees method over here. Within a get all employees method, let us call employee repository. It has find all method. We'll notice here there are multiple overloaded find all methods. Where I want to choose the find all method, it doesn't take any method argument, and find all method returns a list of type employee JP entity. Okay, so let us select find all method over here. Next, let us take the result of this find all method in a local variable of type list. So here, let us declare list. List is a generic. Let us pass employee class as a type and let us call it as employees. Perfect. Now we have list of employee JP entities. But if you can see here, get all employees method returns list of employee DTOs, right? So let us convert a list of employee JP entities into list of employee DTOs. So here go to return statement, remove this null, and here just call employees. So employees is a list. It has a stream method, and then stream has a map method. And notice here map method has a function as a functional interface, and we need to provide the lambda expression implementation for this functional interface. So let us select map method over here. So basically we use map method to map one object into another object. And in our case, we have to convert employee JP entity into employee DTO, right? So here, let us have a lambda expression implementation. So here, let us pass employee as a parameter, and let us have lambda symbol and then call employee mapper. It has map to DTO method and then pass employee object. Perfect. And finally, let us call collect method to collect the result. So here we are using list. So let us call this collect method. It takes to list as a parameter. Now we have written a logic to convert a list of employee JP entities into list of employee DTOs. Next, let us create the REST API that will internally call this method. So go to employee controller over here, and within employee controller, let us build get all employees REST API. So here, let me write the comment build get all employees REST API. Well, creating REST API using Spring Boot is very simple. First, we need to create a method, and then we'll convert that method into REST API by using Spring annotations. So here, let us first create the method public response entity as a return type. Response entity is a generic, so let us pass list as a type. List is also a generic interface. Let us pass employee DTO as a type, and let us give method name as get all employees. Alright, and here let us call employee service. It has get all employees method. So get all employees method returns a list of employee DTOs. So here let us declare a local variable of type list. List is generic. Let us pass employee DTO as a type, and let us give variable name as employees. Perfect. Next, let us have return statement, return response entity, and then call its OK method, and then pass employee objects as a parameter. Perfect. Now we have created get all employees method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map incoming HTTP GET request to this particular method. Alright, perfect. Now we have built get all employees REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. let us choose HTTP GET method and let us enter the URL localhost 8080/API/employees. Click on send button and there we go. You can see the array contains a single JSON object. So let us insert one more employee. So go to add employee request over here and let us change the JSON post name. Let us say Sanjay, last name let us say Jadhav, email sanjay@gmail.com. Next click on send button and there we go. We got the response and the status code 201 created. Next let us go to get all employees request over here and then click on send button and there we go. You can see here there are total 2 employees and in a response also there are 2 employees. Next let us insert one more employee. So go to post request and here let us give first name as Tom and last name Cruz, email tom@gmail.com. Click on send button and there we go. We got the response with the employee ID 3. Next let us go to get all employees request over here. Click on send button and there we go. You can see a Tom employee is present in a array. Okay, it means we have successfully built get all employees REST API. In next lecture we will build update employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build update employee REST API. So let us go to our project in IntelliJ IDEA. Well, first we're going to change the service layer and then we'll change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here. Within this interface, let us define the method. So here let us give employee DTO as a return type of the method and let us give method name as update employee and let us pass employee ID as a post parameter and employee DTO as a second parameter, and this employee DTO basically contains the updated employee details. Okay, so let us call it as updated employee. Okay, perfect. Now we have defined update employee method in an employee service interface. Next let us implement this method in an employee service IMPL class. So let us go to employee service IMPL class over here. Just mouse over on this class, click on this implement methods and then click on OK method. Now let us go and let's implement update employee method. Within update employee method, let us first add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So let us write that logic here. So just call employee repository. It has find by ID method and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and then pass employee ID as a parameter and then optional has or else throw method. So let us call or else throw method over here and notice here or else throw method takes supplier as a functional interface and we have to provide the lambda expression implementation for this supplier functional interface. So just call this method and then let us construct the lambda expression. So here new resource not found exception and then let us pass the custom exception message. Let us say employee is not exist with given ID and then pass employee ID dynamically. Perfect. Next let me put the semicolon over here. Alright, and this or else throw method returns a employee object. So here let us take the result of or else throw method in a local variable of type employee. Perfect. Next we have the updated employee object. It contains all the employee updated information. So let us set all the details from updated employee object into this employee object. Okay, so here employee dot set first name and then updated employee dot get first name, employee dot set last name and then updated employee dot get last name, employee dot set email and then updated employee dot get email. Perfect. Next let us call employee repository. It has a save method and then pass this employee object. Okay, so here basically we have updated this employee object with first name, last name, email and again we are saving this employee object by using save method. So basically this save method performs both save and update operation. Well, if employee object contains ID, then this save method internally perform the update operation, and if employee ID doesn't contain the primary key ID, then it will perform the insert operation. Alright, next this save method returns the updated employee object. So here let us declare the updated employee object like this. Perfect. Next, if you can see here, update employee method returns the employee DTO. So let us convert this updated employee object JP entity into employee DTO. So here go to return statement, remove this null, and then call employee mapper. It has map to employee DTO method and then pass updated employee object as a parameter. Now we have implemented update employee method in a employee service IMPL class. Next, let us create the REST API that will internally call this update employee method. So go to employee controller over here. Within employee controller, let us build update employee REST API. So here, let me first write the comment, build update employee REST API. Let us first create a method and then we will convert that method into REST API by using Spring annotations. So here just type public response entity and then pass employee DTO as a type. Let us give method name as update employee. Alright, and let us pass employee ID as a first argument and employee DTO as a second argument. So this employee DTO is nothing but updated employee information. Perfect. Next, let us call employee service. It has update employee method and then pass employee ID as a first parameter, updated employee as a second parameter. Perfect. Next, this update employee method returns the employee DTO. So here let us have a local variable of type employee DTO. Alright, next let us have a return statement, return response entity and then call OK method and then pass employee DTO. Alright, now we have created update employee method. Let us make this method as a REST API by using Spring annotations. So let us annotate this method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, let us pass the ID. So here is the syntax. Within a open and close curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use @path variable annotation over here. And next, let us pass the URI template variable, that is ID. Perfect. Next, we need to use one more annotation, that is @request_body annotation. Well, this @request_body annotation will basically extract the updated JSON from the request and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have built update employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. And here, let us choose HTTP put method and let us enter the request URL localhost 800/API/employees, and then we need to pass the employee ID that we are going to update. So let us say we are going to update the employee with ID 1. Alright, next let us pass the updated information in the body. So click on body, raw, content type JSON, and here we need to pass the JSON. So here let me quickly create the JSON. First name Ram and last name Jadhav, email ram@gmail.com. Next, go ahead and click on send button over here, and there we go. You can see the response. The post name is updated, last name is updated, and email is also updated. It means we have successfully built update employee REST API. Alright, great. In next lecture, we'll build delete employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete employee REST API. So let's go to our project in IntelliJ IDEA over here. Well, first we'll change the service layer and then we'll change the controller layer because the controller layer is depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give void as a return type of the method, and let us give method name as delete employee, and let us pass employee ID as a parameter to this method. Next, let us go ahead and let us implement this delete employee method in our employee service IMPL class. So go to employee service IMPL class over here, just mouse over on this class, click on this implement methods and choose the method that you want to implement. Click on OK. Alright. Next, let us go ahead and let us implement this delete employee method. So here, first of all, we need to add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So if you go to update employee method over here, we have already written the logic. Okay, so let us copy this piece of code and go to delete employee method, and here just paste this piece of code. So here basically we are calling find by ID method, and this find by ID method returns optional. So again here we are calling or else through method of optional object, and here basically we are providing the lambda implementation of supplier functional interface. So basically if employee with a given ID is not exist in database, then this piece of code will basically throw the resource not found exception. Next, let us call employee repository. It has delete by ID method, and then pass employee ID as a parameter to this method. Okay, perfect. So this delete by ID method will basically delete the employee by ID. Alright, next let us create delete employee REST API that will internally call this method. So go to employee controller over here. Within employee controller, let us build delete employee REST API. So here let me write the comment first, build delete employee REST API. So first we'll create a method and then we'll convert that method into REST API by using Spring annotations. So here just type public and then response entity as a return type. So let us pass string as a type, and then let's give method name as delete employee. Alright, and let us pass employee ID as a parameter to this method. Perfect. Next, within our delete employee method, let us call employee service. It has delete employee method and then pass employee ID. Next, let us have a return statement, return response entity dot OK, and let us pass the success message, that is employee deleted successfully, something like that. Perfect. Now we have created delete employee method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add delete mapping annotation. Well, we use add delete mapping annotation to map the incoming HTTP delete request to this method. Next, we need to pass the ID to this annotation. So here within a curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use add path variable annotation and then pass URI template variable name. Perfect. Now we have built delete employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here, and here let me copy this link and let me create a new request, and here let us choose HTTP delete method, and let us enter the request URL localhost 800/API/employees, and here we need to pass the employee ID that we are going to delete. For example, let us say we want to delete the employee with ID 1, then we have to pass the employee ID 1 in the request URL, and go ahead and click on send button over here, and look at here the response, employee deleted successfully, and the status code 200 OK. Alright, it means the delete employee REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this section of the lectures, we are going to build the REST APIs for simple banking application. Well, we are going to build add account REST API, get account REST API, deposit amount REST API, withdraw amount REST API, get all accounts REST API, and delete account REST API. So these are the simple REST APIs that we are going to build for banking application. Well, what are the tools and technologies that we are going to use to build this banking application? Well, we are going to use Java 17 plus, Spring Boot 2.3.1. This is the latest version of Spring Boot as of now. And we will use Spring Data API that internally uses Hibernate. And we will use MySQL database. We will use IntelliJ IDEA to develop this project. We are going to use Maven build tool. And we will use Postman client to test the REST APIs. Alright, great. In next lecture, we will kickstart our Spring Boot application for a banking application. Alright, great. I will see you in the next lecture. So just let us jump into the browser. So I am in a Chrome browser and open the new tab over here and just type start.spring.io. This will brings up Spring Initializer, and here select the project Maven and choose the language Java, and let us keep the stable version of Spring Boot as of now, that is 3.2.1. So this is the latest and stable version of Spring Boot as of now. Next, go to the project metadata over here, and here let us give group as net.java guides, and let's give artifact as banking app. Next, project name is same as artifact, that is banking app. Next, description, let us give the description something like demo project for Spring Boot banking app. Next, let us give package name as net.javaguides.banking. Next, let us keep packaging as a jar, and let's keep Java version 17. Next, go to the dependency section over here, and here just search for web, and let us select this Spring Web Starter dependency. Well, we use this dependency to build the RESTful APIs, and this dependency internally provides Apache Tomcat server as a default embedded container. So let us select this dependency. Next, let us type Spring Data JPA. Well, we are going to build the JPA repositories using Spring Data JPA. Well, this Spring Data JPA dependency internally provides latest version of Hibernate. Okay, so let us select Spring Data JPA over here. Next, type MySQL. So we are going to use MySQL JDBC driver to connect our Spring Boot application with the MySQL database. Next, let us select the Lombok dependency. Well, we are going to use Lombok dependency to reduce the boilerplate code such as getter setter methods, constructors, toString equals, and hash code methods. Okay, so let us select Lombok dependency over here. Alright, so as of now, these dependencies are enough for our Spring Boot application. Next, go ahead and click on generate button over here. So before that, you can also explore the Spring Boot application using explore option over here. So just click on explore, and here go to the pom.xml file, and you can see the Spring Boot version, Java version, and the dependencies as well. Okay, perfect. Next, click on close button, and go ahead and click on this generate button to generate the Spring Boot application as a zip file. Okay, next go ahead and open this zip file in a folder. Perfect. Next, let us unzip this zip file. Alright, next let us open the IntelliJ IDEA. So here I have opened IntelliJ IDEA. Next, click on open option over here to open the existing project. In my case, the project is downloaded in a downloads folder. So let me go into the downloads folder over here, and next let me select the project. Let me click on open. Now we have successfully imported the Spring Boot application in IntelliJ IDEA. Next, let us go ahead and let us start developing this Spring Boot application. Next step is we will configure the MySQL database in our Spring Boot application so that our Spring Boot application can able to connect to the MySQL database. So go to the SRC folder and go to main folder, go to resources, go to application.properties file. So here inside application.properties file, we are going to configure the MySQL database details. Okay, so before configuring MySQL database details in the application.properties file, let us first create the database in a MySQL server. So in our case, we are going to use MySQL Workbench to interact with the MySQL server. So here, let me quickly create the new database. So here let us write the SQL statement, create database followed by the database name. So let us give database name as banking app. Next let us select this, click on execute, and next refresh schemas, and here you can see banking app database is successfully created. Next we can make this schema or database as a default so that we can only focus on this database. Next let's go back to IntelliJ IDEA over here and go to application.properties file, and here let us configure the MySQL database properties. So just type spring.datasource.url equal to JDBC and then MySQL and then localhost and then port 3306 and then followed by the database name banking_app. So this is the JDBC URL that our Spring Boot application will use to connect with the MySQL database, and here we are using localhost because our MySQL server is running in a local machine. That's why the host name is localhost, and this is the default port for a MySQL server, and this is the database name. Next let us configure the MySQL database username and password. So here spring.datasource.username. In my case the username is root. Next let us configure the password, spring.datasource.password. Well, in my case this is the password, but make sure that whatever the database username and password that you have given while installing the MySQL database, that you have to provide over here. Next let us tell Hibernate to automatically create the tables using JP entities. For that let's configure the property spring.jp.hibernate.dtl-auto equal to update. Alright, so this property basically ensures that the Hibernate should create the database tables automatically based on the JP entities that we will create in the Spring Boot application. Next, we no need to add Hibernate delete for a MySQL database because Spring Boot 3 internally uses Hibernate 6, and Hibernate 6 will automatically configure the Hibernate delete for a database based on the JDBC driver dependency that we add in the Spring Boot application. In our case, we have added MySQL JDBC driver, so Hibernate 6 will automatically configure the Hibernate delete for a MySQL database. Okay, perfect. Next, let us run the Spring Boot application so that we can make sure that our Spring Boot application can able to connect to this banking app database. So go to our main entry point class over here, and from here let us run the Spring Boot application, and here click on enable button to enable the Lombok annotations. And notice here there are no errors in a console logs. It means our Spring Boot application is successfully connected with the MySQL database. Next step is we will create a JPA entity. So before that, let's quickly create the packaging structure for our Spring Boot application. So right click on the base package, new, and then choose package. Let's give name as entity. Next let's create one more package. Right click, new, and then choose package. Let's give package name as controller. Next right click, new, and then choose package. Let's give package name as service. Next let's create one more package. Let's call it as repository. Perfect. Next go to entity package, right click on it, new, and then choose Java class. Let's give class name as account. Next let us define the fields for this account class. Private long ID, and then private string. Let's give name as account holder name, and then private double balance. Well, to keep it simple, let us have these three fields for our account class. Next let us make this class as a JP entity by using JP annotations. So let us annotate this class with add entity annotation to make this class as a JP entity. Next, let us configure the table details by using add table annotation. So here let's use name attribute to give a name to the table, let us say accounts. Perfect. Next, let us use Lombok annotations to automatically create a getter setter methods for this account class. So here let us use add getter Lombok annotation, and next let us use add setter Lombok annotation. Next, let us also use the constructor related annotations. For example, no argument constructor and all argument constructor annotation. Next, let us use few more JP annotations over here. So go to the ID field and let us annotate this ID field with @id annotation to make this ID field as a primary key in a database. Next, let us use @generated_value annotation to configure primary key generation strategy. So this annotation has a strategy attribute, and let us give the generation type as an identity. So this will basically automatically increment the primary key. Next, here let us use @column annotation to configure the column name for this field. So here let us use name attribute and let's give column name as account underscore holder underscore name. Okay, perfect. Now we have created account JP entity. Next, let us run this Spring Boot application and let us see whether the Hibernate will automatically create a table for this account JP entity or not. Okay, so go to main entity point class over here. From here, let us run the Spring Boot application. And notice here there are no errors in the console. Let's go to database and go to banking app database, refresh the schemas, go to tables, and there we go. Accounts table is created, and the columns like ID, account holder name, and balance. It means the table is successfully created and the columns are also looks good. Okay, so let's go back to IntelliJ IDEA. Next step is let us create Spring Data JP repository for this account entity. Okay, so go to a repository package, right click on it, new, and then choose Java class, choose interface, and here let us give the interface name as account repository. Perfect. Next, let us extend this interface from JPA repository interface. And notice here JPA repository interface is a generic, so we have to pass two parameters. First is the entity name, in our case account. Second is the type of the primary key, in our case long. Okay, so if you go to account JP entity, so we have given the long type to this ID field, right? So this long we are passing as a second parameter to this JPA repository interface. Okay, great. Well, once we create account repository interface that extends JPA repository interface, then this account repository will get a CRUD database methods to perform CRUD database operations on this account JPA entity. Alright, perfect. Next step is create add account REST API. So before creating the REST API, let us first create the service layer. Well, the controller layer is depends on service layer. So let us first create add account method in a service layer, and then we'll create the REST API, and that REST API will internally call the service method. So here go to service package, right click on it, new, and then choose Java class. And let us select interface, and let us give interface name as account service. Okay, next let us define the method over here. So let us say account and then create account, and let us pass account. Well, we can also use a DTO to transfer the data between client and server. Okay, so what we will do, we will use the DTO. So let's create a new package for it, and let's give package name as DTO, and here let us create a class and let us give class name as account DTO, and here let us type the field private long ID and then private string account holder name, and then private string, let us go double, and then balance. Alright, and here let us use at data lumber connotation to automatically generate constructors, getter, setter methods. Next, let's go back to account service interface, and here instead of account JP entity, let us use account DTO. So here also let us pass account DTO. Okay, perfect. And let's view the name as account DTO, and let's remove this unused import. Okay, perfect. Next, go to service package and let's create one new package, and let's call it as IMPL. IMPL stands for implementation, so all the implementation classes we keep under this IMPL package. So right click on this package, new, and then choose Java class. Let's give class name as account service IMPL. So this is the naming convention. Next, this class implements account service interface and implement its methods. So here just mouse on this class, click on this implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us annotate this class with at service annotation to automatically create a Spring Bean for this class. Next, let us inject the dependency. So here let us first declare the field private account repository. Next, let us use a constructor based dependency injection to inject this account repository dependency. So here right click and then generate, and then constructor, and select the dependency, click on OK. Alright, next here we can annotate this constructor with at annotation to automatically inject the dependency, but Spring 4.3 onwards we can ignore this at annotation, because whenever Spring will find the single constructor in a Spring Bean, then Spring will automatically inject the dependency. Okay, perfect. Next, go to create account method over here, and within this method we need to convert account DTO into account JP entity, and then we'll save that account JP entity into a database. So this is the conversion logic, right? So let us create one mapper class, and let us write the common logic, like we can convert a DTO into JP entity and JP entity into DTO. So here go to DTO package, or else let's create one more package and let's call it as mapper. Next, within a mapper package, let's create a new class. Let's call it as account mapper. So within account mapper class, let's create static method public static, and let us give the return type account, and let us give method name as map to account, and let us pass account DTO as a parameter. Perfect. Next, let us convert this account DTO into account. So here let us create the object account, and then account equal to new account. Next, let us pass the details to the constructor account DTO.getID, and then account DTO.get account holder name, and then account DTO.get balance, and then finally I return the account object. Now we have converted account DTO into account JP entity. Similarly, let us write one more static method to convert account JP entity into account DTO. So here just type public and then static, and then return type as account DTO. Let's give method name as map to account DTO, and let us pass account JP entity. Perfect. Next, let us create account DTO object over here. Alright, and let us pass values to the constructor like account dot get ID, and then account dot get account holder name, and then account dot get balance, and then finally return this account DTO. Well, let us see what is the compilation error over here. It says the parameterized constructor is not available in account DTO. So go to account DTO over here. So this at data annotation don't provide the constructor. So here let us use at argument constructor annotation. Okay, let's go back to mapper class, and there we go. Alright, now we have created a mapper class to map DTO into entity and vice versa. Next, let us use this account mapper class in a service classes. So go to account service impl class over here and go to create account method, and here let's create object of account and then account, and then let us call account mapper over here, account mapper, and then it has map to account method and then pass account DTO. Next, let us call account repository over here, and then it has a save method. So let us call save method to save the account JP entity, and then pass account JP entity object to this save method. So this save method basically return the saved entity. So here let us introduce a local variable of type account, and let's give variable name as saved account. Okay, perfect. And if you look at the create account method return type account DTO. So let us convert saved account into account DTO. So here let us remove this null and then call account mapper and then map to account DTO and then pass saved account. Okay, perfect. Now we have created create account method. It will call the account repository to save the account into the database. Next, let us create the REST API, and then that REST API will internally call this method. So go to controller package over here, right click on it, new, and then choose Java class. Let us give class name as account controller. Let us annotate this account controller class with @REST controller annotation. So this @REST controller annotation will make this class as a Spring MVC REST controller class. Next, let us annotate this class with @request mapping annotation, and let us pass the base URL over here. Let us say /API/accounts. Okay, so this is basically a base URL for all the REST APIs that we are going to define within this account controller class. Okay, great. Next, let us inject the dependency. For that, let us first define the field, that is private account service. Next, let us use a constructor based dependency injection to inject this account service dependency. So here right click, generate, and then constructor, and then click on OK. Now we have injected account service using constructor based dependency injection, and here again we don't have to use @word annotation because this class has only one constructor, so Spring will automatically inject the dependency. Next, here let's create a add account REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method, and then we'll make that method as a REST API by using Spring annotation. Okay, alright, so just type public, and then let us use response entity as a return type, and this is generic, so we can pass account DTO as a type. Let's give method name as add account, and then pass account DTO as a parameter to this method. Alright, perfect. Next, let us have a return statement over here. Return new response entity, and then call account service dot create account, and then pass account DTO. Next, let us pass the HTTP status, that is created. HTTP status created. Perfect. Now we have created add account method. It will call account service dot create account method, and this create account method basically return the saved account. So this is the first argument. Second argument is HTTP status. Okay, perfect. Next, let us make this method as a REST API by using Spring annotation. So in this case, this method have to handle the HTTP post request. For that, let us use @post mapping annotation. Next, here let us use one more annotation, that is @request body annotation. So this @request body annotation will map the request body to this Java object. So request body basically contains JSON, so this @request body will automatically convert that JSON into this Java object. Okay, perfect. Next, let us go ahead and let us run our Spring Boot application and let us test this add account REST API. So from here, I am going to stop the running application first and I am going to run the application again. And notice here our Spring Boot application is up and running in a embedded Tomcat server on port 8080. Next, let us open the Postman REST client. And here let's create one new request. And here let us choose HTTP post method and just type the request URL HTTP localhost 8080/API/accounts. Okay, so if you go to project again and if you go to account controller, the URL is /API/accounts. So this is the URL we are using over here, /API/accounts. Okay, next go to body and then select raw, select content type as a JSON, and here we need to pass the JSON in the request body. So let us quickly create the JSON object. So if you go to project again and if you go to account DTO, so this account DTO has field account holder name and balance. So these fields we have to use in a JSON. So let me copy this field name and let me paste it over here, and then let's give holder name, in my case Ramesh. Next, balance, let us say 10,000. Okay, next go ahead and click on send button, and there we go, we got the response from the server. And if you look at the ID here, 1, so this ID we are getting from the database. And look at the status, 201 created. Let us verify in the database. So go to MySQL Workbench, go to accounts table, select rows, and you can see the account is successfully stored in a accounts table. Okay, perfect. Now we have successfully built add account REST API. Next, let us build get account REST API. So let's go back to our IntelliJ idea. So here let's first change the service layer. So go to account service interface and let us define the method. So here let's give method name as account DTO. Let's give method name as get account by ID, and then pass ID as a parameter. Perfect. Now we have defined get account by ID method in a account service interface. Next, let us implement this method in a account service IMPL class. So go to account service IMPL class over here, just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Next, let us implement this get account by ID method over here. So here just call account repository, it has find by ID method, and notice here find by ID method returns optional of type account. Okay, so just call find by ID and then pass ID over here, and then call or else throw method over here. Well, let us say the account with a given ID is not existing in database, then we have to throw the exception. For that we can use or else throw method over here. So just call this or else throw method, and then here let us pass the lambda expression implementation. Well, this or else method takes supplier functional interface, and we have to provide the lambda expression implementation for this supplier functional interface. So here is the lambda expression to create a new exception and throw that exception. New, let us throw the runtime exception over here. You can create your own custom exception and you can throw that exception from here. So let us say account does not exist. Okay, perfect. Next, here let us take the return value from this method. Let us say account. Next, this get account by ID method returns account DTO. So let us convert this account JP entity object into account DTO. For that, let us call account mapper, and then it has map to account DTO, and then pass account. Perfect. And here let me align this properly. Perfect. Now we have created get account by ID method in a account service IMPL class. Next, let us create get account REST API that will internally call this method. So go to controller layer, go to account controller class, and here let's create get account REST API. So here let me first write the comment get account REST API. Let us type the method public and then response entity and then pass account detail as a type. Let's give method name as account get account by ID and then pass ID as a parameter to this method. Next, let's call account DTO and then call account service dot get account by ID and then pass ID. Perfect. Next, let us have a return statement, return and then response entity dot OK and then pass account DTO in a body. Perfect. Now we have created a get account by ID method. So let's refactor this. Now we have created get account by ID method. It returns the account object and look at the OK method. So this OK method internally returns the HTTP status 200 OK. Alright, perfect. Next, let us make this method as a REST API by using Spring annotations. So this method have to handle HTTP GET request. For that, let us use add get mapping annotation. Okay. So this add get mapping annotation will map the incoming HTTP GET request to this particular method. Next, let us pass ID to this annotation. Within a double quote slash within a curly braces, just pass ID. So this ID is nothing but a template, variable. Next, we need to bind the value from this template path variable to this method argument. For that, we can use add path variable annotation over here. Alright, perfect. Now we have built get account REST API. Next, let us rerun our Spring Boot application and let us test this get account REST API. So from here, let us stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's head over to the Postman client over here, and here let's create a new request. Let us enter the URL http :localhost 8080/API/accounts and then pass account ID 1. Next, click on send button. And there we go. We got the response from the server. And look at here the ID 1, account holder name Ramesh, balance 10,000 and the HTTP status 200 OK. Now we have developed a get account REST API. Next, let us build deposit REST API. Well, basically we are going to develop the REST API that will deposit amount into a account holder name. For example, here the account holder is Ramesh. He has a balance 10,000. Next, we are going to deposit some amount into this, Ramesh account holder. Alright, so basically we are going to add some amount to the existing balance. Okay, it's pretty simple. So let us go to IntelliJ IDEA over here and let us first develop the service layer. So go to account service interface and here let's give account detail as a return type. Let's give method name as deposit. And let's pass first parameter as ID. Next, let us pass second parameter as a amount that we want to deposit into account. Now we have defined deposit method in account service interface. Next, let us provide the implementation for this deposit method in a account service sample class. So let us jump into account service sample class. Mouse over in this class, click on implement methods over here and then click on OK. Next, let us implement this deposit method. Well, within a deposit method, first we'll check whether the account with a given ID exists in a database or not. If the account with a given ID is not exist in database, then we'll throw the runtime exception, right? So here we have already written a piece of code. So let me copy this piece of code and let me paste in a deposit method. Now we got the account for this particular account ID. Next, let us call its get balance method and then add this amount to existing balance. Okay. Next, here let us introduce a local variable double and let's call it as total equal to. Perfect. Next, let us call account, and then let's call it set balance method, and then pass total. Okay, perfect. Next, we need to save this object into a database. For that, let us call account repository, and then call save method, and then pass account object. Perfect. Next, this save method returns saved account object. So here let us introduce a local variable account, and then saved account. Next, this deposit method returns account DTO. So let us convert this account JP entity into account DTO. So here let us remove this null, and then call account mapper. It has map to account DTO, and then pass saved account. Okay, perfect. Now we have implemented deposit method. It will deposit an amount into an account, and the logic is pretty simple. We will get the existing balance from the account, and we'll add the amount to the balance, and then we'll get the total amount, and then we'll add that total amount as a balance to the account, and then we'll save that account into a database. Okay, it's pretty simple. Next, let us build the deposit REST API that will internally call this method. So go to account controller, and here deposit REST API. Alright, so here let's type public, let's give return type as a response entity, and here let's give the type as account DTO, and let's give method name as deposit, and then let us pass two parameters to this method, long ID, and then second parameter as map. It takes key as a string, value as type double. So basically we'll pass amount in a request body. For that we'll use a map. Okay, next let us call it as request. Perfect. Next, within this deposit method, let us call account service. It has deposit method, and then let's pass ID as a first parameter. Second parameter we need to pass the amount, so we can get that amount from the request object. So here request dot get, and then we can pass key as a amount. Okay, next let us introduce a local variable amount account DTO. Okay, next let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Now we have created a deposit method, and then internally we'll call account service dot deposit method, and then we'll pass ID and then amount. So we can extract this as a separate variable as well. So here what we'll do, we'll store in a local variable, let us say double, and then amount equal to request dot get, and then pass this amount over here. Okay, so this will basically improve the readability. Next, let us annotate this deposit method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, within a double quote slash, and then pass ID. Next, slash deposit. So this is the URL for this REST API. Next, let us store the value of this ID into a method argument using @path variable annotation. So here let us use @path variable annotation to bind value of this template URI variable to this method argument. Next, here let us use one more annotation, that is @request body annotation. Well, this @request body annotation will map the request JSON body into this map Java object. Okay, perfect. Now we have developed a deposit REST API. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this deposit REST API. So here let me stop and rerun the Spring Boot application. Alright, our Spring Boot application is up and running. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method. And here let us enter the request URL. So let me copy this and let me paste it over here. Next let's go to body and then choose raw and then choose content type JSON, and here let us pass the JSON and the key as amount and the value. Let us say we want to deposit 5,000. Okay, that's it. Next click on send button. So this says method not allowed. Well, here we need to give the correct URL. So let's go to IntelliJ IDEA and let's see the URL that we have given to the REST API. We have given the URL id/deposit. So we need to append this deposit in the URL as well. So here's /1/deposit and then click on send button, and there we go. In a response you can see the JSON account 1, account holder name Ramesh, and the balance is 15,000. Earlier it was 10,000. Now you can see the balance 15,000. Okay, it means we have successfully deposited 5,000 into account Ramesh. Next let us say we want to deposit 10,000. Next click on send button and you can see the response, the total balance 25,000. It means the deposit REST API is working as expected. Next you can see the same change in the database table as well. So go to accounts table, right click, select rows, and you can see the balance 25,000. Okay, it means we have successfully built deposit REST API. Okay, great. Next let us build withdraw REST API. So let us go to IntelliJ IDEA and let's create the withdraw REST API. So let us first change the service layer and then we'll change the controller layer. So go to account service interface and here let's define the method. Let's give return type as account DTO. Let's give method name as withdraw and let's pass parameter as long ID. Let's also pass the second parameter, that is amount. Perfect. Now we have defined withdraw method in a account service interface. Next let us provide the implementation for this method in a account service sample class. So let us jump into account service sample class. Just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Perfect. Next let us implement this withdraw method over here. So here first we'll check whether the account with a given ID is exist in a database or not. If the account with a given ID is not exist in database, then we'll throw the exceptions like account does not exist. Okay, so that piece of code we have already written in a existing methods. So we can copy that piece of code from here. So go to deposit method and copy this piece of code. Okay, and again go to withdraw method and here simply paste it. Okay, perfect. Next let us add one more condition, like if the withdraw amount is greater than the balance, then we'll throw the exception like insufficient amount. Okay, so here let's add the if condition and then account dot get balance. So if the account balance is less than the withdraw amount, then we'll throw the runtime exception. So here throw new runtime exception and let us pass the message insufficient amount. Perfect. Next here let us write the logic double total equal to, so here just call account dot get balance minus amount. So in this case we are withdrawing the amount from the balance, that's why we are using a subtraction. Okay, next let's call account dot set balance and then pass total. Okay, perfect. Next let us call account repository and then call save method and then pass this account object. Next this save method return the account saved account object. So let us introduce a local variable of type account. Let's call it as saved account. Perfect. Next if you can look at the withdraw method over here, it returns the account DTO. So let us convert account entity into account DTO. So here let us remove this null and let's call account mapper, and then it has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented withdraw method. Internally it will call account repository dot find by ID method. Let us say if the account with a given ID is not exist in database, then we will throw the runtime exception. Next we have added one more condition, like if the withdraw amount is greater than the balance, then we'll throw the runtime exception like insufficient amount. Next let us say the balance is greater than the withdraw amount, then we'll write the logic like we'll withdraw some amount from the existing account balance, and then we'll add that total to the account, and then we'll save that account into a database, and then we'll return the updated information. Okay, the logic is pretty simple. Next let us build the withdraw REST API that will internally call this method. So go to account controller. So here let me first write the comment withdraw REST API. So just type public and then response entity and then pass account DTO. Let's give method name as withdraw and then pass two parameters. First parameter as ID, second parameter as a map. The key type is string, the value type is double, and let's call it as request. Perfect. Next let us get the amount from the request. So here double and then amount equal to request dot get and then pass amount. Alright, next account DTO equal to account service dot withdraw and then pass ID and then amount. Next let us have a return statement, return response entity dot OK and then pass account DTO in a body. Perfect. Now we have created withdraw method. It will internally call account service dot withdraw method and it will pass account ID and the withdraw amount. Okay, next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add put mapping annotation. Well, this put mapping annotation will map incoming HTTP put request to this method, and then let us pass the ID and then withdraw. Perfect. Next let us bind the value of this ID to this method argument by using add path variable annotation. Next let us use one more annotation, that is add request body annotation. Now we have built withdraw REST API. Next let us rerun our Spring Boot application and let us test this REST API. So from here let us stop and run the Spring Boot application. Alright, our Spring Boot application is up and running. Let's go to Postman client over here, and here let's create a new request. So let me copy the request URL from the existing REST API request. So here let us select HTTP put method and then pass request URL localhost 8080/API/accounts/ the account ID and then withdraw. Alright, so here we are going to basically withdraw some amount from the account with ID 1. Next let us go to body, select raw, choose content type JSON, and here let us pass the withdraw amount. Let us say I want to withdraw 5,000. Next click on send button and there we go. In a response you can see the account holder name and the balance. Earlier the balance was 25,000. Now you can see the balance 20,000 because we have withdrawn the amount 5,000. Okay, next let us say I want to withdraw 5 more thousand, then what I can do is I can click on send button and you can see the response. The balance is 15,000. Next, let us say I want to withdraw 10,000. Then the balance should be 5,000, right? So let's click on send button and you can see the balance 5,000. It means the withdraw REST API is working as expected. Next, let us build get all accounts REST API. Well, first we'll change the service layer and then we'll change the controller layer, because controller layer depends on service layer. So let us head over to account service interface over here, and within this interface let us declare a method. So let's give the method return type as list. List is a generic, so let us pass account DTO as a type. Let's give method name as get all accounts. Perfect. Next, let us go and let's implement this method in a account service IMPL class. So let us jump into account service IMPL class over here. Just mouse over on this class and here you will get a link to implement the methods. Click on this implement methods, select the method that you want to implement and click on OK. Next, let us write the logic to implement get all accounts method over here. So within a get all accounts method, let us call account repository. It has find all method, and notice here find all method returns a list of account. So just call this find all method over here. Next, let us get the result of this find all method in a list. So list and then account, let's call it as accounts. Okay, now we got a list of accounts. Next, let us convert this list of account into list of account DTO. So here let us call accounts. So accounts is a list and list has a stream method. So here just call stream method, and the stream has a map method. So let us use map method to map entity into DTO. And look at here, map method takes function as a functional interface. We need to provide the lambda expression implementation of this function functional interface. So let us call this map method over here and let us pass the lambda expression implementation. Well, here let us pass account entity object as a parameter to the lambda expression, and then this is the lambda symbol, and then call account mapper. It has map to account DTO method, right? And then pass account entity object. Next, let us call collect collectors dot to list method. Okay, perfect. Well, here we are using account mapper dot map to account DTO method to map account entity object into account DTO. And finally, we are returning the list from the stream, and this list basically contains the list of account DTO. Okay, so here let us have a return statement and remove this return null. Okay, now we have implemented get all accounts method. It will return the list of account DTOs. Next, let us create get all accounts REST API that will internally call this method. So let us head over to account controller over here, and here let me write the comment get all accounts REST API. Perfect. So here let us first create the method and then we will make that method into REST API. So just type public and then response entity. Response entity is a generic. Let us pass type as a list, and again list is a generic. So let us pass account DTO as a type. Let's give method name as get all accounts. Okay, next within this method let us call account service and then call get all accounts method. So this get all accounts method return list of account DTO. So here let us have list and then account DTO. Let's call it as accounts. Perfect. Next, let us have return statement and then response entity. It has OK method and then pass accounts in a body. Perfect. Now we have created a method called get all accounts. It returns a list of account DTOs. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Okay, that's it. Next, let us go and let us rerun our Spring Boot application and let us test this get all accounts REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the personal client over here, and let's create a new request, and let us choose HTTP get method over here, and let us enter the request URL. Well, let us copy from the previous REST API and just paste it over here, and here let us remove these parameters and just keep localhost 8080/epa/accounts. Next, go ahead and click on send button, and there we go. In a response, you can see a list of accounts. So as of now, there is only one account. Now what we'll do, we'll add a few more accounts. Okay, so go to the add account REST API over here, and here go to the body and just change the account holder name from Ramesh to John, and then balance, let us have 20,000. Click on send button. Now the John account is created. Next, let's create one more account. Let us say Sanjay, and then let's say balance 30,000. Click on send button, and there we go, Sanjay account is created. Next, let's go to get all accounts REST API, and next send the request, and there we go. In a response, you can see a list of accounts, and there are total 3 accounts in the list. Alright, it means the get all accounts REST API is working as expected. Alright, great. Next, let us go ahead and let us build delete account REST API. Well, first we'll change the service layer, and then we'll change the controller layer. So go to account service interface over here, and here let's define the method. So let's give return type of the method as a void, and let's give a method name as delete account, and then pass account ID as a parameter. Now we have defined delete account method in account service interface. Next, let us implement this method in account service IMPL class. So let us jump into account service IMPL class over here, and just mouse over on this class, click on implement methods, select the method, click on OK. Alright, next let us implement this delete account method over here. Well, first we'll add the condition like if the account is not exist for a given ID, then we'll throw the runtime exception. Okay, so that logic we have already written in a withdraw method and deposit method and get account by ID method, right? So let us copy this piece of code from the get account by ID method, and then let's go back to delete account method over here, and within this method let us paste this logic. So here basically we are adding the condition like if the account with a given ID does not exist in database, then we will simply throw the runtime exception like this. Okay, great. If the account with a given ID exists in database, then we will delete that account. So for that, let's call the account repository. It has a delete by ID method, and then pass account ID. All right, perfect. So this delete by ID method returns a void, so we no need to return anything. Now we have implemented delete account method. It will delete an account by given ID. Next, let us build the delete account REST API that will internally call this delete account method. So let's go to account controller over here, and here let's write the comment first, delete account REST API. Just type the method public, and then response entity, let us pass string as a type. Let's give method name as delete account, and then pass account ID. Perfect. Next, within delete account method, let us call account service. It has delete account method, and then pass account ID. So this will basically delete the account by ID. Next, let us have a return statement, return response entity dot OK, and then pass the success message here. Let us say account is deleted successfully, something like that. Perfect. Now we have created delete account method. It will delete the account by using account service dot delete account method and return the success message. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @delete mapping annotation. Well, we use @delete mapping annotation to map incoming HTTP delete request to this particular method. Next, let us pass the URI template variable over here. So here braces within a double quote slash within a curly braces ID. So this ID is nothing but a URI template variable, and this ID basically contains the account ID. So we need to bind the value of this ID into the method argument. For that, let us use add path variable annotation. Okay, perfect. Now we have implemented delete account REST API. Next, let us rerun our Spring Boot application and let us test this delete account REST API. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running. Next, let us head over to the Postman client, and here let's create a new request. Let us choose HTTP delete method over here, and here let us enter the request URL. So let me copy this and let me paste it over here, localhost 8080/API/accounts. So let us say we want to delete the account with ID 1. So just pass ID 1 in the URL. Next, click on the send button over here, and there we go. You can see the response, account is deleted successfully with HTTP status 200 OK. Next, let us verify in the database. So let's go to MySQL Workbench over here and go to accounts table, select rows, and notice here the account with ID 1 is deleted from the accounts table. Next, let us delete the account with ID 2 as well. So let's go to Postman client, and here let us pass the account ID 2 in the URL and click on send button, and there we go, we got the success message. Next, let's verify in the database. So here let us refresh the table, that is select rows from the table, and there we go, the account with ID 2 is successfully deleted. It means the delete account REST API is working as expected. Alright, great. Hi everyone, welcome back. In this lecture, let us see how to use a Java record class as a DTO class in our banking application. Well, if you look at the banking application code here, we have used a normal class as a DTO class to transfer the data between client and server. Now, we are using Java 17 plus, so we can utilize the latest feature of Java, right? So record class is a special type of class which is introduced in Java 16. So we can use record class to transfer the data between client and server. And the record class basically is a special kind of class that helps you to encapsulate a related data without the need for boilerplate code. It means once we create a record class, then Java compiler will automatically generate a getter methods, setter methods, constructors, equals, hash code, and toString methods. So in normal Java class, we have to manually create all these boilerplate code, right? But this Java record class tells Java compiler to automatically generate all this boilerplate code. Using record class as a DTO in a Spring Boot application is a modern and efficient approach to encapsulating data transfer between application layers. So basically, record class holds the immutable data, and it is a good candidate as a DTO to transfer the data between different layers. Next, records are a good fit for DTOs because they are concise, immutable, and automatically provide the implementations of getter methods, constructors, equals, hash code, and toString methods, which are essential for DTOs. So let us go ahead and let us see how to use a record class as a DTO in our banking application. So let's go to our project in IntelliJ IDEA and go to account DTO class over here, and here let us go ahead and comment out this code. So here just type public and then record keyword, and let us give record name as account DTO, and next define the fields long ID and then string account holder name and then double balance. Perfect. So basically these fields are implicitly final. So once we create this account DTO object, we cannot modify it because records are immutable. Alright, perfect. Next, let us go to account mapper class over here, and here we have to change these getter methods because record basically provides a getter method name as a field name. For example, here let us remove this get ID method and then call ID. Next, let us remove this and then call account holder name. Next, let us remove this get balance and then call balance. That's it. Now what we have done, we have created a record account DTO and then we have changed in a account mapper. Okay, that's it. Next, let us rerun the Spring Boot application and let us test couple of REST APIs. So from here, I'm going to start the Spring Boot application. So notice here our Spring Boot application is up and running. Next, let's go to the Postman client and let us test couple of REST APIs. So here first let us test create account REST API. So here I'm going to create a new account with a holder name Ramesh. So before that, let us go to the database table over here and let us select the rows from the accounts table. So there is only one account holder, that is Sanjay. Next, let us insert one more account. So here let us give account holder name as Ramesh and the balance 10,000. Click on send button and there we go. The record is successfully created. Let us verify in the database table and you can see here Ramesh record is inserted. Okay, it means the create account REST API is working as expected. Next, let us test get account by ID REST API. So here let us select HTTP get method and here let us pass account ID 6 and then click on send and there we go. We got the response of the REST API. Next, let us test withdraw REST API. Okay, so here let us pass the account ID 6 and then click on send button. So basically look at here the amount 10,000 we want to withdraw and look at here the response. And if you go to database table, the Ramesh user has a balance 10,000 and we have just withdrawn that 10,000 and balance remains 0. Okay, it means withdraw amount REST API is working as expected. Next, let us test the deposit REST API as well. Let us deposit 20,000 to the Ramesh account. So click on send button and there we go, the balance 20,000. And let us verify the database table and look at here Ramesh has a balance 20,000. Next, let us test get all accounts REST API. So here let us remove the ID from the URL, click on send button and there we go. There are 2 accounts in the database table and same we can see in the response of the REST API. Next, let us test the delete account REST API. So here let us pass account ID 3 and click on send button and there we go. Account is deleted successfully. It means we have successfully used record class as a DTO class to transfer the data between client and server. Alright, great. Well, in this course we are going to learn everything about Thymeleaf using Spring Boot 3. In this course we are going to use the latest version of Thymeleaf, the latest version of Spring Boot, the latest version of Java and all the tools and technologies in this course. Okay, so in this course you will learn everything about Thymeleaf from the scratch. We will learn step by step like what is Thymeleaf, how it works and how to integrate Thymeleaf with Spring Boot. We will create a forms and we will see how to handle the forms using Spring Boot and Spring MUC. Okay, so we'll learn everything about Thymeleaf in this course. Okay, so without further ado, let's kickstart this course with what is Thymeleaf. Hi everyone, welcome back. In this lecture, we'll take a look into what is Thymeleaf. Well, Thymeleaf is a modern server-side Java template engine for both web and standalone environments capable of processing HTML, XML, JavaScript, CSS and even plain text. Well, Thymeleaf is not only used in web applications but also used in standalone applications. And Thymeleaf is not only capable of processing HTML but Thymeleaf can be also used to processing XML, JavaScript, CSS and even plain text. And in this course we are going to use Thymeleaf to process HTML templates. Well, the main goal of Thymeleaf is to provide an elegant and high maintainable way of creating templates. Well, Thymeleaf is commonly used to generate HTML views for our web applications. Well, consider this is a Spring Web MUC application architecture over here, and Thymeleaf is widely used to develop the HTML views in web applications. And this is the example of Spring MUC web application architecture. And in Spring Web MUC applications, basically Thymeleaf is used to develop the HTML views. Thymeleaf is the best choice for developing Spring MUC web applications. Well, we can also use JSP, but JSP is kind of outdated. So nowadays, Thymeleaf is the best choice for developing Spring MUC applications. And in this course, we are going to use Thymeleaf templates to develop the view layer in Spring MUC web applications. Well, you may have a question like what kind of templates can Thymeleaf process? Well, out of the box, Thymeleaf allows you to process 6 kinds of templates such as HTML, XML, text, JavaScript, CSS and plain text. Well, Thymeleaf is not only used to process HTML templates, but Thymeleaf can be used to process XML, text, JavaScript, CSS and plain text. Alright. Well, you might have a question like what exactly is a Thymeleaf template? Well, Thymeleaf template can be HTML, XML, JavaScript, CSS or plain text. And here if you can see the code snippet over here, this is the Thymeleaf HTML template with some HTML code and Thymeleaf expressions. Okay, so if you can look at this code snippet over here, this is the Thymeleaf HTML template and it has a HTML code as well as Thymeleaf expressions and Thymeleaf attributes. And Thymeleaf engine will basically process the Thymeleaf expressions and Thymeleaf attributes and it will add the result in the HTML page. Okay, so this is how the Thymeleaf HTML template looks like. Well, consider one more example for Thymeleaf template. So this is the Thymeleaf HTML template. It has a HTML code along with that Thymeleaf expressions and Thymeleaf attributes. Well, if you can notice here, dollar within a curly braces employees. So employees is a Java variable and we can use Thymeleaf expression to access the Java variable, and here th colon each and th colon text. So these are the Thymeleaf attributes. Okay. So this is the best example for Thymeleaf HTML template. It has a HTML code along with that Thymeleaf expressions and Thymeleaf attributes. Next, you may have a question like where Thymeleaf template get processed. Well, in web applications, Thymeleaf is processed on the server side and the results are included in the HTML and returned to the browser. For example, consider we have Spring MVC web application architecture over here. In Spring MVC, we have model, view and controller. And the view layer in a Spring MVC is responsible to process the Thymeleaf template at a server side, and it will produce the plain HTML output and it will return that plain HTML output to the browser for rendering. Just remember, Thymeleaf templates are get processed at the server side and the results are included in the HTML and returned to the browser for rendering. Well, consider this is a Spring Boot web MVC architecture, and in this architecture we have different layers like view layer, controller layer, service layer and repository layer. And we are going to use Thymeleaf templates to develop the view layer in a Spring Boot web MVC applications. Alright, and Thymeleaf is one of the best choice for developing Spring MVC web applications. In next lecture, we will see how Thymeleaf template engine works. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen what is Thymeleaf. Well, Thymeleaf is a modern server-side template engine. It is used to process HTML, XML, JavaScript, CSS and even plain text. In this lecture, we will take a look into how template engine works. Well, consider this workflow here. It has a Thymeleaf template, model, controller and output. And this is the Thymeleaf HTML template. It has HTML code along with that Thymeleaf expressions and Thymeleaf attributes. Well, Thymeleaf engine will parse this Thymeleaf HTML template and it will evaluate the Thymeleaf expressions and Thymeleaf attributes and it will add that result in the HTML page. And if you look at the output here, Thymeleaf engine will basically replace all the Thymeleaf expressions and Thymeleaf attributes and it will add the result, and here is the output of that result. Well, look at here this code snippet. We are using Thymeleaf provided th colon each attribute to iterate over a list of students. And this list of student is coming from the Spring MVC controller, and here student is nothing but a model class. It has attributes like first name, last name, email, and here we are using Thymeleaf variable expression to access model attributes like student.first name, student.last name and student.email. So basically Thymeleaf engine will parse this Thymeleaf HTML template and it uses model data to replace the positions marked on the Thymeleaf template to create a new text in the HTML page. Alright, so Thymeleaf engine will basically parse this Thymeleaf HTML template and it uses a model data to replace the Thymeleaf expressions and attributes. Well, consider one more example over here. We have Thymeleaf HTML template and we have model and we have output of the Thymeleaf engine. Well, Thymeleaf engine will basically parse this Thymeleaf HTML template and it uses a Java model data to replace the positions marked on the Thymeleaf HTML template to create a new text in the HTML page. For example, this code snippet has a Thymeleaf expressions, isn't it? And Thymeleaf engine will basically replace this Thymeleaf expressions with a model data and it will produce the new text and that will be added in the final HTML page. Okay, if you look at the result of this Thymeleaf expressions over here. Alright, just remember Thymeleaf engine will parse the Thymeleaf template and it uses model data to replace the positions marked on the Thymeleaf template to create a new text in the HTML page. Alright, so this is how the Thymeleaf engine basically works. Hi everyone, welcome back. In this lecture, we'll create and set up Spring Boot project and we will see how to integrate Thymeleaf in a Spring Boot project. So let's create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA, and then we'll see how to integrate Thymeleaf in a Spring Boot project. So let's go to browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a web tool that we can use to quickly create and bootstrap Spring based applications. Now let's go and let's fill up the Spring Boot project information over here. Well, we are going to use Maven, so let's keep Maven project as selected over here. And here we have three kinds of JVM languages: Java, Kotlin, Groovy. Let's keep Java as selected. And Spring Boot version, so we are going to use Spring Boot 3. So let's select Spring Boot 3.0.0. This is basically milestone 4. Next, let's fill up the project metadata over here. Well, here I am going to give group as net.javaguides. You can give any group that you want. Next, let's view artifact as Thymeleaf tutorial, something like that. And then project name is same as artifact. Next, let's give description as demo project for Spring Boot and Thymeleaf. Next, package name, let's keep net.javaguides.thymeleaf. Next, let's keep packaging as a jar and let's keep Java version 17. Well, whenever we choose Spring Boot 3, we have to use Java version 17 or later, right? So let's keep Java 17 as selected over here. Next, let's go ahead and let's add dependencies to our Spring Boot project. For that, go ahead and click on add dependencies over here, and here just type Spring Web. Well, we are going to use Spring Boot Starter Web dependency to develop the Spring MUC web applications, and this Spring Web dependency internally provides Apache Tomcat as a default embedded container to deploy the Spring MUC application. So go ahead and choose Spring Web dependency over here. Next, we are going to use Thymeleaf. For that, let's go ahead and let's choose Thymeleaf dependency. Well, we are going to learn more about Thymeleaf dependency a bit later. So go ahead and choose Thymeleaf dependency over here. Well, as of now, these two dependencies are enough. Next, if you want to explore this Spring Boot project, you can go ahead and click on explore option over here, and you can explore the Spring Boot project structure, and you can explore the pom.xml content. Alright, so go ahead and click on close, and next go ahead and click on generate button to generate this Spring Boot project as a zip file. Alright, and if you can see here, Spring Boot application is downloaded as zip file. Next, you can open this zip file in a folder, and next let's unzip this zip file. Alright, next let's go ahead and let's import this Spring Boot project in IntelliJ IDEA. So let's open IntelliJ IDEA, and here in IntelliJ IDEA you have three options: new project, open, get from VCS. Well, we are going to open the existing Spring Boot project in IntelliJ IDEA. For that, go ahead and click on open over here, and next go to the location where your Spring Boot application is present. So in my case, it is in downloads folder. So let's select the Spring Boot project, go ahead and click on open. Now our Spring Boot application is opened in IntelliJ IDEA. Next, select the project and go to file, and then project structure, and then project settings, project, and here we have SDK. So make sure that you configure JDK 17 as a SDK here, because we are using Spring Boot 3. We have to configure SDK Java 17. In my case, I am configuring OpenJDK 17, but you can also use Oracle JDK 17 as well. Next, once you configure the SDK, next click on OK. Okay, now we have successfully created and set up Spring Boot project in IntelliJ IDEA. Next, let's go and let's explore the integration of Thymeleaf in a Spring Boot project. So go ahead and click on pom.xml file over here, and here let's explore this very important dependency, that is Spring Boot Starter Thymeleaf dependency. Well, Spring Boot provides Spring Boot Starter Thymeleaf dependency to work with Thymeleaf in a Spring Boot project, and this Spring Boot Starter Thymeleaf dependency internally provides all the required dependencies to integrate Thymeleaf in a Spring Boot project. For example, if we dive into this dependency internally provides Thymeleaf Spring 6 integration dependency. Okay, so in order to integrate Thymeleaf with Spring, we have to use this dependency, right? But this Spring Boot provided Spring Boot Starter Thymeleaf dependency internally provides Thymeleaf Spring 6 integration dependency, and this dependency internally provides Thymeleaf dependency as well. Okay, well, in order to integrate Thymeleaf in a Spring Boot project, we just have to add this single dependency, and this Spring Boot Starter Thymeleaf dependency internally add all the Thymeleaf and Spring integration related dependencies. Alright, this is awesome, right? If you want to use Thymeleaf in a Spring Boot project, we just have to add single dependency, and Spring Boot will take care of adding all the Thymeleaf and Thymeleaf integration related dependencies. Alright, great. Well, let me recap what we have done in this lecture. We have created and set up Spring Boot project in IntelliJ IDEA, and we have seen how to integrate Thymeleaf in a Spring Boot project. So basically we need to add only this single dependency to integrate Thymeleaf in a Spring Boot project. In next lecture we'll see Spring Boot auto configuration for Thymeleaf. Well, whenever we add this Spring Boot starter Thymeleaf dependency in a Spring Boot project, Spring Boot will automatically configure a lot of stuff for Thymeleaf. Okay, in next lecture we'll see how Spring Boot will auto configure Thymeleaf in a Spring Boot project. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created and set up Spring Boot project in IntelliJ IDEA, and we have also explored about Spring Boot starter Thymeleaf dependency. Alright, so in order to integrate Thymeleaf in a Spring Boot project, we just have to use this single Spring Boot starter Thymeleaf dependency, and this dependency does a lot of stuff. Okay, so if you dive into this dependency, it internally provides Thymeleaf Spring 6 integration dependency. Also it will provide Thymeleaf extras Java 8 time dependency, and if you dive inside Thymeleaf Spring 6 integration dependency, it internally provides Thymeleaf dependency. It means that in order to integrate Thymeleaf in a Spring Boot project, we just have to add Spring Boot starter Thymeleaf dependency. Now let's go and let's explore Spring Boot auto configuration for Thymeleaf. Well, here auto configuration means Spring Boot will automatically configure Thymeleaf related configurations. We don't have to manually do it. Okay, Spring Boot will automatically configure Thymeleaf related configurations. We don't have to manually do that. Well, Spring Boot provides auto configuration for Thymeleaf by adding Spring Boot starter Thymeleaf dependency. It means that Spring Boot will provide auto configuration for Thymeleaf whenever we add this Spring Boot starter Thymeleaf dependency in our Spring Boot project. Next, Spring Boot starter Thymeleaf dependency, it internally provides Spring and Thymeleaf integration dependencies. For example, if you dive inside this Spring Boot starter Thymeleaf dependency, it internally provides Thymeleaf Spring 6 integration dependency. Next, Spring Boot automatically configures View Resolver for Thymeleaf. Well, whenever we add this Spring Boot starter Thymeleaf dependency in a Spring Boot project, then Spring Boot will automatically configure View Resolver for Thymeleaf. Well, whenever we develop a Spring MVC application, we have to configure a View Resolver for Thymeleaf. Okay, so Spring MVC basically required a View Resolver in order to resolve the view. Okay, so Spring Boot will automatically configure View Resolver for Thymeleaf. We don't have to manually configure the View Resolver for Thymeleaf. Next, Spring Boot auto configures location for Thymeleaf template. By default, Spring Boot will look for Thymeleaf templates in a resources/templates folder. For example, if you go to our project, we have a resources folder. Within that we have templates folder. Okay, so Spring Boot will automatically configure the location for Thymeleaf templates. By default the location is templates folder. Okay, so by default Spring Boot will look for all the Thymeleaf templates within this templates folder. We don't have to manually configure the location for Thymeleaf templates. Okay, so these are the configurations Spring Boot will automatically does for us. We don't have to manually configure all these things for Thymeleaf. Next, let's explore more about Spring Boot auto configuration by looking into the internal source code. Well, Spring Boot provides Spring Boot auto configure library, and this library contains all the auto configuration classes. And if you can notice here, Thymeleaf auto configuration is one of the auto configuration class, and this class basically provides auto configuration for Thymeleaf. For example, if you just scroll down and if you can see here, this is the Spring Bean, and this Spring Bean automatically configure the View Resolver for Thymeleaf. Okay, and if you can scroll down and notice here a couple of things, like Spring Boot will automatically configure layout dilate whenever it will find Thymeleaf layout dependency in a class path, and Spring Boot will also configure Spring Security dilate whenever it will find Spring Security and Thymeleaf integration dependency in a class path. Next, Spring Boot will automatically configure Java 8 time dilate bean. Alright, perfect. Now we pretty much understood how Spring Boot will provide auto configuration for Thymeleaf. In next lecture, we will create a hello world example using Spring Boot and Thymeleaf. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Thymeleaf hello world example. Well, here are the development steps. First, we'll create a handler method to handle HTTP request, and this handler method returns the model and view. Next, we'll create a Thymeleaf template as a view and we'll display model data. Or it's pretty simple. Just we need to create a handler method to handle the HTTP request, and this handler method will return the model and view, and then we'll create a simple Thymeleaf template view, and then we'll display the model data. So let's go to IntelliJ IDEA and let's create a simple Thymeleaf hello world example. Well, first of all, we need to create a handler method, right? For that, we need to create a Spring MVC controller. So go to Thymeleaf main package, and here let me quickly create a new package, and let's call it as controller. Within a controller, we keep Spring MVC controllers. Next, right click on controller package, new, and then choose Java class, and let's give controller name as hello world controller. Perfect. Next, let's go ahead and let's annotate this class with add controller annotation from org.springframework.stereotype package. Well, once we annotate this class with add controller annotation, then this class becomes a Spring MVC controller, and this class is capable to handle HTTP request. Next, within this Spring MVC controller, we create a handler method. So let me write the comment over here, handler method to handle hello world request. Perfect. Next, let's go and let's create the method. Just type public, and let's give return type of the method is string, and let's give method name as hello world. Alright, and let's annotate this method with @get mapping annotation. Well, we use get mapping annotation to handle HTTP GET request, and let's give URL here, that is, let's say hello world. Okay, and here in order to store the model data, we have to use model interface from org.springframework.ui package. So let us select model interface here, and then next let's store some data in a model. For example, model dot. So this model provides add attribute method, and notice here there are a couple of overloaded add attribute methods. We are going to choose the first one. It takes 2 parameters. So go ahead and choose this add attribute method, and here we need to pass post parameter as a attribute name. Let's give attribute name as message, and let's give attribute value as hello world. Perfect. And in order to access this hello world attribute value in a Thymeleaf template, we have to use this attribute name. Okay, we'll see how we can access this attribute value by using this attribute name bit later. Now we have added a data to the model. Next, we need to return the view. So let's give view name as hello-world. Perfect. Now we have created a handler method. It will handle HTTP GET request with the URL hello world, and within this handler method we have stored hello world data in a model, and we have returned the hello world view. Next, we will create a hello world Thymeleaf template view, and then we will display this model data. So here, before that, let me write the complete URL http localhost :8080/hello world. Well, whenever user hit this link in the browser, then this handler method will get called, and this handler method return this Thymeleaf template view, right? So let's go and let's design hello world Thymeleaf template view. So let me copy this view name and go to templates folder, and within the templates folder let's create a HTML file, and let's give name as hello world. Okay, so remember, by default Spring Boot will look for all the Thymeleaf templates under this templates folder, hence we have to keep all the Thymeleaf templates under this templates folder. Okay, now we have created hello world.html file. Next, let's go and let's write the code. So here let me write the title something like Thymeleaf hello world example, something like that. Next, we need to configure namespace for Thymeleaf. Well, in order to use Thymeleaf syntax in this HTML file, we have to define a namespace for Thymeleaf at the beginning of this HTML page. For example, go to this HTML element, and here we need to define the XML namespace. So just type XML namespace :th, and then http www.thymeleaf.org. So this is basically official website of Thymeleaf, and in order to use Thymeleaf syntax in this HTML file, we have to define XML namespace for Thymeleaf at the beginning of this HTML page like this. Next, let's go ahead and let's display the model data. Well, if you go to hello world controller and go to this handler method, in a handler method we have stored this hello world string in a model, right? Now let's go and let's display this hello world string by using this message attribute name. Okay, let me show you how we can do that. So go to hello world.html page again and go to body. Within a body, let's have a h2 element, and then here within h2 element, let's type th:text. Well, Thymeleaf provides th:text attribute to display the text. Well, we are going to basically access the Java variable. For that, we need to use a variable expression, and here's the syntax: dollar within curly braces, we just need to pass attribute name. In our case, it is a message. For example, if you go to hello world controller, we are using attribute name as a message, attribute value as a hello world. Okay, in order to access this hello world attribute value, we have to use this attribute name, isn't it? This is what we are doing in a hello.html page. We are using attribute name to access the attribute value by using variable expression. So this is called variable expression. Okay, dollar within curly braces, we need to pass attribute name in order to access the attribute value. And here th:text is a Thymeleaf attribute. It will evaluate this expression and it will print the result. Alright, we will learn more about this th:text Thymeleaf attribute as well as variable expression in upcoming lectures. Now let's go ahead and let's run our Spring Boot application and let's see how this Thymeleaf hello world example works. So let me go to main entry point class of the Spring Boot project, and from here we can run our Spring Boot application. Alright, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to browser and let's access our Thymeleaf application. Well, if you go to hello world controller, here we have a URL, right? So let me copy this URL and go to browser, and in a new tab just paste it and just hit enter, and there we go. You can able to see hello world is printed in a web page. It means that we have successfully created Thymeleaf hello world example. Well, let me recap what we have done in this lecture. We have created a hello world controller. Within that, we have defined the handler method to handle hello world request, and within this handler method we have stored hello world string in the model, and next we have returned the hello world Thymeleaf template view. Next we have created hello world Thymeleaf template view, and we have displayed the hello world string by using this Thymeleaf variable expression. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this section of the lectures, we will take a look into Thymeleaf standard expressions. Well, there are 5 types of Thymeleaf standard expressions: variable expressions, selection expressions, message expressions, link expressions, and fragment expressions. Well, we will take a look into each of these Thymeleaf standard expressions with lots of examples. In this lecture, I am going to cover variable expressions with an example. Let's take a look into variable expressions. Well, variable expressions are the most commonly used ones in a Thymeleaf templates, and the variable expressions will help to bind the data from template context into resulting HTML view. Well, basically we use variable expressions in a Thymeleaf template to access the model data which is present in a template context. Well, we will see how we can bind the data from the model using variable expressions in an example section. And here you can see this is the syntax for variable expressions. Like dollar within a curly braces, we pass the variable name. Okay, now let's understand how to use variable expressions with an example. Consider we have added a data to the model in a Spring MUC controller, and in order to access this model data in a Thymeleaf template, we can use Thymeleaf variable expressions. Well, consider we have Spring MUC controller, that is message controller. It has a message handler method. It returns a model and view. And if you can notice here, the model has add attribute method, and it takes 2 parameters. First parameter is attribute name, second parameter is attribute value, and we basically store the data in a model by using add attribute method, and we pass a attribute name and attribute value. Alright, and this handler method returns a message Thymeleaf template view name. And if you can see here, this is basically a Thymeleaf HTML template, and in order to access the model data, we are using variable expression over here. And if you can notice the syntax for variable expression, that is dollar within a curly braces, we are passing the message, and this message is coming from message controller. If you can notice here, this add attribute method has 2 parameters, attribute name and attribute value. Attribute name is message, attribute value is a hello world. In order to access this attribute value, we have to use attribute name. That is what we are doing over here. We are using variable expression, and we are just passing this attribute name in order to access this attribute value. Okay, alright, so this is how we use a variable expression to access the model data from the Spring MUC controller. Well, let's take a look into one more example over here. Here we have student model class, and here we have a handler method. It returns the model and view, and the model contains a list of students. And here we have a Thymeleaf HTML template view, and if you can notice here, in a Thymeleaf HTML template view, we are using variable expression to access a student's variable, and this students is coming from this handler method. If you can notice here, this model has add attribute method, and add attribute method takes two parameters, students as attribute name and students as attribute value, and attribute value is basically a list of students, isn't it? And in order to access a list of students, we are using attribute name here. Alright, and after that, here you can see we are using student.firstname, student.lastname, student.email. So these are basically a model attribute. For example, student is a model class, it has first name, last name, email, and in order to access the model attribute also, we are using variable expression. Now let's go and let's see how to use variable expressions in an action. So let me go to IntelliJ IDEA and let me demonstrate how to use variable expressions in an action. So let me go ahead and let me first create one model class. So here I will create a new package and let's call it as model, and within a model package let me create one class and let me call it as user, and let me define the instance variables within this class. For example, private string name, and then private string user email, and then private string role user role, and then private string gender. Perfect. Now let's go and let's create a constructor for this class. Just right click, generate, and then constructor, and then choose all the fields and click on OK, and also create a getter setter methods. Right click, generate, and choose getter setter and choose all the fields over here and click on OK. Now we have created simple user model class. Next let's create a handler method. So go to controller package, right click, and then Java class, and let's give class name as user controller. Perfect. So let's go and let's annotate this user controller class with add controller annotation to make this class as a Spring MVC controller, and within this Spring MVC controller we can define the handler methods. So let me write the handler method to handle variable expression request. Perfect. So here just type public, and then return type of the method is string, and let's give method name as variable expression, something like that. And then let's annotate this method with add get mapping annotation to handle HTTP GET request with the URL. Let's give URL as a variable expression, something like that. Okay, we are going to demonstrate the usage of variable expression, hence we are creating a handler method with the URL variable hyphen expression. Okay, next let's pass a model as a parameter to this method, and make sure that you choose model from org.springframework.ui package. Next let's go ahead and let's add a data to the model. Well, we are going to add a user model object. For that, let's create a user object first. User equal to new user, and then let's pass the value to the constructor, name as a Ramesh, and then email as ramesh@gmail.com, and let's give role as admin, and then let's give gender as a male. Perfect. Now we have created user model object. Next let's add this object to the model. So let's call model dot, it has add attribute method, and then let's pass first parameter as user, second parameter as actual user object. Perfect. Next let's return the view. Let's give view name as variable expression. Next we will create a variable expression Thymeleaf template, and we will access this model data in a Thymeleaf template. So go to templates folder, and within a templates folder let's create a HTML file, and let's name it as variable hyphen expression. Perfect. Within this variable expression Thymeleaf template, we are going to access the model data using variable expression. So let's give title as variable expressions. Next let's give a Thymeleaf XML namespace. So here let's go to HTML element and let's define the XML namespace for Thymeleaf. Just type XML namespace :th and then http and then www.thymeleaf.com. Now we have defined XML namespace for Thymeleaf at the beginning of this HTML page. Next we can use the Thymeleaf syntax. Next go to body. Within a body, let's have a h1 element and let's give some text, something like variable expression demo. So this is going to be a page heading. Next let's use one more header element, that is h2 element, and here let me pass a text as a user details. So here basically we are going to print the user model object data. Next let's create div, and within a div let's have a paragraph element and let's print username first, and let's use strong HTML element to make username in a bold. Alright, and here within a strong HTML element let's use th:\text Thymeleaf attribute, and then let's use a variable expression, that is dollar within a curly braces user dot name. Well, here user dot name is basically coming from the user controller. Well, if you go to user controller, within user controller we have variable expression handler method. It has a model and we have added user as attribute name and actual user object as attribute value to the model, right? And in order to access the actual user model object, we have to use this attribute name, that is user. And in order to access the user model object attributes, that is name, email, role, gender, we have to use a syntax like this. Okay, dollar within a curly braces, then the attribute name, that is user, dot, and then field name, that is user. Similarly, let's print user email. So here let's have a paragraph element and then email, and then let's have a strong HTML element, and then within a strong HTML element let's have a Thymeleaf attribute, that is th:\text, and then let's have a variable expression dollar within curly braces, just pass user dot email. Okay, next let's print gender and role. For that let's have a paragraph element and let's say role, and then strong HTML element, and then let's use Thymeleaf attribute th:\text, and then let's use variable expression dollar within curly braces user dot role. Similarly, let's print gender as well, gender, and then strong HTML element, and then th:\text Thymeleaf attribute, and then dollar within curly braces user dot gender. Perfect. Now we have printed all the user details like name, email, role, and gender. Okay, now let's go and let's run the Spring Boot application and let's see how this works. So let me start the Spring Boot application. Well, our Spring Boot application is up and running. Let's go to browser, and here in a new tab just type localhost:8080/ the URL we have given in a handler method. So let me show you. Go to user controller. Here we have given this URL, right? So let me copy this URL and paste it over here and just hit enter. Well, we got a 500 internal server error. So let me quickly see what is the issue. So go to console, and here you can able to see error resolving template. It says template might not exist. So let me check. Well, if you can notice here, handler method returns the view name, that is variable -expression, but we have given the Thymeleaf template name as a viable -expression. So make sure that you have to give a same name. Okay, so here let me refactor and let me rename as a variable -expression. Okay, so whatever the view name the handler method returns, that view name should be same as the Thymeleaf template that we create under templates folder. Okay, now let me rerun Spring Boot application and let's see how it works now. So go to browser and just refresh, and there we go. You can able to see the user details successfully printed, like user name, user email, role, and gender. It means that we have successfully used a variable expression to print username, email, role, and gender. I hope you understood how to use a variable expressions in a Thymeleaf templates. In next lecture, we'll take a look into Thymeleaf selection expressions. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into Thymeleaf selection expressions. Well, selection expressions are just like variable expressions, except they will be executed on a previously selected object instead of the whole context variables map. For example, if you look at the code snippet over here, we have selected a object by using th:\object Thymeleaf attribute, And here we are using selection expression to access the selected object attributes. For example, here we are using syntax star within a curly braces. We are passing model object attribute, that is name, email, role, gender. Okay, selection expressions are just like variable expressions, except they will be executed on a previous selected object. So in this example, this user model object is a previously selected object using th:object Thymeleaf attribute. Alright, so whenever you want to use selection expressions, first you need to select the model object using th:object, and then you can access that model object attributes by using selection expression. Okay, and here is a syntax for selection expressions like star within a curly braces. We just need to pass a model object attributes. Okay, so let's go and let's see how to use selection expressions with an example. So let me go to IntelliJ IDEA, and let's first of all create a handler method. So go to user controller, and within user controller we will define the handler method. So here let me write the comment handler method to handle selection expressions. Okay, so let's write the method public, and then let's give return type of the method is string, and let's give a method name as selection expression. Perfect. Next, let's annotate this method with @getMapping annotation to handle HTTP GET request with the URL selection -expression. Perfect. So whenever we hit this link in the browser, then this handler method will get called, and this handler method will return the model and view. So here we can write the complete URL like http localhost :8080/ and then this selection -expression. Okay, whenever we hit this link in the browser, then this handler method will get called, and this handler method will return the model and view. Okay, now just pass a model to this method as a parameter. Next, we are going to store the user model object in a model. For that, let's create a user object over here. User equal to new user, and then pass name as a Ramesh and email as a ramesh@gmail.com, and then role as a admin, and then gender as a male. Perfect. Now we have created user model object. Next, let's add this user model object to the model. So let's have model, and then let's call its add attribute method, and then pass user as a first parameter and actual user model object as a second parameter, and then let's return the view, and let's give view name as selection -expression. So here I am using this naming convention in order to demonstrate the relevant topic. Now we have created handler method. This handler method returns a model and Thymeleaf template view. Next, let's create this Thymeleaf template view and then display this model data. So let me go to templates folder. Within that, let me create a HTML file, and let's give name as a selection -expression, and let's design the HTML page. So let's give title as selection expressions. Next, let's define the XML namespace for this HTML page. So go to HTML element, and here let's type XML namespace, and then :th equal to http, and then www.thymeleaf.org. So in order to use Thymeleaf syntax in this HTML file, we have to define XML namespace for Thymeleaf at the beginning of this HTML page. Next, go to body. Within the body, let's print the user model object using selection expressions. So here let me have a s2 element to just create a page heading. So let me give page heading as a selection expressions demo, and then let me have a s2 element, and let's give a heading as a user details. So we are going to print user details, hence this is the heading. Next, let's have a div. Alright, and in order to use a selection expressions, we have to first define the selected object, isn't it? And in order to define the selected object, we have to use th::object Thymeleaf attribute, and then we can use a variable expression in order to point to the model object. So in our case, model object is user, and this user basically comes from the user controller. Well, if you go to user controller, we have a selection expression handler method, and within this handler method we have model, and within this model we have a user as attribute name and actual user model object as attribute value. In order to access this user model object, we can use this attribute name, right? So that is what we are doing here. We are using variable expression to access user model object. Next, we can use a selection expression to print user model attributes. For example, user model class has name, email, role, gender, right? So let's use selection expressions to access this user model object attributes. So let's go back to selection expression.html file, and within this div let's have paragraph element, and then let's first print the username. For that, name colon, and let's use strong HTML element, and within that let's use th colon text Thymeleaf attribute. Next, let's use a selection expressions, that is star, within curly braces just pass a model object attribute, that is name. Okay, so if you can notice here, the syntax for selection expressions star within curly braces, we just need to pass model object attribute. For example, user is a model class, it has attributes name, email, role, gender. So these attributes we are passing to the selection expressions, isn't it? Next, let's print a user email, and then HTML strong element, and then th colon text, and then selection expression, that is star within a curly braces, and then email. Okay, so here the previously selected object is user model object, it has attribute email. Next, let me copy this and paste it over here, and let me change from email to role, and let's pass a role attribute to the selection expressions. Next, let me copy this and paste it over here, and here let me change from role to gender, and let's pass a model object attribute, that is gender. Perfect. Now we have used a selection expression to access selected model object attributes. Okay, now let's go and let's run the Spring Boot application, and let's see the demo of these selection expressions. So let me stop the server and let me start the Spring Boot application again, and our Spring Boot application is up and running. Let's go to browser, and here we need to pass the URL selection hyphen expressions and hit enter, and there we go, selection expressions demo, and we have printed a user details by using selection expressions. I hope you understood how to use selection expressions in a Thymeleaf templates. In next lecture, we'll see Thymeleaf message expressions. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into Thymeleaf message expressions. Well, message expressions let you externalize common text into properties file. Well, instead of repeating the same common text in all the Thymeleaf templates, what we can do is we can create one properties file, and we can define all the common text in that properties file, and then we can use message expression to access the common text from the properties file. And here is the syntax for message expressions. Hash within a curly braces, we need to pass the message property key. For example, let's say you have a welcome message that you want to show on every view. However, hard coding this message on all these views is a bad idea. Alright, so overcome to this problem, Thymeleaf provides message expressions to externalize these common text in a properties file, and we can use message expressions to access the common text from the properties file. For example, we can create a message.properties file, and we can keep these properties like app.name and then value, welcome.message and then value. Okay, so we can keep a key value pair in a properties file, and we can use a key to access the value by using message expressions. And if you can notice here the example, hash within curly braces, we pass the key is a app.name, and this key is coming from properties file. Okay, now let me demonstrate the usage of message expressions step by step. So let's go to IntelliJ IDEA, and let's first create a one properties file. So go to resources folder, within that let's create a file, and let's give name as messages.properties. Perfect. And within this properties file, let's define key value pair. For example, let's give key name as app.name, and let's give value something like Spring Boot Thymeleaf application. This is the app name, and then let's give a welcome message. So let's type key value here. Welcome dot message is the key, and let's give value as hello, welcome to Spring Boot application, something like that. Next, let's create a handler method that returns the Thymeleaf template view. So go to user controller, and within a user controller, let's quickly create a handler method. So let me write the comment handler method to handle message expressions request, something like that. Alright, and let's type the method public, and the return type of the method is string, and let's give a method name as message expression, and then let's annotate this method with @get mapping annotation to handle HTTP GET request with the URL message hyphen expression. Okay, so whenever user hit this link in the browser, for example this link, then this handler method will get called, and then this handler method will return the message expression Thymeleaf template view. So here just return a Thymeleaf template view name, that is message hyphen expression. Next, let's go and let's create a message expression Thymeleaf template, and then let's see how to use message expressions. So let's go to templates folder, and then let's create a HTML file, and let's give name as message hyphen expression. Perfect. Let's give title as message expressions. Next, let's define the XML namespace for this HTML page. So go to HTML element, and here just type XML namespace :th equal to http and then www.thymeleaf.org. Okay, perfect. Next, go to body. Within a body, we are going to use a message expression to access the property key. So here just type h1 element, and here let me give a page heading something like message expressions demo. Next, let's use h2 element over here, and within h2 element just type th:" text Thymeleaf attribute, and then let's use message expression syntax. The syntax is hash within a curly braces we need to pass property key. For example, if you go to messages.properties file, here we have a property key that is app.name. So let me copy this key and go to message expression.html file and paste it over here. Alright, similarly let's print a welcome message as well. So here let's have h2 element, and then th:" text Thymeleaf attribute, and then message expression syntax hash within a curly braces, and just go to message.properties file and just copy this key and go back to message expression page and paste it over here. And notice here the syntax of message expression hash within a curly braces we need to pass a property key here. Okay, and this th:" text Thymeleaf attribute, so this attribute will basically evaluate this expression and it will print the result. Okay, now let's go and let's run the Spring Boot application, and let's see the demo of this message expressions. So let me start the Spring Boot application. Alright, and go to user controller and just grab this URL and go to browser and just paste this URL and hit enter, and there we go. You can able to see the app name as well as a welcome message successfully printed over here. If you go to our Spring Boot application and go to message.properties file, we have given app name as Spring Boot Thymeleaf application, and if you go to browser and if you can able to see the app name is successfully printed, and go back to our application and go to properties file, and if you can notice the welcome message, hello, welcome to Spring Boot application, and go to browser, here you can see hello, welcome to Spring Boot application. It means that we have successfully used a message expression to access the properties key value. Okay, if you go back to message expression file, you can see we have used the message expression to access app name as well as welcome message. I hope you understood how to use the message expressions in a Thymeleaf templates. In next lecture, we'll see how to use link expressions. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into Thymeleaf link expressions. Well, link expressions are meant to build URLs in a Thymeleaf templates. And notice here, this is the syntax for link expressions. At the rate, within a curly braces, we need to pass the link. And notice here, this is an example for link expressions. If you can notice here, we are using at the rate within a curly braces and we are passing the link. Well, in order to build the URLs in a Thymeleaf templates, we use a link expressions. And you can see a couple of examples like we can use a link expression to pass the parameter in a URL. For example, here /message/id, and we can pass the id dynamically to this URL. And you can notice here we are using link expression to point to the external CSS library. Okay, at the rate within a curly braces and then CSS folder within that demo.css file. Okay, now let's go and let's see how to use a link expressions in an action. So let me go to IntelliJ IDEA and let's first of all define the handler method. So go to user controller and here let's define the handler method. So let me write the comment handler method to handle link expressions. Perfect. And let's create a method public and the return type of the method is string, and let's give a method name as link expression. Alright, and let's go ahead and let's annotate this method with add get mapping annotation to handle HTTP GET request, and let's give URL as a link hyphen expression. Okay, and let's return the Thymeleaf template view, that is link hyphen expression. Okay, perfect. Well, whenever user hit this link in the browser, for example, let me copy this link and paste it over here and let me change accordingly. So instead of message, just pass link. Okay, so whenever user hit this link in the browser, then this handler method will get called, and this handler method returns link hyphen expression Thymeleaf template view name. Next, let's create this Thymeleaf template and then we'll see how to use a link expressions. So go to templates folder. Within that, let's create a HTML file. Let's give name as link expression, and then let's give a title something like link expressions. Perfect. Next, let's define the XML namespace for Thymeleaf. So go to HTML element, here just type XML namespace :th and then http www.thymeleaf.org. Next, to go to body. Within the body, let's have h2 element to define the page heading. Let's give page heading something like link expressions demo. Perfect. Next, let's use anchor tag, and then let's use a Thymeleaf attribute, that is th:/href, and then let's use a link expression syntax here at the rate. Well, within a curly braces we need to pass the link, isn't it? So if you go to user controller, we have a handler methods with different links like variable expression, selection expression, message expression, right? So let's go and let's pass these links. So let me copy this variable expression and go back to link expression and here just paste it slash and then variable expression, and let's give name as a variable expression. Okay, so this is how we can use a link expression to define a link for this anchor tag. Alright, and this th:/href Thymeleaf attribute will evaluate this link expression. Alright, so similarly what we'll do, we'll define one more link using link expression. So let's type anchor tag over here and then let's use th:/href, and then let's use a link expression syntax at the rate within a curly braces, just pass the URL something like selection hyphen expression. Perfect. And let's give a name to the link something like selection expression. Perfect. Now let me run the Spring Boot application and let's see how this works. Let's go to browser and let's type localhost 8080/link hyphen expression and hit enter, and here you can see variable link, okay, and selection link. Well, if you click on this variable expression link, it will call variable expression handler method, and if you click on selection expression, it will call selection expression handler method. It means that we have successfully defined the links using link expression. Now let's see how to pass a parameter to the link using link expressions. So in order to define the parameter, we need to pass a parameter to the model. So go to user controller and go to link expression handler method over here, and here let's pass the model to this method, and let's pass some data to the model dot, let's use add attribute, and then let's pass id and let's use value as a 1. Next, let's see how to pass this id as a parameter to the link using link expressions. So let's go back to link expression.html file, and here let me have a paragraph element, and then within that let me have a anchor tag, and within that let's have a Thymeleaf attribute th:/href. Alright, and let's use a link expression syntax @ within a curly braces, just pass the link. So link is link hyphen expression, and then we pass a parameter as id to this link. So let me copy this link hyphen expression, and let's go to link expression.html file, paste it over here, and in order to pass the parameter in this link, we use curly braces. Within a curly braces we pass the parameter name, that is id, and we need to pass the value to this id dynamically, isn't it? For that, here is a syntax: open and close braces, id equal to, well, we have stored the id value in a model. For example, if you go to user controller, we have stored id value in a model by using this attribute name. So let's go and let's use a variable expression to access a model data. So let's go to link expression, and here let's use a variable expression, that is dollar, within a curly braces, just pass id. Next, let's give name to the link. Let's say link with parameter. Alright, perfect. Now let's rerun our Spring Boot application and let's see how this works. Well, our Spring Boot application is up and running. Let's go to browser and let's refresh, and you can see here we have a link with parameter link. So go ahead and click on this link, and notice here the id is successfully passed in the URL. Okay, it means that we have successfully defined the URL that has a parameter by using link expressions. Okay, so let's say if we have a requirement to create a link in a Thymeleaf template and you need to pass a parameter to that link, then you can go ahead and use this link expression syntax. Okay, next let's see how to use a link expression to point to the external CSS file. So let's say you have a CSS file inside this static folder. So let me create one more folder within this static folder. So let's say CSS. Within this CSS folder, let me create one file. Let's say demo.css. Let's write some code. So let me provide some styling for this anchor tag. So let's say font size. Let's give font size as a 25 pixel. Now let's go and let's see how to use a link expressions to point to the external CSS file. So here go to title. After that, let's have a link element, and then let's have a link expression. So let me close this link, and then here th:/href Thymeleaf attribute, and then link expression syntax @ within a curly braces slash, and then css, and then demo.css. So this is how we use a link expression to point to the external CSS library. Okay, and notice here slash is meant for here a root. Okay, so this will point to the context of our Spring Boot application. So don't forget this, slash. This slash means here root, and then followed by the folder name is css, and then within that folder we have demo.css file. Okay, perfect. Next, well, this is a style sheet. For that, let's have a style sheet value here. Perfect. Now we have used link expression to point to the external CSS file. Okay, now let's run the Spring Boot application and let's see how this works. Well, go to browser and let's refresh this link, that is localhost 800/link expression, and just right click on this page, inspect, and go to network, and in a network section you can able to see demo.css. So just right click on this file and click on open in a new tab, and there we go, you can able to see font size 25 pixel. It means that we have successfully used link expressions to point to the external CSS file in our Thymeleaf template. And if you can notice here, the font size of these links, it becomes a 25 pixel because we have defined a font size 25 pixel for the anchor tag element, isn't it? It means that we have successfully used a link expression to define a different URLs over here. I hope you understood how to use a link expressions in a Thymeleaf templates. In next lecture, we'll see how to use fragment expressions. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into fragment expressions. Well, fragment expressions are an easy way to represent fragments of a markup and move them around templates. Well, consider the example over here. In typical web applications, we create a common piece of code, like we create a header, footer, and we'll include them in all the HTML pages, isn't it? So instead of adding the same code in all the HTML files, what we can do is we can make this common code as a fragment, and then we can use fragment expressions to include this fragment in a respective HTML pages. Well, here is the syntax for fragment expression. This is a tiddly symbol. Within a curly braces, we pass the fragment selector name. And here you can see there are three basic ways to include content from the fragment. Well, here are the three Thymeleaf attributes: th::insert, th::replace, th::include. Well, th::insert will insert the content inside the current tag, and the th::replace will replace the current tag with the tag defining the fragment. And this th::include Thymeleaf attribute is deprecated, so we can focus on these two Thymeleaf attributes. Okay, so most of the time developers uses th::replace Thymeleaf attributes to replace the current tag with the tag defining the fragment. Okay, we'll see an example how we can use th::replace and th::insert attributes to insert the fragment in a Thymeleaf templates. Okay, so we'll take this example, like we'll create a header and footer as a fragment, and we'll include these fragments using fragment expressions. So let's go to IntelliJ IDEA and let's create the example step by step. So let's go to templates folder and let's create the fragments first. So within templates folder, let me create one folder. Let's call it as common, and within a common folder, let's define header and footer Thymeleaf template. So let me create HTML file and let me give name as header. Okay, and let's write the code for this header.html file. Well, here let me give title as a header, and next let's define the XML namespace for Thymeleaf at the beginning of this HTML page. So here just type XML namespace th equal to http and then www.thymeleaf.org. Now we have defined the XML namespace for Thymeleaf. Next, go to body. Within the body, we'll write a piece of code and then we'll make it as a fragment. So let's create a div. Alright, and let's create a h2 element over here, and then let's give heading as a header part, something like that. And after this, let's draw a horizontal line using tr HTML element over here, and let's make this div as a fragment. So in order to make this piece of code as a fragment, we can use th::fragment Thymeleaf attribute. So here we're going to use th::fragment Thymeleaf attribute to define this piece of code as a fragment, and let's give fragment selector name as a header. Perfect. Now we have defined this piece of code as a fragment, and this fragment we can include in any HTML file in our application. Okay, now similarly let's define a fragment for footer. So go to common folder, right click on it, new, and then HTML file, and then let's use file name as footer, and let's use title as a footer, and let's define the XML namespace for Thymeleaf. XML namespace :th equal to http and then www.thymeleaf.org. Next, go to body. Within our body, let's write a piece of code and let's make it as a fragment. So here let me create a div. Alright, and within a div, let me create a h1 element, and let's add some heading like footer part, something like that. Well, before this h1 heading, let's add a horizontal line by using hr element. Next, let's make this piece of code as a fragment by using th::fragment Thymeleaf attribute. So go to div, here just type th::fragment, and let's use fragment selector name as a footer. Now we can include this fragment in a Thymeleaf HTML pages. Okay, now we have defined header and footer fragments. Next, let's create a handler method that will return the Thymeleaf HTML page view. So go to user controller, and here let me write the comment handler method to handle fragment expression request. Okay, so let's write the method public, and let's use return type of the method is string, and let's use method name as fragment expression, and let's annotate this method with add get mapping annotation to handle http get request with the URL fragment hyphen expression. Okay, perfect. Next, this handler method will return the Thymeleaf template view name, that is fragment hyphen expression. Perfect. Now we have created handler method. It returns a fragment selection Thymeleaf template view. Next, let's create this Thymeleaf template and let's use a fragment expressions. So go to templates folder. Within templates folder, let's create a HTML file and let's use name as a fragment expression. Alright, and let's use title as fragment expressions. Perfect. And go to body. Before that, let's define the XML namespace. Just type XML namespace :th equal to http and then www.thymeleaf.org. Next, go to body. Within the body, let's have a h1 element to define the heading. So let's give heading as fragment expressions demo. Perfect. Next, let's create a div. Well, in order to insert a fragment, we have a couple of Thymeleaf attributes. For example, if you can see here, we have th:\insert Thymeleaf attribute as well as th:\replace Thymeleaf attribute. So this th:\insert Thymeleaf attribute will insert the content inside the current tag, and this th:\replace attribute will replace the current tag with the tag defining the fragment. So let's first see how to use th:\replace Thymeleaf attribute, and then later we will see how to use th:\insert Thymeleaf attribute. Alright, and this th:\replace attribute will replace the current div tag with the tag defining the fragment. For example, if you go back to IntelliJ IDEA and go to this file, and here we are defining the div, okay, and th:\replace Thymeleaf attribute will replace this div and it will put the fragment content. Okay, so here within a div, let's use th:\replace Thymeleaf attribute, and then we can use a fragment expressions. So here is a syntax. This is a tiddly symbol, and then within a curly braces we need to pass the fragment selector name. So if you can notice here, we have a common folder. Within that we have header.html as well as footer.html. okay, so here is a syntax, tiddly symbol within a curly braces. We need to pass the folder name, that is common. Within a common folder we have header.html, so slash header, after that ; expression, and then we need to provide a fragment selector name. Well, we have given a fragment selector name as a header, right? For example, if you go to header.html file, here we have given header as a fragment selector name for this div, isn't it? So let me copy this fragment selector name and let's go back to fragment expression, and here let's paste it. Okay, so this is the syntax to use a fragment expression to insert a fragment. Well, here we are using th:\replace Thymeleaf attribute. This attribute will replace this div with a fragment content. For example, if you go to header.html file, we have this div, right? So th:\replace Thymeleaf attribute will replace the current div with this fragment div. Okay, it won't keep this div inside this div. Okay, so th:\replace will simply replace this div with this fragment div. Okay, but th:\insert Thymeleaf attribute, what it does, it will insert this fragment div inside this div. Okay, so I hope you understood the difference between th:\replace and th:\insert. So th:\replace will replace the current div with the fragment div, and th:\insert Thymeleaf attribute will insert the fragment div inside this div. It won't replace the current div. Okay, so most of the time we use th:\replace Thymeleaf attribute with fragment expressions. Okay, next, similarly, let's insert a footer fragment using fragment expressions. So after this div, let's have some content. For that, let's have a div, and then let's have a h1 element, and let's put some heading over here. Let's say page body. Perfect. And after this div, let's have one more div, and let's use th colon replace Thymeleaf attribute. Next, let's use fragment expression to insert a fragment. So here is a syntax: title symbol within a curly braces. We need to pass the fragment. So we have a common folder. Within that, we have a footer, footer Thymeleaf template. If you can notice here, we have a common folder. Within that, footer Thymeleaf template that we are giving here. And then after that, we have a double colon expression, and then fragment selector name, that is footer. Well, if you go to footer.html file, we have given fragment selector name as a footer, right? So this name we are providing over here. Okay, now we have used th colon replace Thymeleaf attribute to insert a footer fragment using fragment expression over here. Now let's go ahead and let's run our Spring Boot application, and let's see the demo of fragment expressions. So let me start the Spring Boot application again. Well, our Spring Boot application is up and running. Let's go to browser, and in a browser just type localhost colon 8080 / fragment hyphen expression and hit enter, and there we go, fragment expressions demo. After that, we have header part, and then page body and footer part, and this header part is basically a header fragment, and after that this is a actual page body, and after that we have footer fragment. It means that we have successfully used fragment expressions to insert a fragments in this Thymeleaf template. Alright, this is how we can use a fragment expressions to insert a fragments in a Thymeleaf templates. Alright, I hope you understood how to use fragment expressions to insert a fragments in a Thymeleaf templates. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into th colon text Thymeleaf attribute. Well, this attribute is responsible for displaying text that is evaluated from the expression inside it. For example, if you can see this code snippet over here, we are using th colon text Thymeleaf attribute, and then here we are using variable expression, that is dollar within a curly braces. We are passing message attribute name. Alright, so basically th colon text Thymeleaf attribute, it will evaluate this variable expression and it will print the result as a text. Alright, and if you can notice here, this hello good morning text, so this is basically dummy data. Well, whenever th colon text Thymeleaf attribute fail to evaluate this expression, then it will print this hello good morning dummy data. Alright, th colon text attribute which evaluates its value expression and sets the result as a body of the host tag, effectively replacing hello good morning text we can see in the code. Th colon text Thymeleaf attribute, it will evaluate this expression and it will set the result of this expression in a body of this host tag, and here host tag is nothing but the paragraph element. Alright, and if there are any issue or if there is anything went wrong while evaluating this expression, then this th colon text Thymeleaf attribute will print this dummy data, that is hello good morning. Now let's go ahead and let's see a couple of examples for this th colon text Thymeleaf attribute. Well, let me go to IntelliJ IDEA and let's go to variable expression.html file, and within this file here, if you can notice here, we are using th colon text Thymeleaf attribute, and then here we are using variable expression. Well, th colon text Thymeleaf attribute will evaluate this variable expression and it will set the result of this expression as a body for this strong tag. Alright, so this is how we can use th colon text attribute to evaluate the variable expression. Next, if you go to selection expression.html file, here we are using th colon text attribute with selection expression. It means th colon text attribute will evaluate this selection expression and it will set the result of this expression as a body to this strong HTML tag. Next, let's go to message expression.html file, and here if you can notice here, we are using th colon text Thymeleaf attribute to evaluate message expression. Okay, so this th colon text attribute will evaluate this message expression and it will set the result of this expression as a body to this h2 element tag. Alright, so these are the couple of examples for th colon text Thymeleaf attribute. Well, basically we use th colon text Thymeleaf attribute to evaluate Thymeleaf expression and it will set the result of that expression as a body of the host tag. Okay, I hope you understood how we can use a th colon text Thymeleaf attribute in a Thymeleaf templates. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into th:(each Thymeleaf attribute. Well, in Thymeleaf, iteration or looping is achieved by using th:(each Thymeleaf attribute. Well, in Java, we use a for loop or for each loop to iterate over a list of elements. Well, in Java, we use for loop or for each loop to iterate over a list of elements, right? So similar to that, Thymeleaf provides th:(each Thymeleaf attribute to iterate or loop over a list of elements. Alright, one interesting thing about this attribute is that it will accept and iterate over a different data types such as list, set, map, array. It means that we can use th:(each Thymeleaf attribute to iterate over different data types such as list of elements, set of elements, map of elements, and array of elements. Alright, and consider the example over here. We have a list of users, and this list of users basically comes from Spring MUC controller, and here we are using th:(each Thymeleaf attribute to iterate over a list of users. And if you can notice here, this user is basically a local variable, and the scope of this user local variable is up to this tr element. We cannot access this user local variable outside this tr element. Alright, and here if you can notice here, we are using variable expression to access user model attribute such as name, email, role, and gender. Alright, so just remember, in Thymeleaf, the iteration or looping is achieved by using th:(each Thymeleaf attribute, and in this example, we are iterating over a list of users using th:(each Thymeleaf attribute. Now let's take a look into th:(each Thymeleaf attribute status variable. Well, Thymeleaf also enables a useful mechanism to keep track of the iteration process via status variable. Well, status variable is pretty useful because we can keep track of each iteration process. For example, consider the code snippet over here. Here we are iterating over a list of users using th:(each Thymeleaf attribute, and here is a syntax to define a status variable for th:(each Thymeleaf attribute. We just need to provide a comma followed by status variable name. Alright, and status variable has multiple properties. For example, count is one of the property. We can use count property to count the iteration process. Alright, so just remember, we can use a status variable of this th:(each attribute to keep track of each iteration process. Well, this status variable provides a lot of properties. For example, if you can notice here, the status variable provides the following properties: index, count, size, even or odd, post, and last. Index property we can use to get the current iteration index starting with 0, and we can use count property to count the number of elements processed so far. We can use size property to get the total number of elements in the list, and we can use even or odd property to check if the current iteration index is even or odd. Next, we can use post property to check if the current iteration is post 1. Next, we use last property to check if the current iteration is last 1. And these are the status variables provided properties. I am going to demonstrate the usage of all these status variable properties with an example. Okay, now let's head over to the IntelliJ IDEA and let me demonstrate the usage of th:(each Thymeleaf attribute and status variable properties. So let me go to IntelliJ IDEA. Well, let's go ahead and let's first create a handler method that will return the Thymeleaf template. So go to user controller. Within a user controller, we are going to write the handler method. So here let's type public, and then let's give return type of the method as a string, and let's give method name as users, and let's annotate this method with add get mapping annotation to handle HTTP GET request with the URL users. Perfect. Next, let's pass model as a parameter to this method. Alright, within this method, we will create a list of users and we will add them to the model, because in Thymeleaf template we need to iterate over a list of users. Hence, let's create a list of users over here. So let me create a user object first. Let's say admin equal to new user, and let's give name as a admin and email ID as a admin @gmail.com, and let's give a role as admin, and then gender as a male. Perfect. So let me maximize it. Now we have created one user. Similarly, let's create another user Ramesh equal to new user, and let's give name as a Ramesh and email as ramesh@gmail.com. and next let's give role as user, and then gender let's give a male. Perfect. Now we have created second user. Let's create one more user. Let's say Meena equal to new user, and let's give name as Meena, and then email ID as meena@gmail.com. and next let's give role as a user, and then gender female. Perfect. Now we have created 3 users. Next let's add them to the list. So here let me create a list of type user, and this is a users equal to new array list. Perfect. And let's use users dot add method to add a element. So let's add admin, and then users dot add Ramesh, and then users dot add Meena. Perfect. Now we have added 3 users to the list. Next let's add this list to the model. So let's have model dot add attribute method. Let's pass attribute name as users and attribute value as a list of users object. Perfect. Now we have added data to the model. Next we need to return the view. For that, here let me give a view name as users. Perfect. Next let's create a users Thymeleaf template, and then we'll display this model data in a users Thymeleaf template. So let's go to templates folder, and within a templates folder let's create a HTML file, and let's name it as users. Alright, let's give title something like iteration in Thymeleaf. Perfect. Next let's define the XML namespace for Thymeleaf at the beginning of this HTML page. So go to HTML element, and here let's type XML namespace :th equal to http and then Thymeleaf www.thymeleaf.org. Perfect. Now we have defined the XML namespace for Thymeleaf. Next go to body. Within a body let's have a table, and then within a table let's create a table heading, and then let's have a table row, and let's define table columns over here. Let's give table column as a name. Next second table column as a email, and next third table column name as role, and then fourth table column name as gender. Now we have added columns to the table. Next let's design the table body. So here let's type table body, and within table body let's have a table row, and within a table row element let's use each Thymeleaf attribute to iterate over a list of users. And here is the syntax for each Thymeleaf attribute equal to, and let's have a local variable name. Let's give user and then colon, and let's use a variable expression in order to access the model object. So here dollar within a curly braces just pass users attribute name. Well, this users attribute name is coming from the Spring MVC controller. If you go to user controller over here we have written users handler method. Within that we have used a model.add attribute to add a model data. So we have used attribute name as users and attribute value as a list of users, and in order to access this list of users we have to use this attribute name, that is users. So these users we are using over here. Okay, perfect. Now we have used each Thymeleaf attribute to iterate over a list of users. Next let's print each user. So within tr element let's use td element, and next let's use text Thymeleaf attribute to evaluate the expression and print the result. So here let's use a variable expression dollar within a curly braces user dot, it has an attribute that is name. Well, if you go to user model class, it has attributes name, email, role, gender. So we are accessing these user model attributes using variable expression over here. Okay, similarly let's print user model object email, role and gender. So here let's have a td element, and then let's use text Thymeleaf attribute, and then dollar within a curly braces user dot email. Next, let's print a role. For that, let's have a td element over here, and then th colon text Thymeleaf attribute, and then dollar within a curly braces user dot role. Next, let's print a gender. For that, let's have a td element, and then th colon text, and then dollar within a curly braces user dot gender. Perfect. Now we have printed user name, email, role, and gender. Okay, now let's go and let's run the Spring Boot application, and let's see how this th colon each Thymeleaf attribute works. So here our Spring Boot application is up and running. Next, let's go to browser. In a new tab, just type localhost :8080/users and hit enter, and there we go. We got a list of users in a table, but the table don't have border, that's why it is looking like this. So let me add a border to the table. So go to table element here and just have a border equal to 1, and let me rerun the Spring Boot application. Alright, and let's go to browser and let's refresh our application, and there we go. You can able to see now the table looks good, isn't it? It means that we have successfully used th colon each Thymeleaf attribute to iterate over a list of users, and this is how we use th colon each attribute. Okay, so the syntax is user, so local variable colon, and then list of users. Alright, so in Java we basically use for each loop to iterate over a list of elements. So similar to that, Thymeleaf provides th colon each attribute to iterate over a list of elements, and the syntax looks same, isn't it? Well, in next lecture I am going to demonstrate the usage of status variable of this th colon each Thymeleaf attribute. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture I have demonstrated th colon each Thymeleaf attribute. In this lecture we will take a look into th colon each attribute status variable. Well, Thymeleaf also enables a useful mechanism to keep track of the iteration process via status variable. For example, we need to specify status variable like this. Alright, so just we need to put a comma, after that a status variable name, and status variable provides a different properties like count property to get a current count of the iteration process. If you can notice here, status variable provides a couple of properties like index, count, size, even or odd, post, and last. So let me go ahead and let me demonstrate the usage of all these status variable properties. So let me go to IntelliJ IDEA, and let me go to users.html file over here, and here let me define the status variable. Well, in order to use status variable, here is the syntax. After this user local variable, just put the comma and then give the status variable name. For example, user stat. You can give any name that you want, but here I am giving user stat. Next, let's go and let's use this status variable properties. Well, here for example, let's say I want to add one more column to print the serial number. For example, let's say th and then serial number. So in order to get the serial number, we can use status variable count property. For example, here add one more td element, and then let's use th colon text Thymeleaf attribute, and then let's use a variable expression, and within a variable expression just pass the status variable and just call its property, that is count property. So this will display a current count of the iteration process. Now let's go ahead and let's run the Spring Boot application, and let's see how this status variable count property works. So let me start the Spring Boot application. Well, our Spring Boot application is up and running. Let's go to browser. In a browser, just type localhost :8080/users and hit enter, and there we go. You can able to see the serial number column. It has 1, 2, 3. Okay, whenever you want to print the serial number in a table, you can go ahead and use this status variable count property. Okay, so next let me demonstrate the usage of other status variable properties. For example, let me demonstrate index, size, even or odd, first and last. So let me add a appropriate column over here. So let me add one more column, and let me call it as index, and let's print a data for this column. So here let's add a td element, and then th colon text, and let's use variable expression, and then status variable user stat, and then index property. Okay, next let me add one more column, and let's call it as even. Perfect, and let me print the data for this column. So let me copy this and paste it over here, and let's change the property from index to even. and let me add one more column, and let's call it as odd. Perfect. And let me print the data for this column. So let me copy this td element and paste it over here, and let me change the property from even to odd. Next, let me add one more column, and let's call it as first. Next, let me print the data for this first column. So here let me copy this td element and paste it over here, and let me change the status variable property from odd to first. Next, let's add one more column, and let's call it as last. And here let me copy this td element and let me print the data for this last column. Perfect. Now we have used all the properties of status variable like count, index, even or odd, post and last. Now let's go and let's run the Spring Boot application, and let's see the usage of these status variable properties. So let me stop the existing server and let me start the Spring Boot application. And next, let's go to browser and just refresh here, and there we go. Serial number 1, 2, 3, index. Well, index property returns the current iteration index starting with 0, hence 0, 1, 2, 3. And this 1 is not a even, hence false. 2 is a even, hence it is true. 3 is not even, hence it is false. Next, 1 is odd, hence it is true. 2 is not odd, hence it is false. And 3 is odd, hence it is true. And 1 is true, hence the first is true. And next, 2 is not a first, hence it is false. And 3 is not a first, hence it is false. And last, 3 is a last, hence it is true. And name, email, role, gender. It means that all the properties of status variables are working as expected. I hope you understood how to use th:\each Thymeleaf attribute to iterate over a list of elements in Thymeleaf templates, and also I hope you understood how to use th:\each Thymeleaf attribute status variable properties as well. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into Thymeleaf if and unless attributes. Well, probably in Java you have used if-else statements, right? So similar to that, Thymeleaf provides if and unless attributes to perform if-else conditions. Alright. Well, if and unless attributes allows us to render an HTML element depending on provided condition. And if you look at the syntax over here, th:\if attribute, and then we add a condition. If this condition is true, then it will print a true, unless it will print false. Okay. And here th:\unless is basically a negativeness of th:\if attribute. It means th:\unless attribute is opposite to th:\if attribute. Well, let's understand more about if and unless attributes with an example. Well, if you can look at the code snippet over here we are using th:\each Thymeleaf attribute to iterate over a list of users, and here we are using if and unless attributes to display the links based on the condition. Okay, so here you can see th:\if user.role equal to admin. It means if user role is admin, then we will print update link, and if user role is admin, then we will print delete link, unless we will print view link. It means that if the user is admin, then we will print update and delete links. If the user is not admin, then we will print view link. Okay, so this th:\unless attribute is a negativeness of if Thymeleaf attribute. So let's go and let's see this if and unless Thymeleaf attribute example in an action. So let me go to IntelliJ IDEA and let me demonstrate the usage of if and unless Thymeleaf attribute, so that you will be able to understand how you can use if and unless Thymeleaf attributes in a Thymeleaf templates. So first of all, go to user controller and let's write the handler method. So go to at the bottom, and here let me quickly write the handler method. So let's type public, and let's give return type of the method is string, and let's give method name as if unless. Alright, and let's go and let's annotate this method with @get mapping annotation to handle HTTP GET request, and let's pass the URL if-unless. Well, in order to demonstrate if unless concepts, I am going to give a URL and method name like this. Alright, next let's pass a model as a parameter to this method. Next, within this handler method, we need to create a list of users, and if you can notice this users handler method, it has already a list of users. Okay, so let me go ahead and let me copy this piece of code and let me paste within this handler method, and here let's return a view name, for example if-unless, unless. Perfect. Now we have created a handler method to handle HTTP GET request with the URL if unless, and within this handler method we have created a list of users and we have added to the model, and this handler method returns if unless Thymeleaf template view name. Next, let's go and let's create if unless Thymeleaf template and let's display the model data, and then we will use if and unless Thymeleaf attributes. So let's go to templates folder. Within that, let's create a HTML file and let's give name as if unless and hit enter, and let's give title as if unless attributes, and let's go ahead and let's define the XML namespace for Thymeleaf. So go to this HTML element and here just type XML namespace :th, and then let's have a HTTP and then www.thymeleaf.org. Perfect. Next, go to body. Within the body, let's design the HTML table. For that, let's have a table element over here and let's give border for this table, let's say 1, and within this table let's have a table header, and within table header let's have a table row element, and within table row element let's have a table columns. So let's give table column as name, and let's give one more table column as email, and let's give one more table column name as role. Perfect. Next, let's give one more table column name as actions. Perfect. Now we have defined a columns for the table. Next, let's design the table body. So here let's have table body element, and within table body element let's have table row element, and then let's go and let's use th colon each Thymeleaf attribute to iterate over a list of users. So here is the syntax: th colon each attribute, and then within a double quote user local variable, and then colon, and let's use variable expression and then pass users. Well, this users is coming from user controller. For example, if you go to user controller, here we have handler method if unless. Within that we have model.add attribute method, and we have passed attribute name and attribute value, and attribute value is a list of users. In order to get this list of users, we have to use this attribute name, that is users, and this users we are using in a here in a th colon each Thymeleaf attribute. Okay, now let's go and let's print each user. So within a table row let's have a table data element, and then let's use th colon text Thymeleaf attribute, and then let's use variable expression and then user dot name. Next, let's print user email as well. For that, let's use td element and then th colon text Thymeleaf attribute, and then dollar within a curly braces user dot email. Perfect. Next, td and then th colon text Thymeleaf attribute, and then let's use a variable expression user dot role. Okay. Next, we need to display the actions. For that, let's have td element, and within this td element we need to display the links, action links based on the if and unless Thymeleaf attributes. So here let me have an anchor tag, and then let me add a link first, th colon href, and let's use a link expression @ within a curly braces. So let me add a link something like update, and here let's use a if condition by using th colon if Thymeleaf attribute, th colon if Thymeleaf attribute, and then let's use a variable expression dollar within a curly braces user dot role. Let's say if this user dot role is equal to admin, then print update link. Perfect. Similarly, let me copy this link and paste it over here, and let me change the link from update to delete, and here if the user role is admin, then we'll display delete link. Next, let's print the view link. So let me copy this anchor tag and paste it over here, and let me change the URL from delete to view, and here instead of th colon if we're gonna use th colon unless. Well, th colon unless is basically negativeness of if Thymeleaf attribute. It means Unless is basically opposite to if condition. It means if the user role is not admin, then we'll display view link over here. Okay, great. Now we have used if and unless Thymeleaf attributes in a Thymeleaf template. Next, let's go and let's run our Spring Boot application and let's see how this if and unless Thymeleaf attribute works. So let me start the Spring Boot application. And if you go to user controller, we have used if unless link to access this handler method. So let me copy this link and go to browser, and in a new tab just type localhost :8080 / if hyphen unless, hit enter, and there we go. You can able to see here admin user has a role admin, that's why admin can able to see update and delete link. Ramesh user not admin, that's why Ramesh user can able to see only view link. Meena is not admin user, that's why Meena can able to see only view link. And if you can compare with the code, go to if unless HTML page. If the user role is admin, then display update and delete links, and if the user role is not admin, then display view link. Okay, so this th:(unless) attribute is a negativeness or opposite of this th:(if Thymeleaf attribute. That's why you can able to see the result. Admin has a role admin, that's why admin can able to see update delete link. Ramesh and Meena, so these are the users not admin, that's why they can able to see view link in the actions column. Well, if and unless attributes allows us to render an HTML element depending on a provided condition, and in our example we have used if and unless Thymeleaf attribute to display the respective HTML elements. If the user role is admin, then we'll display these two links. If the user role is not admin, then we'll display this view link. Okay, I hope you understood the usage of if and unless Thymeleaf attributes in a Thymeleaf templates. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into switch case statement in Thymeleaf templates. Well, probably in Java you have used switch case statements, isn't it? Similar to that, Thymeleaf provides th:(switch and th:(case) attributes to perform switch case condition in Thymeleaf templates. In this lecture, I am going to demonstrate the usage of th:(switch and th:(case) Thymeleaf attributes to perform switch case condition in Thymeleaf templates. Well, if there are more than two possible results of an expression, we can use switch and case attributes for a conditional rendering of the HTML elements. For example, consider this code snippet over here. Here we are using th:(switch Thymeleaf attribute to evaluate this condition, that is user.role. If the user role is admin, then this case will execute and this will print user is administrator, and if none of the case is matched, then this default case will execute, and in Thymeleaf we can use star to denote this case as a default case. So this is pretty simple. If you have already used switch case in Java, then you will easily understand this switch case in Thymeleaf as well. Here we have used th:(switch condition to evaluate this expression. If this expression will match any of the cases, then that respective cases will execute. Okay, now let me demonstrate the usage of switch and case Thymeleaf attributes in an action. So let's go to IntelliJ IDEA and let's go to user controller over here, and here let me write the handler method first. So let's type public and let's give return type of the method as a string, and here let me give method name as switch case, and let's annotate this method with @getMapping annotation to handle HTTP GET request with the URL switch-case, and let's pass a model as a parameter to this method. Alright, so here let me create a user object, user equal to new user, and let's pass parameter to this constructor. So name let's give Ramesh, and then email let's give ramesh@gmail.com, and let's give role as admin, and then let's give gender as a male. Now we have created a user. Next, let's add this user to the model. For that, model dot add attribute, and then attribute name as a user and attribute value as a actual user object. Perfect. Next, let's return the view. So let me give view name as switch-case, Perfect. Now we have created handler method. It will handle HTTP GET request with the URL switch hyphen case, and within this handler method we have created user object and we have added it to the model, and this handler method returns switch hyphen case Thymeleaf template view name. Next, let's go and let's create this switch case Thymeleaf template and let's display the model data. So let's go to templates folder. Within that, let's create a HTML file and let's give name as switch hyphen case and hit enter, and let's give title as switch case condition, something like that, and let's define the XML namespace for Thymeleaf. So go to HTML element and here at the beginning just type XML namespace :th equal to http and then www.thymeleaf.org. Perfect. Next, go to body. Within a body, let's have h1 header element and let's provide the page heading something like switch case Thymeleaf attributes demo, something like that. Perfect. Next, let's use s3 heading element over here, and within that let's use th text Thymeleaf attribute and let's print the username. For that, let's use a variable expression dollar within a curly braces user dot name. Well, this user we are getting from the Spring MVC controller. For example, if you go to user controller and go to switch case handler method, within that we have model dot add attribute and we have used attribute name as a user, attribute value as actual user object. In order to get this actual user object, we are using attribute name called user. So this user we are using over here. Okay, user dot name. So name is basically attribute of this user model class. For example, if you go to user model class, it has name, email, role, gender, right? So this name we are calling over here, user dot name. Next, let's go and let's use Thymeleaf switch and case attributes. So here just have a div, and within a div let's use th switch Thymeleaf attribute and let's add a condition. Within a double quote, let's have a variable expression dollar and then user dot role. Now we have used th switch Thymeleaf attribute to get the user role. Next, we need to use switch case. So here within this div, let's have a paragraph element and then let's use th case Thymeleaf attribute, and then within a double quote, within a single quote, let's pass admin. Let's say if this user role match to this admin case, then we'll print user is a admin user, something like that. And then let's have one more paragraph element over here and then th case, and then if the user role is a user, then what will print? Will print user is a normal user. Next, let's have a default case. For that, let's have a paragraph element and then th case Thymeleaf attribute, and then in order to represent a default case we have to use star over here, and then let's print user is something else, something like that. Perfect. Now we have used switch and case Thymeleaf attributes. Next, let's go and let's run the Spring Boot application and let's see how this switch and case Thymeleaf attribute works. So let me start the Spring Boot application again. Alright, and if you can go to user controller, we have used switch hyphen case a URL to call this handler method, right? So let me copy this switch hyphen case URL and let's go to browser, and here just type localhost :8080/ switch hyphen case and hit enter, and there we go. You can able to see Ramesh user is a admin user, that's why user is a admin user text is printed over here. Well, if you can see the code over here, if the user role is admin, then this text will be printed, that is user is a admin user, and you can see user is a admin user. Now let me change the role. So go to user controller and here let me change the role from admin to user, and let me restart the Spring Boot application. Alright, and let's go to browser and let me refresh, and now you can able to see user is a normal user. Next, let's print the default case. So here let me change the role from user to guest. So this guest user is not exist in our application, so it will print the default case, right? So let me start the Spring Boot application. All right, let's go to browser and refresh, and you can able to see user is something else. So this is basically text which we have added in a default case. Okay, if you see the code over here, we have added user is something else in a default case. Okay, this is how we use switch and case Thymeleaf attributes to perform switch case condition in a Thymeleaf templates. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this section of the lectures, we will take a look into Thymeleaf form handling. Well, let's take a look into the important Thymeleaf attributes that we can use while handling the forms. Well, here we have th::action, th::object, th::field. So these are the three important Thymeleaf attributes that we use while handling the forms. The th::action attribute is used to define the action URL for form. This attribute replaces the HTML action attribute of the form. Well, when we design the plain HTML form, then we use a action attribute of the form, right? Well, when Thymeleaf engine will process this th::action attribute, it will replace this attribute with the HTML action attribute of the form. Next, we have th::object attribute. This attribute is used to bind the fields of the form to the model object. For example, consider we have a code snippet over here. So basically this is the form, and within this form we have used Thymeleaf attributes such as th::object, th::action and th::field. The th::action attribute here we are using to define the action URL for this form, and Thymeleaf engine will process the th::action attribute and it will replace us with HTML action attribute of the form. Next, we have th::object attribute. So this attribute is used to point to the model class object, and if you can see here, this is the model class object, that is user form, and it has fields like name, email, password, gender, address, married and profession. Okay, so th::object attribute is used to point to this model class object, and this model class object is used to store the form data. Well, whenever user fill up this form and submit this form, then this form data will be stored in this user form model object. Okay, and this th::object attribute is used to point to this model class object. Okay, next we have th::field attribute. This attribute is used to point to the field name of the model object. For example, here we are using th::field attribute to point to the model class object attribute, that is name. Well, if you can notice here, user form is a model class and it has attributes like name, email, password, gender, address, married, profession, and here we are using th::field attribute to point to the model class object attributes. Okay, so whenever user enter the data in this input text field, then that data will be stored in this model class attribute, that is name. So similarly, you can able to see here we are using th::field attribute to point to the email field of this model class object, and whenever user enter the email in this input text field, then that email value will be stored in this email model class attribute. Similarly, you can able to see we are using th::field attribute to point to the password field of this model class object, and here you can see we are using th::field attribute to point to the profession field of model class object, and here again we are using th::field attribute to point to the address attribute of model class object. Well, basically we use th::field Thymeleaf attribute to point to the field name of the model class object, and we use this field name to bind the input form data. Alright, so these are the three important Thymeleaf attributes that we use while handling the forms in a Thymeleaf template. In next lecture, we will create a handler method to handle user registration request, and in upcoming lectures we will design the user registration form, and we will see the example for input text field and password text field and selection box text field, text area and radio box. Okay, we will see how to get a data by using all these form controls. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen important Thymeleaf attributes that we use while designing the forms in a Thymeleaf templates. Well, here are the important Thymeleaf attributes like th::action, th::object and th::field. th::action attribute is used to define the action URL for the form, and this attribute replaces the HTML action attribute of the form, and th::object attribute is used to bind the fields of the form to the model object, and th colon field attribute points to the field name of the model object. Alright, we will understand more about these Thymeleaf attributes in upcoming lectures. In this lecture, what we will do, we will create a handler method to handle user register request, and in next lecture we will design user registration form. So let's go to IntelliJ IDEA and let's quickly create a handler method. So go to controller package, let's create a new controller. So right click, new, and then choose Java class, and let's give class name as form controller. Perfect. Let's annotate this class with add controller annotation. Well, whenever we annotate a class with add controller annotation, then this class becomes a Spring MVC controller and it is capable to handle HTTP request. Next, within this controller, let's write a handler method to handle user register request. So let me write the comment over here, handler method to handle user registration page request. Okay, perfect. So let's type public, and string is the return type of the method, and let's give method name something like user registration page. Alright, and let's annotate this method with add get mapping annotation to handle HTTP get request, and let's give URL as a register. Okay, perfect. And let's pass a model as a parameter to this method. Alright, great. Next, here we need to create a model class object. Okay, so let's first create a model class and then we'll come back to this handler method. So here go to model package, right click on it, new, and then choose Java class, and let's give class name as a user form. Next, let's define the instance variables for this class. So just type private and then string and then username, and then private string user email, and then private string password. Next, private string and then gender, private string address, and then private boolean. Let's give married as a field name, and then private string profession. Perfect. Now we have defined the instance variables for this user form class. Next, let's go and let's create a getter setter methods. So right click, generate, and choose getter and setter, and select all the fields and click on OK. Now we have created getter setter methods for these instance variables. Next, let's go back to our handler method. So go to form controller. Well, within this handler method, let's create a empty user model object to store the form data. So here let me write the comment, empty user form model object to store form data. Well, whenever user enter the data in the form and submit the form, then that data will be stored in this user form model class object. So here let's have a user form object first, user form equal to new user form. Perfect. Now we have created empty object. Next, let's add this object to the model. So here we have model dot add attribute, and let's give attribute name as user form, and let's give attribute value as a actual user form object. Perfect. Next, let's create a list of professions. Well, in a user registration page, we will create a selection box and we'll populate the list of professions data. For example, if you can see the demo here we have profession and here we have a selection box, and we need to populate this data in a selection box, isn't it? So in order to do that, let's create a list over here. So let's say list of type string, and then let's call it as list profession. And next, let's use arrays utility class arrays dot as list method, and just pass values like developer, and then let's say tester, and then architect. Perfect. Now we have created list profession. Next, let's add this list profession to the model. So let's call model dot add attribute method, and let's give attribute name as list profession, and let's give value as a actual list profession object. Perfect. Now we have added list profession to the model. Next, we need to return the view. So here let's have return statement, and then let's give view name something like register hyphen form. Perfect. Now we have created handler method to handle user registration page request, and within this handler method we have created empty user model object to store the form data, and then we have added this empty user model class object to the model. And next we have created a list of professions, and then we have added this list of profession to the model, and then this handler method returns register hyphen form view name. In next lecture we will create a register hyphen form Thymeleaf template, and then we will design user registration form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created a handler method to handle user registration page request, and this handler method returns register hyphen form Thymeleaf template view name. In this lecture we will create registration form Thymeleaf template, and then we will design the user registration form, and we will use this user form model class object to store the form data, and we will also use this list profession to populate the data in a selection box. Okay, so let's go to templates folder, and within templates folder let's create a HTML file, and let's give name as register hyphen form. Perfect. Let's give title as user registration form. Next, let's go ahead and let's define the XML namespace for Thymeleaf. So go to HTML element and just type XML namespace :th equal to http and then www.thymeleaf.org. Perfect. Next, go to body. Within the body, let's design the user registration form. So before that, let's have a div first, and let's align this div at a center. For example, let's give align as a center. Well, if you look at the screenshot over here, we are going to design the user registration form something like this, and we are going to align this form at a center. For that we have used align center. Okay, next within this div let's create one more div, and let's have an inline style for this div. So let's type style, and let's give a border hyphen style equal to, so let's give a border style as a solid. Okay, next let's give width as a 500 pixel, so this should be colon. Perfect. So if you look at the screenshot over here, we need to give a border to this form. Okay, for that we have used solid value, and next we need to give width for the form, so that is 500 pixel. Next within this div let's create a heading. So let's use h1 element, and let's give heading something like user registration. Well, if you look at the screenshot, we need to use this user registration heading, right? For that we have used h1 header element, and then we have passed this user registration text in the body. Next, let's go ahead and let's design the form. So here just type form, and then let's define the attribute for this form. So let's say role as a form, and then let's use http method post, and let's use a Thymeleaf attribute, that is th colon action, to define the action URL for this form. So in order to define the URL, we have to use a link expression, and here is the syntax: @ within curly braces, just pass the URL, that is register hyphen save. Well, we will write the handler method to handle this request in next lecture. Okay, next let's use th colon object Thymeleaf attribute to point to the model class object, and in order to point to the model class object we have to use variable expression. So let's type dollar within a curly braces, and then the model class object name is user form. Well, this user form model object is coming from the Spring MVC controller. If you go to form controller, within this form controller we have handler method, And within this handler method we have created empty user form model object, and we have added it to the model object over here. And here this model.add attribute has attribute name and attribute value, and in order to access this attribute value we have to use this attribute name. Okay, so this attribute name we are using over here, user form. Okay, and th colon object Thymeleaf attribute will point to the user registration model object, and whenever user enter the data in the form and submit the form, that form data will be stored in this user form model object. And this user form model object is empty. Basically, if you go to form controller, you can able to see this is the empty object, so that we can store the form data. Okay, great. Next, let's go and let's define the input fields for this form. So here let me have first label. So let's type label, and let's give label name as full name. Okay, next let's create a input field, and let's close it. And within this input field, let's define its properties. Let's say type text, and then let's use th colon field attribute to point to the field name of the model class object. And in order to point to the field name of the model object, we have to use a selection expression. So here is the syntax: star within a curly braces the field name, that is name. Okay, well, in order to use selection expression, we have to define the previously selected model class object, and here we have already using th colon object Thymeleaf attribute to point to the model class object over here. Okay, and here we are using selection expression to get the field name of this model class object. And here's a syntax to use selection expression, like star within a curly braces we need to pass the field name, that is name. Okay, so this name is basically a field name of user form model class object. For example, if you go to user form model class has a name field, right? So this field we are using here. Okay, perfect. Next, let's go and let's define the input field for email. So let's have a label first. So before that, let me add one break element to give space between input fields. So here let's add a label, and let's give label name as email. And after that, let's use an input element, and let's close it. And then let's use its attribute like type. Let's use email, and then let's use th colon field Thymeleaf attribute to point to the name of the model class object. And let's use a selection expression, and here is the syntax: star within curly braces email. Okay, perfect. Now we have defined the input field for email. Next, let me add one break element to give a space, and next let's define the input field for password. So here let's first add the label, and let's give label name as password. Perfect. Next, let's use input field, and let's close it, and let's use its attribute type password, and then th colon field Thymeleaf attribute, and then selection expression, and go to user form. And from here also you can copy the field name. For example, I'm going to copy this password, and I'm going to paste it over here. Okay, so make sure that whatever the field name you have in a model class, the same field name you have to use in a selection expression. Okay, now we have defined the input field for password. Next, let's go and let's use input fields for gender. So here let me add a break element, and after that let me add a label, and let's give label name as gender. Perfect. Next, let's use an input field, and let's close it, and let's give type as a radio. Okay, and next let's go ahead and let's use a th colon field Thymeleaf attribute, and then here let's use selection expression star within a curly braces, and then pass the field name, that is gender. And next, here we need to add one more attribute, that is value, and let's use value name as male. Perfect. And here we need to basically give a name to the radio box, that is male. Okay, perfect. Next, let's go and let's define one more input field over here for female. So let's have a type as a radio, and then th colon field Thymeleaf attribute, and then selection expression, and then path gender, and then here value female. Perfect. And let's give value as a female over here. Next, let's add a break element to give some space, and next let's have a label for profession. Let's give label name as profession, and let's have a selection box over here. So here is the syntax. Next, let's design the selection box. So just type select. Alright, and within this select, let's have an attribute that is th colon field Thymeleaf attribute, and then let's use a selection expression that is star within a curly braces profession. Perfect. And then within this selection box we need to have an option, right? So for that, let's have an option. Well, we need to show a list of professions in this selection box. For that, we need to iterate over a list of profession in this option element. For example, if you go to form controller and go to this handler method, here we have created a list of profession and we have added to the model, right? Now let's go and let's iterate over this list of profession, and let's display a list of profession in this selection box. So here in our option, we need to just use th colon each Thymeleaf attribute to iterate over a list of profession. So let me use th colon each Thymeleaf attribute, and here is the syntax: local variable colon, and then let's use a variable expression dollar within a curly braces. Just pass the attribute name that is list profession. Well, this attribute name is basically coming from the form controller. If you go to form controller, you can able to see we have added attribute name as a list profession and attribute value as an actual list of profession. Okay, and here we are using this attribute name here. Okay, you can copy and paste it over here. Next, let's use th colon value Thymeleaf attribute to get a particular value from this list. So in order to get that, let's use a variable expression and then just pass this p as a local variable. And next, let's display this profession by using th colon text Thymeleaf attributes. For that, let's use th colon text Thymeleaf attribute, and then let's use a variable expression dollar within the curly braces. Just pass a local variable that is p. P stands for profession. Okay, great. Now we have designed the selection box. Next, let's create a text area as well. So here let me add a break element, and after that let me add the label, and let's give label name as address. Perfect. And then let's use text area over here, text area. Okay, and here let's add an attribute for this text area. Let's give rows as 5 and then columns as 25. Alright, and next let's use th colon field Thymeleaf attribute to point to the field name of the model class attribute, and here we have field name as a address. So here let's use selection expression and then pass address as a field name. Okay, perfect. Now we have created a text area for this address. Next, we need to create a submit button. So before that, let me add one break element to give space between this text area and submit button. So here let's have a button, and let's give type for the button as a submit, and let's give name to the button something like register. Next, let's go ahead and let's run our Spring Boot application, and let's see how this user registration form looks in a browser. So let me start the Spring Boot application, and there we go. Our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let's go to form controller, and here we have given a URL to access this handler method. The URL name is register. So let's copy this register link and go to browser. In a new tab, just type localhost :8080/register and hit enter, and there we go. We got a user registration page, but if you can see the alignment, okay, so basically we need to add a CSS to make this form look good. Okay, so we haven't added any CSS, that's why the form looks like this. Okay, so let's go and let's add some CSS so that this user registration form looks good. Okay, so let me go to IntelliJ IDEA. Next, let's see how to add a CSS to this user registration form. So go to register-form.html page and go to head element over here. Right after this title, let's create a style HTML element and let's give type as a text/CSS. Perfect. Within this style element, let me quickly write the CSS code. And notice here, I have given a CSS for label as display inline block width 200 pixel, margin 5 pixel, text align left, and I have provided CSS for input type text, email, password, and select as a display inline block width 200 pixel, and I have added CSS for input type radio, input type checkbox, and also for button. Okay, well, I am going to attach the source code of this section of the lecture so that you can go ahead and you can copy this piece of code. Okay, now we have added CSS for this user registration form. Next, let's go ahead and let's run the Spring Boot application and let's see how this CSS will apply to user registration form. And here you can see our Spring Boot application up and running in embedded Tomcat server on port 8080. Next, let's go to browser and go ahead and refresh our Spring Boot application, and there we go. Now you can able to see the user registration page looks good. Well, in next lecture we will create a handler method to handle user registration submission request, and we will display the user registered data in a separate page. Alright, so whenever user enter the data and submit the form, then we need to handle this form submission request at a backend, isn't it? So in next lecture we will create a handler method to handle this user registration submission request, and we will display the user registered data in a separate page. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have designed user registration form. In this lecture we will create a handler method to handle this user registration form submission request, and we will display the user registered data in a separate page. Okay, so basically we are going to create one more Thymeleaf template and we will display the user registered data. Okay, so go to IntelliJ IDEA and let's quickly create a handler method to handle form submission request. So let's go to form controller over here, and here let me write the comment handler method to handle user registration form submission request. Perfect. Well, whenever user fill up this user registration form and submit this form, then we need to create a handler method to handle this user registration form submission request, isn't it? So that is what we are going to implement over here. So here let me create a handler method. So just type public and let's give a return type of the method as string, and let's give method name as submit form. Next, let's go ahead and let's annotate this method with add post mapping annotation to handle HTTP post request with the URL register/save. Well, if you go to register form.html page, here you can see we have provided register/save link as an action to this form, isn't it? And we are going to handle this link request using this handler method over here. Okay, perfect. Next, let's pass a model as a parameter to this method. And if you go to register form.html page again, you can able to see here user form. Well, this user form model object contains all the form data, and we need to get this user form model object in a handler method, right? So for that, what we'll do, we'll use add model attribute annotation from Spring Framework to get the model object from Thymeleaf template. And here we need to pass the model object. So here we have user form. Okay, so you can simply copy this and you can pass to this annotation like this, and this should be an instance of user form. Perfect. Now we got the model object, it contains form data. Next, let's add this form data to the model. So just call model dot add attribute, and here just pass user form as a attribute name and user form actual object as a attribute value. And next, let's return the view name. Let's give view name as register hyphen success. All right, perfect. Now we have created handler method to handle user registration form submission request, and within this handler method we have used @model attribute annotation to get the model object. It contains the form data, and then we have added this form data to the model, and then we have written register-success Thymeleaf template view name. Okay, next we will create a register-success Thymeleaf template view and we will display this model data. Okay, perfect. Next go to templates folder, right click, new, and then choose HTML file, and let's give file name as register-success. Okay, perfect. Let's give title user registered data, and next let's define the XML namespace for Thymeleaf. So just type XML namespace :th equal to http and then www.thymeleaf.org. Perfect. Now we have defined XML namespace for Thymeleaf so that we can use Thymeleaf syntax in this HTML page. So go to body. Within a body, let's display the model data. So here just type a div, and let's align this div at the center. For that, let's use align attribute, and then let's pass center as a value, and within this div let's have h1 header element, and let's give a text as registered user information, something like that. Next let's display the user registered information over here. So here let's have a div, and within this div let's have paragraph element, and then here let's say username, and let's use strong HTML element to make name in a bold. So here within a strong element let's use th:\text Thymeleaf attribute, and then let's use a variable expression to point to the model object attribute. So in our case we have user form dot name. So this user form is coming from the form controller. If you go to form controller, here we have submit form handler method, and if you can see inside this handler method we have model.add attribute method, and then we have passed user form as attribute name and actual user form object as attribute value, and we can get the user form object by using user form attribute name. So this user form attribute name we are using over here. Okay, user form dot name. So this will give user name. Next let's print user email. So here let me copy and paste it over here, and let me change from name to email, and here let me change the field name from name to email. Next let's display the password. So let me copy this and paste it over here, and let me change from email to password, and here let me change from email to password, and similarly let me print the gender as well. So let me copy this and paste it over here, and let's change from password to gender, and here also change from password to gender. And next let's print the address. So let me copy this, paste it over here, and let's pass address, and here also let's change from gender to address. Perfect. Next let's print a married and profession field. So let me copy and paste it over here, and let me replace from address to married, and here also let me replace address with married. Next let me copy this, paste it over here, and let me give a profession. Next let's give field name as profession. Perfect. Now we have printed username, email, password, gender, address, married, and profession. Next let's run our Spring Boot application, and let's see how the user registered data will be displayed in this page. So let me stop the existing server, and let me start the Spring Boot application again, and here we go. Our Spring Boot application is up and running. Now go to browser and just refresh this page. Let's enter full name as Ramesh Fadtare, and then email ramesh@gmail.com, password let's give Ramesh, and gender select male over here, and profession let's select architect, and then profession, and then address I will put Pune, and click on register, and you can able to see registered user information is successfully displayed over here, and name Ramesh Partare, email, password, gender, address, married, and profession architect. Perfect. It means that we have successfully displayed the user registered information in this separate page, and we have successfully created user registration form, and we have successfully get the value of this user registration form in a Spring MUC controller. Alright, I hope you understood how to create and design forms in a Thymeleaf templates and how to use Thymeleaf attributes to deal with the forms in a Spring MUC projects. Alright, great. I will see you in the next lecture. Hey there everyone, Ramesh here, back again with another crash course titled React.js Crash Course. In this crash course, we will learn all the fundamentals of React.js. Well, you will learn what is React.js, the component, what is component types, JSX, functional components, class components, event handling, conditional statements, JSX, and states, props. Alright, so this crash course covers all the fundamentals of React.js, and most importantly, why you want to use the latest version of React.js in this crash course. Alright, and end of this crash course, I am going to provide you the PDF notes of this crash course so that you can go ahead and refer it anytime. So this is the PDF notes of this crash course. You can use it for your reference, and I am going to provide the location of this PDF notes at the end of this video. And if you are new here, don't forget to subscribe and hit notification button. Never miss the updates. Alright, do support this video, give thumbs up so that this video will reach a larger audience. Alright, so without further ado, let's kickstart this crash course. Hi everyone, welcome back. In this lecture, let us take a look into Introduction to React.js. Well, what is React.js? React.js is an open source JavaScript library for building user interfaces. Well, here in this definition, you can notice two key points. First is JavaScript library and second is building user interfaces. Well, React is a JavaScript library. It is not a framework. It is a JavaScript library, and React, it does only one thing, that is building user interfaces. So React is not concerned with other things like routing or making REST API calls. Okay, so React, it does one important thing, that is building user interfaces. Okay, so you might be wondering how we can implement the routing and making HTTP request in a React application, right? So React.js has a good support with third-party libraries. So we can use third-party libraries in a React application to achieve all this stuff. Like we can use React Router DOM library to implement the routing. We can use Arcgis HTTP library to make the REST API call or HTTP request in a React application. Okay, so just remember, React.js is an open source JavaScript library for building user interfaces. Next, React.js is created and maintained by Facebook. Next, React.js is a component-based architecture, and this architecture promotes reusability. The components are reusable building blocks that encapsulates the logic and UI elements of the application. They allow developers to break down the complex UI into smaller manageable parts. Well, in React.js, the components are building blocks and reusable, and these components allow developers to break down a complex user interface into smaller manageable parts. For example, consider we have user interface over here, and the component-based architecture basically allows the developers to break down the user interface into smaller manageable parts. For example, we can break this user interface into small manageable parts called components. For example, we can have a header component, we can have a footer component, we can have a side navbar, we can have a main content component, we can have a ads component. So React provides a component-based architecture, and this architecture allows the developers to break down the user interface into smaller and manageable parts, and these parts are called components. Okay, and again, component-based architecture promotes the reusability. For example, we can reuse the existing component as many times as we want. For example, here we have a side navbar component, and we can reuse this side navbar component as a left side navbar component or right side navbar component. So one more example is ads component. So we can use this ads component to display multiple ads. Next, let us take a look into React Virtual DOM. Well, React.js uses Virtual DOM as an abstraction of the real DOM to optimize and efficiently update the user interface. So if you look at the diagram over here, so before deep dive into the React Virtual DOM, first let us understand what is real DOM. Well, DOM stands for Document Object Model, and this DOM basically represents a tree structure of your UI application. For example, whenever you load your application in a browser, then browser will create a DOM for your UI application. For example, let us say your UI has a HTML code, div, within a div, S3 element, and then form, and then spam, within a spam, you display the time. Okay, so DOM basically represents a tree structure of your HTML. Now we understood what is DOM and how this DOM looks in a browser. Next, let us understand what is React Virtual DOM. Well, React creates a virtual copy of the real DOM and it is called a virtual DOM. Okay, so in order to improve the performance of the application, React creates a virtual DOM to update only the necessary part of the DOM. Alright, now let us understand how the React Virtual DOM works. Well, initially React will create the virtual DOM. It is the virtual copy of the real DOM. The real DOM which is present in a browser. Okay. Next, let us say if we change something in the React application. For example, let us say we change the time. Then what React will do? It will create one more virtual DOM. And this is what the updated virtual DOM. Okay. Next, React will compare both virtual DOMs. Okay, so React will basically compare initial virtual DOM and updated virtual DOM, and it will identify the changes. If you look at the next diagram, React compares the initial virtual DOM and updated virtual DOM, and it will identify the node that gets changed. For example, in this case, the time node changed. Okay, so basically in a DOM, each element represents a node. Alright, and React compares both the virtual DOMs, and it will identify the node that gets changed. So once React identified the node that gets changed, next React will update that change in an actual DOM. And if you look at here, only the node whose data changes get repainted in the actual DOM. Alright, so this is how the React Virtual DOM works. So basically React don't change the actual DOM in the browser. It maintains the virtual copy of the actual DOM, and it will identify only the necessary changes, and then it will update the actual DOM. So this will improve the performance of the application. Okay, so here are some of the React real world examples. React.js is used by numerous organizations, and it is a foundation of many popular applications and websites including Facebook, Instagram, WhatsApp, Netflix. Alright, so this is a quick introduction to React.js. In next lecture, we will create and set up React application, and we will start learning React.js fundamentals. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up our first React application. Well, in order to create and set up React application, we are going to use build tools. Well, there are two popular build tools out there to create and set up the React application, such as Create React App and Vite.js. Well, in Java, we use the build tools like Maven or Gradle to create and set up the Java projects, right? Similarly, in order to create and set up the React application, we can use the build tools like Create React App or Vite.js. Well, let us first take a look into Create React App. Well, Create React App is an official supported way to create a single page React applications. It offers a modern build setup with no configuration. Create React App is a built-on Webpack and Bubble, and it is a popular tool that enables developers to quickly set up the React application. Well, Create React App provides a pre-configured environment so that developers can focus on the coding part, not on the build setup and the configuration. Alright, and Create React App is especially useful for beginners to get started. Next, let us take a look into Vite.js. Well, Vite is a newer build tool that has gained popularity in recent years. It was created to address the limitations of existing build tools, particularly in the development phase. Well, Vite.js is built on top of Rollup Bundler, which is known for its faster build times. Vite also provides a development server that is optimized for performance. Well, nowadays React developers prefer using Vite.js as a build tool to create and set up the React applications because Vite provides a faster build times. It means we can use Vite.js to bundle or build the React application very faster. Vite also provides the development server that is optimized for the performance. It means if you change something in the React application, then development server will immediately pick up that change and it will update the DOM in a HTML. Alright, so Vite you can use to improve the development experience. Okay. Now the question is, which build tool we have to use to create and set up the React application? Well, both Create React App and Vite are excellent build tools that provide the developers with a solid foundation for building React applications. Create React App is a reliable choice for beginners to learn, while Vite is a better choice for real-world projects that require faster build times. Ultimately, the choice between two will depend on the project's requirements and the developer's preferences. Well, in this course, I am going to show you how to create and set up the React applications using both Create React App and Vite.js. So we'll begin with using Create React App tool to create and set up the React application, and in upcoming sections we'll also see how to use Vite.js to create and set up the React applications. Now let us go ahead and let us use Create React App build tool to create and set up the React application. Well, in order to create the React application, you need to install Node.js and npm. Well, if you just type Node.js in the browser and go to download page, and from here you can go ahead and download the Node.js as per your operating system, and you can install in your operating system. Next, you don't have to install the npm separately. Whenever you will install the Node.js, npm will also get installed. Okay. Next, you need a text editor. Well, in this course we are going to use Visual Studio Code ID to build the React applications. Well, you can just type Visual Studio Code in a browser and click on the first link and click on download link over here. So from here you can go ahead and download the Visual Studio Code ID as per your operating system, and then you can go ahead and install it. Okay, so make sure that before creating the React applications you have to install Node.js and Visual Studio Code ID in your machine. Alright, great. Next, let us go ahead and let's create the React application using Create React App tool. Well, first of all, let's create the workspace. For example, here in my file system, I have created React workspace as a folder. Within this folder, we are going to create the React applications. Alright. Next, let us open the Visual Studio Code ID. Well, I have already installed the Visual Studio Code ID. So here, let me open it. Next, let me maximize this and go to file menu, click on open folder over here, and then go to the folder. So in my case, I have created React workspace as a folder. So let me select it, click on open. Alright, perfect. Next, we are going to create the React application in this React workspace folder. So in order to create the React application, we are going to use the commands. Well, if you go to browser and in a new tab, just type Create React App, hit enter, click on the first link and click on Get Started over here, and you can see, so these are the couple of commands that we can use to quickly create and set up the React application using Create React App build tool. Alright, so let us execute these commands. So in order to execute these commands, we have to use the terminal, right? So let's go back to Visual Studio Code ID here, and here we are going to use inbuilt Visual Studio Code ID terminal. For example, go to terminal, click on new terminal, and here let us execute the command. So if you go back to browser, the command npx create react app followed by the application name. Next, let's go back to VS Code and go to terminal, and here just type the command npx followed by create react app followed by the application name. So let us give application name as React Basics. Next, hit enter. So this will take a couple of seconds to create and set up the React application. So let us wait a couple of seconds, and you can see the statement creating a new React app in this folder. Alright, perfect. And there we go. The React application is successfully created with the name React Basics. Well, if you go to React Workspace folder, within that React Basics is the React application name. Next, in order to run the React application, we can use the command npm start. And in order to build the React application for production, you can use the command npm run build. In order to execute the test, you can use the command npm test. In order to eject the React application, you can use npm run eject. Next, let us type these two commands to start the React application. Right now we are in a React workspace, so let us move into our React application. So here let me clear the terminal and just type the command cd react basics, next npm start, and then hit enter. And there we go, our React application is up and running in a development server on port 3000. Next, let's go to browser. In a new tab, just type localhost :3000, and there we go, our React application is up and running. Next, let's go back to VS Code and go to our project and go to app.js, and here let us remove all this code, and here just type h1 element and then type hello world and just save this file. And let's go back to browser, and you can see hello world is displayed in the browser. Okay, so in next lecture what we'll do, we'll understand the important files and folders of this React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created and set up the React application. In this lecture we are going to understand React application project structure. Well, if you go to VS Code and go to our React application over here, so here let us take a look into the important files and folders of our React application. Well, let us begin with package.json file. So basically package.json file contains all the dependencies and scripts required for our React application. For example, if you go to dependency section, here you can see the dependencies like React, React DOM, and in this course we are using React 18+. Alright, next here we have script section. So this script section contains all the scripts that are required to start the React application, to build the React application, to test the React application, and to eject the React application. Alright, so just remember, package.json file contains all the dependencies and scripts required for our React application. And whenever we run npm install command, then npm will refer this dependency section and it will install all these dependencies in a node_modules folder. Next, we have public folder. Within the public folder we keep all the files that are accessible publicly, and within the public folder you can see the important file, that is index.html. Well, we basically create the single page React applications, right? And in single page React application we can find only one HTML file named index.html. And if you look at the index.html code over here, and especially if you look at the body contains a div with id root. So this div is responsible to render the React component. Alright, so this div is responsible to render the React root component. And most of the time we don't change this index.html file content. We may change this header section to include the scripts and CSS files, but we don't touch the body section. Okay, so the body should contain a single div, and this div is responsible to render the React component. Next, we have src folder. Within src folder all the development related stuff goes, and within src folder we have app.js file. So this app.js file contains a root component named app component. Next, we have index.js file. So this index.js file is a main entry point for our React application. And if you look at the source code of this file, react DOM.create root, and then document.getElementById, and then id root. Well, this create root method will get the div by using the id root. Well, if you go to index.html file, it contains a div with id root. Alright, and if you go back to again index.js, so here this react DOM.create root method will get the div by using this id, that is root. Okay, and then it will render app component within that div. For example, let me repeat again. If you go to index.html file, it contains the body, and body has a div with id root. Next, this react DOM.create root method will get the div from this index.html by using its root id, and then it will render this app component within that div. Okay, next we have app.css and index.css files. So these files basically contains all the CSS related stuff. Okay, so these are the important files and folders in our React application. Now let us understand the flow in our React application. Well, whenever we access the React application from the browser, then this index.html file will get served in the browser. Next, the index.js file will load into the browser. Well, if you go to src folder, go to index.js. So index.js is a main entry point for our React application, right? So once the index.html file will load into the browser, then immediately this index.js file will also load into the browser, and then this piece of code will execute. Well, if you look at the code over here, react dom.createRoot. So this method will get the div from the index.html file by using the id root. Next it will render this app component within the div. Well, if you go to app component contains this HTML code. Well, don't bother about this HTML code right now. So this is basically called a JSX. We'll understand what is JSX and how we can write the JSX code in upcoming lectures. So just as of now understand, this is the app component and it returns some HTML code, and you can see the HTML code h1 hello world. So this will basically print the heading in the web page. For example, if you go to browser, and you can see hello world is displayed in the browser. Okay, and next if you can inspect this web page, go to console. So here you can see download the React DevTools for a better development experience. Just go ahead and click on this link, and let us add this React Developer Tools extension in the Chrome browser. So next, so here I am using Chrome browser, so I am going to install this extension in a Chrome browser. But if you are using Firefox or Edge, then accordingly you can add the extension. So here just click on install for Chrome, and next click on this add to Chrome button, and then click on this add extension. Alright, perfect. Next go to this extensions, and here you can see React Developer Tools extension is added. Alright, great. Next let's go back to our project, and here let us inspect this page again and then refresh, and here you can see the new tab named components. So just click on this components tab. So under this tab you can see all the React components. As of now there is only one component named app component, right? And just click on this app component, and here you can see the details. So this app component is used in a source file named index.js. Next, this app component will be rendered by this method. Okay, so basically you can see all the component related information over here. Alright, so this React Developer Tools extension is pretty useful to track the components and the component tree. Okay, great. Well, notice here by looking into this components tab, we can clearly understand the React application flow. Well, whenever we access the React application using browser, then the index.html file will get served, and then this index.js file will get loaded, and this index.js file is a source for this app component. Okay, so just remember, whenever we access the React application from the browser, then the index.html file will get first served in the browser, and then index.js file will get loaded in the browser, and then this index.js file will render the app component. Okay, so this is how the flow goes in a React application. So let me summarize what we have understood in this lecture. We pretty much understood the important files and folders in the React application, and we have also installed React Developer Tools extension in a Chrome browser, and we have also understood the flow in the React application. Alright, great. In next lecture we will take a look into the components. Well, the components are the building blocks in a React application, so you have to understand the components in order to build the React applications. Alright, so in next lecture we will take a look into React components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures we will take a look into what are the components in React and different types of components in React. Well, what is a component? A component is an independent reusable code block which divides the user interface into smaller pieces. Well, let us understand with an example. Well, consider we have user interface and we can divide this user interface into smaller components. For example, header component, footer component, side navbar component, main content component, and ads component. Alright, and finally these components will come together to create a complete user interface. And notice here I have mentioned component is a reusable. Reusable means we can use the existing component as many as times we want in a React application. For example, here we have side navbar component and we can reuse this side navbar component as a left side navbar or right side navbar. We just have to change the information and properties. The rest of the code remains same in a component. Alright. Next, the components can be nested inside other components. For example, here we have app component as a root component, and this app component is nested the other components like header component, footer component, side navbar component, and so on and so forth. Alright, so just remember components can nested other components as well. Next, in React there are two types of components, functional components and class components. In next lecture we will take a look into what is functional component. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to take a look into functional components. Well, in React there are two types of components, functional components and React components. In this lecture we will take a look into functional components, and in next lecture we will take a look into class components. A functional component is basically a JavaScript function or ES6 arrow function that returns a React element. Well, here React element is nothing but a JSX code. Well, we will understand what is JSX and how to write a JSX code in upcoming lectures. So just try to understand React element is nothing but a JSX code, and JSX allows us to write HTML code inside a JavaScript code. Next, functional components always starts with a capital letter. So this is the important naming convention. Whenever you create a functional component, make sure that the functional component should start with capital letter. Next, functional component takes props as a parameter if necessary. Well, this props is optional. If you want to pass the data from one component to another component, then we can use this props. Alright, next let us go ahead and let us understand about this functional component with examples. So here let's head over to the VS Code, and here go to SRC folder. Within that, let's create a new folder and let's call it as components. Next, within a components folder, let's create a new file and let's give name as welcome.js. Well, you can give the extension for this file as a JS or JSX. Well, some of the developers prefer using JS as extension and some of the developers prefer using JSX as a file extension. Well, you can use either one because React supports both, right? So here in our case, let us use JS as an extension. But in upcoming React projects, we are going to use JSX as an extension as well. Alright, hit enter. Now we have created welcome.js file. Next, within a welcome.js file, let's create a functional component named welcome. So here, look at here the syntax, function. Well, as I mentioned earlier, functional component is nothing but a JavaScript function or ES6 arrow function that returns a JSX. Okay, so here let's create a function and followed by the name welcome. And notice here again, as per the naming convention, the functional component should start with a capital letter, and I have given the capital letter W. Okay, so as this is a function, so here let us have open close braces and open close curly braces. Next, this function returns a JSX code. Well, JSX is nothing but a JavaScript extension that allows us to write a HTML code within a JavaScript code. Well, this is the JavaScript function, right? So within a JavaScript function, we can write the HTML code like this. Let us say we want to print the heading welcome Ramesh. Okay, so this is the JSX code. Well, JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. So in next upcoming lectures, we'll understand more about JSX. As of now, just understand JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. Okay, perfect. Now we have created simple functional component named welcome component. Next, in order to use this component in other components, we have to export this component. For example, here just type export default and then component name welcome. Well, just remember, in order to use this functional component in other components, we have to export this component first, like this. Okay, next let's go to app.js file and let us import this component. So go to app.js, go to app root component, go to div, and here let us remove this h1 element, and here let us use welcome component. So here just type welcome and make sure that this welcome component is imported at the top, and let us close this welcome component over here. Alright, so this is how we use the component inside other component. And notice here the important point, we have exported this welcome component using export keyword, and we have imported this welcome component in an app component using import keyword. Alright, so this is basically ES6 module feature. We can export the component using export keyword, and we can import the component using import keyword. Alright, great. Next, let us save this file and let's go back to browser, and here you can see welcome Ramesh. Alright, so this is how we can create the functional component and we can use in other components. And again, I have mentioned like component is a reusable. Reusable means we can use this component as many times as we want. For example, if you go to app component, and here we can reuse this component many times. For example, here let me use one more time and just save this file and go back to browser. You can see welcome Ramesh. Okay, so this is how the component is reusable in a React application. Alright, perfect. Next, let's go to welcome.js file. So, and if you go to presentation, a functional component is basically a JavaScript function or ES6 arrow function. Well, here we have created this functional component using JavaScript function, but we can also create this functional component using ES6 arrow function. So let us go ahead and let us rewrite this functional component using ES6 arrow function. So here let me copy this and let me paste it over here, and let me comment out this. So here let me show you how we can convert the JavaScript function into arrow function. So in case of arrow function, the function keyword is not required, and in case of arrow function we should have a variable const welcome and then flat arrow symbol. So this is the arrow function. Okay, next, if the arrow function contains a single statement, then we can remove the open and close curly braces and also the return keyword. For example, let us simplify this. Just remove this open and return keyword and also the close curly braces. Alright, so this is the functional component using arrow function. Alright, next let us save this file and let's go back to browser, and you can see welcome Ramesh. If you refresh, you can see the same output, welcome Ramesh. Alright, so this is how we can use the JavaScript ES6 arrow function to create the functional component. Alright, so functional component is a JavaScript function or ES6 arrow function that returns a JSX. JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. Next, in order to use this component, we have to first export it using export keyword. Next, we have to import this component using import keyword, and then we can use in the other components like this. Next, functional component takes props as a parameter if necessary. Well, here we can use props to transfer the data from one component to another component, especially from parent component to child component. For example, here we have app component as a parent component and welcome as a child component. And here, let us say we want to transfer the data from app component to welcome component. Then we can use props. So props stands for properties, and we can pass the properties from parent component to child component. For example, here go to welcome, and here just type name and then give name as Ramesh. Okay, next we want to get this Ramesh in a welcome component. So go to welcome component, and in order to get the Ramesh in a welcome component, we have to use props. So here we can pass props as a parameter to this functional component, and next, in order to access these props, we can use open close curly braces. So here just remove this Ramesh and let's have open close curly braces, and then type props and then name. Okay, so this is how we can use props to transfer the data from parent component to child component. Next, let's go back to app.js, go to app component. Next, here also let us use the name and let us pass the name. For example, let's say Umesh. Okay, so this is how we can use the props to dynamically pass the data from one component to another component, especially from parent component to child component. Okay, next let us save this file. Let's go back to browser, and here you can see welcome Ramesh, welcome Umesh. So here we are passing the data dynamically to the component. For this first welcome component, we are passing name as a Ramesh. For this second welcome component, we are passing name as a Umesh, and in a welcome component we are getting that name using props. Okay, so this is all about functional components. In next upcoming lectures, we'll understand more about props, like how we can pass the object or array and how we can get that object and array using props. We'll understand more about props in upcoming lectures. Alright, great. In next lecture, we'll take a look into class components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have understood how to create a functional components in a React application. In this lecture, let us understand how to create class components in a React application. Well, class components are ES6 classes that return the JSX. Class components extend the component class from React library. In case of naming convention, class components always starts with a capital letter. Class component takes props if needed. Class component must have a render method for returning the JSX. Well, let us go and let us understand all these points with an example. Alright, so as per these points, let's create the class component. So let us head over to VS Code IDE over here, and look at here. I am using VS Code and browser simultaneously in the same window, so that whatever the changes I do in the React application, that will be reflected in the browser right here. Okay, so this is the good way to teach. So here I am using browser and Windows simultaneously in the same window. So in order to understand the class components, let's create a new file. So here, go to src folder, go to components folder, and within that let's create a new file. Let's call it as greeting.js. Next, let me maximize this. Next, within a greeting.js file, let us create a class component. Well, as I mentioned, class components are ES6 classes that return the JSX. So here just type class and then followed by the component name greeting, and in case of naming convention, the class component should start with the capital letter, right? So you can see the G is capital over here. Next, the class component should extend the component class from the React library. So here let us have extend keyword and then React dot component, and make sure that this React should be imported from the React library. So in order to import that, let us have an import statement, import React from React library. Alright, perfect. Next, this class component should have a render method to return the JSX. So here let us have a render method, and within a render method we can have a return statement, and then we can have a JSX code. For example, here let us have h1 element, and then let us say welcome Ramesh. Okay, perfect. Now we have created a class component. Next, in order to use this class component in other components, we have to export this class component. So here export default and then component name, that is greeting. Perfect. Next, let us use this greeting component in an app component. So go to app.js file, and here let me comment out this welcome component, and here let us use greeting component. So here greeting, and make sure that greeting component is imported at the top. Alright, perfect. Next, save this file and look at here the changes in the browser. Welcome Ramesh. And if you go to the greeting component, you can see welcome Ramesh. So this is the heading displayed in a browser. Next, if I change from Ramesh to Umesh and save the file, and you can see the changes in the browser, welcome Umesh. It means we have successfully created the class component. Okay, so look at here the syntax again. Class components are ES6 classes, and class component should extend a component class from a React library, and the class component should have a render method to return the JSX code. Alright, and in order to use the greeting class component in other components, we have to export it using export keyword, and in order to import these greeting components in other component, we have to use import keyword. Next, this greeting component is reusable, so we can use this greeting component as many as times we want in the React application. For example, here let me use greeting component one more time, and you can see the changes. Welcome Umesh. Okay, next we can use props to transfer the data from parent component to child component. So in our case, app component is a parent component, greeting component is a child component, isn't it? So from app component we can pass the data to the greeting component, and we can access that data by using props. For example, here let us use name property and then pass the data, let us say Ramesh, and for this greeting component also let us use name property and then let us use name Umesh. Perfect. Next, in order to access this information we can use props, right? So let us go back to greeting component over here, and here we are using class component, so the props will automatically available in this class component. We don't have to pass props to this render method. Okay, so here let us remove this Umesh and let us get the data dynamically by using props. And in order to access the props, we have to use open close curly braces and then this dot props. So look at here, in a class component, props will automatically available. We don't have to pass props to the render method. So just access this props and then the property name. So notice here we are using this name property in an app component to assign the data, and we are using the same property to retrieve the data from the props. Okay, so this is how we can use props to transfer the data from one component to another component, especially from parent component to child component. Next, let us quickly summarize the component types. We create a functional component using JavaScript or ES6 arrow function that returns a React element. For example, here we have welcome functional component that we have created using JavaScript function, and this welcome component returns a JSX code. Next, we can also create a functional component using ES6 arrow function like this. For example, here we have welcome functional component that is created using ES6 arrow function. And on the other hand, here we have a class component that is created using ES6 class, and whenever we create a class component, that component should extend the class component from React, and this class component should use a render method to return the JSX code. Okay, so this is how the difference between functional component and class component. Next, you may have a question like which component type is recommended to use. Well, React team recommend to use functional components to build the user interfaces, and most of the React developers prefer using ES6 arrow functions to create the functional components. Well, in this course also we are going to follow the same. We are going to use functional components to build the user interfaces. Alright, so whenever you work on React projects, make sure that you use functional components to build the user interfaces and try to use ES6 arrow functions to create the functional components. Alright, great. In next lecture we will see how to import and export components in a React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into how to import and export the components in a React application. Well, here are the important points. We can export the component using export keyword, and we can import the component using import keyword. And there are two types of exports, named export and default export. We can have multiple named exports in a single file. We can have only one default export per file. We can import named export using curly braces, and we can import default export without curly braces. So let us understand these points with an example. So let us go to our VS Code IDE over here, and in order to understand importing, exporting components, let's create a new file. So go to components folder, right click, new file. Let us give file name as mycomponent.js. Within a mycomponent.js file, let's create a functional component. So here just type function and let us give component name as first component, and then here let us have a return statement and then return the heading first component. Okay, and just save it. Next, in order to use this first component in other component, we have to export this first component, right? So here let us have export. So this export is basically called a named export. Okay, and if we export something like this, export default post component, so this is called a default export. Okay, if we use export default keyword, then this is called a default export, and the earlier one, that is this one, is called the named export. Okay, and within a single JS file we can have multiple named exports. For example, here let me create one more component. So let me copy this, paste it over here, and let us give name as second component and just change the content second component. Alright, just remember, within a single JavaScript file we can create a multiple functional components and we can export them using named export. But if you want to export the functional component as a default export, then you should have a single component in a single JavaScript file. Okay, for example, if you want to export this first component as a default export, then you should have only one component per file. Okay, and you should remove this named export and you should give a default export like this, export default and then the component name. Alright, just remember, if you want to export a component as a default export, then you should have only one default export component in a single file like this. Okay, perfect. Next, let us see how to import the named export and default export. So here let me undo it and let me first show you how to import the named export. So here we have created first component, second component, and we have exported these components as a named export. Next, let us see how to import these two components. So let us go to app.js file. Now let us see how to import the named exports. Well, if you go to mycomponent.js file, so here we have exported first component, second component using named export. Next, let us see how to import these two named exports. So go to app.js, and in order to import the named export components, here we have to use import keyword and then open and close curly braces and then post component from my component file. Okay, so whenever you want to import the named export component, then you should have to use the open and close curly braces like this. Next, here let us use it. So here just type first component and close it and then show this file, and here you can see in a browser first component is displayed. Similarly, if you go to mycomponent.js file, here we have a second component and we have exported this second component using named export. So let us see how to import this second component in a app.js file. So here go to import statement, and within curly braces we have already imported post component. Along with that, let us also type second component, and here let us use it, second component. Perfect. And if you look at the browser, second component is printed. Alright, so this is how we import a named exported components in a app component like this. Okay, so make sure that you use open and close curly braces to import the named components. And let us say you want to give a different name to this component, then you can use alias over here. For example, al and just give fc. Okay, and if you save this file, you will get the error because you have given different name to this component, right? So here, instead of first component, we have to give fc, and then if you save this file, you can take a look at the browser. First component is displayed. And again, if you want to give alias to second component, you can just type as and then sc stands for second component, and just remove this second component name and then just type the alias second component. Okay, so this is how you can change the exported component name by using alias. So this is all about how to export and import the components using named export. Next, let us see default export. So go to mycomponent.js file. Here, let's create one default export component. So here, function and then component name, let us say my component, and let us have return statement, and let us print my component. Next, in order to import this component in another component, we have to export it. So far we have seen how to export the components using named export. Now we are going to see how to export the component using default export, right? So here, just type export and then append default. So this is the default export. Okay, so you can prefix the component using export default like this, or you can give this default export at the end like this. Okay, so most of the developers use this kind of syntax. Okay, now we have one default export per file. Next, let us save this file and let us go to app.js file and let us see how to import the default export component. So here, let us have import statement, import and then my component from my component.js file. So notice here, while importing the default exported component, we don't have to use the open and close curly braces. But in case of named exports, we are using the curly braces to import it. Next, let us use this my component in an app component. So here, go at the bottom and then just type my component and then close it, and then just save this file and take a look at the browser. You can see my component is displayed over here. Next, let us say how to give a different name to this my component. Well, in case of named exports, we have used alias to give the different name to the component, right? But in case of default export, we don't have to use the alias. We can simply change the component name itself. For example, here, instead of my component, let me give my C and then just save the file, and look at here, we got the error because we have given the different name to the component while importing. So here, instead of my component, just give MC and then save the file, and look at here, my component is displayed in the browser. Well, as I mentioned earlier, there should be only one default export component per file. That's why while importing the default export component, we can give any name that we want, because we showed that the file contains only one default export, isn't it? So this is all about the default export. When we create a full stack application using Spring Boot and React, we are going to use these named export and default export a lot. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into JSX. Well, JSX stands for JavaScript XML. JSX allows us to write HTML elements within a JavaScript code. Well, let us create example and let's understand the JSX with all these points. So here, let me head over to the VS Code. In order to understand the JSX, let's create a new file. So go to components folder, right click on components folder, click on new file, and let's give file name as hello world.js. And within a hello world.js file, let's create a functional component. So let us use arrow function to create a functional component. So here const and then component name hello world and then parenthesis and then arrow symbol, and here we have functional component body, and this functional component return the JSX code. For example, let us say h1 hello world. Perfect. Next, in order to use this component in other component, we have to export it. So here export default and then hello world. Perfect. Next, go to app.js and here we have app component. So within this app component, let me comment out this and just use hello world component. So here hello world and just close it and make sure that hello world component is imported at the top and just save this file and look at the browser. You can see hello world is printed. Next, let us understand the JSX. Well, if you go to hello world component, this hello world component returns a JSX code. Well, JSX basically allows us to write HTML elements within a JavaScript code. So this is a JavaScript code and JSX allows us to write this HTML element within a JavaScript code. Alright, so even we can assign this HTML element to a JavaScript variable. For example, here let me create a JavaScript variable. Let us say my element equal to, and let us assign this HTML element as a value to this variable and just return this JavaScript variable and just save this file. And if you look at the browser, hello world is printed. Okay, so it means JSX allows us to write HTML element in the JavaScript code like this. Next, let us take a look into next point. JSX makes it easier to write and add HTML elements in a React. Well, without using JSX, we can also create the user interface in a React application. Well, React provides create element method which we can use to create the React element. But this JSX makes it easier to write and add the HTML elements in React. So React team recommended to use a JSX. Okay, so now let me demonstrate how we can create the React element using create element and how we can replace this code with JSX. So let us go to VS Code and here let us see how to create the React element using create element method first. So here let me comment out this and go to return statement and here just call React and make sure that React is imported from the React library, and this React provides create element method over here, and then we need to pass the HTML element tag name. So in our case h1, and then let us pass second parameter as a null and then third parameter as a content of this HTML element. So the content is hello world and just save this file. And if you take a look at the browser, you can see hello world is printed. Well, notice here this is the JSX code and this is the react.createElement code. Which one looks easier? Obviously the JSX code looks easier, right? Because using JSX we can write the code like HTML code, isn't it? But if we use react.createElement, then we have to call this createElement method on each and every HTML element. For example, let us say we want to include this h1 tag within a div, then we have to pass div, and then here we need to again call react.createElement method, and then we need to pass the tag name h1 and then second parameter null and third parameter the content, that is hello world, and just save this file and look at the browser hello world. And next, same code we can rewrite in the JSX like this. For example, here we can just include this h1 element in a div. Alright. Okay, so if you look at the code again, using JSX we can write this much of code only, but if we use react.createElement method, then we have to write a lot of code. Okay, so this is how the JSX makes it easier to write and add the HTML element in a React. Alright, and React team recommended to use JSX approach instead of this react.createElement approach. Alright, and in this course we are going to use a JSX to create the React element or user interface. Next, let us take a look into next point. JSX will be converted into JavaScript on a browser using transpiler bubble.js. Well, React will convert a JSX into JavaScript that browser understands. Alright, so browser basically does not understand the JSX code, right? So React will convert this JSX into JavaScript using Bubble JavaScript library. So once it will convert JSX into JavaScript, then browser will load that JavaScript code in a browser. Alright, so this is how the JSX works in a React application. Next, JSX rules in a React. Well, here I have listed certain rules that we can follow while writing JSX code in a React. The component should return a single React element. Well, let us say you have multiple HTML elements in a JSX, then you have to return one parent React element. For example, so here let me go to Visual Studio Code ID and let me demonstrate that. So here let me remove this, and let us say you have multiple HTML elements in a JSX. For example, return h1, let us say title, and you have one more HTML element, let us say h2, and let us pass subtitle, and then let us say you have a paragraph, and let us call it as paragraph, and let us say you have image. Well, whenever you have multiple HTML elements in a JSX, then you have to wrap all these multiple HTML elements in a single parent HTML element. So most of the time we use div. For example, here let us wrap all these HTML elements in a div like this. Alright, so this is the important point. So whenever you have multiple HTML elements in a JSX, then make sure to wrap all those HTML elements within a single parent HTML element. So most of the time we use div or we use fragment. For example, so here instead of div we can also use the fragment. So this is the empty tag. So this is basically called a React fragment. Okay, so either you can use div or fragment. Next, let us save this file, and if you take a look at the browser, the content is not displayed in a web page. Well, whenever you have multiple HTML elements in a multiple lines, then make sure that you include all these multiple HTML elements in a parenthesis. For example, after this return statement, let us have a parenthesis, and within a parenthesis just copy and paste this code. Okay, now if you save this file and if you take a look at the browser, the content is displayed: title, subtitle, paragraph. Okay, so these are the two important points. So whenever you have multiple HTML elements in a JSX, then make sure that you wrap all these multiple HTML elements in a parent HTML element. Either you can use div or fragment. Next, if you write the HTML code in a multiple lines, then make sure that you keep this HTML code within a parenthesis. Next, let us take a look into next point. To write the HTML on multiple lines, put the HTML code inside a parenthesis. Well, this point I have already demonstrated. Next, use camel case for HTML attributes. To specify the CSS classes for an HTML element, use the class name attribute instead of class attribute. This is because class is reserved keyword in a JavaScript. Well, in order to style the HTML element in a JSX, we have to use class name attribute instead of class attribute, because the class attribute is reserved keyword in a JavaScript. Next, event handlers in a JSX are specified using camel case syntax. For example, on click instead of on click, or on change instead of on change. Well, if you look at the naming convention for this event handler, on click, so this is a camel case, right? But you can see the on click, so this is the HTML attribute. But if you want to use this HTML attribute in a JSX, you have to use the naming convention as a camel case. Next, let me demonstrate these 2 points. So let us go to Visual Studio Code ID over here, and here let us first create the CSS class. So we can create a CSS class within app.css. So go to app.css, and here just type dot, and let us give the class name as title, and then within a curly braces just type color. So let us give title color as a red. Just save this, and let's go back to hello world.js, And here, in order to add the CSS class to the HTML element, we have to use class name property. For example, here go to HT1 element and just type class name and then pass title CSS class, and then just save this file. And if you look at the browser, title is in red color. Okay, so this is how we can use class name property to add the CSS class. Alright, and if you use class attribute, this will give the error. For example, if you go to browser and here just inspect this page, right click, inspect, and if you go to console, here you can see invalid DOM property class. Did you mean class name? Alright, so browser will give hint like instead of using class, just use class name in a React. Alright, it means the class is a result keyword in JavaScript. That's why whenever we want to add a CSS class to the HTML element in a React, we have to use class name property like this. Alright, perfect. Next point is event handlers in a JSX are specified using camel case syntax. For example, on click instead of on click. So let us go to Visual Studio Code ID, and here let me remove this image, and here let me add the button, and let us add the handler by using on click attribute. Well, if you can notice here, in a plain HTML we use the attribute that is on click, and if you look at here, the on click attribute in a lowercase. Okay, and same on click attribute we want to use in a JSX, we have to use camel case. For example, here instead of on click, let us type on click, and this on click should be in a camel case. Alright, and next let us pass the event handler name. Let us say handle click. Well, in a plain HTML element, in order to specify the event handler name, we have to use the string. For example, like this. Right, but in JSX we have to include the handler name within a curly braces. For example, like this, handler click. So this is the event handler name. Next, let us use a JavaScript function to handle this handle click. So here just create one JavaScript function handle click, and then just let's have a alert statement. Let us say button clicked, and then just save this file. Alright, and let us give name to the button here. Let us say click, and then save this file. And if you take a look at the browser over here, the click button is visible in the page. Next, go ahead and click on this click button, and there we go, the alert is popped up. It says button clicked. Okay, next click on OK button. Alright, so this is how we can specify the event handler in a JSX using the on click, and the on click should be in a camel case. Okay, perfect. Next, let us take a look into next point, expressions within a curly braces. You can embed JavaScript expressions within a JSX elements by wrapping them in a curly braces. Well, JavaScript expressions can be a variable or an expression. For example, let me demonstrate this. Let's go to Visual Studio Code ID, and here let me create one JavaScript variable. Let us say const name, and let us give name Ramesh. So if you want to use this JavaScript expression in a JSX, we have to wrap this expression within a curly braces. For example, here after this paragraph, let me use one more paragraph, and in order to access this name in this HTML element, we can use open and close curly braces and just pass name. And if you save this file, and if you take a look at the browser, you can see Ramesh is displayed in a web page. Alright, so this is how we can access the JavaScript expression or a variable within a JSX by using open and close curly braces. Next, let us take one more example. Let us say const and then addition 1 plus 2, and then let us use this addition in a JSX by using curly braces. For example, let us use paragraph element over here, and then within a curly braces just call addition and then save this file. And if you take a look at the browser, you can see 3 is printed. Alright, so JSX will basically execute this expression and it will print the result like this. Alright, great. Next, let us take a look into next rule. JSX follows XML rules and therefore HTML elements must be properly closed. If an element does not have any children, you can use self-closing tag. For example, if you go to VS Code and if you go to app.js file over here, and if you look at the component, so here we are using hello world component within an app component, and this hello world component don't have any content within it. That's why we have used self-closing tab to close this hello world component like this. Okay, so make sure that whenever you use the component or any HTML element in a JSX, make sure that you close them. Alright, so these are the important rules that you have to keep in mind whenever you work with JSX in a React. So these are the JSX rules I have listed over here as per my experience. So just try to follow these rules to write the JSX code. Alright, great. In next lecture, we'll take a look into the props. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into props. Well, the props is a special keyword in React that stands for properties and is being used to pass the data from one component to another component and mostly from parent component to child component. Alright, so props is a special keyword in React that stands for properties, and we use props to transfer the data from parent component to child component. Next, we can say props is a data carrier or means to transport data. Next, React props is an object which you get instantly when you create a React component. Well, whenever you create a React component, either functional component or class component, you will get a props empty object, and then you can store the properties in a props empty object. Alright, so let us go ahead and let's understand more about props with an example. So let us go to VS Code ID over here. Well, in order to understand props, let us create a new file. So go to components folder over here. Within that, let's create a new file and let's give a name as student.js. Within a student.js file, let's create a functional component, and we are going to use arrow function to create a functional component. So here just type const and let us give the component name student and then parenthesis and then flat arrow symbol, and within a functional component let us write the JSX code. So here let us have a return statement and then parenthesis. Within that, let's have a div as a parent element, and within div let's have a h1 element to give the heading. So let us say student details. Alright, next let us print the student first name. So let us say student first name. As of now, let us hard code it. Let us say Ramesh, and then let us also print the student last name. Let us say Partare, and let us also print student email address. Let us say ramesh@gmail.com. Perfect. Next, let us export the student functional component using default export. So here just type export and then default and then followed by the component name. Perfect. Next, let us go ahead and let us use this student component in an app component. So go to app.js file over here and go to app component, and here let me comment out this hello world component, and here let us use student component and make sure that student component is imported at the top. Alright, next save this file, and if you look at the browser over here, you can see the student first name, last name and email address is printed over. Alright, next let us go ahead and let us see how to use props to transfer the data from app component to student component. Well, as of now you can see the student component, we have hard coded the value first name, last name, email address. Right, now let us use props to transfer the data from app component to student component dynamically. Okay, so go to student over here, and here let us pass the information. So first name is the property name, and let us give value Ramesh, and then last name, let us give value as a Padtare, and then email, let us give value as ramesh@gmail.com. Perfect. Now we have passed the data to the student component. Next, let us use props to access these property values in a student component. So let us head over to student component over here, and in order to use props, we have to pass props as a parameter to this student. So here just pass props. Okay, perfect. Next, let us go ahead and let us retrieve all the properties from the props. So here let us remove this hard-coded value Ramesh, and let us have curly braces. Within that, let us call props, and the property name is first name. Alright, so whatever the property name you have given while assigning the data, same property name you have to give. For example, if you go to app.js, you can see here we have given the property name first name. Same property name you have to use while accessing the data from the props. Okay, next let us remove this Padtare and let us use props, and then property name last name. Similarly, let us do it for email as well. So within a curly braces, props dot email. Perfect. Next, let us save this file and let us take a look at the browser. You can see here student first name last name email is printed. Next, let us reuse this student component and let us pass the different data dynamically. So go to app.js, and here let us reuse this student component and make sure to close it. Next, let us pass the student data. So here first name, so let us give Umesh, and then last name, let us give Padtare, and then email umesh@gmail.com. Perfect. Next, save this file, and if you take a look at the browser over here, the another student, that is Umesh student, is also displayed over here. So this is how we can reuse the existing component, and just we need to pass the information. Okay, perfect. Now let us go ahead and let us see how to pass the object from parent component to child component. Now we have passed the string. Next, let us see how to pass the object from app component to student component. So first of all, here let us create the object const student, and then first name, let us say Ramesh, last name Padtare, and then email ramesh@gmail.com. Perfect. Next, we need to transfer this student object from app component to student component. So let us see how to do that. So here, first of all, let us remove all this, and here let us give property name as student, and then within a curly braces just pass the object, that is student. Next, let us see how to use props to get this student object in a student component. So before that, let us comment out this code. Alright, perfect. Next, let's go to student component over here, and here we have props. So we should get the student object from this props, right? So here, in order to get the student, so here is the syntax: props dot student is the property name, and then student object has first name attribute. Next, props dot student dot last name, and then props dot student dot email. Well, if you go to app.js, you can see here the property name student, and if you go to student.js, here we are using the same property name. Okay, and the student object has first name last name email, right? So this is how we can use the syntax to retrieve the student object first name last name email. Next, if you save this file and if you look at the browser, you can see the Ramesh student details is displayed over here. Alright, so this is how we can pass the object from parent component to child component using props. Okay, perfect. Next, if you go to app.js file over here, so here let us pass the different student information. Let us say Sanjay, last name Jadhav, and email, let us say Sanjay, and just save this file. And if you take a look at the browser, the Sanjay student details is successfully displayed. Alright, perfect. Next, let us see how to use props to transfer the array from one component to another component. So instead of passing the object, let us pass the array. So here let me comment out this, and here let me quickly create the array const, and then let us give the array name as skills, and let us provide the elements in the array. Let us say HTML, CSS, JavaScript. Perfect. Now we have array. Next, we need to pass this array to the student component using props. So here what we'll do, we'll just give property name as data, and we'll pass skills over here. Perfect. Next, let us change the student component to get this skills data using props. So go to student component, and here we have props. So let us get the array from this props. So here what I will do, I will comment out this, and I'm going to create one more paragraph element. Alright, and here let us say array data, and within a curly braces props dot data. Next, save this file, and if you take a look at the browser, you can see array data, HTML, CSS, JavaScript. Alright, so this is how we can pass the array data from one component to another component. Alright, just remember, we use props to transfer the data from parent component to child component. Alright, so this is all about props. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we pretty much understood about props. In this lecture, let us take a look into destructuring props. Well, destructuring was introduced in year 6. It's a JavaScript feature that allows us to extract multiple pieces of data from an array or object and assign them to their own variables. In React, destructuring props improves code readability. Well, there are two ways to destructure props in a functional component. The first way is destructuring it in a function parameter itself. The second way is destructuring props in the function body. So let us go ahead and let us see how to destructure props with an example. So let us go to VS Code ID over here. In previous lecture, we have created student functional component to demonstrate the props. In this lecture, let us use the same student functional component to demonstrate destructuring props. So here, go to the JSON code, and here let us uncomment this, and here let us remove this student. Just keep props dot first name and props dot last name, and then props dot email. Perfect. Next, go to app.js file over here, and here just comment out this and just uncomment this. Okay, now save the file, and if you look at the browser, the image student details is printed. Okay, next go to student component over here, and here let us remove this array data paragraph element, and next save this file, and if you look at the browser, the image student details is displayed over here. Now let us go and let us see how to destructure these props. Well, there are two ways. First way is we can destructure these props in function parameter itself. For example, here this props contains first name, last name, email properties, right? So here we can destructure like this. So within curly braces, just pass first name, comma, last name, comma, email. So this is the syntax to destructure the props. Next, while accessing these properties, we don't have to use props. For example, here let us remove this props, just keep first name, and here remove the props, just keep last name, and here also remove props and just keep email, and then save this file. And if you take a look at the browser, you can see student details is successfully printed. Okay, so this is how we can destructure the props in a function parameter itself. Well, here destructuring allows us to extract some of the data from an array or object and assign them to their own variable. For example, here we have extracted first name, last name, email from the props, and we have assigned them to its own variable like first name, last name, email, and we are accessing these variables over here. So we can also extract only first name, last name from the props by using destructuring like this. If you save this file, and here we got email is not defined, so we can simply remove this, and you can see Umesh Padhar is printed over here. Well, notice here, even though the props object has first name, last name, email, but we are only extracting first name, last name from the props object using destructure feature like this. Alright, perfect. Next, let us say how to destructure props in a function body. So here we have destructured props in a function parameter itself. So let us see how to destructure props in a function body. So let us cut this and go to function body, and let us have a const and then paste this and then props, and then this props we should pass as a parameter to student. Perfect. Next, if you save this file and if you take a look at the browser, you can see still the student details is printed properly. Next, let us say we want to only extract the first name, last name from the props object. Then what we can do is we can simply remove this email, and here also we need to simply remove this paragraph element. Alright, so even though this props has first name, last name, email, but we are only extracting first name, last name from the props object using destructuring feature like this. So basically here we are extracting first name, last name from the props object, and we are assigning them to the separate variables, that is first name, last name, and we are accessing these variables in a JSX code like this. Alright, so this is how we can destructure the props in a functional components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into state object and set state method in a class components. Well, the state is an inbuilt object in a React class components. In a state object, we can store property values that belong to that particular class component. When the state object changes, the class component re-renders. We use setState method to change the state object in a class component. Well, notice here we are talking about the class components, not the functional components. Alright, so we can use state inbuilt object in only class components, not in the functional components. Alright, well, let us understand about state object and set state methods with an example. So let's go to VS Code IDE over here, and here let's create a new file. So go to components folder. Within that, let's create a new file. Let's call it as employee.js. Next, within employee.js file, let us create a class component. So before that, let's first import React from React library. Alright, next let us type class. Let us give component name as employee. So this employee component should extends react.component. Okay, perfect. Next, here let us have a constructor. This constructor takes props as a parameter, and then let us have a super and then pass these props to the super class constructor. Next, within a constructor, let us specify the state object. So here just type this dot state, and notice here whenever we create the React class component, then this state inbuilt object is immediately available. Okay, next let us choose state over here, and then within a state inbuilt object we can define the property and its values. For example, here let us say first name as a property and value as a Ramesh. Alright, perfect. Next, let us say how to access this state object and its property is in a JSX code. So after this constructor, let us have a render method, and then let us have a return statement, and then parenthesis, and then let us have a div. Perfect. So within a div, let's have a h1 element, and let's give heading something like employee details. Next, let us have a paragraph element. Next, we want to access the state object property, that is first name, right? So here is the syntax. Within a curly braces, this dot state dot first name. So this is the syntax to access the state object property. Alright, perfect. Next, in order to use this employee component in an app component, we should have to export this component, right? So here let us use default export to export this employee class component. So just type export default and then employee. Perfect. Now we have used default export to export this employee class component. Next, let us use this employee class component in an app component. So go to app.js file over here and let me expand this, and here let me comment out this student, and here let us use employee component. So just type employee and hit enter and just close it, and make sure that this employee component is imported at the top. Next, just save this file, and if you take a look at the browser, you can see Ramesh employee detail is printed over here. And if you go to employee component, you can see we have accessed this first name property from the state object. So this is how we can access the property from the state object. Next, we can have as many as properties and its values in a state object. For example, here let us have a last name property and its value, let us say Patare, and we can access this last name property from the state object using the same syntax. So here let us have paragraph element, and then within a curly braces this dot state dot last name, and if you save this file and if you take a look at the browser, the Patare is displayed over here. Similarly, let us also have an email property and then ramesh@gmail.com, and let us access this email property from the state object over here. So let us have a paragraph element within a curly braces this dot state dot email. Save the file, and if you take a look at the browser, the email is displayed. Okay, so this is how we can use inbuilt state object in a class component to define the property and its values. Next, in order to access the state object, we can use the syntax this dot state dot property name. Alright, perfect. Next, let us see how to update this state object using set state method. So here, first of all, let's create one method. Let us say update employee, and then within the update employee method, let us use set state method to update the state object. So here set state, and then within a curly braces first name. So let us update from Ramesh to Ram, and also update the last name from Padatari to Jadhav, and also update the email ram@gmail.com. Next, let us have a button, and whenever user click on that button, then this update employee method will get called. So here go to div, and after that let us have a button over here. Next, let us give name to the button. Let us say update employee. Next, let us attach the event handler to this button. For that, let us use onClick attribute. Well, this is a class component, so we have to call the event handler using arrow function. So within curly braces, just have a arrow function over here. In order to call the event handler, just type this dot, the event handler name, update employee, and then parenthesis. Next, save this file, and if you take a look at the browser, update employee button is visible. Next, let us refresh this and go ahead and click on update employee button over here, and there we go. The employee details successfully updated from Ramesh to Ram, Padatari to Jadhav, Ramesh@gmail.com to Ram@gmail.com. So notice here the code. Once user click on this update employee button, then this update employee event handler will get called, and within this update employee event handler, we have used set state method to update the state object. Okay, so just remember, class component has an inbuilt state object. So within this state object, we can define the properties, and in order to access the inbuilt state object, we can use the syntax like this dot state dot property name, and in order to update the state object, we use set state method like this. So this is all about state object and set state method. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen how to use state object in a class component to manage the state of the component, and we have also seen how to use setState method to update the state object in a class component. Now the question is, only class components has an inbuilt state object, then how to define the state variables in a functional components? Well, the answer is hooks. So we can use state hook to define the state variables in a functional components. Alright, the use state is a hook that allows us to have a state variables in a functional components. Well, here hook is nothing but a function that allows us to use the React features in a functional components. For example, the React features like state object, lifecycle methods and other React features. So just remember, hooks are nothing but a functions that allows us to use React features such as state object, lifecycle methods in a functional components. For example, here we are using use state hook that allows us to use state variables in a functional components. So in order to use state hook in a functional component, first we need to import use state hook from the React library, and then use state hook is a function that takes initial value as a one argument and it returns the two values. One is the current state and another is a function that updates the current state. Okay, so let us understand the use state hook with an example. So let us go to VS Code IDE over here, and here let's create a new file. So go to components folder and then let's create a new file. Let's give name as user.js. Let's expand this, and here let's create a functional component using arrow function. So just type const, let's give component name as user and then parenthesis and then arrow symbol. Perfect. Next, here let us use state hook to define the state variables. So just type use state and make sure that you import use state hook from React library. So just click on it and notice here use state hook is imported from the React library over here. And again notice here use state hook is nothing but a functional component and it is imported using named export. That's why we have imported using curly braces here. Alright, perfect. So here use state hook is nothing but a JavaScript function and it takes one argument, that is the initial value. So here let us give initial value as empty. Next, this use state hook returns an array. So here let us destructure it. So array, and the first value is the current state. So let us give state variable name as first name. Second value is the function that we can use to update this first name state variable. So here let us give the function name as set first name. So this is the syntax to use state hook. So if you can notice here, use state hook takes initial value as a first argument and this use state hook returns an array, and the array contains exact two values. The first value is current state variable name, second value is the method that updates the current state. Okay, perfect. Next, let us write the JSX code and let us access this state variable in a JSX code. So here what I'm going to do is we're going to have a return statement and then parenthesis and then let us have a div, let us have h1 element and let us give heading as a employee details or user details. Perfect. After that let us have paragraph and then here let us access the state variable using open and close curly braces and then just call first name. Okay, so look at the syntax. In order to access the state variable that is defined by use state hook, we just have to use the syntax like this. Within a curly braces we just need to call the state variable name like this. Okay, perfect. Next, in order to use this user component in app component, we have to export it. So here let us use default export to export this component. So just type export and then default and then user. Perfect. Next, let's go to app.js, go to app component and here let us comment out this employee component and let us use user component. So here user, and make sure that this user component is imported at the top. Alright, perfect. Next, let us save this file. And if you take a look at the browser, user details, and if you again go to the user.js file and go to user component, the initial value for this first name is empty. That's why nothing is displayed here. Okay, so let us give initial value as a Ramesh. Next, if you save this file and if you take a look at the browser, Ramesh is displayed over here. Okay, so this is how we can use useStateHook to define the state variable and assign the initial value to this state variable. Next, let us use useStateHook to define one more state variable. So here const and then array. Let us use state variable name as last name, and then method set last name, and then use state, and then pass the initial value for the array. Next, in order to access this last name state variable, here let us have paragraph element within a curly braces, just pass last name. Perfect. Next, save this file, and if you take a look at the browser, further is displayed over here. Similarly, let us define one more state variable using useStateHook. So here let us copy this, paste it over here, and let us use state variable name as email, and let us use method name as set email, and here let us use initial value as ramesh@gmail.com, paragraph within a curly braces, just call email state variable, and then save this file. And if you take a look at the browser, email is printed. Okay, so this is how we can use useStateHook to define the state variables in a functional component. Next, let us see how to update the state variables using the corresponding set methods. For example, here in order to update the first name state variable, we have to use set first name method, and in order to update the last name state variable, we have to use set last name method. In order to update the email state variable, we have to use set email method. Okay, so let us go and let us see how to update these state variables using the corresponding set method. So here let us have one button. Let us give button name as update user. Next, let us attach onClick event to this button. Well, whenever user click on this update user button, then we have to create a event handler method that will handle this update user event, right? So here let us have onClick attribute, and let us pass the event handler name. Let us say update user. Next, let us add the implementation for this update user event handler. Let's create a JavaScript function, and let's give name as update user. Next, within update user method, let us call set first name method to update first name state variable. So right now the first name state variable contains the initial value Ramesh. So let us update the initial value from Ramesh to Ram. So here go to update user method again and just call set first name and then pass value as a Ram. Next, just save this file. Next, let us call set last name, and then let us update the last name state variable from Padhatare to Jadhav. Next, let us call set email method and then pass ram@gmail.com. Perfect. Now we have used set first name method to update the first name state variable. We have used set last name method to update last name state variable, and we have used set email method to update email state variable. Alright, perfect. Next, save this file, and if you go to browser, here you can see update user button is visible. Next, go ahead and click on this update user button over here, and look at here, the user details are updated. Earlier it was Ramesh, now you can see Ram. Okay, and similarly the last name and email also updated. Alright, so this is how we can update the state variables using the corresponding set methods. Okay, perfect. Next, let us see one more example using useStateHook. In previous example, we have passed string to the useStateHook, but we can also pass the object or array to the useStateHook. For example, here let us comment out this, and here let us use use state hook and let us pass initial value as an object. Okay, and then let us have property first name Ramesh and then last name Padthare and then email ramesh@gmail.com. Perfect. So this is how we can use state hook to pass the object. Next, this use state hook returns an array with two values. So here let us have a destructuring array and the state variable let us give user and the method name is set user. Next, save this file and go to return statement, go to div, and here we have used first name, last name, email state variables, but here we are not using these state variables. We are using the user object. It has first name, last name, email properties, right? So in order to access the user object properties, we have the syntax like this: user dot first name. Okay, similarly user dot last name and then user dot email. Okay, perfect. Next, save this file, and if you go to update user method, within that we have used set first name, set last name, set email methods, right? Right now we are not using these methods, so let us comment it out. And if you take a look at the use state hook, in order to update the user object state variable, we have to use set user method. So go to update user again, and here just call set user method, and then let us have its property first name. Let us update the first name from Ramesh to Ram, and then last name property let us update from Padthare to Jadhav. So either you can use single quote or double quote, and then email ram@gmail.com. Perfect. Next, save this file, and if you take a look at the browser, Ramesh Padthare ramesh@gmail.com. So these user details successfully displayed, and along with that you can see update user button. So go ahead and click on this update user button over here, and there we go. The user details are successfully updated. So this is how we can update the user state object using set user method. Alright, so this is the example that demonstrates how to use state hook to define the user state object as a state variable. Alright, great. So this is all about using use state hook in a functional component. Alright, so just remember we use state hook to define the state variables in a functional components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will see how to perform event handling in a React application. Well, in React, event handling allows you to handle user interactions such as button clicks, form submissions or mouse movements within your React application. Event handling in React follows similar pattern to standard JavaScript event handling, but with some differences. React events are written in camel case syntax, for example on click instead of on click. So this on click is a camel case. React event handlers are written in inside a curly braces. For example, here you can see on click within a curly braces, shoot is the event handler name instead of on click, and here we are passing shoot event handler name within a double quote, right? But in React we typically pass the event handler's name within a curly braces like this. Alright, so let us go and let us understand how to perform event handling in React application with an example. So let us head over to VS Code IDE over here, and here I am going to create a new file. Go to components folder, within that create a new file. Let's call it as event handling.js. Perfect. Next, let me expand this, let me minimize this, and within a event handling.js file, let's create a functional component using arrow function. So here const, and then let's give functional component name as event handling, and then parenthesis, and then arrow symbol. Next, within a event handling functional component, let us maintain count state variable using use state hook. So here let us call use state hook from React library, and make sure that use state hook is imported at the top. Next, let us destructure it. So here const and then let us give the state variable name as count, and then the method name set count. Next, let us give the initial value to this count state variable as 0. Okay, perfect. Now we have maintained count state variable using useStateHook. Next, let us have a return statement over here, and within a return statement we are going to write the JSX code. So within a parenthesis, let's have a div as a parent element, and within a div, then let us first print the heading by using h1 tag. Let us give the heading something like event handling example. Next, let us use paragraph element over here, and then let us print the current count by using count state variable. So here, in order to access the count state variable in a JSX, we have to use curly braces. So within a curly braces, just pass count state variable name here. Next, let us create a button. Let us give button name as increment, and here let us attach the onClick event. For that, let us use onClick property here, and notice here the React event should be in a camel case. Okay. Next, we need to pass the event handler name within a curly braces. For example, here let us give event handler name as handle click. Okay. So whenever user click on this increment button, then this handle click function will be triggered. So let us implement this handle click function over here. So here just type function and then handle click. Alright. Next, in order to update the count state, we have to use set count method. So here just call set count method and then increment the count by 1. So count plus 1. Alright, perfect. Next, here let's create one more button, and let us give name as reset, and let us attach onClick event to this button. So let us type onClick, and then let us pass the event handler name within a curly braces, handle reset, something like that. Next, let us implement this event handler over here. So here function and then function name handle reset, and then call set count method and then pass 0. Well, handle reset function will get triggered when reset button clicked, and this handle reset function will set the count value back to 0 by using set count method. Okay, perfect. Next, let us save this file, and here you can see we haven't exported this component yet. So let us use default export to export this event handling functional component. So here just type export default and then component name, that is event handling. Perfect. Next, let us open app.js file over here, and within app.js file, let me comment out this, and here let us use event handling component, and make sure that event handling component is imported at the top. Perfect. Just save this file, and if you take a look at the browser, you can see initially the count value is 0 and increment and reset buttons are displayed over here. Next, let us go ahead and click on increment button over here. So look at here, the count value is incremented by 1, and again if you click on increment button one more time, you can see the count value 2. Alright, and if you click on reset button, it will reset the count value back to 0. Okay, it means we have successfully handled the onClick event. Well, here in heading we have a typo, so this should be handling. Perfect. So this is how basically we perform event handling in React. Well, let me recap what we have done. We have created a functional component named event handling. Within this functional component, we have maintained count state variable using useStateHook. Next, this handle click function is get called when the increment button is clicked, and this function updates count state by incrementing it by 1 using set count method, and this handle reset function set the count state value back to 0. Well, in this example we have seen onClick event handling, but in upcoming lectures we'll also take a look into form handling, and within a form handling we'll learn how to perform different events like on submit event, on change event, etc. Alright, so this is how we can perform event handling in React. And just remember the syntax. React event should be in a camel case, for example like onClick, and the event handler should be passed in a curly braces like this. Okay, perfect. I will see you. Hi everyone, welcome back. In this lecture, we'll take a look into conditional rendering in React application. Well, conditional rendering in React allows you to render different content or components based on certain conditions or state values. It helps you dynamically control what gets displayed in your UI based on certain conditions. Well, there are different ways to implement conditional rendering. For example, we can perform conditional rendering using if-else statement. We can implement conditional rendering using ternary operator. We can implement conditional rendering using short circuit operator. Alright, so these are the three different ways to implement conditional rendering, and in this lecture we will see all these different ways to implement conditional rendering. So let us begin with conditional rendering using if and else statement. So let us head over to Visual Studio Code IDE over here, and here first of all let's create a new file. Go to components folder. Within that, let's create a new file named conditional rendering.js. Next, let us maximize this, and here let's create a functional component named conditional rendering. So here let us use const and then conditional rendering is the component name, and then parenthesis and then arrow symbol. Perfect. Next, within a conditional rendering functional component, let us maintain the state variable using useStateHook. So here let us use useStateHook and make sure that useStateHook is imported at the top from React library. And then here let us perform the destructuring. Like let us use the state variable name as is logged in is the state variable name, and let us use the corresponding setter function, that is set is logged in, and then let us give the initial value as a false. Okay, it means user is not logged in. Alright, perfect. Next, let us have if else statement over here. If is logged in, then we will return the JSX code. So let us have paragraph element and let us say welcome user. Perfect. Else return please log in. Okay, perfect. Next, let us export this component by using default export default and then component name conditional rendering. Perfect. Next, let us go to app.js file, and here go to app component, go to return statement, and here let us comment out this and let us use conditional rendering component, and make sure that conditional rendering component is imported at the top. Okay, just save this file, and if you take a look at the browser, please login is displayed. Well, if you go back again to the conditional rendering component over here, you can see initially the is logged in state variable value is false, and if you look at the if else condition, if is logged in is true, then this functional component will return welcome user, and if is logged in state variable has a false value, then it will return please login, and that is what get displayed in a browser. Okay, so this is logged in state variable has initial value false. That's why this functional component will return please login, and this please login is printed over here. And if you pass true over here, for example, and if you save the file and if you take a look at the browser, you can see welcome user is displayed. So this is how we can use if else statement to conditionally render different content. Next, instead of returning, we can assign this HTML code to variable as well. For example, here let us say let message and then remove this return and then assign this part to message variable, and again here message. Next here let us have return statement, and then let us have a div over here within a parenthesis, div, and then here within a curly braces just call message, and then save this file. And if you take a look at the browser, you can see still welcome user is displayed. And if you pass the false value here, and if you save the file, and if you take a look at the browser, you can see please login is displayed. Okay, so this is how you can use if else statement to return the JavaScript variable. It contains the JSX code. Okay, next let us have button over here. So here let me add break element, and let us have a button. Let's give button name as login, and let us attach the onClick event to this button. For that let us use onClick attribute, and let us pass the event handler name handle login. Next let us implement this handle login event handler over here. So here just type function and then handle login, and here let us use set is logged in method to set the value to this state variable. So here let us give value as a true. It means whenever user click on this login button, then this is logged in state variable will be updated with the true value. Okay, perfect. Next let us save this file, and if you take a look at the browser, login button is displayed over here. Next click on this login button, you can see welcome user is displayed. Alright, so this is how we can use if else statement to conditionally or dynamically render the content based on the condition like this. Okay, perfect. Next approach is conditional rendering using ternary operator. So let us go back to VS Code over here, and let us use ternary operator to dynamically display the content. So we can use ternary operator within a JSX code itself, but if you can see the if else condition, we are using if else condition outside the JSX code. Okay, but we can use ternary operator within a JSX code itself. Alright, for example here let us remove this, and here within a curly braces just have a ternary operator. So here is the syntax, just call the current state variable, that is logged in, and then question mark, and then if this is logged in is true, then we'll display welcome user. So just copy this, paste it here. If is logged in false, then we'll display please login. So just copy and paste it over here. Okay, so this is how we can use ternary operator to reduce some amount of code. So if we use if else, then we need to write this much of code, but if we use ternary operator, then we can write this much of code. Alright, so ternary operator is pretty useful because we can use ternary operator in a JSX code itself to render the content dynamically. Alright, so notice here the ternary operator has a syntax like the variable name, and then expression 1, and then expression 2. If the variable is true, then this expression 1 will get evaluated, and if this variable value is false, then this expression 2 will get evaluated. Okay, and in this case this is logged in variable contains true value, that's why this expression is get evaluated, and this is what displayed in a browser. Next let us go to browser over here, and let us refresh this, and the initial value for this is logged in state variable is false, that's why you can see please login is displayed over here. Next if you click on this login button, you can see welcome user is displayed. Alright, perfect. Next let us take a look into next approach, conditional rendering using short circuit operator. So let's go to VS Code over here, and here just remove this, and here let us use the short circuit operator and. Okay, it means if is logged in state variable has a value true, then only this expression will get evaluated, otherwise nothing will display in the browser. For example, just save this file, and if you go to browser, just refresh, and you can see nothing is displayed because this is logged in state variable has a value false. If this is logged in variable has a value true, then only it will display this part, otherwise it won't display anything in the browser. Okay, next if you click on login, it will display welcome user because this is logged in state variable has a value true. Okay, so this is how the short circuit operator works. Okay, so whenever you want to display something or nothing, then you can go ahead and use this short circuit operator. Alright, so these are the three different ways to implement conditional rendering in a React. Okay, perfect. I will see you in the next lecture. Hey there everyone, Ramesh here, back again with another video. In this video I am going to show you how to create a React application using Vite tool. Well, earlier we were using create a React app tool to create a React application, but alternative to create a React app we have one more tool, that is Vite. Well, nowadays React developers prefer using Vite tool to create the React project. So in this video I am going to show you how to use Vite to create a React project. Well, Vite is a build tool that aims to provide a faster and learner development experience for modern web projects. Well, using Vite we can create the React application faster, and basically Vite bundles the React application very faster. Alright, so let's go ahead and let's see how to create a React project using Vite build tool. Well, here you can see Vite supports two templates, one is JavaScript and another is TypeScript. So using Vite we can create different applications, like we can create JavaScript vanilla project, Vue project, React project, and so on. And we can use Vue to create a different TypeScript applications like vanilla TypeScript, Vue TypeScript, React TypeScript, and so on. In this video I am going to show you how to create a React application with JavaScript template using Vite tool. So let's go to Visual Studio Code IDE. So here I have created Vite workspace folder and I have opened this Visual Studio Code IDE in this folder. Alright, next let us use Visual Studio Code IDE built-in terminal to execute the commands. So here we have a terminal, so click on new terminal over here. Next here just type the command npm. So make sure that you have installed Node.js and npm in your machine, because in order to create the React application using Vite we have to use the npm command. So here npm followed by create and then Vite. So we are going to use a latest version of Vite. So here add latest and then followed by the project name. So here let us say Vite React app, something like that. So this is the command that we can use to create a React application using Vite build tool. Next go ahead and hit enter, and notice here it prompts select a framework. So here we have vanilla, Vue, React. So we are going to use React. So here let us select the React and hit enter, and here we need to choose the template. So we are going to use JavaScript. So here let us select the JavaScript and hit enter, and now you can able to see here the project is created. So if you can see here, within a Vite workspace folder Vite React app application is created. So just expand and here you can see here this is the project structure. Next here you can see couple of commands. So just follow these commands and just run this application. So here just type cd and then followed by the project name, that is Vite React app, and then hit enter. Now we are in a Vite React app application. Next just type the command npm install. So just follow these three commands, okay, and then hit enter. So this will install all the dependencies for our React application. So just wait a couple of seconds. Now we have installed all the dependencies. Next, in order to run the React application, just type the command npm run dev and hit enter, and there we go. Our React application is deployed in a local development server which is running on port 5173. So just copy this URL and go to browser, in a new tab just paste it and hit enter, and there we go. Our React application is up and running. Next let us go ahead and let's quickly understand the project structure for our React application. So here we have package.json file. So within a package.json file you can see all the dependencies. For example, here you can see dependency section, and within that we have a React and React DOM dependencies. Next, here we have scripts section, and within that we have different scripts to build the React application, to run the React application, and to preview the React application. And here we have dev dependency section. Alright, and whenever we execute npm install command, then npm install command will download all the dependencies as per the dependency section, and it will create node_modules folder, and it will keep all the downloaded JavaScript dependencies within the node_modules folder. Next, we have index.html file. Well, this is the single page React application. So in this React application we have only one HTML file, that is index.html file. And if you can notice here, within this HTML file we have a body, within that we have a div with the ID root. So whatever the components that we are going to create in a React application, that components will be rendered within this div. Alright, next, expand src folder, within that we have main.jsx file. So within a main.jsx file you can see we have react dom.create root, and here document.get element by id, and then we have passed the root as a id. Well, in index.html file you can see we have a div with id root, right? And in main.js file you can see document.get element by id, and then this is the root. So whatever the components that we are going to create in a React application, that components will be rendered within this div by using this statement. Okay, right now you can see we have only one component, that is app component. So basically app component is a root component, and we import the other components within an app component. Just remember, this statement is responsible to render the components within a div. It has id root. Next, we have app.jsx file. So this file contains an app component. So app component is basically a root component, and this is the default generated code. So we can simply remove this code and we can write our own code. Alright, next let me remove this import as well. This is the unused import. Next, we have app.css file. So this file basically contains all the CSS styles. So right now we can remove all this because we are not going to use it. Next, we have index.css. So this file also contains all the CSS styles. So let me remove this as well. Next, we have assets folder. So within assets folder we keep all the images and other static files. Next, we have a public folder. Within a public folder we can keep the static files such as images, svg files, videos, and etc. Alright, so this is a very simple project structure of our React application. Next, we have one more important file, that is vite.config.js. So within this file we can configure all the Vite related configuration. For example, right now the development server is running on port 5173, but we can configure different port as well. For example, here let us have a server section, and here we can change the port by using port attribute port 3000. Next, let's go to browser, and here you can see this site can't be reached because we have changed the port. So here let me give the port 3000, and now you can see we can access the React application. So we don't have any content to display, that's why you can see the blank. Next, let's create one component. So go to src folder, right click on it, and new file, and let's give file name as hello world.jsx. So make sure that you provide the extension for this file as a JSX, because we are going to write a JSX code within this file. Next, here let's use a functional component to create a React component. So here export default and then function. Let's give component name as hello world. So make sure that the first letter of the component name should be a capital, and then just return some HTML code. So here h1 and then hello world. Perfect. Now we have created hello world functional component. Next, let us import this component in a app component. So go to app.jsx file and here go to return statement, and this is basically a fragment. Within a fragment, just use hello world component and make sure that you import this hello world component at the top. Alright, perfect. Next, save this file and go to browser, and here you can see hello world is displayed in a web page. So this is how we create a React application using Vite, and this is how we create a functional component in a React project, and we import and use in a app component. Alright, great. I hope you understood how to create a React application step by step using Vite build tool. Alright, so Vite is basically faster and it improves the development experience. So now onwards you can go ahead and use Vite tool to create the React application. Alright, great. I will see you in the next video. Hi everyone, welcome back. We'll start building employee management full stack project. Well, here is a technology stack that we are going to use to build employee management system full stack project. So at the back end, we'll use Spring Boot 3, Spring Data GPA it internally uses Hibernate 6, and we'll use database as a MySQL database, and we'll use IntelliJ IDEA to develop the Spring Boot project. Next, we'll use Maven as a build tool. Next, we'll use Postman client to test the REST APIs. Next, at the front end, we are going to use React.js 18+, and we'll use Vite.js as a build tool, and then we'll use Bootstrap CSS framework to style the web pages. Next, we'll use JavaScript. Next, we'll use npm as a package manager. Next, we'll use Visual Studio Code IDE to develop the React application. Next, we'll use Axio's HTTP library to make a REST API call in a React application. So this is the technology stack that we are going to use to develop our employee management full stack project. Next, let us take a look into the requirements. In a requirement 1, we will build crude REST APIs for employee management module. Well, we are going to basically build add employee, get all employees, update employee, and delete employee REST APIs. Next, in a requirement 2, we will build front-end React application for employee management module. Well, in this module, the user should be able to perform these crude operations, like user should be able to add a new employee, user should be able to list all the employees, user should be able to update the existing employee, user should be able to delete existing employee. Well, this is the full stack application architecture that we are going to follow in order to develop a full stack web application using Spring Boot and React.js. Well, this full stack application architecture follows client-server model. At a client side, we will build a React front-end application. At a server side, we will build Spring Boot backend application. Well, notice here in this full stack application architecture, we are going to create a separate project for React front-end application and separate project for Spring Boot backend application. Alright, and front-end application, backend application, both are loosely coupled. Alright, so Spring Boot backend application will basically exposes the REST APIs, and React front-end application will consume those REST APIs, and both the applications are loosely coupled. So at a front end, we can also use different technologies to build the front-end application. For example, instead of using React.js, you can also use AngularJS or Vue.js to create the front-end application. Because both front-end application and back-end applications are loosely coupled. Loosely coupled means both front-end application and back-end applications are independent to each other. So you can develop front-end application using any JavaScript framework, like you can use either React.js or AngularJS or Vue.js. Okay, so this is basically a client-server model. So at a client side, you can create front-end application using any JavaScript framework. Okay, so let us take a look into some of the key components and their roles in this architecture. So let us begin with Spring Boot backend application. Well, in a Spring Boot backend application, we will create the 3-layer architecture: the controller layer, service layer, and DAO layer. The DAO layer is responsible to talk with the database, and service layer basically contains the business logic of the application, and the controller basically contains the Spring MVC controllers, which exposes the REST APIs. Next, we have a React frontend application. It consumes the REST APIs that is exposed by Spring Boot backend application. And in React frontend application, we create the components, services, router, And React is not concerned with the HTTP library. We have to use third-party HTTP library to make a REST API call. Okay, so in this project we are going to use Axios HTTP library to make the REST API call in a React application. Okay, and we are going to use a JSON format to exchange the data between React front-end application and Spring Boot backend application. Alright, so just remember, React.js is not concerned with HTTP library. We have to use the third-party HTTP library to make a REST API call in a React application. And in this project, we are going to use Axios HTTP library to make a REST API call in a React application. Alright, so overall, Spring Boot backend application exposes the REST APIs, React application consumes the REST APIs. Alright, so this is pretty much about Spring Boot React full stack application architecture. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up Spring Boot project in IntelliJ IDEA. Well, first, we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So let us first go ahead and create a Spring Boot project using Spring Initializer. Well, here I am in a Chrome browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a tool that we can use to quickly create a Spring based application. So here, let us fill up the project information. So here we have different types of projects. So let us select Maven over here, and here we have different JVM languages, Java, Kotlin, Groovy. So let us keep Java as selected over here. Next, let us choose Spring Boot version. Well, here you can see by default 3.1.0 is selected, but whenever you create a Spring Boot project, then that time the Spring Boot version may be different. And let us keep the default one selected as it is, because this is a stable and latest release of Spring Boot. Next, let us fill up the project metadata over here. So let us give group as net.javaguides. You can give any group that you want. Next, artifact. So let us give artifact as EMS backend. So here we are developing employee management system. That's why the name EMS and then backend. Next, project name is same as artifact. Next, let us give description as demo project for Spring Boot employee management system. Next, package net.javaguides.ems. Packaging, let us keep jar as selected. Next, Java version 17. Well, remember, whenever you choose Spring Boot 3, then make sure that you choose Java version 17 or later. Next, let us go ahead and let us add the dependencies. So go ahead and click on add dependencies over here, and here just type web. Well, we use Spring Web dependency to build web applications as well as RESTful web services, and this Spring Web dependency internally provides Apache Tomcat as a default embedded container. Alright, so whenever you want to develop the Spring Boot RESTful web services, then make sure that you choose Spring Boot starter web dependency. Next, let us go ahead and let us select Spring Data GPA dependency. Well, we are going to use Spring Data GPA dependency to develop the persistence layer or the repository layer, and Spring Data GPA internally uses Hibernate as a JPA provider, and Spring Data GPA, it reduces a lot of boilerplate code that is required to develop the repository layer. So let us go ahead and select Spring Data GPA over here. And next, in order to connect our Spring Boot application with the MySQL database, we need a MySQL JDBC driver. So here just type MySQL and select MySQL JDBC driver over here. Next, we're going to use a Lombok library to reduce the boilerplate code such as getter setter methods, constructors, and other stuff. So here just type Lombok and select this Lombok annotation library, which helps to reduce the boilerplate code. Alright, so as of now, let us keep these 4 dependencies. Next, if you want to explore this project structure, you can go ahead and click on explore option over here, and then you can explore the project structure and the files. So here you can see pom.xml, and you can confirm the dependencies, like we have added Spring Boot starter web, Spring Boot starter data JPA, MySQL JDBC driver, Lombok dependency, and by default Spring Boot starter test dependency is also added to the project. Okay, next you can also explore the project structure as well. Alright, next let us click on close button, and next go ahead and click on generate button over here. So this will generate the Spring Boot application as a zip file, and it will download it in a file system. Okay, next let us go ahead and let us open this zip file in a folder. Alright, next let us go ahead and let us unzip this zip file. Perfect. Next, let's open the IntelliJ IDEA over here, and here you can see we have three options: new project, open, get from VCS. So we are going to open the existing Maven project. So let us click on open button, and next go to the location where your Spring Boot application is present. So in my case it is in download folder, and here let me select EMS backend project, click on open. Now we have opened Spring Boot application in IntelliJ IDEA. Alright, perfect. Next, let us go ahead and click on pom.xml file, and you can see the dependency over here. And next you can see the project structure. So this is the standard Maven project structure. So this is the Spring Boot main entry point class. From here we can run the Spring Boot application. Next, under resources folder you can see application.properties file. Here we can configure the application level properties. Okay, well, let me recap what we have done in this lecture. We have created Spring Boot project using Spring Initializer, and then we have imported that project in IntelliJ IDEA. In next lecture we'll configure MySQL database details in our Spring Boot application. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us configure MySQL database in a Spring Boot application. Well, let's go to our project in IntelliJ IDEA and go to application.properties file, and within application.properties file we are going to configure the MySQL database details. Well, before configuring MySQL database details in a Spring Boot application, let us first create a database in a MySQL workbench. So let's go to MySQL workbench over here, and here let us type the SQL statement create database and then followed by database name. Let us give database name as EMS. EMS stands for Employee Management System. Next, let us go ahead and execute this SQL statement and refresh the schemas, and here you can see EMS database successfully created. Next, let's go back to our project in IntelliJ IDEA and go to application.properties file, and within this application properties file let's configure the MySQL details. So just type the property spring.datasource.url. Next, let us give the JDBC URL that connect to the MySQL database. So here JDBC MySQL and then localhost, and then the port 3306, and then followed by the database name, that is EMS. Okay, so this is the JDBC URL that we use to connect to the MySQL database. And look at here the localhost. Well, our MySQL server is running on local machine, that's why the localhost. But if your MySQL server is running on in different machine, then you can specify that machine IP address or the host name over here. Next, let us configure the database username and password. So here just type the property spring.datasource.username. Well, in my case the MySQL database username is root, but make sure that whatever the database username you have used, you have to mention over here. Next, let's configure the password as well. spring.datasource.password. Well, in my case this is the password, but make sure that you replace the password you have given while installing a MySQL server. Next, let us configure the Hibernate properties. So here let's first configure Hibernate dilate. spring.gpa.properties.hibernate.dilate, and then let us give the value org.hibernate.dilate.mysql dilate. Now we have configured MySQL dilate. Well, Hibernate uses this dilate to create the SQL statement based on the database that we are using. In our project we are using MySQL database, so Hibernate will create the SQL statements that are compatible with MySQL database. Next, let's configure one more property, spring.jpa.hibernate.ddl auto equal to update. Well, this property is pretty useful in a development environment because this property tells Hibernate to automatically create the database tables if the tables are not existing in the database, and if there are any changes in a JP entities, then it will also tell Hibernate to update those changes in the database tables as well. Alright, great. Now we have configured MySQL details in a Spring Boot application. Next, let us go ahead and let us run the Spring Boot application and let us see whether our Spring Boot application is able to connect to the MySQL server or not. So go to main default class over here, and from here let us run the Spring Boot application, and here click on enable over here, and look at here in the console there are no errors or exceptions. It means our Spring Boot application is successfully connected with MySQL database, and you can see the important information. Spring Boot by default uses Hikari data source and Hikari connection pool, and look at here the Hibernate dialect, MySQL dialect. So this is the dialect we have configured in a application.properties file. Alright, it means we have successfully configured MySQL database in a Spring Boot application. In next lecture we will create an employee JP entity. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to create an employee JP entity. So let's go to our project in IntelliJ IDEA, and here before creating the employee JP entity, let's quickly create a packaging structure for our Spring Boot application. So go to base package over here, right click, new, and then choose package. Let's give package name as entity. Next let us create one more new package. Let's call it as controller. Within a controller package we keep all the Spring MUC controllers, and within an entity package we keep all the JP entities. Next let's create one more package. Let's call it as repository. Within a repository package we keep all the Spring Data JP repositories. Next let's create one more package. Let's call it as service. Within a service package we keep all the interface and classes that are related to service layer. Next let's create one more package. Let's call it as DTO. Within a DTO package we keep all the DTO classes. Next let us create one more package. Let's call it as exception. Within an exception package we keep all the custom exceptions. Alright, so as of now let us keep these packages. Next go to entity package, right click on it, new, and then choose Java class. Let us give class name as employee. Alright, next let us go ahead and let us add the instance variables to this class. So here private long id, and then private string first name, and then private string last name, and then private string email. Perfect. Next let us go ahead and let us use Lombok annotations to reduce the boilerplate code. So here let us use add getter Lombok annotation to generate a getter methods for these instance variables. Next let us use add setter Lombok annotation to generate a setter methods for these instance variables. Next let us use add no argument constructor annotation to create a no argument constructor. Next let us use add all args constructor to create a parameterized constructor. Okay, now we have created employee Pojo class. Let us make this employee class as a JP entity by using JP annotations. So let us annotate this class with add entity annotation from jakarta.persistence package. Well, we use add entity annotation to specify a class as a JP entity. Next let us annotate this class with add table annotation from jakarta.persistence package. Well, we use add table annotation to specify the table details. So here let us use name attribute to specify the table name. So let us give table name as employees. Perfect. Next let us configure the primary key for this employee entity. So here let us annotate the ID field with add ID annotation. So make sure that you choose ID annotation from jakarta.persistence package. Next let us configure the primary key generation strategy. For that let us use add generated value annotation, and next add generated value annotation has a strategy attribute. So here let us configure the primary key generation type. So here let us use add entity. So this add entity primary key generation strategy basically uses database auto increment feature to automatically increment the primary key. Okay. Next let us use add column annotation to map a database table column with a class field. For example, here let us have a column mapping for this first name field. So let us annotate this first name field with add column annotation from jakarta.persistence package, and let us give the column name first underscore name. So this column name will be mapped with the first name field. Okay, perfect. Well, if we don't specify add column annotation, then by default JP will give the column name as field name. Okay, but the column name like first underscore name makes sense. That's why here we are using add column annotation to explicitly configure the column name for this field. Okay, perfect. Next, let us annotate last name field with add column annotation, and let's give column name as last underscore name. Next, let us annotate email field with add column annotation, and let us give a column name as email underscore id. Next, let us make this email underscore id column as a not null by using null label equal to false attribute, and we can also make this email as a unique by using unique equal to true. Alright, now we have created employee JP entity. Next, let us run our Spring Boot application and let us see whether Hibernate will automatically create this employees table in a database or not. So let's go to main entity point class over here. From here, let us rerun the Spring Boot application. Well, look at here, there are no errors or exception in the console. It means our Spring Boot application is successfully connected to the MySQL server. So let's go to MySQL Workbench and let us refresh the schemas and expand this EMS, expand tables, and there we go. You can see employees table is successfully created. Next, right click on this employees table, select rows, and let us verify the columns ID, email underscore ID, first name, last name. Alright, so this looks good. So let me recap what we have done in this lecture. We have created employee JP entity and we ran the Spring Boot application, and we have seen that Hibernate is successfully created employees database table in a MySQL database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created employee JP entity. In this lecture we are going to create employee repository. So let's go to our project in IntelliJ IDEA and go to repository package over here. Right click on repository package, new, and then choose Java class, select interface. Let us give interface name as employee repository. Next, let us extend this employee repository interface from JPA repository interface and make sure that you choose JP repository interface from org.springframework.data.jpa.repository package. Well, notice here JP repository is a generic interface, so we have to pass two parameters. First parameter is the type of the entity, second parameter is the type of the primary key. So let us select JPA repository over here and let us pass the parameters. First parameter as a type of the entity, in our case employee entity. Next, let us pass the type of the primary key, that is long. Well, if you go to employee JP entity, you can see here we have given the type to the primary key ID as a long. So this long data type we are passing to JPA repository as a second parameter. Okay, perfect. Well, once our employee repository interface extends JPA repository interface, then this employee repository will get a CRUD methods to perform CRUD database operations on this employee JPA entity. Alright, so if you go to JPA repository interface source code, you can see JPA repository interface provides these methods, and again JPA repository interface extends list CRUD repository interface, and list CRUD repository interface provides all these methods, and this list CRUD repository method internally extends CRUD repository interface, and this CRUD repository interface exposes CRUD methods to perform CRUD database operations. Alright, it means this JPA repository will inherit all the methods from all the extended interfaces, and again Spring Data JPA will provide the implementation for this JPA repository interface. For example, if you click on this, you will get the implementation classes, and here simple JPA repository is a class that implements all the methods of JPA repository interface and its child interfaces. So just click on simple JPA repository class over here, and you can see simple JPA repository class implements JPA repository implementation interface, and this interface internally extends JPA repository interface. It means simple JPA repository indirectly implements JPA repository interface and its methods. Alright, and if you can notice here, simple JPA repository class, it is already annotated with add repository annotation, so we don't have to annotate our repository interface with add repository annotation. For example, if you go to employee repository, we don't have to annotate this employee repository interface with add repository annotation, because the implementation class, that is simple JP repository class, is already annotated with @repository annotation. And here one more important point is simple JP repository class annotated with @transactional annotation. It means all the methods in a simple JP repository class are by default transactional. We don't have to use again @transactional annotation in a service layer to make the methods as a transactional. Okay, for example, if you just scroll down, you can see delete by id method is a transactional because it is annotated with @transactional annotation, and delete method is a transactional because it is annotated with @transactional annotation. Alright, so all the public methods in a simple JP repository class are transactional, so we don't have to again use @transactional annotation to make these methods transactional. Alright, just remember these couple of important points, like simple JP repository is a class that implements JP repository interface, and simple JP repository class is already annotated with @repository annotation, so we don't have to again annotate our repository interfaces with @repository annotation. And simple JP repository class is annotated with @transactional annotation, so all the methods, all the public methods in a simple JP repositories are by default transactional. We don't have to again make those methods transactional by using @transactional annotation. Alright, perfect. So let me recap what we have done in this lecture. We have created employee repository interface that extends JP repository interface. So this employee repository will get CRUD methods to perform CRUD database operations on employee JP entity. In next lecture, we will create an employee DTO and employee mapper classes. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create an employee DTO and employee mapper classes. So let's go to our project in IntelliJ IDEA and go to DTO package over here. Right click on DTO package, new, and then choose Java class. Let's give class name as employee DTO. Perfect. Next, let us define the instance variables for this class. So here private long id, and then private string first name, and then private string last name, and then private string email. Next, let us annotate this class with @getter lombok annotation to generate the getter methods for these instance variables. Next, let us use @setter lombok annotation to generate the setter methods for these instance variables. Next, let us use @noArgument constructor and @allArgument constructor annotations to create a constructors for this class. Well, we use the employee DTO class to transfer the data between client and server. So when we build the RESTful web services, we'll use this employee DTO as a response for REST APIs. Next, let us create an employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. So whenever we build the RESTful services, then we have to convert employee DTO into employee JP entity and employee JP entity into employee DTO, right? So instead of writing the same logic in all the classes, let's create a mapper class and let's keep the common logic. So here what we'll do, we'll create a new package and let's call it as mapper. Let's create a class. Let's give a class name as employee mapper, and next let us create a static method, public static. Let's give return type as employee DTO, and let's give method name as map to employee DTO, and let us pass employee JP entity as a parameter to this method. And next here return new employee DTO, and let us pass the values to the constructor. So let us get all the values from employee JP entity and let us set those values to the employee DTO. So here employee dot get ID, and then employee dot get first name, employee dot get last name, employee dot get email. Perfect. Now we have created map to employee DTO method. It will map employee JP entity into employee DTO. Similarly, let's create one more method that will map employee DTO to employee JP entity. So here public static, let us give employee JP entity as a return type. Next, let us give method name as map to employee, and let us pass employee DTO as a parameter to this method. Next, return object. So let us construct the object of employee JP entity, and here employee DTO dot get ID, employee DTO.get first name, employee DTO.get last name, employee DTO.get email. Alright, perfect. Now we have created map to employee static method. It convert employee DTO into employee JP entity. Alright, perfect. So let me recap what we have done in this lecture. We have created employee DTO class to transfer the data between client and server, and next we have created employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. Alright, great. In next lecture onwards, we will start building the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will build add employee REST API. Well, let us take a look into the development steps. First, we will create the service layer. Well, if you can see here, the controller layer is depends on service layer, and the service layer is depends on a repository layer, and we basically create the REST APIs in a controller layer, right? So controller layer is depends on service layer. So let us first create the service layer. Well, we have already created the repository layer, so we don't have to write any methods in a repository layer as of now. So let us first create the service layer, and then we'll build the REST API in a controller layer. Okay. So create the service layer, like we'll create an employee service interface, and then we create an employee service IMPL class that implements employee service interface. Next we'll build the add employee REST API in a controller layer, and next we'll test this add employee REST API using Postman client. Okay, so let us go to our project in IntelliJ and here let us first create the service layer. So go to service package, right click on it, new, and then choose Java class, select interface. Let us give interface name as employee service. Within employee service interface, let us define the method. So let us give method return type as employee DTO. Let us give method name as create employee, and let us pass employee DTO as a parameter to this method. Perfect. Next, let us create employee service IMPL class that implements this interface and its methods. Next, go to service package, right click on this package, new, and then choose package. Let's give package as IMPL. IMPL stands for implementation. So right click on IMPL package, new, and then choose Java class. Let's give class name as employee service IMPL. Perfect. Next, this class implements employee service interface. And next, go ahead and mouse over on this class, and here you will get the option to implement the methods like the link. So go ahead and click on this implement methods link over here and select the method that you want to implement. Click on OK. Perfect. Next, let us annotate this class with @service annotation, and make sure that you choose service annotation from org.springframework.stereo.package. Well, this annotation tells Spring container to create the Spring Bean for this class. Next, let us implement create employee method. Well, before implementing this method, let us first inject the dependencies. So here, private employee repository. Well, we are going to use constructor based dependency injection to inject the dependencies, and instead of creating the constructor manually, let us use Lombok annotation. So let us annotate this class with @all-argument constructor annotation. Okay, now we have injected employee repository as a dependency. Next, let us implement create employee method. So go to create employee method, and within this create employee method, first we need to convert employee DTO into employee JP entity, because we need to store the employee entity into database, isn't it? So here, let's say employee equal to, let us call employee mapper class to map employee DTO to employee JP entity. So here employee mapper, it has map to employee method and then pass employee DTO. Okay, now we have converted employee DTO to employee JP entity. Next, let us save this employee JP entity into database. So for that, let us call employee repository. It has a save method and then pass employee JP entity object. Perfect. Next, this save method return the saved employee object. So let us get into a local variable. So here employee, and let us give a variable name as saved employee. Next, we need to return saved employee object back to the client. So here let us convert saved employee JP entity into employee DTO. So here let us remove this null and let us type employee mapper. It has map to employee DTO, and let us pass saved employee. Perfect. Now we have implemented create employee method. Next, go to controller package over here. Right click on controller package, new, and then choose Java class. Let us give class name as employee controller. Next, let us annotate this employee controller class with @REST-controller annotation. Well, once we annotate a class with @REST-controller annotation, then this class becomes a Spring MUC REST controllers, and this class is capable to handle HTTP requests. Next, let us annotate this class with one more annotation, that is @RequestMapping annotation. Well, here we are using @RequestMapping annotation to define the base URL for all the REST APIs that we are going to build within this controller. So here let us give the base URL /API/employees. Okay, perfect. Next, within this employee controller, let us first inject the dependencies. So private employee service, and instead of creating the constructor manually, let us annotate this class with @argument constructor annotation. Okay. Next, let us build add employee REST API. So here let me write the comment, build add employee REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method, and then we'll make that method as a REST API by using Spring annotations. So here let's first create a method, public, and let's go return type of the method as a response entity. So response entity is a generic class. We have to pass the type. So here let us pass employee DTO as a type. Next, let us give method name as create employee, and let us pass employee DTO as a parameter to this method. And next, here let us call employee service. It has create employee method, and then pass employee DTO object as a parameter to this method. And this create employee method returns a saved employee. So here employee DTO, and let us give the variable name as saved employee. Next, let us have a return statement, return object of response entity. So let us pass value to the constructor. So first value as saved employee, second value as HTTP status code. So here just type HTTP status dot created. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @postMapping annotation. Well, we use @postMapping annotation to map the incoming HTTP post request to this method. Next, let us use one more annotation here, that is @requestBody annotation. Well, this @requestBody annotation will extract the JSON from the HTTP request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have created add employee REST API. Next, let us run our Spring Boot application, and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to the Postman client over here, and here let me create a new request. Let us choose HTTP post method, and let us enter the request URL HTTP localhost 8080/API/employees, and next go to the body, select raw, select content type JSON, and within a body we need to pass the JSON object. So here let's create a JSON object. So first name, let us give first name as Ramesh, and then last name, let us give last name as Padtari, and then email, let us give email as ramesh@gmail.com. Well, if you can go to our project in IntelliJ IDEA and go to create employee REST API, and here you can see employee DTO, and if you go inside employee DTO, and this employee DTO class has the fields first name, last name, email, and if you go to Postman client, and if you can notice the JSON over here, the attributes name like first name, last name, email. So whenever you pass the JSON in the request, make sure that the JSON attributes should be same as the DTO class fields, because we are using @request_body annotation here to extract the JSON and convert that JSON into employee DTO Java class object. And in order to convert a JSON into Java object, the JSON attributes and Java object fields should be same. Okay, perfect. Next, let's go to Postman client over here. Next, go ahead and click on send button, and there we go. We got a response of the REST API, and if you can notice here, the status 201 created and the saved employee object in the response. Next, let us verify whether this record is stored in a MySQL database table or not. So let's go to MySQL Workbench over here and go to employees database, just refresh, go to employees table, select rows, and there we go. Ramesh employee successfully stored in a employees table. Alright, it means we have successfully built add employee REST API. In next lecture, we will build get single employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get employee REST API. So let's go to our project in IntelliJ IDEA, and let us first change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let's go to employee service interface over here. Within this interface, let us define the get employee by ID method. So here, let us give employee DTO as a return type of the method, and let us give method name as get employee by ID, and let us pass employee ID as a parameter to this method. Perfect. Now we have defined get employee by ID method in a employee service interface. Next, let us implement this method in employee service IMPL class. So let us go to employee service IMPL class over here and just mouse over on this class, and here we have implement methods link. So go ahead and click on this link over here and then select the method that we want to implement. Next, click on OK. Perfect. So here we can implement the get employee by ID method. Well, before implementing this method, let's go ahead and let's first create one custom exception. Well, whenever an employee with a given ID is not exist in database, then we have to throw the custom exception, isn't it? So let us go ahead and let us first create the custom exception. So go to exception package, right click, new, and choose Java class. Let us give exception name as resource not found exception. Perfect. Next, let us extend this class from runtime exception, and then let us create a parameterized constructor, public resource not found exception, and then let us pass message as a parameter. Alright, and here let us call super keyword to pass this message to the super class constructor. Next, let us annotate this class with @response status annotation, and let us specify the HTTP status. So here, let us give HTTP status not found. Well, if employee with a given ID is not exist in database, then we will throw this resource not found exception, and then Spring Boot will catch this exception and it will get the error message from the exception, and it will send the error message along with the HTTP status to the client. Next, let us go back to employee service IMPL class over here. Next, let us implement this get employee by ID method. So here, let me maximize this. So within a get employee by ID method, let us call employee repository. It has find by ID method, and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and just pass employee ID. Next, optional has or else throw method. So here let us call or else throw method over here, and notice here or else throw method returns a employee object, and or else throw method takes supplier as a functional interface, and we have to pass the lambda expression implementation of this supplier functional interface. So let us call this or else throw method over here, and let us create the lambda expression. So here lambda symbol, and then new resource not found exception, and let us pass the message employee is not exist with a given ID. Alright, and let us pass the ID dynamically over here, that is employee ID. Perfect. Next, let me maximize this a bit. Next, you can see the type over here exists, so let me correct it. Employee is not exist with a given ID, and then employee ID. Next, let me also break this statement. Perfect. So this or-else-throw method returns the employee object. So here let us take the result of this or-else-throw method in a local variable of type employee. Perfect. Next, if you can notice here, get employee by ID method returns the employee DTO. So let us convert this employee JP entity into employee DTO. So go to return statement, remove this null, and let's call employee mapper over here. It has a map to employee DTO method, and then pass employee JP entity object. Perfect. Now we have implemented get employee by ID method in a employee service IMPL class. Next, let us create the REST API that will internally call this get employee by ID method. So here let me minimize this and go to employee controller over here, and within employee controller let us build get employee by ID REST API. So here let me write the comment build get employee REST API. Well, creating a REST API using Spring Boot is very simple. We just need to create a method and then we will convert that method into REST API by using Spring annotations. So here let us first create a method public and then response entity as a return type. Response entity is a generic, so let us pass employee DTO as a type. And next let us give a method name as get employee by ID. Next let us pass employee ID as a parameter to this method. Within this get employee by ID method, let us call employee service. It has get employee by ID method and then pass employee ID. Perfect. So this get employee by ID method returns employee DTO. So here let us take the result of this method in a local variable of type employee DTO. Perfect. Next let us have a return statement. Return response entity. It has a OK method. And next let us pass employee DTO as a parameter to this method. Perfect. Now we have created get employee by ID method. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map the incoming HTTP GET request to this method. Next let us pass the ID. Well, this ID is basically called a URI template variable. Next we need to bind the value of this URI template variable to this method argument. So in order to do that, we have to use add path variable annotation. So here let us use add path variable annotation, and we need to also pass the URI template variable name here, that is ID. So notice here the URI template variable name is ID and the method argument name is employee ID. So both the variable names are different. That's why we have to pass the URI template variable name to the path variable annotation. Then only the path variable annotation will bind the value of this URI template variable to this method argument. Okay, perfect. Now we have created get employee REST API. Next let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here I want to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next let us go to Postman client over here and let us create a new request, and here let us choose HTTP GET method and let us enter the request URL http localhost 8080/API/employees and then /1. Well, if you go to MySQL Workbench over here and if you go to EMS database and employees table, you can see here we have Ramesh employee and Ramesh employee has ID 1. So in order to retrieve this Ramesh employee, we have to pass the ID 1 in the URL. Okay, so let us go back to Postman client and here we have passed employee ID 1. Okay, next click on send button and there we go. You can see the response. The REST API returned the response and the response contains the employee object in a JSON format and the status 200 OK. It means we have successfully built get employee REST API. In next lecture we are going to build get all employees REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build get all employees REST API. So let's go to our project in IntelliJ IDEA over here. And first we will change the service layer and then we will change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface let us define the method. So let us give a return type of the method as list of employee DTO. Next let us give method name as get all employees Alright, now we have created get all employees method in our employee service interface. Next, let us implement this method in our employee service IMPL class. Let us head over to employee service IMPL class over here and just mouse over on this class. Click on this implement methods link. Next, let us select the method that you want to implement. Click on OK. Alright, now let us go ahead and let us implement this get all employees method over here. Within a get all employees method, let us call employee repository. It has find all method. We'll notice here there are multiple overloaded find all methods. Where I want to choose the find all method, it doesn't take any method argument, and find all method returns a list of type employee JP entity. Okay, so let us select find all method over here. Next, let us take the result of this find all method in a local variable of type list. So here let us declare list. List is a generic. Let us pass employee class as a type and let us call it as employees. Perfect. Now we have list of employee JP entities, but if you can see here, get all employees method returns list of employee DTOs, right? So let us convert a list of employee JP entities into list of employee DTOs. So here go to return statement, remove this null, and here just call employees. So employees is a list. It has a stream method, and then stream has a map method, and notice here map method has a function as a functional interface, and we need to provide the lambda expression implementation for this functional interface. So let us select map method over here. So basically we use map method to map one object into another object, and in our case we have to convert employee JP entity into employee DTO, right? So here let us have a lambda expression implementation. So here let us pass employee as a parameter, and let us have lambda symbol, and then call employee mapper. It has map to DTO method, and then pass employee object. Perfect. And finally let us call collect method to collect the result. So here we are using list, so let us call this collect method. It takes to list as a parameter. Now we have written a logic to convert a list of employee JP entities into list of employee DTOs. Next, let us create the REST API that will internally call this method. So go to employee controller over here, and within employee controller let us build get all employees REST API. So here let me write the comment build get all employees REST API. Well, creating REST API using Spring Boot is very simple. First we need to create a method, and then we will convert that method into REST API by using Spring annotations. So here let us first create the method public response entity as a return type. Response entity is generic, so let us pass list as a type. List is also a generic interface. Let us pass employee DTO as a type, and let us give method name as get all employees. Alright, and here let us call employee service. It has get all employees method. So get all employees method returns a list of employee DTOs. So here let us declare a local variable of type list. List is generic. Let us pass employee DTO as a type, and let us give variable name as employees. Perfect. Next let us have return statement, return response entity, and then call its OK method, and then pass employee objects as a parameter. Perfect. Now we have created get all employees method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map incoming HTTP GET request to this particular method. Alright, perfect. Now we have built get all employees REST API. Next let us rerun our Spring Boot application and let us test this REST API. So from here I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. Let us choose HTTP GET method and let us enter the URL localhost 8080/API/employees. Click on send button, and there we go. You can see the array contains a single JSON object. So let us insert one more employee. So go to add employee request over here, and let us change the JSON. Post name, let us say Sanjay. Last name, let us say Jadhav. Email sanjay@gmail.com. Next click on send button and there we go. We got the response and the status code 201 created. Next let us go to get all employees request over here and then click on send button and there we go. You can see here there are total 2 employees and in a response also there are 2 employees. Next let us insert one more employee. So go to post request and here let us give first name as Tom and last name Cruz, email tom@gmail.com. Click on send button and there we go. We got the response with the employee ID 3. Next let us go to get all employees request over here. Click on send button and there we go. You can see a Tom employee is present in a array. Okay, it means we have successfully built get all employees REST API. Let us also verify the database table. So go to MySQL Workbench, go to employees table, select rows and notice here there are total 3 employees. And if you look at the response of the REST API, there are total 3 employees, 3 employee JSON objects present in the array. Okay, it means we have successfully built get all employees REST API. In next lecture we will build update employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build update employee REST API. So let us go to our project in IntelliJ IDEA. Well, first we want to change the service layer and then we'll change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here. Within this interface, let us define the method. So here let us give employee DTO as a return type of the method and let us give method name as update employee and let us pass employee ID as a post parameter and employee DTO as a second parameter. And this employee DTO basically contains the updated employee details. Okay, so let us call it as updated employee. Okay, perfect. Now we have defined update employee method in an employee service interface. Next, let us implement this method in an employee service IMPL class. So let us go to employee service IMPL class over here. Just mouse over on this class, click on this implement methods and then click on OK method. Now let us go and let us implement update employee method. Within update employee method, let us first add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So let us write that logic here. So just call employee repository. It has find by ID method and notice here find by ID method returns optional app type employee. So let us call find by ID method over here and then pass employee ID as a parameter and then optional has or else throw method. So let us call or else throw method over here and notice here or else throw method takes supplier as a functional interface and we have to provide the lambda expression implementation for this supplier functional interface. So just call this method and then let us construct the lambda expression. So here new resource not found exception and then let us pass the custom exception message. Let us say employee is not exist with given ID and then pass employee ID dynamically. Perfect. Next let me put the semicolon over here. Alright, and this or else throw method returns a employee object. So here let us take the result of or else throw method in a local variable of type employee. Perfect. Next we have the updated employee object. It contains all the employee updated information. So let us set all the details from updated employee object into this employee object. Okay, so here employee dot set first name and then updated employee dot get first name, employee dot set last name and then updated employee dot get last name, employee dot set email and then updated employee dot get email. Perfect. Next let us call employee repository. It has a save method and then pass this employee object. Okay, so here basically we have updated this employee object with first name, last name, email and again we are saving this employee object by using save method. So basically this save method performs both save and update operation. Well, if employee object contains ID, then this save method internally perform the update operation and if employee ID doesn't contain the primary key ID, then it will perform the insert operation. Alright, next this save method returns the updated employee object. So here let us declare the updated employee object like this. Perfect. Next, if you can see here, update employee method returns the employee DTO. So let us convert this updated employee object JP entity into employee DTO. So here go to return statement, remove this null, and then call employee mapper. It has map to employee DTO method, and then pass updated employee object as a parameter. Now we have implemented update employee method in a employee service IMPL class. Next, let us create the REST API that will internally call this update employee method. So go to employee controller over here. Within employee controller, let us build update employee REST API. So here, let me first write the comment, build update employee REST API. Let us first create a method, and then we will convert that method into REST API by using Spring annotations. So here just type public response entity and then pass employee DTO as a type. Let us give method name as update employee. Alright, and let us pass employee ID as a first argument and employee DTO as a second argument. So this employee DTO is nothing but updated employee information. Perfect. Next, let us call employee service. It has update employee method, and then pass employee ID as a first parameter, updated employee as a second parameter. Perfect. Next, this update employee method returns the employee DTO. So here let us have a local variable of type employee DTO. Alright, next let us have a return statement, return response entity, and then call OK method, and then pass employee DTO. Alright, now we have created update employee method. Let us make this method as a REST API by using Spring annotations. So let us annotate this method with @putMapping annotation. Well, we use @putMapping annotation to map incoming HTTP put request to this method. Next, let us pass the ID. So here is the syntax. Within a open and close curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use @path variable annotation over here. And next, let us pass the URI template variable, that is ID. Perfect. Next, we need to use one more annotation, that is @requestBody annotation. Well, this @requestBody annotation will basically extract the updated JSON from the request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have built update employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us go to Postman client over here, and here let me copy this URL and let me create the new request. And here let us choose HTTP put method, and let us enter the request URL localhost 800/API/employees, and then we need to pass the employee ID that we are going to update. So let us say we are going to update the employee with ID 1. Alright, next let us pass the updated information in the body. So click on body, raw, content type JSON, and here we need to pass the JSON. So here let me quickly create the JSON. First name. Well, if you go to MySQL Workbench and go to employees table over here, and if you look at here, employee ID 1 has a first name Ramesh, last name Partare, email ID ramesh@gmail.com. So let us update all these three column values. So let us update the first name from Ramesh to Ram, last name from Partare to Jadhav, email ID ramesh@gmail.com to ram@gmail.com. Alright, so let us go back to Postman client, and here let us give the updated first name, that is Ram, and last name Jadhav, email ram@gmail.com. gmail.com. Next, go ahead and click on send button over here, and there we go. You can see the response. The post name is updated, last name is updated, and email is also updated. Let us verify this information in database table as well. So let us go back to MySQL Workbench, and here let us select rows from employees table. Notice here the employee ID 1. The post name is changed from Ramesh to Ram. Last name is changed from Partari to Jadhav. Email ID is changed from ramesh@gmail.com to ram@gmail.com. It means we have successfully built update employee REST API. Alright, great. In next lecture, we will build delete employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete employee REST API. So let's go to our project in IntelliJ IDEA over here. Well, first we'll change the service layer, and then we'll change the controller layer, because the controller layer is depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give void as a return type of the method, and let us give method name as delete employee, and let us pass employee ID as a parameter to this method. Next, let us go ahead and let us implement this delete employee method in our employee service IMPL class. So go to employee service IMPL class over here, just mouse over on this class, click on this implement methods, and choose the method that you want to implement. Click on OK. Alright. Next, let us go ahead and let us implement this delete employee method. So here, first of all, we need to add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So if you go to update employee method over here, here we have already written the logic. Okay, so let us copy this piece of code and go to delete employee method, and here just paste this piece of code. So here basically we are calling find by ID method, and this find by ID method returns optional. So again here we are calling or else through method of optional object, and here basically we are providing the lambda implementation of supplier functional interface. So basically if employee with a given ID is not exist in database, then this piece of code will basically throw the resource not found exception. Next, let us call employee repository. It has delete by ID method, and then pass employee ID as a parameter to this method. Okay, perfect. So this delete by ID method will basically delete the employee by ID. Alright, next let us create delete employee REST API that will internally call this method. So go to employee controller over here. Within employee controller, let us build delete employee REST API. So here let me write the comment first. Build delete employee REST API. So first we'll create a method, and then we'll convert that method into REST API by using Spring annotations. So here just type public and then response entity as a return type. So let us pass string as a type, and then let's give method name as delete employee. Alright, and let us pass employee ID as a parameter to this method. Perfect. Next, within our delete employee method, let us call employee service. It has delete employee method, and then pass employee ID. Next, let us have a return statement, return response entity dot OK, and let us pass the success message, that is employee deleted successfully, something like that. Perfect. Now we have created delete employee method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add delete mapping annotation. Well, we use add delete mapping annotation to map the incoming HTTP delete request to this method. Next, we need to pass the ID to this annotation. So here within a curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use add path variable annotation and then pass URI template variable name. Perfect. Now we have built delete employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here, and here let me copy this link and let me create a new request, and here let us choose HTTP delete method, and let us enter the request URL localhost 800/API/employees, and here we need to pass the employee ID that we are going to delete. For example, let us say we want to delete the employee with ID 1, then we have to pass the employee ID 1 in the request URL. Next, if you look at the database table, employees table, so employees table has a employee with ID 1. Okay, now we are going to basically delete the employee with ID 1 from the employees table. So let us go back to Postman client and go ahead and click on send button over here, and look at here the response, employee deleted successfully and the status code 200. Okay, next let us go to MySQL Workbench, go to employees table, select rows, and look at here the employee with the ID 1 is successfully deleted from the employees table. It means the delete employee REST API is working as expected. Next, let us delete one more employee, like we are going to delete an employee with ID 3. So let us go back to Postman client, and here let us pass the employee ID that we are going to delete. We are going to delete employee with ID 3. Next, click on send button, and there we go. We got the response, that is success response. Next, let us go to MySQL Workbench, select rows from the employees table, and there we go. You can see here the employee with ID 3 is successfully deleted from the employees table. Alright, it means the delete employee REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up React application for our employee management system. Well, in order to create the React application, we are going to use Vite.js build tool. Well, Vite.js is a build tool that aims to provide the faster development experience. For example, if you go to browser and in a new tab, just type Vite.js and go ahead and click on the first link and click on the guide tab over here. So Vite is a build tool that aims to provide a faster and learner development experience for modern web projects. And this Vite.js provides a development server to run the React applications, and it will also provides a build command to bundle the React application. Okay, so basically Vite is a build tool that aims to provide a faster and learner development experience for modern projects. And you can see here Vite supports different types of templates, like you can use JavaScript or TypeScript. In this project we are going to use JavaScript to build the React application. Well, in order to use Vite.js build tool to create the React application, you have to install the Node.js and npm. Well, in order to install the Node.js, you can just go to official documentation's download page, and you can go ahead and download the Node.js as per your operating system, and you can install it in your machine. Well, npm comes with Node.js, so you don't have to install npm separately. Alright, well, let us first create the workspace for this React application. So here I am going to create a folder in a desktop. You can create a folder anywhere on your file system. So here I am going to create a workspace folder in a desktop. So let me call it as full stack. Alright, within a full stack folder, we are going to create the React application. Next, let us open the Visual Studio Code ID in a full stack folder. So here, let me first open the Visual Studio Code ID over here, and here go to File, Open Folder, and go to Desktop, select Full Stack Folder, click on Open. Now we have opened Visual Studio Code ID in a full stack folder. Next, let us go ahead and let's create the React application using Vite.js. So here I am going to use the inbuilt terminal. So go to Terminal, click on New Terminal over here. Alright, and here let me maximize this, and here let us type the command npm create vite@latest, and then followed by the React application name. So here we are going to give the project name as EMS-frontend. Well, EMS stands for Employee Management System, and this is basically a front end. Well, if you can notice here we are using the latest version of Vite. That's why I have mentioned @latest. Okay. Next, go ahead and hit enter. And look at here, it gives the options like select the framework. Well, we are going to use React. So let us select the React and hit enter. Next, we need to select the variant. Either we can use TypeScript or JavaScript. So let us use the JavaScript. So here let us select JavaScript and hit enter. And there we go. You can see scaffolding project is created under post-app folder, and if you can see here, EMS front-end React application is created under post-app folder. Well, if you can notice here, within a fraction of seconds, the Vite.js created the React application. Alright, next let us use these commands to install and run the React application. Well, first of all, we need to move into our project by using this command. So here just type cd and then EMS frontend. Now we are in a EMS frontend project folder. Next, let us type npm install and hit enter. So this will install all the dependencies required for our React application. So it will take couple of seconds. So just wait couple of seconds, and there we go. All the JavaScript libraries are installed, and if you expand EMS frontend over here, you can see node_modules folder is created, and within this folder, npm install command will keep all the downloaded JavaScript packages. Alright, perfect. Next, we need to run the command. So let me check the command npm run dev. So in order to run the React application using Vite.js, we have to run this command. So this command will run the React application in a development server. So here, let me first clear the terminal and just type npm run dev and hit enter. And notice here, the React application is up and running in a development server on port 5173. So here, let us copy this URL and go to the browser. In a new tab, just paste this URL, hit enter, and there we go. You can see Vite plus React. Okay. Next, let's go back to our project, and if you can notice the port over here 5173. So let us change this port from 5173 to 3000. Well, Vite.js provides a configuration file named vite.config.js. So within this JS file, we can configure the development server related details. For example, here, let us create a server section. So this is basically object, and within that, let us have a port, and let us give port 3000, and then just save this file. And notice here, as soon as we save the file, the development server port is changed from 5173 to 3000. Okay, next, if you go to browser and if you refresh here, it says this site can't be reached because we have changed the port. So here, let us give the port 3000. Hit enter, and there we go. Now you can see the React application is up and running. Okay, so this is how we can change the port of our development server. Alright, perfect. Well, let me recap what we have done in this lecture. We have created the React application using Vite.js. So basically, we have used a couple of commands like npm create vite at latest and then followed by project name. So this is the command that we have used to create a scaffolding project for our React application. Next, we have used npm install to install all the JavaScript packages or libraries for our React application. Next, we have used npm run dev command to run the React application in a development server. Alright, it's pretty simple. Just we have to use these couple of commands to create and run the React application. In next lecture, we'll understand the folder structure of our React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created and set up React application. In this lecture, we are going to understand the React application project structure. Well, if you go to VS Code, here we have our React application. Next, let us understand the important files and folders of our React application. So let us begin with package.json file over here. Well, package.json file basically contains all the required dependencies and scripts required for our React application. For example, if you can go to dependency section over here, you can see the React library and its version, that is 18.2.0. React DOM is a library, its version 18.2.0. Okay, so within a dependency section, we configure all the dependencies required to our React application. Next, you can see the dev dependencies, and these are the dependencies for our development. Next, here we have scripts to run the React application, to build the React application, and to preview the React application. And here we have React application name, React application version, and the type like module. Alright, so basically in a package.json file, we configure all the dependencies and scripts required for our React application. And whenever we run the npm install command, then npm install command will install all the dependencies and scripts. Okay, next we have v.config.js file. So within this JS file we can configure the plugins and development server related details. For example, here you can see plugin section. So within this plugin section we can configure all the plugins, and within server section we can configure the development server related details. Alright, next we have an index.html file. Well, we use React.js to develop the single page application, and in typical React application you can find only one HTML file named index.html file. And if you go to index.html file code over here, especially if you go to body contains a single div with id root. Well, React uses this div to render the component. Next we have node_modules folder. Well, whenever we run npm install command, then npm will create this folder and it will keep all the downloaded JavaScript libraries and packages within this folder. Next we have public folder. Within a public folder we can keep all the static files like images and SVGs. Next we have a src folder. So all the development related things will go inside a src folder. So if you expand src folder, you can see here main.jsx file. Well, main.jsx file is the main entry point for a JavaScript. For example, if you go to index.html file, within index.html file the main.jsx file is imported using script tag, right? So whenever we run the React application, then index.html file will served in a browser, and then it will internally call this main.jsx file. It means main.jsx file is a main entry point for all the JavaScript related code. And within a main.jsx file you can see react dom.create root and document.getElementById and then root. Well, this root is basically a div id. If you go to index.html file again, you can see here div has id root, right? So again, if you go to main.jsx file, so here we are getting the div by div id, and next this react dom again call the render method to render the component in a div. Okay, so basically React DOM uses create root method to get the div by div id, and then again it will call the render method to render this app component within that div. Just remember, this piece of code is responsible to render the top level component in a div. Next, let us move into index.css file. So this CSS file contains all the CSS related code. Next, this is the default generated CSS code, so we can simply remove this code. Next, go to app.jsx file. So this JSX file contains an app component. So app component is a base level component or a root component, and this is the auto generated code. So what we can do is we can remove this code. Okay, we can write our own code over here. Alright, so here also let me remove this code. Let me remove the imports as well. Perfect. Next, go to app.css file. So here we can configure all the application level CSS classes. Okay, so here this is the auto generated code, so let me remove this. Next, go to assets folder. Within assets folder we can keep the static files like SVG and images. So these are the important files and folders in our React application. Next, let us understand how the flow goes whenever we run the React application. Okay, so whenever we access the React application from the browser, then index.html file will get served in a browser, and then within an index.html file you can see script tag. Here basically imported main.jsx file, right? So next, main.jsx file will get called, and within a main.jsx file you can see here react dom.create root method. So this create root method will get the div by using the div id root, and then it will again call the render method to render this app component within that div. Next, within an app component we can write the code. For example, here go to return statement, and here let me write something like heading. So here let us use h1 tag to write the heading, for example hello world. Next, let us save the file, and you don't have to restart the development server. The changes will be automatically reflected. Next, let us go to browser, and you can see here hello world heading is displayed in a web page. Okay, so this is how the flow goes whenever we run the React application. Okay, so whenever we run the React application, the index.html file will get served in the browser, and then index.html has a script main.jsx. This script will be loaded in a browser, and then this script is responsible to render the component. Okay, next if you go to a browser, so here just inspect this page, and if you go to console over here, you can see download the React DevTools for a better development experience. So go ahead and click on this link, and from here we can download the extension. So here I am using Chrome, so let me install the extension for Chrome over here, and click on add Chrome, click on add extension. Alright, so this React developer tools is pretty useful. We can track the components. So here let me close this. Next go back to our React application, and here let us refresh our React application, and here you can see the components. So here let me use this side, and you can see the components. So go ahead and click on components over here. Right now we have only one component, that is app component, and you can see its details, like the source is main.jsx. It means the app component is imported in this source file, that is main.jsx file. Okay, next what we will do, we'll quickly create one more component, and we will import that component in this app component. So let's go back to our project, and here let me quickly create a file. Let's call it as hello world.jsx. Well, either you can use JS extension or JSX extension. Next, within a hello.jsx file, let's create one functional component. So here let us type function, let us give component name as hello world. Alright, and let us export it, export default hello world. Next, within a functional component, let us write the JSX code. So first of all, let us have a return statement, and then let us use h1 tag to print the heading hello world. Perfect. Now we have created a simple functional component named hello world component. Next, we have exported this hello world component as a default. So let us import this hello world component in app component. So go to app.jsx file over here. Let us remove this, and notice here this tag is basically called a fragment. Okay, so this is an empty tag basically. So this tag in a React is called a fragment. Within a fragment tag, let us import hello world component. So make sure that hello world component is imported at the top. Perfect. Next, save this file, and let's go to browser and just refresh this page and go to components, and here you can see the component tree structure, app component. Within that we have a hello world component. So this is how you can track the components, like the parent component and its child components. Alright, great. In next lecture we will see how to install Bootstrap in a React application using npm. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to add a Bootstrap to our React application using npm. Well, Bootstrap is a CSS framework that we can use to style the web pages, and basically we can create the responsive web applications. Alright, so installing Bootstrap in a React application is very simple. We just have to run the npm install command to install Bootstrap in a React application. Okay, let's go to our project in Visual Studio Code ID, and here let's open a new terminal. So go ahead and click on this plus icon over here. Next, let us go inside our project. Just type the command cd ems frontend, and in order to install the Bootstrap in a React application using npm, just type the command npm install and then followed by Bootstrap. Next, ---- save. Well, this ---- save option will add the Bootstrap dependency entry in a package.json file. Next, let us hit enter, and there we go. Bootstrap library is installed in our React application, and you can see the Bootstrap version 5.3.0. As of now, the Bootstrap CSS library version is 5.3.0. Next, let us verify in a package.json file. So go to package.json file and you can see the dependency section, and within that we have Bootstrap library and its version 5.3.0. It means we have successfully installed a Bootstrap using npm. Next, we need to import the appropriate CSS file in a React application. Well, if you go to node_modules folder and just search for Bootstrap folder over here, and within a Bootstrap folder we have dist, within a dist we have CSS, within that we have bootstrap min.css. So this is the CSS file we have to import in order to use the Bootstrap CSS classes. Alright, so let us go and let us import this bootstrap.min.css file. So go to main.jsx file. So main.jsx is a entry point. So here let us import the bootstrap.min.css file. So just type import and then bootstrap, and then Bootstrap folder has a dist folder. Within dist folder we have CSS folder. Within that we have bootstrap.min.css file. Perfect. Now we have imported bootstrap.min.css file. Next, we are good to use Bootstrap CSS classes. So in order to test that, what we can do is we can use one of the Bootstrap CSS class. So go to hello.jsx file here, and here we have hello world component. So let us display this hello world heading at a center using Bootstrap CSS class. So here go to h1 tag and just call class name property and then pass the CSS class name, that is text center. So this is the Bootstrap CSS class that we can use to display text at a center. Next, let us save this file and let us go to browser, and notice here the hello world heading is displayed at a center. It means we have successfully installed Bootstrap CSS library in a React application. Alright, well, let me recap what we have done in this lecture. We have installed a Bootstrap library using npm install bootstrap --save command. Next, we have imported bootstrap.min.css file in a main.jsx file. Next, we have used one of the CSS class, that is text center Bootstrap CSS class, to test the Bootstrap installation in a React application. In next lecture onwards, we will start implementing list employee feature. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures, we are going to implement list employee feature in a React application. Well, if you look at the screenshot over here, we are going to design the UI that looks something like this. Okay, so basically we are going to create a web page. It will display a list of employees in a table. Alright, in this lecture we are going to create a list employee component, and in upcoming lectures we are going to connect our React application to the REST API, and we will populate the response of the REST API in a list employee component. Alright, so in this lecture let us focus on creating React list employee component. Well, here are the development steps. First, we will create a React functional component named a list employee component. Next, we will prefer the dummy data to display in the HTML table. Next, we will write the JSX code to display list of employees in a HTML table. Next, we will import and use list employee component in a app component, and finally we will test all these changes. Okay, so the first step is create a React functional component named list employee component. So let us go to our project in VS Code, and here go to src folder. Within that, let's create a new folder and let us call it as components. Perfect. So within a components folder, let us create a file. Let us give name as list component or list employee component. Next, let us give extension as JSX. Perfect. Next, within this file, let's create a functional component named a list employee component. Well, instead of writing the same code to create the functional component, what we can do is we can use the code snippets. Well, VS Code has extension, that is React code snippets. So we can use this extension to quickly create the code snippets or the templates. Okay, for example, go to extensions over here and here just search for React snippets. Alright, and you can see the extension over here, ES7 plus React Redux Reactive Native snippets. So just click on it and go ahead and install this extension. Well, this extension is pretty useful because this extension provides a commonly used code snippets. Okay, So go ahead and install it. So I have already installed, that's why you can see uninstalled. So let me quickly uninstall it. So you can see the install button over here. So go ahead and just click on it. So once you install it, you can use the React code snippets. Alright, perfect. Next, go to list employee component.jsx file. So let me close this. Alright, so here let us use React code snippets command to create the functional component. So just type React functional component export and hit enter, and there we go. You can see we got the functional component code snippet. So instead of typing the same code, what we can do is we can use this kind of code snippets to quickly create a code like this. Okay, well, notice here we are using JavaScript function to create the functional component, but we can also use JavaScript arrow function to create the functional component. Well, I prefer using arrow functions over a JavaScript function. So here let us go ahead and let us use JavaScript arrow function. So you can also use the plain JavaScript function as well. Alright, so here let me remove this and just type the command React arrow function component export. Okay, just type RAFCE. So this gives React arrow function export component like this. Okay, perfect. Next, let us take a look into next step. Next step is prefer dummy data to display in a HTML page. Well, in HTML table we need to display something, right? For that, let us prefer the dummy data. So let's go back to list component over here. Within a list employee component, let's create an array. So const, let us give variable name as dummy data. So this is the array. So within array, let us create a employee objects. So here first name, let us give ID first, ID1, and then first name Ramesh, last name Padhare, and then email ramesh@gmail.com. Perfect. Now we have created one object in array. Next, let me copy this. Let me create few more objects. So here ID2, and then first name Umesh, last name Padhare, email Umesh. Next ID3, and here let's give first name Rajkumar, last name Padhare, email rajkumar@gmail.com. Perfect. Now we have created a dummy data to display in the HTML table. Next, let us take a look into next step. Next step is write JSX code to display list of employees in a HTML table. So let us go ahead and let us write the JSX code to display the dummy data in a HTML table. So let's go back to our component, and here go to return statement. So let me maximize this. So go to return statement and let us remove this. Alright, so here let us first have a page heading. Let us say list of employees. So this is the page heading. Next, let's create the HTML table. So here table, and within table we have table header. Within a table header we have table columns. So the table columns should be in a table row. Perfect. Let us give a column name as employee name or employee first name. Perfect. Next, let us give one more column name, that is employee last name. Next, let us have one more column, employee email ID. Perfect. So we can also display the ID as well. For that, let's create one more column over here. Let's call it as employee ID. Perfect. Now total we have 4 columns. Next, after table heading, let's create a table body. For that, let's have table body HTML element, and next let us have table row. Well, here we have an array. We need to iterate over array and we need to display each object in a table row, right? So for that, what we can do is we can write the JavaScript code over here. So in order to write the JavaScript code within a JSX, we need to use open and close curly braces like this. So here let us call dummy data array. It has a map method. So let us call map method over here. And notice here map method takes a callback function. So let us pass the arrow function. Well, we can use map method to iterate over an array and display each object. So here let us pass the arrow function. So we can pass employee object as a parameter to the arrow function, and then flat arrow symbol, and then here let us have a tr element, that is table row. Alright, so here let us remove this tr element because we need to iterate over an array and we need to display each row, right? Perfect. Next, each row should have a unique key. For that, let us use key attribute over here, and then within a curly braces just pass employee.id. Alright, perfect. Next, within a table row, let us display the table data. For that, let's have a table data element, and then within a curly braces employee.id. So this value should be populated in a employee ID table column. Next, table data element within a curly braces employee dot first name. Next, td within a curly braces employee dot last name. Next, td within a curly braces employee dot email. Perfect. Now we have written a code to iterate over an array and display each object in a row. Okay, perfect. Next, let us take a look into next step. Next step is import and use list employee component in an app component. Next, let's go back to our project and go to app.jsx file, and here instead of hello world, let us import list employee component. So here just call list employee component, just close it and make sure that list employee component is imported at the top. Okay, so here we have unused import, so let us remove it. Perfect. So let us take a look at next step. Next step is run and test the React application. Well, let us go back to our project and let us see our React application is running or not. So here go to the first terminal and notice here our React application is up and running. Next, let us go to browser and look at here the list of employees is displayed in the table, but the UI not looks good. So let us go and let us use Bootstrap CSS classes to style this page. Okay, so let us make this page beautiful by using Bootstrap CSS classes. So here just search for Bootstrap CSS or Bootstrap 5 container. So we are using Bootstrap 5, so just search for Bootstrap 5 container and click on the first link. So here you can see we have three containers: container, container prelude, and custom container. So let us use this container CSS class to display this data in a container. Okay, so let us go to Visual Studio Code ID and go to list employee component and go to this div over here, and here let us use class name property and just paste this container CSS class. Okay, just save this file and let's go back to browser, and now you can see here this list of employees page displayed in the container. Next, go to new tab and here just search for Bootstrap 5 table. Click on this first link and you can see the Bootstrap CSS class table. So let's copy this and go back to VS Code and go to table element, and here let us use class name property and just paste this table CSS class. Next, go back to browser. Let us use few more Bootstrap CSS classes. So here let us use table stripped. So let me copy this and let me paste it over here, and let us use one more CSS class, that is table bordered. Okay, so this is the table bordered. Okay, next let's go back to browser and go to our React application, and there we go. Now you can able to see the table looks good, right? And you can look at the page heading. The page heading should be displayed in a center, right? So let's go back to our code and here let's use bootstrap CSS class, that is text center. Let us save this file and let's go back to browser, and there we go. You can able to see list of employees table is displayed at a center. Alright, well, let me recap what we have done in this lecture. We have created a functional component named list employee component. Next, we have preferred a dummy data to display in the HTML table. Next, we have written a JSON code to display a list of employees in the HTML table. Next, we ran the React application and we have seen that a list of employees is displayed in a HTML table, and we have also used a bootstrap CSS classes to style this list of employees page. Alright, great. In next lecture, we will connect our React application to get all employees REST API and will populate the response of that REST API in a table. So instead of displaying the dummy data, we are going to display the real data that we will get from the REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to connect our React application with get all employees REST API. Well, here are the development steps. First, we'll install Axios library. Well, in order to make a REST API call in a React application, we have to use third-party HTTP library. Well, in this project, we are going to use Axios third-party library to make a REST API call in a React application. Next, we will create an employee service.js file. Next, within this employee service.js file, we are going to write a REST client code to make a REST API call using Axios API. Next, we will change list employee component to display the response of the REST API. Well, instead of displaying the dummy data, we are going to display the response of the REST API in a list employee component. And finally, we are going to test all these changes. So first step is install Axios library. So let us go to our VS Code and let us first install the Axios library. So here, go to the terminal over here. So go to second terminal, and here let me clear the terminal first. So in order to install the Axios, we have to use the command npm install and then Axios -- save. So this is the command that we use to install the Axios. So just hit enter. Notice here the Axios is installed. So let us confirm. So go to package.json file and go to dependency section, and notice here the Axios library is successfully installed. Next, let us take a look into next step. Next step is create employee service.js file, and within this file, let us write the REST client code to make a REST API call using Axios API. So let us go back to VS Code and here go to src folder. Within that, let's create a new folder and let's call it as services. Within a services package, let's create a new file. Let's call it as employee service.js. Next, within this employee service.js file, let us write the REST client code to make a REST API call using Axios API. So here, let me minimize this. So here, let us import Axios object from the Axios library. So once we got the Axios object, next we can call its APIs. Next, let's declare the constant. Let us give variable name as REST API base URL equal to. So here let us give the base URL for our Spring Boot project, that is http localhost 8080/API/employees. So this is the base URL for all the REST APIs for employee resource, right? Next, let us create a JavaScript function. Within that, we will make get all employees REST API. So here, let us use JavaScript arrow function and let us export that function. So let us use export keyword to export the function, and then const, and then let us use the variable name list employees, and then flat arrow symbol. Within a open close braces, let us have a return statement, and then Axios dot get method, and then pass REST API base URL. Perfect. Now we have written a REST client code to make get all employees REST API call. Alright, and notice here this JavaScript arrow function has a body, and within a body there is only one statement, right? So we can even simplify this function. So for example, let us remove this open curly braces and return keyword and also the close curly brace. Okay, so this is the simplified version of this JavaScript arrow function. Okay, perfect. Now we have written a REST client code to make get all employees REST API. Next, let us take a look on the next step. Next step is change list employee component to display response of the REST API. So let us go to list employee component over here, and within list employee component we have dummy data. So let us remove this dummy data. So we are going to display the response of the REST API instead of dummy data. Alright. So in order to hold the response of the REST API, we have to use the state variable. And in a functional components, in order to define the state variables, we have to use state hook. Okay. So just remember, use state hook allows us to use state variables in a functional components. Alright. So in order to use state hook, we have to first import use state hook at the top. So here, let us have open close curly braces, and within that just import use state hook, and make sure that you use state hook from React library. Alright. Next, use state hook is just a JavaScript function. So let us call use state hook, and use state hook takes the parameter. So the parameter is a initial value of the state variable. So in this case, let us give empty array. Next, use state hook returns an array with exact two values. First is a state variable, second is a function that updates the state variable. So here const and then array. So array should have two values. First is the state variable name, for example in this case employees. Second value as a function that updates the state variable. So the function name is set employees. Okay, just remember, use state hook allows us to define the state variables in a functional components, and this is the syntax to use state hook. Okay, so use state hook is just a JavaScript function. We can pass the initial value to this use state hook, and use state hook returns the array with exact two values. First is the state variable, second is the function that updates the state variable. Next, in order to make the REST API call or the AJAX call in a React functional components, we have to use effect hook. For example, here let us call use effect, and make sure that you choose use effect hook from React library, and make sure that use effect hook is imported at the top from the React library. Alright. Next, notice here use effect hook takes two parameters. First parameter is the callback function, second parameter is a dependency list. So here let us pass arrow function as a callback function, and second parameter is a dependency list. As of now there is no dependency, so let us keep empty array like this. Next, within a use effect hook, let us call list employees method from employee service, and this method has a then method. And look at here, then method takes a promise object. So let us have a promise object over here. A response is a promise object. Next, let us have an arrow function. Alright. Next, let us go ahead and let us set the response to this employees state variable. So in order to do that, we can use set employees method. So here just call set employees and then pass response dot data. Perfect. Next, let us have a catch block over here. So if there are any errors while calling the get all employees REST API, that we can catch here and we can display that error to the console. So here let us pass error object. So in order to display this, let us use arrow function over here and then console dot error and then pass error object. Perfect. Now we have written a logic to get the response of the REST API and store that data in a employees state variable. Next, scroll down and here you can see dummy data. We are not using dummy data variable, we are using employees state variable, and this employee state variable holds the response of the REST API, right? The response is basically a list of employees, and here we are using map method to iterate over this employees array and display employees in a table. Next, let us save this file and let's go to browser and just refresh, and here you can see the issue blocked by course policy issue. Well, React application is running on port 3000 and Spring Boot application is running on port 800. Both the applications are running on different ports. That's why the browser typically gives this kind of coarse policy error. Alright, so now in order to solve this issue, what we need to do is we need to handle this kind of coarse policy issue at a Spring Boot application. So Spring Boot provides @coarse origin annotation that we can use to allow React application to call the REST APIs. Alright, so let me show you how we can resolve this issue. So let's go to IntelliJ IDEA and go to employee controller over here, and let us go and let's annotate this employee controller class with @cross origin annotation, and here let us pass star. So star means all the clients can able to call the employee related REST APIs. Alright, perfect. Next let us go and let us restart this Spring Boot application. Alright, perfect. Our Spring Boot application is up and running. Next let's go to browser and let us refresh the React application, and there we go. You can able to see the 2 employees are displayed in a list of employees table. Next let us confirm whether this data is really coming from the MySQL database or not. So let's go to MySQL Workbench, go to EMS database, go to employees table, and look at here the employees table has 2 employees, Sanjay and Ramesh. And if you go to React application, you can see Sanjay and Ramesh. It means our React application is successfully connected with get all employees REST API and displayed the response of that REST API in a list of employees table. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous couple of lectures, we have implemented list employee feature. In this lecture, we are going to add header and footer to the React application. Well, you can see the screenshot over here. We are going to add header and footer like this. Okay. So in a header section, we are going to display the application name, and in a footer section, we are going to display the copyright statement. Alright. So here are the development steps. We will create a header component as a functional component, and then we'll import and use header component in an app component. Next we will create a footer component as a functional component, and next we will import and use this footer functional component in an app component. Well, the first step is create a header functional component. So let's go to our project and go to components folder. Within that, let's create a new file. Let's call it as header component.jsx. Perfect. And within a header component.jsx file, let's create a header component as a functional component. So here just type the React code snippet, React arrow function component export, and hit enter, and here you can see header component is created. Next let us design the header component. Well, here go to return statement and just remove this header component string, and here let us have header HTML element, and within that let's have a navbar, and let's add the Bootstrap CSS classes. Well, if you go to browser and just search for Bootstrap 5 navbar, click on first link and just search for the dark navbar. So here we have a dark navbar. So let me copy these Bootstrap CSS classes. So these are the standard Bootstrap CSS classes that we can use to design or style the navbar. So let's me copy them and go to header component and just paste them over here. Okay, perfect. Next, within a header, we need to also display the brand name or the application name, right? So let's go back to browser. In order to display the brand name like this in a header, we have to use navbar brand CSS class. So here let me copy this anchor tag and let me go back to header component, and within this navbar just paste it, and here let us give the application name or the brand name as employee management system, and here we can give the URL something like https www.javagets.net. You can give any URL that you want. Now we have written a code to design a simple header component. Next, let us take a look into next step. Next step is import and use header component in an app component. So let's go back to our code, and next go to app.jsx file, and here let us import header component. So just above this list employee component, just import header component and make sure that header component is imported at the top. Perfect. Next, save this file and let's go to browser and go to our React application and look at here. The header is successfully added to the React application and employee management system project name is also displayed, and you can see the console there is a error. Did you mean class name? Well, if you go to header component, so here we have to use the class name attribute like this. Okay. Next, save this file and let's go back to browser and just refresh this, and you can see there are no errors. Okay, now we have added header. Next, let us take a look into next step. Next step is create a footer component as a functional component and import and use this footer component in an app component. Let us go ahead and let's create a footer component as a functional component. So let's go to our project in VS Code and go to components folder, right click, new file. Let us give file name as footer component.jsx. Perfect. Within this file, let's create a functional component named footer component. So in order to create the functional component, let's use React code snippet command. So React arrow function component export. Next, let us design the footer component. So go to return statement and here let us remove this footer component, and within this div let us use footer HTML element. Next, let's create one custom CSS class named footer and let us write the CSS code for this footer custom CSS class. So go to app.css file and here let me write the code. Footer is the CSS class name. It has a position offset, bottom 0, width 100%, height 50 pixel, background color dark, text align center, color white. So this is how we basically write the custom CSS class. So dot followed by the class name, and within a curly braces we define the CSS properties like this. Okay, next let us use this class name in a footer component by using class name property like this. Okay, next within a footer let's use span element to define the footer copyright statement. So here all rights reserved 2023 by Java Gates, something like that. So you can write any copyright statement as per your requirement. Next, let us take a look into next step. Next step is import and use footer component in an app component. So let us go back to our project and let us import and use this footer component in an app component. So after this list employee component, let us use and import footer component like this and make sure that footer component is imported at the top. Next, let us save this file and let us go to browser and look at here the footer all rights reserved 2023 by Java Gates. Okay, now the header and footer looks good for our React application. Alright guys, I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to configure routing in a React application. Well, here are the development steps. First, we want to install React Router DOM library using npm. Well, in order to configure the routing in a React application, we are going to use React Router DOM library. Next, we need to configure the routing in an app component. Well, in our React application, app component is a root component or a base component, so we have to configure the routing in an app component. Next, configure route for list employee component and then test the route for list employee component. So first step is install a React Router DOM library using npm. So let us go to our project in VS Code and let us install React Router DOM library. And here let us open a new terminal and here let us go inside our project cd ems frontend and then here just type the command npm install React Router DOM and then save option, hit enter. So this will take a couple of seconds and there we go. React Router DOM library is successfully installed. Let us verify in a package.json file. So go to package.json file over here and go to dependency section, and notice here React Router DOM library is installed, and notice here the version 6.12.1. okay, perfect. Next, let us take a look at the next step. Configure routing in an app component. Well, let's go back to our project. Go to app.jsx file, and here we need to configure the routing. Well, in order to configure the routing, we have to use routing related components from React Router DOM library. So here let us first import routing related components. So import, so these are the named export. So within a curly braces, just type browser router. So this named export from React Router DOM library. Perfect. Now we have imported browser router. So go to return statement, and notice here we have header component, list employee component, and footer component. Well, we no need to configure the route for header component and footer component because these two components are fixed. Okay, so we are going to only configure the route for this list employee component. So here we have to use this browser router at a top level. For example, before this header component, let us use browser router component here, and let us close this here. Okay, so just enclose all the components within this browser router component. And next, this is basically a React fragment, and within a React fragment we are going to enclose browser router. Okay, perfect. Next, let us use a routes component from React Router DOM. So here go to import, and let us import routes from React Router DOM, and go to header component. After that, just call here routes. So routes is basically a container or a parent for all the individual routes. Alright, so within this routes we can define the individual routes. Alright, so here let's configure the route for list employee component. So first of all, let me remove this because we are going to configure the route for list employee component in a routes. So here just type route. So this route should be from React Router DOM. So here let us first import it. So go to import statement, and here a route component from React Router DOM. Next, this route has path property. So here we can configure the URL for the component. For example, let us configure the base URL or the root URL. Well, whenever user enter this URL, that is http localhost 3000 in the browser, then the corresponding component should be rendered, right? So for that, let us use element property, and let's configure the component name. So here list employee component, and then close it. Okay, so here basically we have configured a list employee component that this route will render whenever user hit this link in the browser. Okay, next let us configure one more route. Well, let us say if user enter the URL something like this in the browser, localhost 3000/employees, then we have to display the list employee component, isn't it? So here let's configure the route for the same route, and then path/employees, and the corresponding component name, that is list employee component. Alright, so whenever user hit this link in the browser, then the list employee component will be rendered. Now we have configured the route for list employee component. So here you can see the comment. So just select it and press Ctrl /, and then here also select it and Ctrl /. So this is how we can add the comment in a JSX code. Okay, perfect. Now we have configured the route for list employee component. Next, let us take a look at the next step. Next step is test the route for list employee component. So let us go to browser and go to our React application, and here notice here the site can't be reached. So let us go back to our project and go to this first terminal, and look at here restarting the terminal because the connection to cell process was lost. So let us rerun our React application. So just clear the terminal. Next, let us type the command cd ems frontend, and then let us run the command npm run dev. Perfect. So React application is up and running. Next, let's go to browser and just refresh and look at here the base URL localhost 3000. Well, you can use either this IP address or localhost. For example, here instead of this IP address we can use localhost. Okay, so this is the route for list component, right? For example, if you go to app.jsx file and go to app component, so here we have configured the route for the base URL. So whenever user hit this link localhost 3000, then the corresponding component will be rendered in a browser, right? So this is what we are testing here, localhost 3000, and the list employee component is displayed. Next, we have one more route, that is /employees. So whenever user hit this link localhost 3000 /employees in the browser, then the corresponding list employee component will be rendered, right? So let us test this. So let us go back to browser and here just type the URL localhost 3000 /employees and hit enter, and there we go. The list employee component is displayed. Alright, it means we have successfully configured the route for list employee component. Alright, so in upcoming lectures we will be creating a lot more components and we will also configure the route for those components. Okay, so I hope you understood how to configure the route for React components. Alright, so we have to use these three important components from React Router DOM to configure the routes, and make sure that this browser router component should be at the top. And next, we need to enclose all the individual routes within a routes component. Alright, perfect. In next lecture onwards, we will start implementing add employee feature. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures, we are going to implement add employee feature. In this lecture, we will focus on creating employee component as a functional component. Well, here are the development steps. We first need to create a React functional component named employee component. Next, we will add employee button in the list employee component. Next, we will configure the route for employee component, and finally we are going to test all these changes. Well, if you look at the screenshot over here, we are going to add employee button in a list of employees page. So whenever user click on this add employee button, then user should navigate to the add employee page. Okay, so the first step is create a React functional component named employee component. So let us go to our project in Visual Studio Code ID, and here let me minimize this and go to components folder, right click, new file. Let us give file name as employee component.jsx. Next, let us use React code snippets command to create the functional component. So here just type RAFCE. So this will create React arrow function export component. Now we have created employee component as a functional component. Next, let us take a look into next step. Next step is add employee button in a list employee component. So let us go to our project again and go to list employee component over here and go to return statement, go to heading. Right after this heading, we are going to add the button. So here just type button. Next, let us use Bootstrap CSS classes to style this button. Well, if you go to browser and in new tab just type Bootstrap 5 buttons and hit enter, and go ahead and click on this link and just scroll down, and here you can see the Bootstrap CSS classes button primary, and you can see the corresponding button primary. So this looks good. So let us copy these two Bootstrap CSS classes. Let's go to our project and let us add these two Bootstrap CSS classes to button. So here class name property and then paste button primary, and let us give margin bottom 2, and let us give the name of the button add employee. Alright, next, whenever user click on this add employee button, then we have to handle on click event, right? For that, here let us have on click event handler, and next we need to pass the function here. So for example, here let us give function name as add new employee. Next, let us provide the implementation for this function. So here go to return statement. Just above this return statement, let's create the JavaScript function and then add new employee Alright, so whenever user click on this add employee button, then we have to navigate that user to the add employee component, right? So in order to navigate user from one page to another page, we can use navigate hook. So here go to import statement, and here let us first inject use navigate hook from React router DOM. So import within curly braces, just type use navigate. So this use navigate hook from React router DOM. Next, use navigate hook is nothing but a JavaScript function. So let us assign this JavaScript function to a constant variable. So const navigator equal to use navigate. Next, let us use this navigator in a add new employee function. So go to add new employee function, and here just call navigator and then pass the URL /add employee. Well, whenever user click on add employee button, then user should navigate to add employee page. Alright, so next let us take a look into next step. Next step is configure the route for employee component. Well, here we have specified the URL, but we haven't configured the route for this URL yet, right? So let us go and let's configure the route for employee component. So let us go to app.jsx, and here let us type route. Let us use its path property, and let's configure the URL /add employee. Next, let us use the element property, and let us specify the component name employee component. So whenever user hit this link in the browser, for example, let me copy this, paste it over here, and let me change the URL localhost 3000/add employee. Then the corresponding employee component will be rendered in a browser. Okay, well, if you go to list employee component.jsx file and go to add new employee, so here we have configured the URL /add employee. So whenever user click on add employee button, then user will navigate to the add employee route, and the component for this route is employee component. Okay, so basically whenever user click on this add employee button, then user will navigate to employee component. Next, let us take a look into next step. Next step is test the above changes. So let us go ahead and let us test all these changes. So let's go to browser and look at here, add employee button is added to list of employees page. Next, go ahead and click on add employee button over here, and look at here, the user is navigated to employee component. And if you can look at the URL, add employee. Alright, so if you can compare with the code, so go to VS Code and look at here, whenever user hit this link in the browser localhost 3000/add employee, then the corresponding employee component will be rendered, right? And within employee component you can see employee component text. So this is the text displayed over here. Okay, it means we have successfully created employee component as a functional component, and we have configured the route for this employee component. Alright, in next lecture we are going to design add employee form. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture we'll take a look into add employee form handling. Well, if you look at the screenshot over here, we are going to design the add employee form that looks something like this. So we'll basically create a card. Within that we are going to create a form. Alright, so basically we are going to use Bootstrap CSS classes to design this form, and this form looks good, isn't it? Next, let us take a look into the development steps. First, we'll define the state variables such as first name, last name, email in an employee component using useStateHook. Next, we'll design add employee form using HTML and Bootstrap. Next, we'll create a JavaScript function to handle onClick event. Well, whenever users submit the add employee form, then we have to handle the submit event, right? So for that, we'll create a JavaScript function. Next, we'll test the React application. So basically, I want to print the form data to the browser console. Alright, so first step is define state variables in a employee component using useStateHook. So let us go to our project in VS Code and go to employee component over here, and here let me minimize this. So within employee component, let us define the state variables using useStateHook. So here let us use useStateHook to create first name state variable. So just type use state and make sure that you import useState from React library at the top. So useState hook is nothing but a JavaScript function, so we can pass the initial values. So here let us pass empty value and then const and then array. So here let us give state variable name as first name and let us give the function name set first name. So here first name is a state variable name and set first name is a function name that we use to update the first name state value. Alright, next let us define the last name state variable using useState hook. So here const and then array, let us give state variable name as last name, set last name is a function name and then useState, let us give initial value empty. Perfect. So similarly let us define email state variable using useState hook. So here const and then state variable name email, set email as a function that we use to update the email state variable value and then useState hook, let us give initial value empty. Perfect. Now we have defined the state variables like first name, last name, email using useState hook in a employee component. So this is the first step. Let us take a look into the second step. Second step is design add employee form using HTML and Bootstrap CSS classes. So let us go to our project and go to employee component, go to return statement and here let us remove this employee component string. So we are going to display the form in a container. For that let us use container Bootstrap CSS class over here and next let us create a div and let us pass the Bootstrap CSS class, that is row. Next let us create a one more div and let us give Bootstrap CSS class, that is card. Well, we are going to display the form within a card, that's why here we are using Bootstrap CSS class, that is card. Well, if you go to browser and go to new tab over here and just search for Bootstrap for your cards, click on first link and you can see the Bootstrap CSS classes card body, right? So these are the Bootstrap CSS classes that we are going to use to create the card, and within the card we will create the form. Okay, so let's go back to VS Code and here within a card let's first add the heading. For that let us use h2 element and let us give heading something like add employee. Perfect. Next let us display this add employee heading at a center by using Bootstrap CSS class, that is text -center. Perfect. Next after heading let us have one more div and let's give Bootstrap CSS class name, that is card body. Next within a card body let's create the form. Perfect. Next within a form let's create a div. Alright, and let's give Bootstrap CSS class, that is form -group. Next let us give margin bottom 2. Perfect. So within this div let's create the label and input element. So here label and then let us use Bootstrap CSS class for this label, that is form-label. Next let us give name to the label, that is employee first name, or let us give only first name. Okay, so let us remove this employee from here. Next we need to have a input text box to enter the text. For that let's have a input element over here and then this input element has the properties like type. Let us give text and then let's give the placeholder, let us say enter employee first name and then it has a name property. Let us give name as first name and then it has value, so let us give value as a state variable name, that is first name. Well, if you look at here we have defined first name as a state variable using useState hook, and this state variable we are passing to the value property here. Okay, next let us use the Bootstrap CSS class, that is form hyphen control. Next, whenever user enters some value in the text box, then we have to get that value, right? So for that we can use unchange event handling. So here just type unchange and just pass the event handler name. Let us say handle first name. So this is the event handler name. Next, let us create a JavaScript function to get the value from this input text box. So here let us copy this handler name. So here go to return statement. Above this return statement, let's create a JavaScript function. Let us give name as handle first name, and here let us pass event as a parameter. Next, we can get the value from this event object by using event.target.value. For example, here let us call set first name method and then pass event.target.value. Alright, so this is how we can get the value from the event object. Now we have used set first name method to set the value to the first name state variable. Alright, so next go to form. So here we have created the field for first name. Similarly, let us create the field for last name and email. So here let me copy this div and let me paste it over here, and let me change the content accordingly. So here instead of first name, last name, and here placeholder enter employee last name and name last name, and let us pass state variable name, that is last name. Next, on change and the handler name handle last name. Perfect. Next, let us create a JavaScript function that will handle this unchange event. So go to return statement. Just above this return statement, let's create a JavaScript function handle last name and then pass event object. Let us get the value from this event object. So here let us call set last name, and we can get the value from event object like event.target.value. Alright, perfect. Now we created input field for last name. Similarly, let us create it for email. So let us copy this div and let us paste it over here, and let us give label as email, and here go to input element type, let's give password. Next, placeholder enter employee email and name, let's give email, and value let us pass the state variable, that is email, and then let us give handler name, that is handle email. Alright, so let us create a JavaScript function that will handle this unchange event. So go to return statement. Just above this, let's create a JavaScript function handle email and then pass event object and then call set email event.target.value. Perfect. Now we have created input field for email as well. Next, let us create the submit button. So here let us have button. Let us give Bootstrap CSS classes such as button success. Perfect. Let us give button name as submit. So here whenever users submit the form, then we have to handle the onClick event, right? So here let us have a onClick property, and here let us pass the handler name. Let us say save employee. Okay, perfect. Next, let us take a look into next step. Next step is create a JavaScript function to handle onClick event. So let's go to our project again. So here we have specified the handler name save employee. So let us create a JavaScript function that will handle this onClick event. So let's go to return statement. Just above this return statement, let's create the JavaScript function and let's give name as save employee, and then let us pass event object. Next, within a save employee method, just call event object dot prevent default. So this will prevent the default activities that will happen while submitting the form. Next, here let us put the console.log. So before that, let's create the object. So const and then employee. Let us set all the fields to the object, such as first name, last name, email. Next, let us print this employee object to the console. Alright, perfect. Now we have created a JavaScript function to handle form submission event handler. Next, let us take a look into next step. Next step is test the React application. Well, let us go back to our project and look at here, restarting the terminal because the connection to the cell process was lost. So let us start our React application again. So here, let me clear the console and then let us type the command cd ems frontend and then type the command npm run dev. Perfect. Our React application is up and running. Next, let's go to browser and go ahead and click on this add employee button over here, and notice here the add employee form not looks good. So some bootstrap CSS are missing for this add employee form. So let us go ahead and let us add some bootstrap CSS classes to make this add employee form more beautiful. So let's go back to our VS Code and here go to this div, that is container, and go to row, go to card, and here let us use bootstrap grid system related classes to align the form at a center. For example, here column mid 6. Well, the bootstrap grid has total 12 columns and we are using 6 columns for form. Next, we need to align the form at a center. For that, we are going to use offset to move columns to right and left. So here we are going to move the form by 3 columns from left and 3 columns from right. So here again offset mid 3. Okay, next, let us save this file and let's go back to browser, and now you can see the form is located at the center of the page. Next, here you can see the card is slightly attached to the header. So let us give some space between this form and header. So let's go back to employee component again, and here after this container let us have some break elements. Perfect. Let us save this file. Let's go back to browser, and there we go. Now the add employee form looks good. Okay, next let us test this add employee form. So here right click, inspect, and then go to console, clear the console, and here just enter the first name Ramesh, last name Fadtare, email ramesh@gmail.com. So look at here, we have given the input type as a password, that's why the text looks like this. So let's go to our project again and go to form and go to email feed over here, and here input type password. So let us change from password to text. Okay, next let's go to browser, and now you can see email is visible, ramesh@gmail.com. okay, next clear the console and go ahead and click on submit button, and look at here the employee object is printed and the employee has first name Ramesh, last name Fadtare, email ramesh@gmail.com. It means we have successfully done add employee form handling. Okay, now let me show you some of the best practices that you can follow while form handling in a React application. Well, let's go to our project and go to employee component, and notice here we have written a separate handlers to handle each form input field, right? So instead of writing this much of code, what we can do is we can use JavaScript arrow function to set the values to the state variable in the input text field itself. For example, here go to first name and go to unchanged event handler. Well, notice here for this unchanged property we are passing the complete function, we are not calling the function. Well, in JavaScript we typically use the syntax like this to call the function, right? But here we are not using the braces over here, we are passing the function itself to this unchanged property. Okay, and this handle first name is a handler function, and this function basically set the value to the first name field. So here if we write the arrow function, so instead of Java function we can write the arrow function like this: const handle first name and then arrow symbol, like this, isn't it? And here also for last name we can write the arrow function const and then handle last name equal to and then arrow symbol. Next for handle email also we can write the arrow function like const handle email and then arrow symbol. So if you can notice the arrow functions, each arrow function body has a single statement, right? So if arrow function has a single statement in the body, we can also remove the open and close curly braces like this. Alright, so this is how we can simplify the arrow function. So here also let us remove open and close curly braces from handle last name and similarly from handle email. Perfect. Next, go to again first name field. Here we are passing the function itself, right? So instead of writing the separate arrow function like this, we can simply pass the arrow function body here itself. So let me copy this body and go to first name field and go to unchange event handler. Here instead of this, let me paste over here. So we can also provide the arrow function to unchange property like this. Okay, so again we can reduce this line of code as well. Similarly, let's copy this from last name and go to last name field, and instead of this handler name, let us paste this function body. And next let us remove this line of code as well. Next, similarly let's do it for email as well. So let's copy this body and go to email field, and here instead of passing the function name, let us pass the function body itself. Next we can remove this line of code. So this is how we can refactor the code and we can reduce some amount of code. So this is basically best practice we use while developing the React application. In next lecture we will connect our React application to add employee REST API, and we'll send the add employee form details to the add employee REST API, and then add employee REST API will save those form details into a MySQL database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to connect our React application to add employee REST API. Well, in previous lecture we have designed add employee form, and whenever users submit this form, then our React application have to connect to add employee REST API, and then our React application will send this form information to add employee REST API, and add employee REST API internally store this form data into MySQL database. Alright, great. So let us take a look into the development steps. In an employee service, we will write the REST client code to call add employee REST API using Axios. Next we will change employee component to call employee service method. Next we will navigate to list employee page after form submission done, and finally we will test all these changes. Alright, so let us head over to employee service and let us write the REST client code to call add employee REST API using Axios. So here let us head over to VS Code and go to employee service.js file, and here let us write the REST client code to call add employee REST API. So let us create the arrow function and let us export it. So export const, and then let's give the name create employee, and this is arrow function, and this arrow function takes employee object, and this employee object holds the employee form data. Next arrow symbol, and then call Axios dot post. Well, in order to send the post HTTP request, we have to use post method. Next let us pass the URL, that is REST API base URL, and second parameter is a employee object. Perfect. Now we have written a REST client code to call add employee REST API using Axios.post method. Alright, great. Next let us take a look into next step. Next step is change employee component to call employee service method. Well, just now we have created create employee method in a employee service. So let us call this method from the employee component. So go to employee component over here. So here we have save employee function. So within this save employee function, let us call the create employee method from employee service.js file. So here let us call create employee method from employee service, and make sure that this create employee should import it at the top. Next, this create employee expect employee object. So let us pass this employee object, and notice here this employee object contains first name, last name, email. Next, let us call then method, and then this then method expect the promise object. It contains the response. So here response, and then let us get the response using arrow function over here. So here let us print the response console.log and then response.data. Perfect. Now we have changed employee component to call create employee method from employee service. Next, let us take a look into next step. Next step is navigate to list employees page after form submission done. Well, whenever user submit add employee form, then user have to navigate to the list of employees page, isn't it? So let us write the logic to navigate user to list employees page after form submission done. So let us go to our project again. So in order to navigate user from one page to another page, we can use navigate hook. So here let us first import use navigate hook. Import and then use navigate hook from React router DOM library. Perfect. So use navigate hook is nothing but a JavaScript function. So we can call use navigate hook here, and then we can assign this function to a variable. So const and then navigator equal to use navigate. Okay. Next, let us go ahead and let us use this navigator within this create employee method. So after this console.log, just call navigator, and then let us pass the URL, that is /employees, and notice here this /employees will navigate to the list employee component. For example, if you go to app.jsx and you can see the route /employees. So whenever user hit this link in the browser, then user should navigate to list employee component, isn't it? Perfect. Next, let's go back to employee component.jsx. Now we have navigated user to list of employees page whenever a user submit this add employee form. Next, let us take a look into next step. Next step is test above changes. Next, let us go to our project and let us see our application is up and running in a development server or not. Yes, our application is up and running. Let's go to browser and just refresh. Now let us fill up the add employee form over here. So first name, let us say Tom, last name Cruz, email tom@gmail.com, and click on submit button, and there we go. You can able to see here Tom employee is added to the list of employees table. Alright, and you can see the console log here. The response is printed. The response contains ID 6. It means our React application has successfully connected with add employee REST API. Well, let us verify this data in a database as well. So let us go to MySQL Workbench over here and go to EMS database, go to employees table, and look at here Tom employee successfully inserted in a employees table. It means we have successfully connected our React application to add employee REST API, and we have stored the employee form data into a employees table. Alright, perfect. In next lecture we will see how to validate the add employee form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to add a validation to add employee form. Well, if you go to our React application and go to add employee page, so here we haven't added any validation to the add employee form. For example, if I click on submit, it will add a empty entry in the list of employees table, and in a database also the empty values are inserted. For example, here let me select the rows from employees table, and notice here employee ID is empty, first name is empty, last name is empty. So this is not a good idea to store the null values or empty values in a database columns. Alright, so let us go ahead and let us add the validation to add employee form so that user have to enter the data in the fields. Okay, so let us go to the presentation and look at here the screenshot. So we're going to basically add a validation that looks something like this. The first name is required, last name is required, email ID is required. Next, let us take a look into the development steps. First, we use state hook to initialize the state variables that will hold the validation errors. Next, we will write the validation function that checks the form data and returns validation errors. Next, we will validate the form on submission. Next, we will display the validation errors, and finally we are going to test all these changes. Alright, so very simple steps. The first step is we are going to use state hook to initialize the state variables that will hold the validation errors. So let us go to our project and go to employee component over here. So let me maximize this, and here let us type use state. Make sure that you choose use state from React library, and then let us pass the initial value as an object, and the object has the attributes like first name, and let us give empty, and then last name let us keep empty, and then email let us keep empty. So these are the object attributes to hold the validation errors with respect to the state variables. Okay, next, this use state hook returns an array. So here const and then array. So let us give the state variable name as errors and the function name as set errors. Perfect. Now we have use state hook to initialize the state variables that holds the validation errors. Next, let us take a look into next step. Next step is we will write the validation function that will checks the form data and returns the validation errors. So let us go back to our employee component over here, and here we are going to write the JavaScript function that will check the form data. So here just type function and let us give function name as validate form. Alright, next within a validate form let us declare a flag let valid equal to true. So let us give flag as a true initially. Next, here let us have a constant variable, so let us call it as errors copy, and here let us use the spread operator to copy the errors object into this errors copy. For example, here within a curly braces 3 dot, so this is basically a spread operator. Okay, so we use spread operator to copy object into another object, and here we are going to copy the errors object. Alright, so here look at here, this errors object is nothing but a state variable, and here we are basically copying this errors object into a separate variable, and then we'll store all the validation errors in this errors copy variable. Okay, next here let us add the if condition to validate the first name. If first name dot trim, so here basically we are going to trim the string. If first name is not empty, then we'll keep this validation field as a empty. For example, here errors copy dot first name, so let us keep empty because we are not going to show any validation error. If the first name is null or empty, then in the else part what we're going to do is we're going to add the validation error. For example, here errors copy dot first name equal to first name is required. So this is the validation error message, and then we'll set valid flag as a false. So here basically we have added if else condition, like if first name is not empty or not null, then we don't show any validation error. If first name is null or empty, then we will show the validation error, that is first name is required. Okay, and then valid equal to false. Next, let us add if else condition for last name and email as well. So here if last name dot trim, then we don't show any validation error. So here just call errors copy dot last name equal to empty. Next, in the else part, errors copy dot last name equal to the validation error last name is required, and then set this valid flag as a false. Perfect. So similarly, let us add a condition for email as well. So here if email dot trim, then errors copy dot email equal to empty, else errors copy dot email equal to, well, here let us give a validation error something like email is required, and then set this valid flag as a false. Perfect. And then let us set this errors copy object to state variable using set errors method. So here just call set errors method and then pass errors copy. Okay, and finally let us return this valid flag. Okay, now we have written the validation function that checks the form data and returns the validation errors. Next, let us take a look into next step. Next step is validate form on submission. So let us go to our project again, go to employee component, go to save employee method over here, and here let us add the if condition, if validate form. So notice here this validate form method returns a boolean value either true or false. If any one of the validation fails, then this method returns a false. Alright, next, if this validate form returns true, then only we need to execute this logic. So here let us cut this logic and paste it in this if block. Alright, so if first name, last name, email fields are not null or not empty, then this validate form returns true and this piece of code will get executed. Okay, now we have validated the form on submission. Next, let us take a look into next step. Next step is display validation errors. So let us go back to our project again and go to the form over here and go to this div. Here we have input field and here we have a class name. So basically we need to display the CSS class based on the condition. Okay, so if you go to browser, in a new tab just search for Bootstrap validation, click on this first link. So here basically we need to use validation related couple of Bootstrap CSS classes. For example, we are going to use is invalid CSS class, and then we are going to use invalid feedback. Okay, so these two CSS classes we are going to use to add the validation to the input fields. Alright, so let's go back to our project and here go to input field for this first name, and here is a class name property. So here we need to dynamically set the Bootstrap CSS class based on the validation error. If validation error is there, then we'll add is invalid CSS class, otherwise we'll add form control class. Okay, so here just remove this form control and let us write the JavaScript code to dynamically add the Bootstrap CSS class. So here within a curly braces just add the backtick symbol. So notice here this is not a single quote, this is a backtick symbol, and then form control. Next we need to add the one more Bootstrap CSS class based on the validation error. If there is a validation error, then only we will add a is invalid Bootstrap CSS class. For that, let us write the code here. Dollar within a curly braces, just access this errors object. It has a first name. Alright, so if the first name contains validation error, then what we're going to do is we're going to add a Bootstrap CSS class that is hyphen invalid. Perfect. If there is a no validation error, then what we're going to do is we're going to keep empty. Alright, perfect. So here we have added a condition. So based on the validation error, we will add the Bootstrap CSS class. Okay, perfect. Next we need to show the validation error message right after the input text box. So here go to input element. After this input element, let us add the JavaScript code. So here errors dot first name. So if the first name contains the validation error message, then we're gonna display that validation error message in a div. So for that, let us add the condition and then let us have a div. Let us close this div over here, and let us add the bootstrap CSS class for this div. So class name, and let us give the bootstrap class name, that is invalid feedback. Perfect. Next, let us display this validation error message. So within a curly braces, errors dot first name. Perfect. Now we have displayed the validation error message for this first name field. So similarly, let us do it for last name and email as well. So here let me copy this class name and go to last name and go to input element, and here we have a class name. So let us remove this and paste it over here, and here let us change from first name to last name. Perfect. Next, go to first name field over here and just copy this and go to last name. After this input element, just paste it, and let us change the attribute from first name to last name, and here also change from first name to last name. Okay, now we have displayed the validation error message for last name. So let us do it for email as well. So let me copy this class name and go to email and just paste it here, and just change from last name to email, and here just copy this and go to email. After this input element, just paste it, and let us change from last name to email, and here also let us change from last name to email. Perfect. Now we have displayed the validation error message for all the input fields. Okay, next let us take a look at the next step. Next step is test about changes. So let us go to our project and let us say our application is up and running or not. Well, our application is up and running. Let's go to browser and let us test all the changes. So here go to our React application, and here let me refresh this add employee page, and let me click on submit button. Well, notice here the error in a console. Even though we have added a validation, but our React application is calling add employee REST API. So let us see what is the issue. So go to our React application and go to employee component over here, and here go to save employee method, and look at here in a if condition we have called valid form method, right? So here basically we need to provide the open close braces like this. So in order to call the JavaScript function, this is the syntax, right? Now we have corrected the syntax. Next, let us save this file, and let's go back to browser, and now let us refresh and then click on submit button, and there we go. You can able to see the validation is successfully applied to add employee form. All right, the first name is required, last name is required, email is required. Okay, next let us fill up the form. So first name John, last name Sina, and then email john@gmail.com, and click on submit, and there we go. John employee is added to the list of employees table, and here you can see in the console the response contains the ID 14. Let us verify in a database table. So go to MySQL Workbench, go to employees table, and look at here John employee successfully inserted in the employees table. It means we have successfully added a validation to add employee form. In next lectures we will start implementing update employee feature in a React application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures we are going to implement update employee feature in a React application. So in this lecture we are going to add update button, title and route. So if you can see the screenshot over here, we are going to add the update button like this, and whenever user want to update the employee, then user can go ahead and click on update button. So this will navigate to the update page, and from there user can update the employee. Alright, so in this project we are going to use the employee component to perform both the operations like add employee and update employee. Alright, so instead of creating a separate component for update operation, we can use a single employee component to perform both add employee and update employee operations. Alright, so here are the development steps. First, we're going to add update button to the list employees page. For example, we're going to add the update button to list employees page like this. Next, we'll add a route for update employee in the app component. Change page title dynamically. Well, we are going to use employee component to perform both add and update operations. So dynamically we have to change the page title. For example, if you look at here the add employee page. So in case of add employee operation, the page title should be add employee, and in case of update employee operation, the page title should be update employee, right? So we're going to change this page title dynamically based on the operation. Next, we're going to test all these changes. Okay, the first step is add update button to the list employees page. So let us go to our project in VS Code and go to list employee component and go to table and go to table heading and go to table row here, and here let us add one more column. So let us call it as actions. So within actions column we can add the buttons like delete, update. Alright, next, correspond to these actions columns we are going to add the button. So go to table body, go to table row, and here let us add TD element. Within a TD element let us add the button. So here just type button and let us give button name as update. Next, let us add bootstrap CSS classes to this button. So here let us use class name property and let us give bootstrap CSS classes like button info. Next, whenever user click on this update button, then we have to handle the on click event, isn't it? For that, let us have on click event handler, and then here we need to pass the handler function name. So if you can notice here, we need to pass the employee ID to the handler function. So for that, let us use the arrow function over here. So this is the arrow function, and let us give the function name something like update employee, and then we need to pass the employee ID. So here employee dot ID. So here we have employee object, so we can get the ID from the employee object like this. Okay, perfect. Now we have added a button and we have passed the handler function to this on click event. Next, if you go back to browser and if you go to employees page over here, you can see update button is added in the actions column. So whenever user click on this update button, then user should have to navigate to the update employee page. For that, we need to configure the route. Well, if you look at the development steps, second step is add a route for update employee in an app component. So let us configure the route. So let's go to VS Code and go to app.jsx file, and here let me write the comment first. So whenever user click on this link like localhost 3000 edit -employee /employee ID, then user should have to navigate to the employee component. So here just create the route and then path and then the URL edit employee, and we need to pass the employee ID dynamically. For that, here is the syntax :ID. And next, let us use element property to configure the component. So within a curly braces, just pass the component, that is employee component, just close it. Okay, so whenever user hit this link in the browser, then user should navigate to the employee component. Alright, perfect. Next, let us go to list employee component over here, and in previous step we have added update button, right? So whenever user click on this update button, then we have to handle this on click event handler. So here we have written the handler name, but we haven't implemented this handler. So here let us create the JavaScript function. Let us give the function name as update employee, and it takes ID as a parameter. Next, whenever user click on this update button, user have to navigate to the update employee page, right? So here let us use navigate hook to navigate user to the update employee page. So here let us call navigator. Navigator is nothing but use navigate hook. Next, we need to pass the URL, that is edit employee, and we need to pass the employee ID in the URL. So here is the syntax, backtick symbol, and then slash edit employee slash, and then we need to pass the employee ID dynamically. So here is the syntax, dollar within curly braces, just pass the ID. Okay, so make sure that you add the backtick symbol, not the single quote like this. Okay, so just enclose this URL in a backtick symbols, not in a single quote. Alright, perfect. Next, let us take a look into next step. Next step is change page title dynamically. Well, this employee component supports both the operations like add employee, update employee. So let us change the page title dynamically based on the employee ID. So let us go back to employee component, and here let us write one JavaScript function. So just type function and let us give function name as page title. So notice here within this function we have to write the logic like if employee ID is present in the URL, then we need to return the page title as update employee or else add employee. Alright, so let us get the employee ID from the URL by using use params hook. So here go at the top, and here let us import the use params hook from React Router DOM. So here use params hook from React Router DOM library. So this use params hooks is a JavaScript function. So here just call use params hook, and this hook returns an object with key value pair, and we just want key. So here const, and then just add a destructuring and then pass ID. Okay, now we got the ID by using use params hook. Next, let us use this ID in a page title method. So go to page title method. Within that, let's add a if condition, and if ID is present, then we need to simply return the page title as update employee. So here we have page title. So let us copy this and go to page title method and just return update employee. In a else part, return page title as a add employee. Perfect. Next, go to this h2 element over here, just remove this, and we need to dynamically add the page title. So let us write the JavaScript code. So within a curly braces, just call this page title method. Alright, so let us remove this semicolon. Okay, perfect. Now we have added the page title dynamically based on the employee ID. Okay, perfect. Next, let us go to the development steps. The final step is test all the changes. So let us go back to our project and let us see our project is up and running or not. Well, our project is up and running in a development server. Next, let us go to browser and let us test all these changes. So go to React application in the browser and go ahead and click on this update button, and there we go. The user is successfully navigated to update employee page, and you can see the URL edit employee /2. So 2 is nothing but the employee ID. It means we have successfully added update button in a list of employees table, and we have added a route to this update employee page, and we have also updated the page title dynamically based on the employee ID. Alright, good. In next lecture, what we're gonna do is we're gonna connect our React application to get employee REST API. Well, if you look at the update form, so we have to populate this update employee form with the data so that user can go ahead and update the employee details, isn't it? So in order to populate this employee form, we have to connect our React application to get employee REST API, and we'll get the response and we'll populate this form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we want to connect our React application to get employee REST API, and we need to populate the response of this REST API in a update employee form. Well, if you go to our React application. So here we have update employee form. So in order to update the employee, we have to populate that employee data in the update employee form, isn't it? So in order to do that, let us connect our React application to get employee REST API and populate the response of this REST API in a update employee form. For example, if you look at the screenshot over here, we are going to populate the update employee form with the data like first name, last name and email like this. Alright, great. Next, let us take a look into the development steps. In an employee service, let us write the REST client code to call get employee REST API using Axios. Next, we will use effect hook to populate the employee data in the form for update operation. Next, we will test all these changes. Alright, so first step is in an employee service, let us write the REST client code to call get employee REST API using Axios. So let us go to our project and go to employee service.js file, and here let us write the REST client code to call get employee REST API. So let us create the arrow function and let us export it. So here export const and let us give the variable name get employee, and this method takes employee ID as a parameter, and then arrow symbol, and then call Axios dot get. Well, in order to make the HTTP GET request, we can use GET method over here and then pass REST API base URL. Next, we need to append this employee ID to this base URL. So here single quote slash and then employee ID. Perfect. Now we have written a REST client code to call get employee REST API using Axios.get method. Next, let us take a look into next step. Next step is use effect hook to populate the employee data in the form for update operation. So let us go back to our project and go to employee component over here. So let me minimize this. Next, go to employee component. Within employee component, here let's call use effect hook, and notice here use effect hook takes two parameters. First parameter is a callback function, second parameter is a dependency list. So let us call use effect hook and let us pass first parameter as a arrow function, second parameter is a dependency list. So here let us add ID as a dependency. Okay, perfect. Next, within a use effect hook, let us write the logic like if ID is present, then we'll populate the update employee form with the response of the REST API. So here just call get employee method from employee service and then pass employee ID as a parameter to this method, and then call then method and then response object and then arrow function. So next we have to set the data from response to these state variables. For example, here we have state variables like first name, last name, email, and we have to set the data to these state variables using the respective methods. Okay, so here just call set first name method and then pass response dot data dot first name. Similarly, let us call set last name method and then pass response dot data dot last name. Next, set email and then response dot data dot email. Perfect. Next, let us have also a catch block, catch and then error object and then arrow function, console dot error method and then pass error object. Perfect. Next, let us take a look into next step. Next step is test above changes. So let us go back to our project and look at here our application is up and running in a development server. Next, let us go to browser and here go to list of employees page and just go ahead and click on this update button, and there we go. You can able to see here the update employee form is populated with the data like first name Sanjay, last name Jadhav, email sanjay@gmail.com. Okay, now you might be wondering how this data is displayed in this input text box. Well, let me explain that. So go to VS Code ID again, go to employee component over here, and here we have called getEmployee method. It returns the response of the REST API, and here we are using setFirstName method to set the response, that is first name, to the state variable first name, right? And this first name we have used in the form. For example, if you go to form, go to first name field, go to input element, and here you can see value and then first name state, and this first name state basically contains the value. Okay, similarly you can go to last name and you can see the input element, value, last name, state variable, and this state variable basically contains the data. Okay, next email, so email state variable also contains the data, and this data we are basically setting over here by using the respective set method. Okay, so this is how the data will be populated in the form fields using state variables. In next lecture, we'll connect our React application to update employee REST API, and we'll send this updated form information to the update employee REST API, and then update employee REST API will update that data into a database. Alright, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to connect our React application to update employee REST API. Well, in previous lecture, we have populated the update employee form with the data. Next, once user submit this update employee form, then we have to call update employee REST API, and then we have to send this updated employee data to the update employee REST API, and then update employee REST API will store that updated information into the database. Alright, great. So let us take a look into the development steps. First step, in an employee service, we need to write a REST client code to call update employee REST API using Axios. Next, we will change employee component dot save or update employee method to perform both add and update employee operations, and next we will test all these changes. Alright, so let's go to employee service file, and let us write the REST client code to call update employee REST API. So let us go to our project and go to employee service.js file, and here let us write the REST client code. So let us have export and then const. Let us give variable name update employee, and let us pass the parameters. First parameter is the employee ID, second parameter is the employee object. So this employee object basically contains the updated employee information, and next arrow symbol, and then call Axios dot put. Well, in order to make the HTTP put request, we have to use put method over here, and then pass the REST API base URL. Next, let us append the employee ID to this URL. For that, let us use a concatenation operator plus, and then single quote slash plus employee ID. So this is the first parameter. Second parameter is the employee object. Perfect. Now we have written a REST client code to call update employee REST API using Axios.put method. Next, let us take a look into next step. Next step is change employee component dot save or update employee method to perform both add and update employee operations. Well, let's go to employee component over here and go to save employee method. So within a save employee method, let's write the logic. Well, this save employee method supports both add employee and update employee operations. So let us rename this save employee method from save employee to save or update employee. Next, copy this function name and go to form and go to submit button, and here we have save employee handler method name. So let us remove this and paste this save or update employee handler method name. Okay, perfect. Next, let's go back to save or update employee method over here, and here let's write the logic to support update employee operation as well. Next, within this if condition, let's add one more if condition over here. If employee ID is present in the URL, then only we'll execute the update employee logic. So here within a if condition, just call update employee method from employee service, and then pass employee ID as a first parameter, and then employee object as a second parameter. So here what I'm going to do is we're going to cut this piece of code and we'll keep at a top, and then here the employee object is available. So just pass employee object and then call then method, and then have a response object over here, and then arrow function. Perfect. So here let us print the response console.log and then response.data. Perfect. So once user submit the update employee form, then user have to navigate to the list of employees page. For that, let us have a navigator and then within a single quote /employees. Perfect. So here let us also have a catch block. So catch and then error object and then arrow function console.error and then pass error object. Perfect. Next, let us have a else block. Within else block, let us keep this add employee logic. Just cut it and paste here. Perfect. And go to this create employee method, and here also we can have a catch block. So catch and then error object and then arrow function console dot just call error method and then pass error object. Perfect. Now we have updated save or update employee method to support both update employee and add employee operations. Okay, next let us take a look into next step. Next step is test above changes. So let us go back to our project and look at here our application is up and running in a development server. Next, let's go to browser and let us test all these changes. So here go to our application and go to employees page over here, and let me clear the console and let me click on update button, and here let us update the first name from Sanjay to Sanjay123, last name Jadhav123, sanjay123@gmail.com. click on submit and look at here the employee first name is updated, last name is updated, and email ID is also updated. It means we have successfully connected our React application with update employee REST API, and update employee REST API stored the updated employee information into a database. Alright, so let us verify in a database as well. So go to MySQL Workbench, go to employees table and look at here the Sanjay employee. First name is updated, last name is updated, and email ID is also updated. It means we have successfully implemented update employee feature. Okay, now let us add a new employee and let us update that new employee. So here click on add employee button and let us add an employee. So let us give the employee name Meena, last name Padhare, email ID meena@gmail.com. click on submit. Now the Meena employee is added to the list. Next, let us update this Meena employee. So click on update button. Let us give first name as Meenakshi and then change the email ID meenakshi@gmail.com. click on submit and look at here the first name is updated, email ID is also updated. It means update employee feature is working as expected. In next lecture, we'll implement delete employee feature. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to implement delete employee feature in a React application. Well, if you look at the screenshot over here, we are going to add a delete button in actions column like this, and whenever user want to delete the particular employee, then user can go ahead and click on the corresponding employee delete button. For example, here let us say user want to delete the Ramesh employee, then user can go ahead and click on this delete button to delete this Ramesh employee. Alright, great. So here let us take a look into development steps. In the employee service, we will add the REST client code to call delete employee REST API using Axios. Next, we will add a delete button to list employees table. Next, we will create a JavaScript function to handle delete button event. And finally, we are going to test all these changes. Okay, so let us go to employee service and then let us write the REST client code to call delete employee REST API using Axios. So here let's head over to VS Code and go to employee service.js file, and here let us write the REST client code. So here export const and let us give variable name delete employee and then pass employee ID as a parameter to this method, and then arrow function and then call axios.delete. Well, in order to make HTTP delete request, we can use delete method and then pass REST API base URL. Next, we need to append this employee ID to this URL. So here let's have a concatenation operator, that is plus within a single quote slash and then employee ID. Perfect. Now we have written a REST client code to call delete employee REST API using axios.delete method. Next, let us take a look into next step. Next step is add delete button to list employees table. So let us go to our project and go to list employee component over here, and here we have a table, and go to table body, and here we have already a update button. So similarly, let us add the delete button. So here let us have a button, and let us give name to the button as delete, and let us add the bootstrap CSS classes. So here class name property, and then bootstrap CSS class name button danger. Perfect. Next, let us have a onClick event handler. For that, let us call onClick property, and here we need to pass the handler function name. So we need to also pass the employee ID. So let us use the arrow function to pass the employee ID to the handler method. So arrow function, and let us give the function name as remove employee, and then pass employee.id. Perfect. Next, let us implement this remove employee event handler method. So just copy this method and go to return statement, and just above this return statement just create a JavaScript function and then remove employee, and then pass employee ID, and here let us have a console.log just to print this employee ID. Perfect. Next, let's go to browser and look at here the delete button is added to the actions column. Next, just right click, inspect, and go to console, clear the console, and click on the delete button, and you can see here the ID 2 is printed in a console. It means the ID is available in a remove employee method. Okay, next let us call delete employee method from employee service, and make sure that this delete employee method is imported at the top. Alright, next let us pass employee ID as a parameter to this method, and then call then method, and then let us have a response object, and then let us use arrow function. Alright, and here let's have catch block, catch error, and then arrow function console dot error, and then pass error object. Perfect. So here once user click on the delete button, then the corresponding employee will be deleted, and then user have to navigate to the list of employees page, isn't it? Next, if you go to use effect hook, so here we have written the logic like we have called list employees method from employee service. So here what we can do is we can have this logic in a separate method. So let us cut this logic, and here let's create a separate JavaScript function get all employees, and then paste this logic, and next go to use effect hook, and here simply call this get all employees method. Okay, perfect. Now we have quickly refactored this code. So we have created a separate function and we have kept the logic over here. Next, we can call this function in a remove employee method as well. So go to remove employee method, go to this delete employee call, and here just call get all employees. Next, let us take a look into next step. Next step is test above changes. Well, let's go to our project and look at here our React applications up and running in a development server. Next, let us go to browser and let us test all these changes. So here go to list of employees page, and let us say we want to delete the employee, that is Sanjay123. So go ahead and click on the corresponding delete button, and there we go, the Sanjay employee is deleted. Next, let us say we want to delete the employee with ID 7. Just click on the corresponding delete button. There we go, the employee is successfully deleted. It means the delete employee feature is working as expected. Well, notice here update and delete button. So both the buttons are attached. So let us give some space between update and delete buttons. So let us go to our project and go to list employee component and go to delete button over here, and here let us add the inline style. So for that, let us call style property, and then object, and then it has margin left. So let us call margin left, and let us give value as 10 pixel. Perfect. Next, let us save this file and let's go to browser, and now look at here, there is a space between update and delete buttons. Now it looks good, isn't it? So next, let us click on this delete button to delete the employee with ID 6, and there we go. It means we have successfully implemented delete employee feature. Alright, great. I will see you in the next lecture. Hey there everyone, Ramesh here, back again with another crash course on Spring Boot and Docker. Well, in this crash course, you will learn how to Dockerize the Spring Boot application. Well, if you are a beginner and if you don't know how to Dockerize the Spring Boot application, then this course is for you. So in this course, I am going to explain each and every concept, like how to Dockerize the Spring Boot application from start to end. Okay, so in this course, you will learn the Docker workflow. So this is very important. In order to understand how to Dockerize the application step by step from start to end, you need to understand the Docker workflow. If you are a beginner, then you have to understand the Docker workflow in order to Dockerize the complete Spring Boot application. Okay, and I am going to explain the Docker workflow at a beginner level so that you will understand the complete Docker workflow. Okay, next we'll create a Spring Boot project and build some REST APIs. Next, we'll create a Docker file to build the Docker image. Well, I am going to explain you how you can create a Docker file to build the Docker image at a beginner level, so you don't need to have a prior experience on this. Next, we'll see how to build the Docker image from a Docker file. Next, we'll see how to run the Docker image in a Docker container. Next, we'll see how to push the Docker image to the Docker Hub. And finally, we'll also see how to pull the Docker image from a Docker Hub. So these are the very important steps, and these steps cover Dockerizing the Spring Boot application from start to end. And I'm going to explain each step in depth so that you will understand each and every concept of the Spring Boot and Docker. Well, I'm going to cover all the important Docker commands in this crash course, and you can use all those Docker commands in real-time projects. Alright, so without further ado, let us go and let us start this crash course with Docker workflow. Hi everyone, welcome back. In this lecture, let's take a look into the general Docker workflow. Well, this is a typical Docker workflow that we follow to Dockerize the application. As a developer, first we need to create a Docker file, and we need to define all the instructions and commands in a Docker file to build the Docker image. Alright, so Docker file is nothing but a text file. It contains all the instructions or commands to build the Docker image. Once we create a Docker file, next we can use Docker build command to build the Docker image. Okay, so Docker image is nothing but an executable package, and we can run this Docker image in a container. Alright, so Docker container is nothing but a running instance of Docker image. So this complete process is called Dockerization. Okay, so as a developer, we need to create a Docker file, and we need to define all the instructions or commands to build the Docker image. And we use Docker build command to build the Docker image from the Docker file, and then we can use Docker run command to run this Docker image in a Docker container. Here the Docker container is nothing but a running instance or runtime instance of Docker image. Okay, so this complete process is called Dockerization. Next, once we have a Docker image in our local machine, then we can push this Docker image in a online cloud repository called Docker Hub. Okay, once we push Docker image in a Docker Hub, then we can pull that Docker image on any environment, and we can start deploying this Docker image in a Docker container. For example, let's say we have different environments like staging environment, test environment, production environment, or UAT environment. Alright, once we push Docker image on a Docker Hub, then we can pull this Docker image on any environment, and we can run that Docker image in a container. Alright, so this is how the typical Docker workflow looks like. Let's understand this general Docker workflow with an example. For example, consider we want to Dockerize the Spring Boot application. Then what we need to do is we need to create a Docker file first, and we need to define all the instructions or commands to build the Docker image. Alright, so once Docker file is ready, then we can use Docker build command to build the Docker image from the Docker file. So here Docker image is nothing but an executable package. Next, we can use Docker run command to run this Docker image in a container. So Docker container is nothing but a running instance or a runtime instance of Docker image. So this complete process is called a Dockerization. Well, once we have a Docker image on our local machine, then we can go ahead and push this Docker image on a Docker Hub using Docker push command. Okay, so once we push Docker image on a Docker Hub, and if we make this Docker image as a public on Docker Hub, then anybody can go ahead and pull this Docker image from the Docker Hub and they can run that Docker image in a Docker container. Okay, so this is how the typical Docker workflow looks like. In next lecture onwards, we'll see how to Dockerize the Spring Boot application step by step. First, we'll create a Spring Boot application and we'll build some REST APIs. Next, we'll create a Docker file and we'll define all the instructions and commands to build the Docker image. Next, we'll see how to create a Docker image from the Docker file, and next we'll see how to run a Docker image in a Docker container, and next we'll see how to push a Docker image to the Docker Hub. So these are the steps that we are going to perform in order to Dockerize a Spring Boot application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen the general Docker workflow. In this lecture onwards, we'll start Dockerizing Spring Boot application. Well, here are the development steps to Dockerize a Spring Boot application. First step, we'll create a Spring Boot application and we'll build some REST APIs. In second step, we'll create a Docker file to build the Docker image for our Spring Boot application. Next, we'll see how to build the Docker image from the Docker file. And next, we'll see how to run a Docker image in a Docker container. And next, we'll see how to push this Docker image on a Docker Hub. So these are the steps that we are going to perform in order to Dockerize a Spring Boot application. In this lecture, let's go ahead and let's create a Spring Boot application and we'll import that Spring Boot application in a IntelliJ IDEA. Alright, so let's go to a browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer, and here we have different types of projects. We are going to use Maven, so let's select Maven over here, and here let's keep Java as selected. Next, here we are going to use Spring Boot 3, so let's keep Spring Boot 3 as selected over here. Next, let's pull up the project metadata. So here let's give group as net.javaguides. Well, here I am going to give project group as net.javaguides, but you can give any group that you want. Next, let's give artifact as Spring Boot Docker demo, and then project name is same as artifact, and description demo project for Spring Boot and Docker, and then package name net.javaguides.springboot. Next, packaging, let's keep jar as selected over here, and next Java 17. Well, remember, whenever you select Spring Boot version 3, then make sure that you have to select Java version 17 because Spring Boot 3 requires Java 17 or later. Alright, next let's go to dependency section over here, and here let's add Spring Boot starter web dependency to build the REST APIs. Okay, so this single dependency is enough as of now. Next, let's go ahead and click on generate button to generate this project as a zip file in a local machine. Next, let's go ahead and let's open this zip file in a folder, and next let's unzip this zip file. Let's go ahead and let's open the IntelliJ IDEA. Here I have opened the IntelliJ IDEA. Next, here we have three options: new project, open, get from VCS. Well, we are going to open the existing Maven project in IntelliJ IDEA, so go ahead and click on open over here, and next go to the location where your Spring Boot application is present. In my case, it's in download folder, so go to downloads folder, and here we have Spring Boot Docker demo project. Select it and click on open. So this will open Spring Boot application in IntelliJ IDEA. Once we create a Spring Boot application and import in IntelliJ IDEA, next let's go and let's create one simple REST API. So go to base package over here, and here let me create one new package, and let's give name as controller. Within a controller package, let's create one Java class, and let's give class name as Docker controller, something like that. And let's go ahead and let's annotate this controller class with @REST controller annotation to make this class as a Spring MUC REST controller, and within this controller we can define the REST APIs. So here just type public, and let's give a return type of the method as string, and let's give method name as Docker demo, and then let's return some string over here. Let's say Dockerizing Spring Boot application. Alright, perfect. Next, let's go and let's annotate this method with add get mapping annotation. So this get mapping annotation will map incoming HTTP get request to this particular method. Next, let's provide the REST API URL for this method over here. So let's give something like Docker. Alright, perfect. Now we have built a simple REST API. Next, let's go and let's run the Spring Boot application and let us test this REST API. So here, let me go to main entity point class, and from here I'm going to run our Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to browser. In a new tab, just type localhost :8080/docker, hit enter, and there we go. The client got the response of the REST API as a Dockerizing Spring Boot application. It means we have successfully created a Spring Boot application, and we have imported an IntelliJ IDEA, and also we have created one simple REST API. Next step is we need to create a Docker file, and we need to define all the instructions or commands to build the Docker image for a Spring Boot application. Alright, in next lecture we'll see how to create a Docker file and how to define the instructions or command to build the Docker image. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created a simple Spring Boot application and we have built a simple REST API. In this lecture we are going to create Docker file and will define all the instructions or commands to build the Docker image. Alright, so if you go to browser and just search for Docker file and hit enter and go ahead and click on first link, it will navigate to the official Docker website. And if you want to know more about Docker file, you can go ahead and check out this documentation over here. Okay, so Docker can build images automatically by reading the instructions from Docker file. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It means that the Docker file is nothing but a text file. It contains all the commands or instructions required to build a Docker image. Okay, and the Docker file name should be same as Docker file. Okay, next let's go ahead and let's create a Docker file in our Spring Boot application and let's define all the instructions. So let me go to IntelliJ IDEA over here. Well, before creating a Docker file, let's go ahead and let's Maven build our Spring Boot application. We'll go to Maven section over here and go to project and go to lifecycle, and here just choose clean and package and go ahead and click on this run Maven build icon over here. So this will Maven build our Spring Boot application, and there we go, build success. And if you go to target folder, within the target folder Spring Boot Docker demo jar file is created. Okay, next we are good to create a Docker file. So go to Spring Boot project root directory over here, and here right click new and then choose file, and let's give file name as Docker file, and make sure that the file name should be same. Okay, and this D should be in uppercase. Next, within this Docker file, let's go ahead and let's define the instructions. Well, let's begin with from. Well, remember the Docker file always starts with from instruction. So we use from instruction to define the base image or a parent image for this image. Well, basically we can create a Docker image from another image which is available in a Docker Hub. For example, if you go to browser, in a new tab just search for Docker Hub and go to Docker Hub website over here and just search for Java and hit enter and just scroll down, and here you can see Java Docker official image. So go ahead and click on this. So this will navigate to the OpenJDK Docker official image. So if you can notice here, deprecation notice. Well, OpenJDK is deprecated and they are recommending to use these alternative official Docker images. Well, we are going to use Eclipse Tamarind as a alternative official Docker image. So go ahead and click on this Eclipse Tamarind over here and just copy this Docker image name and go to our project and go to Docker file, and after from just paste it and let's define the tag that is 17. So this will provide basically a Java 17. Okay, great. So remember, the Docker file always starts with from instruction, and we use from instruction to define the base image or a parent image. Okay, next let's go ahead and let's define the metadata. Well, in order to define the metadata, we can use a label instruction, and then we can use its attribute, that is maintainer equal to, and then we can define the email ID. For example, let's say javaguides.net@gmail.com. Next, let's create a working directory in a container. For that, let's use work directory instruction over here, and then let's define the directory name. Let's give directory name as a /app. Well, whenever we run the container, then app directory will be created in a container. Next, let's use copy instruction to copy source file from our system into a destination in a container. For example, we are going to copy the Spring Boot Docker demo jar file into a container. For example, copy, and then let's define the source. Source here is target/Spring Boot Docker demo jar file. So basically, we are going to copy this jar file from our project into the app folder in a container. For example, if you look at the location of jar file, we have Spring Boot project, within that we have target folder, within that we have Spring Boot Docker demo jar file, right? So we are going to basically copy this jar file from our project into the app folder in a container. Okay, next the destination should be /app, and then within this app directory we are going to copy this jar file, and let's give jar file name something like Spring Boot Docker demo jar. Well, once we copy the jar file in a Docker container, next we need to start this jar file, right? For that, we need to have a entry instruction over here, and then within a double square brackets we need to define the command java, and then second argument -jar, and then third argument the name of the jar file, that is Spring Boot Docker demo.jar. So let me copy this and paste it over here. Okay, so this is how we define the entry point to run the jar file. Now we have created a Docker file, and we have defined all the instructions or commands to build the Docker image. In next lecture, we will see how to build a Docker image from this Docker file. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created a Docker file and we have defined all the instructions to build the Docker image. In this lecture, we will see how to build a Docker image from the Docker file. Well, before building a Docker image from the Docker file, make sure that a Docker desktop is running in your machine. For example, I have started a Docker desktop. Once the Docker desktop is running in your machine, then it looks like this. Okay, and using Docker desktop, you can track the images and you can track the containers, volumes. Okay, so make sure that before building a Docker image from the Docker file, your Docker desktop is up and running in your machine. Okay, next let's go to our project, and in previous lecture we have created a Docker file. Within that we have defined these set of instructions, like we have a from instruction over here. So we use from instruction to define the base image or a parent image for this Docker image, and next we have used a label instruction to define a maintainer or a author. Next we have used the working directory as an app directory in a container. Well, whenever we deploy a Docker image in a Docker container, then this app directory will be created in a Docker container. Next we have used a copy instruction to copy this jar file from our project into the directory in a container. Okay, next we have used entry point to start the jar file in a Docker container. So these are the simple instructions that we have defined in a Docker file. Next we are going to use this Docker file to build the Docker image. Alright, so let's open the terminal. Well, I'm using Mac operating system, so I can open the terminal over here, but if you are using Windows machine, make sure that you open the command prompt. Okay, well, let me open a new cell. It has a background white. Okay, so let me zoom it a little bit. Next, let's go ahead and let's jump into our project. So just type cd and then downloads. Well, our project is present in downloads folder, so go to downloads folder. Within that we have a project that is Spring Boot Docker demo. Okay, so make sure that you are in a Spring Boot Docker demo project. Okay, because the Docker file is present within this project, isn't it? Next, let's go ahead and let's use docker build command to build the Docker image by using this Docker file. So here just type the command docker followed by build and then -t. So this option is to tag the Docker image and then followed by the Docker image name. So let's give Docker image name something like Spring Boot Docker demo followed by the location of the Docker file. Well, if you can notice here, the Docker file is present within the project, so that's why I have given dot here. So dot means the current working directory, and the Docker file is present within a current directory, that's why we have given a dot over here. Alright, next hit enter. So this will build a Docker image by using a Docker file. Well, notice here the build instructions: load build definition from Docker file, and Eclipse Tamarind image is pulled from the Docker registry. Next, created the working directory in a container. Next, copied this jar file from our project into container. Next, the image is exported and layers are also exported. Alright, so it means that the step-by-step instructions are executed, and finally the Docker image has built and stored in a local machine. So if you want to check whether the Docker image is created and stored in a local machine, we can just type the command docker images. So this will give a list of Docker images in our machine. For example, look at here, Spring Boot Docker demo. So this is the Docker image that we have built using Docker file, and notice here the tag name latest. Well, we haven't given a tag name while building the Docker image, that's why by default the Docker added the tag name as a latest, and this is the image ID, and this is the created time, the image created time, and this is the size of the Docker image. Okay, next what we can do is we can also add a tag to the Docker image as well. So let's see how to do that. Just type the command docker build -t. So -t option we use to provide a tag name to the Docker image, and then followed by Spring Boot Docker demo. So this is the image name, followed by colon, and then we need to provide a tag name. For example, let's say 0.1.release. So this is the tag name that we are giving to this Docker image. Okay, next let's go ahead and hit enter. So this will build a Docker image with this tag name. Okay, now the Docker image is built. Next, let's see the list of images. Just type the command. So let me clear the terminal first, and just type the command docker images. So this will display all the images in our machine, and if you can notice here, Spring Boot Docker demo is the image name, and the tag is 0.1.release, and then created time is 19 minutes ago. So notice here we have a Docker image, it has different tags. Okay, so this is how we can use the docker build command to build the Docker image with tag. Okay, in next lecture we will see how to run the Docker image in a Docker container. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have seen how to build a Docker image from a Docker file, and also we have seen how to provide a tag name to the Docker image. For example, let's go to terminal, and we have used the command docker build -t followed by the Docker image name and then working directory. So basically we have used this docker build command to build this Docker image from the Docker file, and then we have used docker build -t Spring Boot Docker demo is the Docker image name followed by the tag name. So we have used this command to build the Docker image with tag. Okay, in this lecture we will see how to run a Docker image in a Docker container by using docker run command. Okay, so let's go to a terminal, and here let me list out the Docker images first. So just type the command docker images. So this will display all the images in our system. So if you can notice here, we have Spring Boot Docker demo image. It has 2 tags. Next, let's go ahead and let's see how to run Docker image in a Docker container. So let's type the command docker run and then followed by -p. So -p is to map the port. So basically we need to map the container port with host operating system port. For example, 8080:8080. So this 8080 is basically a port for host operating system, and this 8080 is a port of container. Well, basically container has its own private network, and in order to access that network we have to expose the port to the host operating system. So that is what we are doing over here. So we are mapping the container port with host operating system port. Okay, so if we map the port like this, then we can able to access the container private network by using this exposed port, that is 8080. Alright, great. Next, followed by the image name. So image name in our case, Spring Boot Docker demo. So let me copy this image name and paste it over here. Okay, so this is the docker run command that we use to run a Docker image in a Docker container. So just hit enter. Next, let's go to browser and let's call the REST API. So let's go to browser. In a new tab, just type localhost :8080/docker, hit enter, and there we go. The client got the response of the REST API. Okay, next let's go to terminal, and here just press Ctrl+C to kill the Docker instance. Okay, so if you are using Windows, then just press Ctrl+C. Okay, now we have stopped the Docker container, and in order to check whether the Docker containers are running or not, for that we can just type the command docker ps. So let me clear first the terminal and just type the command docker ps to check the running containers. As of now, there are no running containers. Okay, next let's type the command docker run followed by -p and then 8081 and then 8080. Well, notice here we are mapping the container port 8080 with the host OS port 8081 and then followed by the image name, that is Spring Boot Docker demo, and hit enter. So notice here the port mapping, we are mapping the container port 8080 with the host OS port 8081, and in order to access our Spring Boot application we have to use the host OS port, that is 8081. Okay, for example, if you go to browser and just try to access localhost 8080/docker, it won't access because we have exposed the port 8080 with 8081, right? So we have to use 8081 port over here. Okay, so there we go, we got the response of the REST API. So this is how we need to map the container port with the host OS port. Alright, next let's see how to run the Docker container in a background. So just press Ctrl+C, so this will stop the Docker container. Next, let's see how to run a Docker container in a detached mode. Detached mode meaning at a background. Okay, so here let me clear the terminal and just type the command docker run and then -p followed by the port mapping 8081:8080 and then followed by -d. So -d option is for to run the Docker container in a detached mode. Detached mode meaning the Docker container will basically run at a background. Okay, so next hit enter. Alright, next we can use docker logs command to see the logs of the Docker container. For example, here just type the command docker logs and then -f to tail the logs and then followed by the Docker ID. So instead of giving this whole Docker ID, we can just provide first 4 digit, that is 1424, and hit enter, and there we go. You can able to see the logs of our Spring Boot application. Okay, next let's go to browser and let's access the REST API. So here I am going to access the REST API, and there we go, you can able to see the logs over here. Well, basically we have provided -f option in a command to tell the logs. That's why you can see all the logs over here. Okay, next just press Ctrl C if you are using Mac operating system. If you are using Windows, press Ctrl C. It will just exit the process, but it won't stop the Docker container. Okay, so if you just type the command docker ps, it will list all the running Docker containers. And notice here the Docker container is running. Okay, we haven't stopped the Docker container because we are running the Docker container in the background. So in order to stop the Docker container, we have to type the command docker stop followed by the Docker container ID, that is 1424. So you can just enter first 4 digit and hit enter. So this will stop the Docker container. Okay, so these are the couple of commands that we can use to play with Docker containers. Alright, so in this lecture we have seen how to run a Docker image in a Docker container. Alright, in next lecture we will see how to push a Docker image from a local machine into a Docker hub. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have seen how to run a Docker image in a Docker container. In this lecture we will see how to push a Docker image from our system into a Docker hub. Well, in order to push a Docker image from our local machine into a Docker hub, we need to first create an account in a Docker hub. For example, if you go to browser and just type Docker hub in a new tab and click on this first link, so this will navigate to hub.docker.com. So in order to push Docker images to the Docker hub registry, you need to first register to this Docker registry. Well, Docker hub is nothing but a Docker registry where we can store the Docker images as a repositories. Well, in order to push the Docker images in a Docker hub, first you need to register. So just click on register and go ahead and enter username, email ID and password. Okay, so once you create a Docker account, then you can use this username as a Docker ID to push the Docker images as a repositories. Okay, well, I have already created a Docker account and I just logged into Docker hub over here, and if you can notice here a couple of repositories in a Docker hub. Well, here Java guides is nothing but my username or a Docker ID, and within this Docker ID you can see list of repositories. So these repositories are nothing but a Docker images, and these Docker images are associated with number of tags. Okay, so the Docker image can contain a number of tags over here as per the release. Okay, so this is how the repositories looks in a Docker hub. Well, whenever we push a new image to the Docker hub, then a new repository will be created under Docker ID, and the repository name should be same as image name. Okay, and you can also create a new repository by using this create repository button over here, and then you can push the image name to this particular repository. Okay, next let's go and let's see how to push an image to the Docker hub, and then we'll log in into Docker hub and then we'll see the repository. Okay, so let's go to terminal over here, and here let's type the command clear to clear the terminal, and here let me type the command Docker images to list all the images. So here we have two Docker images, we have one Docker image with two tags. Okay, now let's go ahead and let's push the Docker image to the Docker hub. Well, in order to push a Docker image from our system into a Docker hub, first we need to log into Docker through terminal. So here just type the command docker login. It will ask a username and password. Just provide a Docker hub username and password over here. Alright, now I have already logged into Docker, that's why you can able to see login succeeded. So once you enter username and password, then you can able to see login succeeded. Okay, next we are good to push a Docker image to the Docker hub. Well, in order to push the local Docker image into Docker hub, first we need to associate this local Docker image with the repository on a Docker hub. Okay, so in order to do that, let's type the command docker tag followed by the local Docker image name, that is Spring Boot Docker demo. So let me copy this, paste it over here, and then followed by the repository on Docker hub. So here just type Java guides is the docker id followed by, so we are going to create a repository with the name as Spring Boot docker and then demo. So this is the repository that will create in a Docker Hub. Okay, and this repository will be created under the docker id java guides. All right, make sure that you replace the docker id from java guides with whatever the docker id you have. Okay, and next followed by, we need to also add the tag name for this repository. So here let me give tag name something like 0.1.release. okay, so this is the command that we need to tag the local docker image with the repository on a Docker Hub. Okay, so if you can go to Docker Hub, so we have Java Guides as a docker id. So under this Java Guides docker id, the repository will be created with the name Spring Boot Docker Demo. Okay, and then this repository will contain this docker image. Okay, next just hit enter. Now we have associated the local docker image with the repository in a Docker Hub. Next let's enter the command to push this docker image to Docker Hub. So if you just enter the command docker images, you can able to see here the repository java guides / spring boot docker demo. Okay, so this is a docker id and then this is a repository name. Next we are good to push this docker image on a Docker Hub. All right, so here just type the command docker push and then followed by the repository name. So let me copy this and paste it over here, and then we can also have a tag name that is 1.0.release. So let me copy this tag and here colon and then paste this tag over here. Okay, now this is the command that we use to push the local repository into a Docker Hub repository. Okay, next hit enter and notice here the push refers to repository, this repository. Okay, so it will take a couple of seconds to push the image from local machine into a Docker Hub. And there we go, the push is completed. Next, in order to verify the Docker image is pushed to Docker Hub or not, let's go to Docker Hub. So go to browser and go to Docker Hub and just log in to Docker Hub if you are not logged in. And there we go, Spring Boot Docker Demo repository is created under Java Guides docker id, and this repository contains a Docker image. And just click on this repository, and if you can notice here the tags 0.1.release. So this is the tag we have provided while pushing a Docker image to the Docker Hub. Okay, so this is how we can push Docker image from our system into a Docker Hub. Alright, well, let me recap what we have done in this lecture. We have created a Docker account in a Docker Hub. Next, we have logged into Docker using Docker login command, and then we have associated the local Docker image with the repository on a Docker Hub. For example, we have used the command docker tag and followed by the local Docker image name and then followed by the repository on Docker Hub in this format. Okay, so docker id followed by the repository and then followed by the tag name. So this repository basically contains this Docker image name. Okay, next we have used docker push command to push the Docker image into Docker Hub. So these are the couple of steps that we have performed in order to push an image from local machine into a Docker Hub. Okay, great. I hope you understood how to create a Spring Boot application and how to create a Docker file and how to build a Docker image from the Docker file and how to run a Docker image in a Docker container and how to push a Docker image into a Docker Hub. Hi everyone, welcome back. In previous lecture we have seen how to push a local Docker image in a Docker Hub. In this lecture we will see how to pull a Docker image from the Docker Hub and run that Docker image in a Docker container. Well, if you can see the general Docker workflow here, so once we push the Docker image in a Docker Hub, then we can pull that Docker image from the Docker Hub and we can deploy in different environments. Okay, so in this lecture let's see how to pull a Docker image from the Docker Hub and run that Docker image in a Docker container. So let me go to Docker Hub over here and let me log in into Docker Hub account, and here you can see I have a couple of repositories in a Docker Hub. And now let me show you how to pull the Docker repositories from Docker Hub. So here let me pull this repository, that is Java Guides / Spring Boot Docker Demo. So Spring Boot Docker Demo is a repository under Java Guides Docker ID. Okay, so in order to pull this repository or a Docker image, we need to enter this entire path. Okay, for example, if you go to terminal and just enter docker pull command over here, let's say docker pull and then followed by Java Guides is a Docker ID and then followed by the image name or the repository name, for example Spring Boot Docker Demo, and hit enter. And look at here, by default it will look for the tag with the name latest. So here we got the error because the latest tag is not exist. For example, if you go to Docker Hub over here and if you go to tags for this repository, you can see the tag present is 0.1.release. There is a no latest tag present for this repository. Okay, so just type this tag in a command. Let me re-enter the command docker pull followed by Java Guides / Spring Boot Docker Demo and then followed by the tag that is 0.1.release. Hit enter and there we go. Now we can able to successfully pull this Docker image or a repository from the Docker Hub. Okay, and here just type the command docker images to just check whether the image is present in a local machine or not. Okay, so images already exist, so let me pull another Docker image. For example, if you go to Docker Hub and here just search for one of the Docker image. For example, let me pull MySQL Docker image. So just go to Docker image, official image, and let me go to tags over here and let me pull the MySQL Docker image with latest tag. Okay, so just go to terminal, here just type docker pull followed by MySQL and then followed by the tag that is latest and then hit enter. And here you can see it will take a couple of seconds to pull the Docker image from the Docker Hub. Now you can able to see downloaded newer image for this particular repository. Okay, in order to check whether this image is downloaded in our machine or not, we just type the command docker images and there we go. Repository is MySQL and tag is latest. Okay, so here let me clear it and let me pull one more image. So here let me pull MariaDB Docker image and go to official Docker image over here and go to tags. So let's pull MariaDB latest. Okay, so go to terminal and here just type the command docker pull and followed by MariaDB and then latest. So if you don't mention the latest tag, then by default it will pull the MariaDB image with latest tag. Okay, so hit enter and if you can notice here using default tag latest. So we haven't mentioned the tag in a command, that's why by default it is using latest tag. Okay, so it will take couple of seconds to pull this MariaDB image from the Docker Hub. So just wait for a couple of seconds and there we go. You can able to see the status downloaded newer image for MariaDB latest. Okay, so in order to check whether this image is present in our local machine or not, just type the command docker images and there we go. You can able to see MariaDB latest and this image is created 7 days ago. So this is how we pull the Docker image from the Docker Hub. Next, let me show you how to run one of the Docker image in a Docker container. So let's see how to run this MySQL Docker image in a Docker container. Okay, so here let me quickly type the command docker run followed by -p option to map the port. So here we are mapping the container port with the host OS port and followed by the container name, that is localhost, and followed by we define some of the environment variables like the MySQL root password is MySQL@123 and then database name is employee_db and then new user name is Ramesh, password is Ramesh, and here we need to provide the image name, that is MySQL:/latest. Alright, perfect. Next, so we are going to run this image in a detached mode, that's why -d option. Okay, next hit enter and there we go. The MySQL image is successfully running in a MySQL container. Next, let's go ahead and let's type the command docker logs -f to tail the logs, and then followed by the container name, so that is localhost. So if you can notice here, we have given the container name, that is localhost, right? So notice here the option --name localhost. So localhost is basically a container name. Okay, next hit enter, and there we go. You can able to see the logs for MySQL database. Okay, next, if you want to check whether the MySQL database is running in a Docker container or not, so we just need to log in into MySQL database in a Docker container. So let me show you how to do that. So just press Ctrl C, and here just type the command docker exec and then -it, and then followed by the container name, that is localhost, and then followed by bash. Hit enter, and there we go. You can able to see the bash over here, and within the bash, so let me first exit and clear the terminal so that you can see it better. So just type the command docker exec -it localhost bash, hit enter. So this will jump into bash bash terminal, bash shell basically, and here we can type the command mysql -u for user, and then root, and then p, and then enter password, that is mysql@123, and there we go. We can see the MySQL cell over here, and here just type show databases, and notice here employee_db database is successfully created. It means we have successfully deployed MySQL Docker image in a Docker container. Okay, so this is how we pull the Docker image from the Docker Hub and we run the Docker image in a Docker container. Alright, great. I will see you in the next lecture. I will be covering top 25 plus Spring Boot annotations. Let's kickstart one of the top Spring Boot annotation, that is add Spring Boot application annotation. Hi everyone, welcome back. In this lecture, we'll take a look into add Spring Boot application annotation. Well, this annotation is very important because whenever we run our Spring Boot application, then this annotation does a lot of things behind the scene. Alright, so many Spring Boot developers like their applications to use auto configuration, component scan, and also need to define the extra configuration on their application class level, right? So this single Spring Boot application annotation does all these three things. Okay, so basically add Spring Boot application annotation internally composed with three important annotations, that is add enable, auto configuration, add component scan, and add configuration. So these are the three very important annotation, and add Spring Boot application internally uses all these three annotations to provide three important features, like it uses enable auto configuration annotation to enable Spring Boot's auto configuration mechanism, and this annotation internally uses add component scan annotation to enable component scan on the package where the application is located. Next, this annotation also uses add configuration annotation. It will allow to register extra beans in a context or import additional configuration classes. Well, if you look at the diagram over here, add Spring Boot application annotation, it internally has three annotations: add Spring Boot configuration, add enable auto configuration, add component scan annotation. And this add Spring Boot configuration annotation internally uses add configuration annotation. Alright, so basically add Spring Boot application annotation uses all these three annotations to provide three important features. Alright, so Spring Boot application annotation enables Spring Boot's auto configuration mechanism. It will enable add component scan on the package where the application is located, and it will also enable the configuration where we can define the extra Spring beans or we can import the extra configuration classes. Alright, so let's go to our project and let's explore more about add Spring Boot application annotation. Let's head over to the IntelliJ IDEA. Let's go to our project, and here we have Spring Boot first app application. So this is the main entry point class of the Spring Boot application. Alright, and this class is annotated with add Spring Boot application annotation. Well, whenever we create a Spring Boot application using Spring Initializer, then Spring Initializer by default create this application starter class and annotate this class with add Spring Boot application annotation. Well, many Spring Boot developers like to enable the auto configuration like to add the component scan, and also like to define the extra configuration in a configuration class, isn't it? So in order to do all this stuff, we can use this annotation on top of this main entry point class. Next, if we dive inside this annotation source code, you can able to see this annotation is composed of add spring boot configuration annotation, add enable auto configuration annotation, add component scan annotation. And if you go inside add spring boot configuration annotation, you can see this annotation is alias for configuration annotation. So you can compare this hierarchy with this diagram. So add spring boot application is composed of these three annotations, and add spring boot configuration annotation internally composed with add configuration annotation. Alright, perfect. Hi everyone, welcome back. In this video, let us take a look into add configuration properties annotation. Well, add configuration properties annotation is used to bind external configurations to a strongly typed Spring Bean in your application code, and next you can inject and use this Spring Bean throughout your application code just like any other Spring Bean. Well, add configuration property annotation is widely used in real-time projects because we can use this annotation to directly bind an external configuration properties to a Java class. For example, look at here the code snippets. Here we have properties file, and here we have a Java class. Well, this Java class is annotated with add component annotation, so we can call this class as a Spring Bean. Next, in order to directly bind this properties file content to this Java class fields, we can use add configuration properties annotation. For example, if you can notice here the properties app.name, app.description, app.upload directory. So these properties we can directly bind to the Java class fields like name, description, and upload directory fields. Next, we can bind the nested object properties. For example, here app.security.name, app.security.password, app.security.roles, app.security.enabled. So in order to bind these nested object properties, what we can do is we can create a separate class. For example, look at here security, and within a security class we have defined all these properties. For example, username, password, roles, and enabled. So this is how we can use add configuration properties annotation to bind nested object properties in a Java class. Next, we can bind the properties to the map. For example, here are the properties, and in order to bind these properties, we can create a map with the name permissions, and after the permissions you can see can view post equal to true. So these are the key value pair, and this key value pair will be stored in this map. Okay, so this is how we can use add configuration properties annotation to bind the properties directly to the Java class fields. Well, here one more important point is add configuration properties annotation has attribute prefix, and we have provided a value as an app. So basically this add configuration properties annotation will bind all the properties which are prefixed with a string app. For example, if you can observe here, all these properties are prefixed with the string app, right? So this add configuration properties annotation will basically bind all these properties to this Java class fields. Next, let me demonstrate the usage of add configuration properties annotation with an example. So let's go to our project in IntelliJ IDEA and go to application.properties file. Within application.properties file, we are going to define all the properties. So here, let's first define the top level application properties. So here just type app.name equal to, let's give application name something like configuration properties demo. Next, let's give application description something like configuration properties demo description. Next, app.upload hyphen directory equal to, let's give directory name something like uploads. Okay, now we have defined the top level application properties. Next, let's use add configuration properties annotation to bind these properties. So here, go to the base package. Within that, let's create a new package. Let's call it as configuration properties. So here I am demonstrating the usage of add configuration properties annotation. That's why I have given the package name configuration properties. Next, within this package, let's create a class. Let's give name as app properties. Within an app properties class, let's define the instance variables private string name and then private string description, and then private string upload directory. Well, make sure that the field name should be same as the property names. For example, if you go to application.properties file, here we have given the property name, description, and upload -dir. So in order to bind this property to the field, we can give field name as a upload directory. Okay, we can give the property name in a camel case like this. Okay, perfect. Next, let's annotate this class with at configuration properties annotation, and then let's use its prefix attribute and then pass a value as a app. So this prefix attributes basically we use to tell at configuration properties annotation that read all the properties which are prefixed with the string app. And if you go to application.properties file, here we have defined these three properties, and these three properties are prefixed with the string app. Okay, next let's go back to app properties class, and within app properties class let's create a getter methods for these private fields. So here right click, generate, and then getter, and then select these fields, click on OK. Perfect. Next, what we'll do, we'll annotate this class with add component annotation so that we can inject this class as a Spring Bean in another class. For example, here let me create one more class. Let's give name as app properties demo, and let's annotate this class with add component annotation. Next, we can inject app properties Spring Bean in a app properties demo class. So here just create a field private app properties, and in order to inject the Spring Bean we have to annotate this field with @word annotation. Perfect. Next, here let me quickly create a method public void, and then let's give method something like display. Alright, and let me put the system.out.println over here, and then app properties dot get name, and then let's put system.out.println, and then app properties dot get description, and then system.out.println app properties dot get upload directory. Perfect. Next, in order to test this, we will retrieve this Spring Bean from the application context, and then we'll call its display method. So go to main point class over here, and here we have application context object. So here what we'll do, we'll retrieve app properties demo Spring Bean from the application context dot get bean method, and then pass app properties demo dot class. Perfect. Next, here let's call its display method. So app properties demo dot display. Perfect. Next, let us run this application and let us see how this works. So from this main method, I am going to run this Spring Boot application, and here we got the exception. It says no setter found for property description. Well, if you go to app properties class over here, we have only created the getter methods, so we need to also create a setter methods. So here what I will do, I will remove these getter methods and right click, generate, and choose getter and setter, and select all these fields, click on OK. Now we have created getter setter methods for these private fields. Next, let's go to main point class and let's run the application again. So from here I am going to run the Spring Boot application, and there we go. In output you can able to see the application name, description, and upload directory is printed. Okay, it means we have successfully used add configuration properties annotation to bind the properties to the Java class fields. Next, let me demonstrate how we can bind the nested object properties. So first, let me define the properties. So here, let me add the comment. Let's say nested object properties, and here just type the property app.security.username equal to, let's say, Java guides, and then app.security.password equal to, let's say, secret, and then app.security dot roles. So we can give roles separated by comma, for example user, admin, guest. Well, in order to bind these values we can use list in a Java class. Next, app dot security dot enabled equal to true. Now we have defined the properties. Next, let us bind these properties to the Java class. So go to application.properties file, and here let's quickly create a class, public static class. Let's give class name as security, and within a security class let's create a instance variable private string username, and make sure that the field name should be same as the property name. For example, if you go to application.properties file, here we have given the property name username, right? So this username should be same as this field name. Next, private string password. So this password field name should be same as this property name. And notice here the roles are separated by comma, and in order to bind these roles we can use list. So let's go back to app properties over here, and here let's have a list of type string, and let's give field name as roles and then new array list. Perfect. Next, private and then boolean and then the field name enabled. Okay, so if you go to application.properties file, here we have a property name enabled and the value is true. So true is a boolean, right? So in order to bind this enabled property to the Java class field, we can use a boolean type like this. Okay, perfect. Next, let's create a getter setter methods for this security class. So here right click, generate, and choose getter setter and choose all these fields and click on OK. Now we have created security class. Next, let's create an object of this security class in a app properties class. So go to here, and here let's have a private security equal to new security. Well, make sure that the field name should be security, because if you go to application.properties file, we have used the property name as a security. Okay, perfect. Next, we need to create a getter setter method for this security field as well. So go at the bottom, and here right click and then generate and then getter setter and select the security field, click on OK. Alright, perfect. Next, let's go to app properties demo class. Here go to display method. Within that, let's print the security details. So here system.out.println and then app properties and then call get security, and then it has get username. So let's have one more system.out.println statement and then app properties dot get security dot get password, and next system.out.println app properties dot get security dot get roles, and then system.out.println app properties dot get security dot get enabled. Perfect. Now we have printed the security related property values. Next, let's go to main point class. From here, let's run the application, and there we go. We can able to see the values in the console. The security username is printed, password is printed, roles are printed, and enabled property value is printed. And if you go to application.properties file, and if you can notice here the values, security.username equal to Java guides, security.password equal to secret, and the roles like user, admin, guest, and enabled is true. So this is how we can use add configuration properties annotation to bind nested object properties. Okay, next let me demonstrate how to bind the properties to the map. So here let me first write the comment map properties, and here just type the property app dot security dot permissions dot add equal to true. Let me copy this property, paste it over here, and let us change from add to update, and let me copy, paste it, and let's say delete, and let's copy and paste, and here let's say get equal to true. So notice here the properties. App is the top level property. Within that we have security. Within the security we have permissions, and then we have a key value pair. Add equal to true, update equal to true, delete equal to true, get equal to true. Right? So let's see how to bind these properties directly to the map. So go to app properties class and go to security class. Within a security class, let's create a map, and let's give the field name permissions equal to new hash map, and make sure that the permissions field name is same as the property name. Okay, perfect. Next, go back to app properties class, and here let's quickly create a getter setter methods for this permissions field. So go at the bottom in a security class, and here right click, generate getter setter, select the permissions field, click on OK. Now we have created a getter setter methods for permissions field in a security class. Next, let us test this change. So let's go to app properties demo class over here, and here let's go to display method, and let's print the permissions map. So here just put the system.println and then app properties dot get security dot get permissions. Perfect. Next, let us run the application and let's see how this works. So go to main endpoint class. From here let's run the application, and there we go. You can able to see the map is printed, and the map contains key value pair like add equal to true, update equal to true, delete equal to true, and get equal to true. So this is how we can use add configuration properties annotation to directly bind the properties to the map in a Java class. Well, in real-time project we use add configuration properties annotation a lot to directly bind the external configuration to the Java Pojo class. Alright, I hope you understood how to use add configuration properties annotation to bind the external configuration properties to the Java class. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into add component annotation. Well, add component annotation indicates that an annotated class is a Spring Bean or a Spring component. Well, add component annotation tells Spring container to automatically create a Spring Bean. Alright, so in annotation based configuration, we can use add component annotation to tell Spring IOC container to automatically create a Spring Bean for a particular class. Alright, so basically Spring offers three kind of configuration styles. First one is XML based configuration, second annotation based configuration, third Java based configuration. And this add component annotation is used in annotation based configuration. Alright, perfect. Now let's go ahead and let's understand more about add component annotation with an example. So let me first create a project using Spring Initializer. So go to browser and just type start.spring.io, and here let us fill up the project information, and let us download this project and let us import in a IntelliJ IDEA. Well, here we have different types of projects, so let us choose Maven over here, and let's keep Java language as selected, and here let us choose Spring Boot version 3.0.2, and here let us fill up the project metadata. Let's give group as net.javaguides. Well, you can give any group that you want. Next, let us give artifact as Spring annotations. Next, project name is same as artifact. Next, description demo project for Spring and Spring Boot annotations. Next, let us give package name as net.javaguides.spring annotations. Next, packaging jar, and let us select Java version 17. Next, as of now don't add any dependency because Spring Initializer will add a default dependency. For example, if you go to Explorer and go to pom.xml file, and you can able to see here Spring Boot starter. So this dependency internally add Spring Core dependency. Alright, so as of now we need a Spring Core dependency to explore Spring Core related annotations. Next, close this and go ahead and click on generate button to generate this project as a zip file. Next, open this zip file in a folder. Next, just unzip this. Alright, next open the IntelliJ IDEA and open this project in IntelliJ IDEA. So click on open and go to the location where your Spring Boot application is present. In my case it is in downloads folder. Select the project, click on open. Well, this will import Spring Boot project in IntelliJ IDEA. Next, let me demonstrate the usage of add component annotation. Well, add component annotation indicates that the annotated class is a Spring Bean or a Spring component, right? So let us create a class and annotate that class with add component annotation so that Spring IOC container will create a Spring Bean or a component for that class. Okay, so let's go to project, expand this src folder, go to main package. Within this main package, let's create one more package and let's call it as controller. Within a controller package, let's create a class. Let's give a name as pizza controller. Alright, next within this pizza controller, let's create a simple method public. Let us give string as a return type and let's give method name as get pizza. Next, this method returns some dummy string. Let us say hot pizza. Perfect. Next, we want to make this class as a Spring Bean or a Spring component. So let us go ahead and let us annotate this class with add component annotation. Well, this add component annotation tells Spring IOC container to automatically create the Spring Bean for this class and manage that Spring Bean. We don't have to create object of this class manually using new keyword. Spring container takes a control to automatically create the Spring Bean and manage that Spring Bean for us. Alright, so Spring IOC container is also called inversion of control, right? Because Spring container takes a control to automatically create the objects and manage those objects for us. Next, let us go ahead and let us test this change. Well, in order to test this change, we will create an instance of Spring IOC container and then we'll retrieve this pizza controller Spring Bean from the Spring container and then we'll call its get pizza method, and this get pizza method returns hot pizza dummy string. Alright, so let's go to main 80 class over here and go to main method, and within main method we have a run method called. So this run method returns the application context object. Well, basically application context acts as a Spring IOC container, right? And the pizza controller Spring Bean is already there in a Spring IOC container. So let us go ahead and let us retrieve the pizza controller Spring Bean from the IOC container. So here let's have a Java 10 var type and then let's give variable name context. So this is basically a configurable application context object. So this object provides get bean method to get the particular bean from the IOC container. Alright, so here context, it has get bean method, and notice here there are multiple overloaded get bean methods. We can use appropriate method to get the Spring Bean. Now let's use this second get bean method. It takes class type, okay, and just pass pizza controller as a class type here. And next, let us take the result of this get bean method in a pizza controller variable. Perfect. Next, let us type system.out.println. So here is a shortcut. Just type sysout and hit enter. So IntelliJ IDEA will give sysout statement, and then pizza controller, it has a get pizza method. Okay, now we have retrieved pizza controller Spring Bean from the Spring IOC container using get bean method. Next, let us run this program, and there we go. You can able to see hot pizza is printed in a console. It means the class which we have annotated with add component annotation is working as expected. Alright, so Spring IOC container created the object of this pizza controller class and it managed that object, and we have retrieved that object by using get bean method over here. Well, one more important point is by default Spring container will give name to the Spring Bean as a class name, but the first letter of the class name in a lowercase. Okay, and we can also explicitly give a name to the Spring Bean by passing value to this add component annotation. For example, let's say we want to give a bean name pizza demo. So this is the Spring Bean name for this Spring Bean. Next, we can retrieve Spring Bean by using this name. For example, let me copy this bean name and go to main 80 class, go to main method, and here we have used class type to get the bin. Now let us use bin name to get the bin. Next we need to provide a casting. Alright, next let us run the program, and there we go, it is working as expected. Alright, so this is how we can get the Spring Bean by using bin name as well. And by default, if we don't specify the bin name, then Spring IOC container will provide a default name to this bin name as a class name, but the first letter of the class name is in lowercase. For example, here let me remove this bin name and go to again main method, and here let me pass the default bin name, that is pizza controller, and look at here, the first letter in a lowercase. Right, so here let me run the program, and there we go, this is working as expected. Well, in real-time project we use add component annotation to tell Spring IOC container to automatically create the Spring Bean and manage the Spring Bean for a particular class. We don't have to create the object of that class manually using new keyword. Alright, so Spring IOC container takes care of creating and managing the objects of the class for us. Alright, and whenever we required the Spring Bean, then we can simply use add afterward annotation to inject that Spring Bean, and we can use that Spring Bean. Well, we'll see how to use add afterward annotation to inject the Spring Beans as a dependency in upcoming videos. Hi everyone, welcome back. In this video, let us take a look into add afterward annotation. Well, add afterward annotation is used to inject the bean automatically. The add afterward annotation is used in a constructor injection, setter injection, as well as in a field injection. Well, in case of annotation based configuration, we use add afterward annotation to automatically inject the Spring Bean. Next, let us go and let's learn more about add afterward annotation with an example. So let's go to our project in IntelliJ IDEA, and notice here in previous video we have used add component annotation to tell Spring container to automatically create the Spring Bean and manage the Spring Bean for this pizza controller class. Next, what we'll do, we'll see how to use add afterward annotation to inject the Spring Bean automatically. So in order to demonstrate this, let me create one more class. So go to base package, and within that let's create one more package. Let's call it as service. Within a service package, let me create a class, and let's call it as veg pizza. Alright, within this veg pizza class, let's quickly create one method. Let's say public string, and let's give method name as get pizza, and let us return some dummy string. Let us say veg pizza. Perfect. And in order to make this class as a Spring Bean or a Spring component, we can annotate this class with add component annotation. Alright, next what we'll do, we'll see how to use add afterward annotation to inject this veg pizza Spring Bean in a pizza controller class. So go to pizza controller. Within this pizza controller, let us inject veg pizza dependency or a Spring Bean. So for that, let's first create the instance variable of veg pizza class. Well, add afterward annotation is used to inject the Spring Bean using constructor injection, setter injection, and field injection, right? So let us first see how to use add afterward annotation to inject the Spring Bean using constructor injection. So here let us create the constructor public pizza controller, and then let us pass this veg pizza variable as a argument, and then this dot veg pizza equal to veg pizza. Next, go to this get pizza method, and here let us remove this hard-coded value, and here let us call veg pizza dot get pizza. Perfect. Next, let us use add afterward annotation to automatically inject the veg pizza Spring Bean in a pizza controller. So in order to do that, let's annotate this constructor with add afterward annotation. Okay. So this add afterward annotation tells Spring container to automatically inject the veg pizza bean using this constructor. Okay, perfect. Next, let us go to main method and let us test this change. So here, let us go and let's run the program. And notice here the output veg pizza. Well, if you look at the flow, go to pizza controller. Within pizza controller, we have injected veg pizza Spring Bean using constructor, and within this get pizza method we are calling veg pizza dot get pizza method, and this get pizza method of veg pizza object returns veg pizza, and this is the veg pizza is printed over here. Alright, it means we have successfully injected the veg pizza spring bean in a pizza controller using @attod annotation. Next, let us see how to use @attod annotation with setter injection. So here, let me comment out this and let me quickly create a setter method. Alright, and let us annotate this setter method with @attod annotation. Now this @attod annotation tells Spring Container to inject this veg pizza spring bean as a dependency using this setter method. Alright, next let us test this change. So go to main method. From here let us run the program, and there we go. You can able to see veg pizza is printed in a console. Alright, so this is how we can use @attod annotation to tell Spring Container to automatically inject the veg pizza spring bean as a dependency using this setter injection. Next, let us see how to use @attod annotation to inject the dependency using field injection. So here let me comment out this and go to field, and let's annotate this field with @attod annotation. Okay, perfect. Next, go to main method, and here let me run the application, and there we go. Veg pizza is printed. Alright, so this is how we can use @attod annotation to automatically inject the spring bean as a dependency using constructor injection, setter injection, and field injection. Alright, so this is all about @attod annotation. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into @qualifier annotation. Well, @qualifier annotation is used in a conjunction with @attod annotation to avoid confusion when we have two or more spring beans configured for the same type. Well, let me write some code to demonstrate the usage of @qualifier annotation so that you will understand better. So let me go to project in IntelliJ IDEA, and here let me quickly create one interface in a service package. So within a service package, let's create an interface, and let's give a name as pizza, and within a pizza interface, let's quickly create a method. So let's give a return type as string, and let's give method name as get pizza. Next, go to veg pizza class and let us implement this interface. So go to veg pizza class and implements pizza interface, and override get pizza method and provide the implementation. So we have already implemented get pizza method. So let's annotate this method with @attod annotation. Next, let us create a one more class named non-veg pizza, and that class implements this pizza interface. So go to service package, and let's create a new class. Let's give name as non-veg pizza, and this class implements pizza interface and provide implementation for its methods. So just more so in this class, click on implement methods and select the method that you want to implement and click on OK. Alright, perfect. And go to get pizza method and provide the implementation. So here go to return statement, and instead of returning null, let us return non-veg pizza. Perfect. Next, let's annotate this class with @component annotation so that Spring Container can automatically create a spring bean and manage that spring bean for this class. Next, in a pizza controller, to achieve loose coupling, we'll inject the interface and we'll pass the implementation dynamically. Alright, so here let me avoid field injection and let me use constructor injection over here, and instead of injecting the class, let us inject the interface to achieve the loose coupling. So here pizza interface, and go to constructor, and here pass pizza interface as an argument, and here let us remove this, and this dot pizza equal to pizza. Perfect. And here let us remove the reference variable and let us give reference variable pizza. Now we have injected the dependency using pizza interface. Well, Spring team basically recommended to use interface for dependency injection because this will achieve the loose coupling. Alright, and if we can look at the constructor over here, this constructor takes pizza interface as an argument, isn't it? And this pizza interface has a multiple implementations like veg pizza and non-veg pizza. So Spring IOC container will get confused like which pizza interface implementation they have to inject using this constructor, because there are multiple implementations of pizza interface. isn't it? So in order to avoid this confusion or ambiguity, we can use add qualifier annotation. For example, go to this constructor and go to this pizza interface over here, and let us use add qualifier annotation, and let us pass the bin name here. Let us say we want to inject veg pizza bin by using this constructor. Then we can simply pass this veg pizza bin name. So by default, Spring IOC container will give bin name to this veg pizza Spring Bean as a class name, but the first letter in a lowercase, right? So veg pizza. Okay, now this add qualifier annotation tells Spring IOC container to inject this veg pizza Spring Bean using this constructor. Okay, perfect. Next, let us test this change. So go to main method and let us run the program, and there we go. You can able to see veg pizza is printed in a console because we have injected veg pizza Spring Bean in a pizza controller by using add qualifier annotation. So here basically we told explicitly Spring IOC container to inject veg pizza Spring Bean. Next, if you want to inject non-veg pizza Spring Bean, then we can simply pass non-veg pizza Spring Bean name here. For example, non-veg pizza. So this is the name for the Spring Bean. Next, let us test this change. So go to main method. From here, let us run the application, and there we go. In a console, you can able to see non-veg pizza string is printed because we have told Spring container to inject non-veg pizza Spring Bean in a pizza controller by using add qualifier annotation. Alright, so this is how we can use add qualifier annotation to tell Spring IOC container to inject a specific Spring Bean. Okay, so basically Spring IOC container gets confused like which pizza interface implementation it have to inject, because this pizza interface has a multiple implementations, isn't it? So in order to avoid that confusion, we have used add qualifier annotation. Hi everyone, welcome back. In this video, let us take a look into add primary annotation. Well, we use add primary annotation to give higher preference to a bean when there are multiple Spring Beans of the same type. Well, let us understand add primary annotation with an example. So go to our project in IntelliJ IDEA, and here we have a veg pizza and non-veg pizza classes. These classes implements pizza interface. Well, in previous video, we have seen the usage of add qualifier annotation, isn't it? So if there are two or more Spring Beans configured for the same type, then Spring IOC container gets confused like which Spring Bean it have to inject, isn't it? So in order to avoid this confusion or ambiguity, we have used add qualifier annotation. So alternative to this add qualifier annotation, we can use add primary annotation as well. Alright, for example here, let me remove this add qualifier annotation and let us see how to use add primary annotation. Well, let us say the pizza controller want veg pizza Spring Bean as a dependency. Then we can go ahead and annotate this veg pizza class with add primary annotation. Well, this add primary annotation tells Spring IOC container to give higher preferences for this Spring Bean while injecting the dependency. For example, if you go to pizza controller, within this pizza controller we are injecting the dependency using this constructor, and notice here we have passed the pizza interface as a parameter to this constructor, and while injecting the dependency, Spring container gets confused like which implementation of this pizza interface it have to inject using this constructor. So to avoid this confusion or ambiguity, we can annotate one of the Spring Bean using add primary annotation so that Spring IOC container will give higher preferences for this Spring Bean while injecting the dependency. Alright, now we have annotated veg pizza class with add primary annotation. So Spring IOC container will inject this veg pizza Spring Bean in a pizza controller. Next, let us go ahead and let us test this change. So go to main method. From here, run the application. And notice here in a console, veg pizza is printed because we have used add primary annotation to tell Spring IOC container to give higher preferences for this Spring Bean and inject this Spring Bean in a pizza controller, isn't it? Next, let us say you want to inject non-veg pizza Spring Bean in a pizza controller. Then you can go ahead and annotate this non-veg pizza class with add primary annotation. Next, go to veg pizza and remove add primary annotation from veg pizza class. Now this add primary annotation tells Spring container to give higher preferences for this Spring Bean while injecting the dependency. For example, if you go to pizza controller, here we are injecting the dependency using constructor, right? So now Spring IOC container will inject non-veg pizza Spring Bean using this constructor. Alright, so let us test this change as well. So go to main method. From here run the application and notice here non-veg pizza is printed in a console. Alright, so this is how we can use add primary annotation to give higher preferences for a Spring Bean whenever we have multiple Spring Beans for the same type. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into @bin annotation. Well, @bin annotation indicates that a method produces a bean to be managed by Spring container. The @bin annotation is usually declared in a configuration class to create Spring Bean definitions. So let's go ahead and let's see how we can use @bin annotation with an example. So let's go to IntelliJ IDEA and go to our project. And so far we have used annotation based configuration, like we have used add component annotation, we have used add primary annotation, and we have used add attr annotation. Alright, so far we have used annotation based configuration. Next, this @bin annotation is used in a Java based configuration, and in order to use @bin annotation we have to create a configuration class. So here let me quickly create one more package and let me call it as config, and within a config package let's create a class. Let's call it as app config, and in order to make this class as a configuration class we have to annotate this class with add configuration annotation. Well, whenever we annotate a class with add configuration annotation, then this class becomes a configuration class, and within this configuration class we can define a Spring Bean definitions using @bin annotation. Alright, now let me first remove the annotation based configuration for one of the class. For example, here let me go to veg pizza class, and here we have used add component annotation to tell Spring IOC container to automatically create a Spring Bean for this class, right? Now we need to use @bin annotation to explicitly create a Spring Bean for this veg pizza class, and then we tell Spring container to manage that Spring Bean. Okay, so here what I will do, I will remove this add component annotation. Next, let us see how to use @bin annotation to create a Spring Bean for this class. So go to app config class over here. So this is the configuration class. Within this class we can create a Spring Bean definitions by using @bin annotation. Right, so here just create a method public, and then let's view return type as pizza. So pizza is the interface and veg pizza is the implementation of this pizza interface. And next let us give method name veg pizza. Next return the object of veg pizza. Now we have created a method, it returns the object of veg pizza class. Next we need to tell Spring IOC container to manage this veg pizza object, right? So in order to do that we can annotate this method with @bin annotation. Now this @bin annotation tells Spring IOC container to manage the object of this veg pizza class. Alright, and if you can closely observe this code, we are explicitly creating the object of veg pizza class, and we are telling Spring container to manage this object. Okay, but in case of annotation based configuration we have used add component annotation. So this add component annotation tells Spring IOC container to automatically create the Spring Bean for this class. Okay, we haven't created the object of this class using new keyword in case of annotation based configuration, but in case of Java based configuration we are using new keyword to create object of this veg pizza class, and we are telling Spring container to manage this object. Okay, so I hope you understood the difference between annotation based configuration and Java based configuration. Now the Spring IOC container is managing the object of this veg pizza class, right? Next let us see how to retrieve this veg pizza object from the Spring IOC container. So go to main method over here, and here we have a application context object. So application context is nothing but a Spring IOC container. We can retrieve Spring Bean from the IOC container by using getBean method. So here let us call context object, it has getBean method, and then pass veg pizza as a class type. Next veg pizza. Okay, now we got a veg pizza Spring Bean from the Spring IOC container. Next let us put the system.out.println and then call veg pizza object, it has get pizza method. Okay, now for time being, let me comment out this code. Alright, so next let us run the program. And there we go, veg pizza is printed in a console. It means we have successfully created a Spring Bean by using @bean annotation. Next, one more important point is, by default Spring container will give a name to this Spring Bean as a method name. Okay, and you can also explicitly provide a name to the Spring Bean by using name attribute of this @bean annotation. For example, here this @bean annotation has name attribute, and we can explicitly give a name to the Spring Bean by using this name attribute. For example, here let me give bean name something like veg pizza bean, and we can retrieve this Spring Bean by using this bean name. For example, let me copy this bean name and let me go to main method over here, and here instead of passing the class type, let us pass the bean name and let us provide the casting. Alright, and let us run the application, and there we go. So this is how we can use bean name to get a Spring Bean from the application context. And by default Spring container will give name to this Spring Bean as a method name. For example, here let me copy this method name and let me remove the bean name that we have provided explicitly and go to main method and just pass the method name as a bean name, and let us run the application, and there we go, veg pizza is printed. Okay, so by default Spring container will give a name to the Spring Bean as a method name. Next, let us see how to inject the dependencies. So here let me create one more Spring Bean, public pizza, and let's give method name as non-veg pizza, and then let us return the object of non-veg pizza class, and let us annotate this method with @bean annotation. Next, go to non-veg pizza class and let us remove these two annotations because we are not using annotation based configuration, we are using Java based configuration, right? So again go back to app_config class. Now we have created two Spring Bean definitions by using @bean annotation. Next, go to pizza controller, and here also we have used @component annotation to create a Spring Bean for this pizza controller. Now we need to use @bean annotation, right? So here let me remove @component annotation, and here also let me remove @attribute annotation because we are not going to use annotation based configuration. Okay, next let us go back to app_config, and here let's create a Spring Bean for pizza controller. So just type public and then pizza controller as a return type and pizza controller as a method name, and then return an instance of pizza controller, and pizza controller depends on a pizza. Alright, so pizza can be a veg pizza or non-veg pizza. Let us say we want to inject veg pizza as a dependency in a pizza controller, then we can simply pass this veg pizza method call. So this veg pizza returns object of veg pizza class. So this is how we inject the dependency in a Java based configuration. Next, let us annotate this method with @bean annotation. Alright, so just try to compare the annotation based configuration and Java based configuration. In case of annotation based configuration, we have used @attribute annotation to inject the dependency automatically, but in case of Java based configuration, we have to explicitly provide the dependency to a class. Okay, and then we need to annotate this method with @bean annotation so that Spring container can start managing the object of this pizza controller class. Next, let us go ahead and let us test this change. So let's go to main method over here, and here let me uncomment this pizza controller code, and here let me comment out this veg pizza code. So basically here we have retrieved pizza controller Spring Bean from the application context using bean name. Well, by default Spring container gives bean name as a method name, and this is what we are using over here. Alright, next let us run this program, and notice here veg pizza is printed in a console because we have injected veg pizza class object as a dependency to pizza controller. Okay, next let us say we want to inject non-veg Spring Bean as a dependency to pizza controller, then we can simply change over here. So here instead of veg pizza, let us call non-veg pizza. Perfect. Next, let's go to main method and let us test this quickly. And notice here in the console non-veg pizza is printed. So this is how we can inject the dependency in a Java based configuration. Alright, I hope you understood how to use @bin annotation to create the Spring Bean definitions and how to inject the dependencies and how we can give a name to the @bin annotation. Next, by default, the bin name is same as method name. We can specify the bin name using name attribute of this @bin annotation. Well, this we have already seen. Next, @bin annotation provides init method and destroy method attributes to perform certain actions before bin initialization or before bin destruction by a container. Well, let us see how we can use init method and destroy method attributes of @bin annotation. So let's go back to our example, and here in a pizza controller, let us use init method and destroy method attributes. So go to @bin annotation over here. It has init method attribute, and here we can pass the value as a method name. For example, let us say we use a method name as init. So this init method will get called before creating or initializing this class object. Next, it has destroy method attribute, and we can pass a value as a method name. So let's give method name as a destroy. So Spring container will call this destroy method before it gets shut down. Okay, now let us define this init and destroy method in a pizza controller class. So go to pizza controller class over here, and here let's create a method named init, and within a init method we can write the initialization logic. For example, here let me simply put the system.out.println, and let me print something like initialization logic. And next, let me create one more method, public void, and then destroy, and then let me put the system.out.println, and let me print something like destruction logic. So make sure that the init method and destroy method names should be same as the value we have passed to init method and destroy method attributes. Okay, next let us see how this works. So go to main method. From here let us run the program, and notice here in a console initialization logic is printed and destruction logic is also printed. Alright, so this is how we can use init method and destroy method attributes of @bin annotation. Well, the best use case of using init method and destroy method attributes of @bin annotation is that whenever you have a requirement to insert records in a database table at application startup, then you can use this init method attribute and you can specify the method name. So this method will basically insert the records in a database while application startup. Next, if you have a requirement to destroy or delete those records from the database table while application is shut down, then you can simply use destroy method attribute and you can specify the method. So within this method you can write the logic to delete the records while application shut down. So this is the best use case using init method and destroy method attributes of @bin annotation. Alright, so this is all about @bin annotation. Hi everyone, welcome back. In this lecture, let us take a look into stereotype annotations. Well, stereotype annotations are used to create a Spring Beans automatically in an application context. So here application context is nothing but a Spring IOC container. Well, the main stereotype annotation is add component annotation. By using this add component annotation, Spring provides more stereotype meta annotations such as add service, add repository, and add controller annotations. The add service annotation is used to create a Spring Beans at a service layer. Add repository annotation is used to create a Spring Beans for repositories at a DAO layer, and add controller is used to create a Spring Beans at a controller layer. Well, in typical Spring based applications, we use 3-layer architecture: controller layer, service layer, and DAO layer. So Spring provides 3 stereotype annotations such as add service, add repository, add controller annotation to create a Spring Beans with respect to these 3 layers. For example, in a controller layer, we can create a controller classes and we can annotate these controller classes with add controller annotation, so that Spring container will create a Spring Beans for these add controller classes. In a service layer, we can create a service classes and we can annotate these service classes with add service annotation, so that Spring container can automatically create a Spring Beans for these add service classes. Next, in a DAO layer, we can create a repository classes, and we can annotate these classes with add repository annotation, so that Spring Container can create a Spring Beans for these add repository classes. Well, notice here the diagram. Add component annotation is a main stereotype annotation, and the other annotations like add controller, add service, add repository. So these stereotype annotations are derived from the add component annotation. Okay, derived meaning these add controller, add service, add repository. So these stereotype annotations are specialization of add component annotation. Okay, now let us understand more about these stereotype annotations with example. Let's go to our project in IntelliJ IDEA, and within this project let's create 3 packages. So we have already created a controller package and service package. Let's also create a repository package. So we can give name as repository or DAO. So typically different developers give different naming convention. So here let's give a repository. Okay, now within a controller package let's create a class, and let's give name as my controller. Let's annotate this my controller class with add controller annotation. And notice here you have to choose controller annotation from org.springframework.stereotype package. Alright, within this my controller class, let's quickly create one method, public string. Let's give method name as hello. Next, let us return some dummy data over here. So let us say hello controller. Perfect. So we have created my controller class. Within that class we have created hello method. It returns hello controller string, and we have annotated this class with add controller annotation. Well, this add controller annotation tells Spring Container to automatically create a Spring Bean for this my controller class. And if you can go inside this add controller annotation, and notice here this add controller annotation is derived from the add component annotation. Alright, it means this add controller annotation is basically a specialization of this add component annotation. Okay, so let's go back to our controller class and let us test this change. So in order to test this, what we can do is we can get this my controller Spring Bean from the Spring Container. So go to main method over here, and here we have already application context. It acts as a Spring IOC container. So let us retrieve my controller Spring Bean from this application context. So here let me comment out this code, and here let's call context.getBean method, and then pass my controller class type. Perfect. Let us take the result of this method in a local variable of type my controller. Perfect. And next let us put the system.out.println statement, and then my controller object, it has hello method. Perfect. Next let us run this program, and notice here hello controller is printed. Okay, so basically if you go to my controller, within a my controller class we have hello method. So this hello method returns hello controller. So this is what printed in a console. It means Spring IOC container automatically created a Spring Bean for this class. Next let us go ahead and let us see how to use add service annotation. So go to service package over here. Within this service package let's create a class, and let's give name as my service. And within this my service class let's create a method public string, and let's give method name as hello, and let us return some dummy data. Let us say hello service. Next let us annotate this class with add service annotation. Well, if you go inside add service annotation, this add service annotation is derived from the add component annotation. It means the add service annotation is a specialization of add component annotation. Okay, so whenever you create a classes under service package, then make sure that you annotate those classes with add service annotation. Alright, perfect. Next, in order to test this, what we can do is we can retrieve this my service Spring Bean from the Spring Container. So go to main method. So here we have a context object. It has a getBean method, and then pass my service as a class type, and let us get the result of this getBean method in a local variable of type my service. Alright, and next let us put the system.out.println statement and then call my service object. It has hello method. Next let us run the program and notice here hello service is printed in a console. It means Spring IOC container automatically created a Spring Bean for this my service class. Alright, next let us go ahead and let us see how to use add repository annotation. So go to repository package. Within that let's create a new class. Let's give class name as my repository, and let's annotate this class with add repository annotation. And notice here you have to choose add repository annotation from org.springframework.stereotype package. Next, within this my repository class, let's quickly create a method public string. Let's give method name as hello, and let us return some string here. Let us say hello repository. Perfect. Next, if you go inside a repository annotation, this repository annotation is derived from the add component annotation. It means repository annotation is a specialization of add component annotation. Well, whenever you have a requirement to create a repository classes under repository package, then make sure that you annotate those classes with add repository annotation. Next, in order to test this, go to main method and retrieve the Spring Bean. So here just call context object. It has getBean method and then pass my repository class type, and let us get the result of this method in a local variable of type my repository. And next let us put the sysout statement and then my repository dot hello. Perfect. Next let us run the program, and there we go, hello repository is printed in a console. Alright, so this is how we can use these important stereotype annotations based on the layer. Well, in real-time project we create a controller class. Within a controller class we write the logic to handle the HTTP request, and in real-time project we create a service class, and within service class we keep all the business logic. And in real-time project we create a repository class, and within a repository class we keep all the database related logic. Alright, I hope you understood how to use these stereotype annotations to create a Spring Beans automatically with respect to different layers. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this lecture, let us take a look into add controller annotation. Well, Spring provides add controller annotation to make a Java class as a Spring MVC controller. The add controller annotation indicates that a particular class serves the role of a controller. Well, whenever you annotate a class with add controller annotation, then that class becomes a Spring MVC controller. Well, controller in a Spring MVC web application is a component that handles incoming HTTP request. Add controller annotation is simply a specialization of add component annotation that allows us to auto-detect implementation classes through the component scanning. It means add controller annotation is derived from add component annotation, and whenever we annotate a class with add controller annotation, then Spring IOC container will automatically detect that class and it will create a Spring Bean for that class. Alright, next we typically use add controller in a combination with add request mapping annotation for request handling methods. Next, let me demonstrate all these points with an example. So let me go to IntelliJ IDEA and let me go to project over here. So first of all, we need to add Spring Boot Starter Web dependency. So go to permit.xml file and go to dependency section over here. Here we need to add a Spring Boot Starter Web dependency in order to build Spring MVC based applications. So here we have Spring Boot Starter. So let's convert it into Spring Boot Starter Web. Alright, so remember, whenever you want to develop the REST APIs or Spring MVC web applications, then you have to use Spring Boot Starter Web dependency. Next, go ahead and click on this load maven changes icon over here. Alright, perfect. Now we have added Spring Boot Starter Web dependency. This dependency internally uses Spring MVC related dependencies. For example, look at here, Spring Web MVC, and this dependency also internally provides embedded Tomcat server to quickly run the Spring MVC application in a embedded Tomcat server. And also this dependency internally includes all the required JSON libraries. Alright, so just remember, whenever you want to develop the REST APIs or Spring MVC based applications, then you can go ahead and use this Spring Boot Starter Web dependency. Alright, perfect. Next, go to controller package. Within a controller package, let's create a class. Let's give name as book controller. Next, let us annotate this book controller class with add controller annotation, and make sure that you choose add controller annotation from org.springframework.stereotype package. Well, whenever we annotate a class with add controller annotation, then this class becomes a Spring MVC controller, and this class is capable to handle the incoming HTTP request. Next, if you go inside this add controller annotation, this add controller annotation is an alias for add component annotation. It means add controller annotation is a specialization of add component annotation, and whenever we annotate a class with add controller annotation, the Spring IOC container will automatically detect that class and automatically create a Spring Bean for that class. Alright, perfect. Next, let's go back to book controller over here. Next, within a book controller, we can create a handler methods that will handle the incoming HTTP request. For example, here, let's create a method public string. Let's give method name hello world. Next, let us return some string. Let us say hello world. Perfect. Now we have created a method. Let's make this method as a handler method by annotating this method with add request mapping annotation, and make sure that you choose add request mapping annotation from org.springframework.web.bind.annotation package. Next, we can specify the URL for this handler method. For example, here let us say hello world. Alright, and if you look at the points over here, we typically use add controller in a combination with add request mapping annotation for request handling methods. So this is what we have done over here. We have used add controller annotation along with add request mapping annotation to handle this incoming HTTP request. Next, we need to annotate this method with one more annotation, that is add response body annotation. Well, whenever you want to develop the REST API using Spring MVC, then you have to annotate a handler method with add response annotation, so that this handler method will return the JSON as a response to the client. Okay, and this add response body annotation internally uses Spring MVC provided HTTP message converters to convert the response into a JSON format, and then it will return that JSON into client. Alright, so just remember, whenever you want to develop the REST APIs using Spring MVC, then you have to use these three annotations. Next, let us go ahead and let us run the Spring Boot application, and let us see how this works. So from this main point class, I am going to run the Spring Boot application, and if you can notice here, our Spring Boot application is running in an embedded Tomcat server on port 8080. Next, let's go to browser. In a new tab, just type localhost 8080/hello world and hit enter, and there we go. The REST API return the response, that is hello world string. Okay, next let's go back to our project and let's go to book controller. Now let's create one more REST API that return the book object in a JSON format. So here what we will do, we'll create a new package. Let's call it as beans, and within a bin package, let's quickly create a class. Let's call it as book, and let us define the instance variables: private int id, private string book title, and then private string description. So here is a typo, this should be string. Perfect. Next, let us go ahead and let's create a constructor. Generate constructor and select all the fields, and also create a getter setter method over here. Right click, generate, choose getter setter and choose all these fields, click on OK. Now we have created a book class. Next, let's go to book controller, and within a book controller, let's create a REST API that return a book instance in a JSON format. So here, just follow the same steps. Let us first create a method public, and in this case, let us return book as a return type, and let's use method name as get book. And then here, within this method, let's create an instance of book first. Book equal to new book, and then let us pass book ID 1, and let us give the title something like core Java. Next, let us view description, learn core Java and latest features, something like that. Next, let us go ahead and let us return this book instance. So here, let us return the book instance. Now we have created a method. Let's make this method as a REST API by annotating this method with @request mapping annotation, and let's specify the URL. Let us say book. Next, in order to return this Java object as a JSON to the client, we have to annotate this method with @responseBody annotation. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application and let us see how this REST API works. So go to main entity point class over here, and from here let us run the Spring Boot application. Perfect. Our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let's go to browser, and here let us type the URL localhost 8080/book, hit enter, and there we go. The REST API returned the response, that is the book object in a JSON format. So this is how we develop the REST API using Spring MUC. So let me recap the important points. Whenever we annotate a class with @controller annotation, then this class becomes a Spring MUC controller and it is capable to handle the HTTP request. And @controller annotation is a specialization of @component annotation, and whenever we annotate a class with @controller annotation, then Spring IOC container will automatically scan that class and it will automatically create a Spring bean for that class. Next, within a @controller class, we create a handler methods and we make these handler methods REST API by using @request mapping and @request_body annotation. Next, this @request mapping annotation is used to map the incoming HTTP request to this particular method. Next, @response_body annotation is used to convert the return type of this method into the JSON format and then write that JSON into HTTP response object, and then it will return that HTTP response object back to the client. Alright, so we'll learn more about this @request mapping annotation in upcoming lectures as well. Alright, so this is all about @controller annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into @REST controller annotation. Well, in order to develop the RESTful web services using Spring MUC, we need to use @controller and @response_body annotations. Well, if you look at the code snippet over here, in order to develop the RESTful web services using Spring MUC, we have to use @controller annotation and @response_body annotations. Well, whenever we annotate a class with @controller annotation, then this class becomes a Spring MUC controller and it is capable to handle the incoming HTTP request. Next, whenever we annotate a method with @response_body annotation, then this @response_body annotation tells Spring MUC controller to automatically convert the Java object into JSON and return that JSON object back to the client. Alright, and this @response_body annotation internally uses HTTP message converters to convert the Java object into JSON and return that JSON to the client. So this is how the response_body annotation works. Spring 4.0 introduced a new annotation, that is @REST controller annotation, and it is a combination of @controller and @response_body annotations. Well, in order to develop the RESTful web services using Spring MUC, you need to annotate a Java class with @REST controller annotation. So let us go ahead and let us see the usage of @REST controller with an example. So let's go to our project in IntelliJ IDEA, and here we are using @controller and @response_body annotation, isn't it? So here we can also refactor this code, like instead of annotating all the methods with @response_body annotation, we can use @response_body annotation at a class level. For example, here we have annotated this hello world method with @response_body annotation. So let me comment out this, and here to get method also we have annotated @response_body annotation, right? So instead of annotating all the methods with @response_body annotation in this book controller class, we can use this @response_body annotation at a class level. For example, here let's annotate this book controller class with @response_body annotation. Okay. Next, Spring 4.0 introduced a new annotation, that is @REST controller annotation, and it is basically a combination of @controller and @response_body annotation. For example, instead of using these two annotations, we can use a shortcut annotation, that is @REST controller annotation. Okay, so at rest controller annotation is nothing but combination of at controller and at response body annotation. For example, if we dive inside this at rest controller source code, and here you can see rest controller is the alias for at controller annotation, and this rest controller annotation is also annotated with at response body annotation. It means at rest controller annotation is a combination of both at controller and at response body annotations. Okay, just remember, instead of using these two annotations, we can use at rest controller annotation like this. Okay, next let us go and let us rerun our Spring Boot application and let us quickly test the REST APIs. Well, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to browser, and here just call this get book REST API, and there we go. This REST API return the response, that is book object in a JSON format. Next, let us also test the hello world REST API. So here just type the URL localhost 8080/hello world and hit enter. There we go. The hello world REST API is also working as expected. It means whenever you want to develop the RESTful web services using Spring MVC, then we can annotate the class with at rest controller annotation. Okay, so this is a very important point. Whenever you want to develop the RESTful web services using Spring MVC, then you can go ahead and annotate a class with at rest controller annotation. But if you want to develop the Spring MVC web application, then we have to use at controller annotation. Okay, so this at rest controller annotation won't work for Spring MVC web applications. If you want to develop only the RESTful web services, then only you can use this at rest controller annotation. Alright, just try to understand the difference between at rest controller annotation and at controller annotation. Whenever you want to develop the RESTful web services using Spring MVC, then you can go ahead and use at rest controller annotation. And whenever you want to develop the Spring MVC applications that returns the view, then you can go ahead and use at controller annotation. Okay, perfect. In next lecture, we'll take a look into at request mapping annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into at request mapping annotation. Well, at request mapping annotation is used to map web requests to a Spring controller methods. At request mapping annotation can be applied to a controller class as well as handler methods. So let us understand more about request mapping annotation with examples. So here are the examples that we are going to take a look into in this lecture. So we'll see how to use request mapping annotation at a class level. We'll see how to use request mapping annotation at a method level. We'll see how to use request mapping with multiple URIs. We'll see how to use request mapping with HTTP methods like get, post, put. Okay. Next, we'll see how to use request mapping annotation with produces and consumes attributes. Alright, so let us go ahead and let us see all these examples. So let's go to IntelliJ IDEA and let me go to the project. Well, we have already seen how to use request mapping annotation with method. Next, let us see how to use request mapping annotation at a class level. So here, let us go ahead and let us annotate this book controller class with at request mapping annotation, and let us give the URI. For example, let us say /API. So basically, whenever you want to define the base URI for all the REST APIs within the controller class, then you can go ahead and annotate a class with at request mapping annotation, and then you can define the base URI. So base URI meaning whenever you call these REST APIs, then you have to use this URI as a base URI. Okay, so just remember, whenever you want to define the base URI for all the REST APIs within the controller class, then you can go ahead and annotate that controller class with at request mapping annotation, and then you can specify the base URI. Alright, so in real-time project, basically we annotate a class with at request mapping annotation to define the base URI. Next, let us go ahead and let us run the Spring Boot application and let us see how we can use this base URI. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to browser, and here we have the URL localhost 8080/book. So this URL won't work now because we have used the base URI /API, right? For example, if you go to code, here we have used the base URI /API. So we have to use this /API in the URL. For example, if you go to browser, here we have to use localhost 8080/API/book. So this should work, and there we go. So this is how we use the base URI. Okay, next, if you want to call the hello world REST API, that is localhost 8080/hello world, then this won't work because we have to add the base URI for this REST API. So here let us type /API/hello world. So this should work. Okay, so whenever you want to use the base URI or the common URI for all these REST APIs within the controller class, then you can go ahead and annotate that class with add request mapping annotation, and then you can define the base URI like this. Okay, perfect. Next, let us see how to use add request mapping annotation with multiple URIs. So let's go back to our project, and here let us go ahead and let us add multiple URLs to this REST API. So here we have a single URI, that is /book. Let us add one more URI. So in order to define the multiple URIs, we have to use a value attribute and then within a curly braces. Next, let us add the comma and let us define one more URI. Let us say core-java. Next, let us define one more URI /Java. Alright, now we have defined multiple URIs using add request mapping annotation for this REST API. Next, let us go ahead and let us stop and rerun the Spring Boot application, and let us see how this REST API works. Well, our Spring Boot application is up and running. Next, let's go to browser, and here let us call this get book REST API. So here we are using book URI first. Just refresh. This REST API is working as expected with this URI. Next, let us pass core-java and hit enter, and there we go. This REST API is working for this core-java URI as well. Next, let us pass the Java URI, hit enter, and there we go. Alright, so this get book REST API is working for all these URIs. So this is how we can use multiple URIs using add request mapping annotation for the REST API. Alright, next, let us see how to use request mapping annotation with HTTP method. Well, here if you can see, we haven't specified any HTTP method for this request mapping annotation. Well, by default, if we don't specify the HTTP method for this request mapping annotation, then it will take the HTTP method as a get method. Well, add request mapping annotation has a method attribute, so we can use method attribute to specify the HTTP method. For example, here we can use a method attribute and then we can specify the HTTP method. For example, request method dot get. Well, if you don't specify the request method explicitly, then by default this add request mapping annotation provides HTTP method as a get. Next, if you want to specify the HTTP method put, then you can simply use request method dot put over here like this. Next, if you want to specify the HTTP method post, then you can simply use request method dot post. Next, if you want to use HTTP method delete, then you can simply use delete like this. Alright, so this is the get book REST API, so we have to use HTTP get method over here. Next, if you want to have create, update and delete REST APIs, then you can go ahead and use the respective HTTP methods like post, put and delete. So we'll see how we can use these different HTTP methods in our upcoming lectures. So here just use HTTP get method. Next, let us see how to use request mapping annotation with produces and consumes attributes. So let's go back to our example over here, and let us say this REST API want to produce a JSON and then return that JSON to the client. Then we can explicitly specify the JSON media type over here. For example, here let us use produces attribute and then media type dot application / JSON. It means this producers attribute tells this REST API that produce the result in a JSON format. Next, we can also define multiple media types. For example, here we can specify the curly braces and then we can specify multiple media types. For example, here media type dot application / XML. Well, let us say this REST API want to return the result in a different formats, like this REST API want to return response in a JSON and XML format. Then we can specify like this. Alright, next let us say how to use consumes attribute. So let us say this REST API want to consume the JSON that is sent by the client. Then we can go ahead and use consumes and then media type application / JSON. Next, let us say this REST API want to consume the XML data that is sent by the client in a request. Then we can go ahead and use application / XML. And we can also specify multiple media types as well. For example, here within a curly braces we can specify multiple media types. For example, here media type dot application / JSON like this. Alright, so this is how we can use producers and consumes attribute to specify the media types, and based on the media types the REST API will consume the data and produces the data. Alright, so this is all about add request mapping annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us quickly take a look into add get mapping annotation. Well, the get HTTP request is used to get a single or multiple resources, and add get mapping annotation is used for mapping incoming HTTP get request to a specific handler method. Specifically, add get mapping annotation is a composed annotation that acts as a shortcut for add request mapping annotation plus HTTP get method. Well, basically add get mapping annotation is a shortcut for add request mapping annotation plus the HTTP get method. Next, let us go ahead and let us understand more about add get mapping annotation with an example. So let's go to our project in IntelliJ IDEA, and in previous lecture we have created an example to demonstrate the usage of add request mapping annotation, isn't it? So basically we use add request mapping annotation to map the incoming HTTP request to a particular method, and we use add get mapping annotation to map incoming HTTP get request to a particular method. For example, here let me remove this producers and consumes attribute, and let me keep the add request mapping annotation with multiple URIs and HTTP get method. So as we know that add get mapping annotation is a shortcut for add request mapping annotation plus HTTP get method, right? So here, instead of using this much of code, what we can do is we can simply use add get mapping annotation. For example, here let me use add get mapping annotation, and whenever we use add get mapping annotation, then we don't have to specify the HTTP method. So let us remove this. Okay, next, if we go inside the source code of get mapping annotation, here you can see get mapping annotation is annotated with add request mapping annotation plus HTTP get method. It means get mapping annotation is a shortcut annotation for request mapping annotation plus the HTTP get method. So get mapping annotation will work same as request mapping annotation plus HTTP get method. Alright, so let's go back to book controller, and if you can notice here the name of the annotation, get mapping. The name itself says that this get mapping annotation is used to map the incoming HTTP get request to this particular method. Alright, so just remember we use add get mapping annotation to map the incoming HTTP get request to a particular method. Next, we can use get mapping annotation to specify multiple URIs. So let me first use a single URI. So in order to define the URI, just pass the double quote. Within double quote we can specify the URI. For example, let us say book. Okay, next let us go ahead and let us rerun the Spring Boot application, and let us see how this get mapping annotation works. Well, our Spring Boot application is up and running. Next, let's go to browser. Here just type the URL localhost 8080/API/book, and there we go. The get book REST API is working as expected. So this is how we can use get mapping annotation to map incoming HTTP get request to this particular method. Next, we can use add get mapping annotation to specify multiple URIs. For example, here we can use value attribute, and we can specify multiple URIs like this /book and then /java. Next, let us rerun the Spring Boot application, and let us see whether these multiple URLs work or not. So our Spring Boot application is up and running. Let's go to browser, and here just refresh. Well, this REST API is working. Next, let us pass Java, and there we go. So this is how we can use multiple URIs with add get mapping annotation. Alright, so basically add get mapping annotation is a shortcut annotation for request mapping annotation plus HTTP get method. And this at get mapping annotation, it works same as at request mapping annotation. Okay, so whatever the attribute the request mapping annotation has, same attribute we can use with at get mapping annotation as well. For example, we can use producers attribute to define the media type. For example, here you can see media type application/JSON, and we can also use consumes attribute to define the media type application/JSON. Alright, so this is all about at get mapping annotation. Alright, great. In next lecture we will take a look into at post mapping annotation and at request body annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will take a look into at post mapping annotation and at request body annotation. Well, the post HTTP method is used to create a resource, and at post mapping annotation is used for mapping HTTP post request to a specific handler method. Specifically, at post mapping annotation is a composite annotation that acts as a shortcut for at request mapping annotation plus HTTP post method. Next, at request body annotation is responsible for retrieving the HTTP request body and automatically converting it into Java object. So let us go ahead and let us see the usage of these two annotation with example. So let's go to our project in IntelliJ and go to book controller, and here let me quickly create a REST API. So let us type public and let's give return type of the method as book, and let's give method name as create book, and then let us pass the book as a method argument. Next, let us print this book. So here just type system.out.println and then book dot get id, and then system.out.println book dot get title, and then system.out.println book dot get description. Next, let us return this book. Alright, perfect. Now we have created create book. Next, let us annotate this create book method with at request mapping annotation. Next, this at request mapping annotation is used to map the incoming request to this particular method, right? In this case, the incoming request is HTTP post request. So here basically we need to use method attribute to define the HTTP post method. So here just pass request method dot post, and next we can also specify the URI for this REST API. So here we can use value attribute and then simply pass the URI. Let us say books and /create. So this is how we create a REST API that handles incoming HTTP post request, and here we use at request mapping annotation to map incoming HTTP post request to this particular method. Next, as we know that at post mapping annotation is a shortcut annotation for at request mapping annotation plus HTTP post method. So if you look at this example over here, so at post mapping annotation is a shortcut annotation for this at request mapping annotation plus HTTP post method, right? So instead of using this line of code, what we can do is we can simply use at post mapping annotation. For example, here just remove this at request mapping annotation and just use at post mapping annotation, and whenever we use at post mapping annotation, then we don't have to specify the HTTP post method over here. Alright, perfect. Next, if you go inside post mapping annotation, you can see post mapping annotation is already annotated with at request mapping annotation plus HTTP post method. It means post mapping annotation is a shortcut annotation for at request mapping annotation plus HTTP post method, and this post mapping annotation, it works same as request mapping annotation plus HTTP post request. Alright, next let's go back to our code, and here we can also use different attributes, like we can use consumes attribute to specify the media type. For example, here let us say media type application/JSON. It means this REST API consumes the data that we have specified using media type. For example, here we have specified application/JSON as a media type. So this REST API will consume the data that is in a JSON format from the request. Next, we need to use one more annotation, that is @requestBody annotation. So here go to create book method, and you can see book is the argument for this method, right? So here let us annotate this method argument with @requestBody annotation. Well, this @requestBody annotation is responsible to retrieve the JSON data from the request body, and it will convert that JSON into this book Java object. Okay, and again @requestBody annotation internally uses Spring MVC provided HTTP message converters to convert a JSON into Java object. Alright, so this is how the @requestBody annotation works. Alright, so just remember, @requestBody annotation, it is responsible to retrieve the JSON data from the request body, and it will convert that JSON into this Java object. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application, and let us see how this post mapping annotation works. So from here, I am going to stop and run the Spring Boot application. Well, our Spring Boot application is up and running. Next, in order to test this post REST API, we have to use the Postman client. Well, we can call the get REST APIs from the browser itself, but in order to test post, put, delete REST APIs, we have to use the Postman client, isn't it? So let us open the Postman client over here and create a new request, and here let us choose HTTP post method, and let us type the URL localhost HTTP and then localhost /8080/API/ well, if you go back to the code, we have specified the URI /books/created. So let me copy this and let me paste it over here. Next, we need to pass the book object in a body, right? So go to body and select raw here, and then choose content type JSON, and within a body we need to pass the JSON. Okay, next go ahead and click on send button, and there we go. In a response, you can see the book object in a JSON format and the HTTP status 200 OK. It means the create book REST API is working as expected. Next, let's go back to IntelliJ IDEA or go to console, and you can see we have printed the book ID, book title, description, right? So this is what you can see in a console. Alright. So basically we use @post mapping annotation to map incoming HTTP post request to this particular method. Next, notice here this post request contains a JSON in a request body, and we use @requestBody annotation to retrieve this JSON object from the request body and convert that JSON object into this book Java object. Okay, now it makes sense, right? So @requestBody annotation is used to retrieve this JSON from the request body, and it convert that JSON into this book Java object. Okay, and in order to convert JSON into Java object, @requestBody annotation internally uses HTTP message converters. Well, here one more important point is, whenever we create a REST API that create a new resource, then that REST API have to return the HTTP status 201 to the client. So in this case, this REST API returns the HTTP status 200 to the client. For example, if you look at the Postman client, you can see the HTTP status 200 OK, right? But ideally, this create book REST API have to return the HTTP status 201 created to the client. So let us go ahead and let us see how to add a HTTP status as a response to this REST API. So here we can use either @response status annotation to specify the HTTP status. For example, here let us use @response annotation, and it has a value attribute, and here we can specify HTTP status created as a HTTP status. Okay, next let us rerun the Spring Boot application and let us see how this change works. Well, our Spring Boot application is up and running. Let's go back to Postman client and let's again make the request, and you can see the HTTP status 201 created. So this is how we can specify the HTTP status for the REST API. Well, one more way is we can use response entity class as well. For example, let me comment out this, and here let me use the response entity class. So make sure that you choose response entity class from ord.springframework.http package. So response entity is a generic class. We have to pass book as a type, and we need to return the instance of response entity. So here return new response entity, and then we need to pass book as a value to the constructor, and then we can specify the HTTP status that is created. So this is how we can configure the response for the REST API. Okay, next let us rerun the Spring Boot application and let us see how this works. Well, our Spring Boot application is up and running. Next, let's go to Postgres client and again make the request, and there we go, HTTP status 201 created, and the response contains the book object in a JSON format. So this is how we can specify the HTTP status in a response of the REST API. Either you can use @response status annotation or response entity class. Alright, so this is all about post mapping and request body annotations. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into @put mapping annotation. Well, put HTTP method is used to update the resource, and put mapping annotation is used for mapping HTTP put request on a specific handler method. Specifically, @put mapping annotation is composed annotation that acts as a shortcut for @request mapping annotation plus HTTP put method. So basically, @put mapping annotation is used to map the incoming HTTP put request to a specific method handler, and @put mapping annotation is a shortcut annotation for @request mapping annotation plus HTTP put method. So let us go ahead and let us understand more about @put mapping annotation with example. So let's go to our project in IntelliJ IDEA and go to book controller, and here let me quickly create a REST API. So here let me first create a method public, and let's give the return type of the method as a response entity, and let's pass book as a type. Let us give method name as update book, and then let us pass the method argument, for example int id and then book. So this is basically updated book that is sent by the client. Next, here let us print the id. So here system.out.println and then pass id. Next, system.out.println and then update book dot get title, and then system.out.println update book dot get description. So here basically we have printed book id, title, description to the console. Next, let us have a return statement, return a response entity. Well, response entity class has a generic OK method, so let us use OK method and then pass updated book object in a body. Perfect. So before passing this updated book to the OK method, let us first set the ID to this object. Perfect. Now we have created update book method. It returns updated book to the client. Next, let us make this method as a REST API. Well, traditionally we are using @request mapping annotation, and then we are passing the URL by using value attribute. For example, let's give URL something like books/update/id. So this is a book ID. Next, let us use method attribute to specify the HTTP method. So in this case, we have to provide request method dot put. Alright, so traditionally we were using @request mapping annotation to map incoming HTTP put request to a specific method handler. Later, Spring 4.3 introduced @put mapping annotation, which is a shortcut for @request mapping annotation plus HTTP put method. Alright, so instead of using @request mapping annotation plus HTTP put method, we can simply use @put mapping annotation. For example, here we can replace this annotation with @put mapping annotation, and whenever we use @put mapping annotation, then we don't have to specify the HTTP put method over here. Alright, perfect. Now let us dive into this put mapping annotation source code And notice here put mapping annotation is annotated with at request mapping annotation plus HTTP put method. It means at put mapping annotation is a shortcut for request mapping annotation plus HTTP put method. Well, notice here the name of the annotation put mapping. Well, the name itself says like this annotation is used to map the incoming HTTP put request to a specific method. Well, notice here the URL. Here we have ID. So this ID is basically called URI template variable. Well, whenever a user hit the request with the URL something like this, HTTP localhost 8080/API/books/update and then ID, let us say book ID 1. So this 1 will be stored in this URI template variable. Next we need to bind the value of this ID to a method argument. So in order to do that we use add path variable annotation. So here let's use add path variable annotation. Next, whenever a client calls this update book REST API, then client have to send the updated book information in the request as a JSON, right? So here we have to use at request body annotation to retrieve the JSON from the request and convert that JSON into the Java book object. Alright, so just remember we use add path variable annotation to bind the value of this URI template variable to the method argument, and we use at request body annotation to retrieve the JSON from the request and convert that JSON into Java book object. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman REST client over here and let us create a new request. And here let us choose HTTP put method and just type the URL HTTP localhost 8080/API/books and then followed by update and then 1. Okay, next we need to pass the updated book information in the body. So go to body, click on raw here and choose content type JSON, and here let us pass the updated book information. Let us say title core Java and then description, let us say learn core Java with coding example, something like that. Next, go ahead and click on send button and there we go. In a response you can see the book object in a JSON format and the HTTP status 200 OK. Next, let us go to our project and go to console and notice here the book ID, book title, book description is printed to the console. Alright, so this is how basically we create the update REST API using add put mapping annotation. Alright, just remember we use add put mapping annotation to map incoming HTTP put request to this particular method, and add put mapping annotation is a shortcut for add request mapping annotation plus HTTP put method. And whatever the attributes that add request mapping annotation provides, all those attributes we can use with add put mapping annotation. For example, we can use multiple URLs using this add put mapping annotation, and we can also use producers attribute to specify the media type, and we can also use consumes attribute to specify the media type. Alright, perfect. So this is all about add put mapping annotation. In next lecture we will take a look into add delete mapping annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will take a look into add delete mapping annotation. Well, delete HTTP method is used to delete the resource, and delete mapping annotation for mapping HTTP delete request to a specific handler method. Specifically, add delete mapping annotation is a composite annotation that acts as a shortcut for add request mapping annotation plus HTTP delete method. Well, we use add delete mapping annotation to map the incoming HTTP delete request to a specific handler method, and delete mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP delete method. Well, let us go ahead and let's create an example to understand more about delete mapping annotation. So let's go to our project in IntelliJ IDEA and go to book controller over here, and here let's quickly create one REST API. So here let us type public and let's give response entity as a return type, and let us pass string as a type, and then let us give method name as delete book Alright, and let us pass book ID as a method argument. Next here, let us have a return statement, return response entity, and it has a OK method. So this OK method internally provides HTTP 200 OK status. Next, let us pass some string in the body. Let us say book deleted successfully. Well, in real-time project, basically we call the repository to delete the book from the database table, but this is the simple example to demonstrate the usage of add delete mapping annotation, so we don't have to use any database operation over here. Alright, perfect. Next, here what we'll do, we'll print this ID to the console. Now we have created a method that returns book deleted successfully message to the client. Next, let us make this method as a REST API by using Spring annotations. Well, traditionally we were using add request mapping annotation to map the incoming HTTP request to this particular method, right? So let us use add request mapping annotation, and let us use its value attribute to specify the URI. So here /books/delete/ID. So this is the standard URI for this REST API. Next, let us use method attribute to specify the HTTP delete method. So here let us call request method dot delete. Alright, so traditionally we were using add request mapping annotation to map incoming HTTP delete request to a specific method. Later, Spring 4.3 introduced a new annotation, that is add delete mapping annotation, which is a shortcut for this add request mapping annotation plus HTTP delete method. Alright, so instead of using this add request mapping annotation plus HTTP delete method, let's use the shortcut annotation, that is add delete mapping annotation. So here let's use add delete mapping annotation, and whenever we use add delete mapping annotation, then we don't have to specify the HTTP method over here. So this is the shortcut annotation. Alright, next, if we dive inside this delete mapping annotation code, you can able to see here delete mapping annotation is annotated with add request mapping annotation plus HTTP delete method. It means delete mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP delete method. Alright, perfect. Well, notice here the annotation name delete mapping. Well, the name of this annotation itself says like this annotation is used to map the incoming HTTP delete request to this particular method. Alright, next, within this URL we have ID. So this ID is called URI template variable, right? Next, we need to bind the value of this URI template variable to this method argument. So in order to do that, we use add path variable annotation. Alright, perfect. Next, let us go ahead and let us rerun our Spring Boot application, and let us see how this add delete mapping annotation works. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to Postman REST client over here, and here let's create a new request, and here let's choose HTTP delete method, and let's enter the URL http localhost 8080/api/books/delete, and then pass book ID, let us say 1. Next, click on send button, and there we go. REST API return the response book deleted successfully, and the HTTP status 200 OK. Next, let's go to IntelliJ IDEA, and you can see in a console the book ID 1 is printed. Alright, so this is how we use add delete mapping annotation to map the incoming HTTP delete request to this specific method handler. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into add path variable annotation. Well, add path variable annotation is used on method argument to bind the value of URI template variable to a method argument. For example, look at here the code snippet. This is the hello world path variable method. It has a ID as a method argument. And look at here, we are using add get mapping annotation to map the incoming HTTP get request to this method. And you can see the URL, hello world/ID/name. And ID you can see here. So this ID is basically called URI template variable. Next, we need to bind the value of this URI template variable to the method argument. So in order to do that, we use add path variable annotation. And look at here the response of this REST API in a screenshot over here. So client basically uses this URL to call this REST API, that is localhost 8080/hello world/100/Ramesh. So 100 is basically a ID, Ramesh is a name. and this 100 value will basically stored in this URI template variable, that is ID, and Ramesh name is basically stored in this URI template variable, that is name. Next we need to bind the value of this ID to a method argument, right? So in order to do that, we use add path variable annotation. Next, let us see a few more examples in an action to understand more about add path variable annotation. So let's go to our project in IntelliJ IDEA, and here let me quickly create a REST API that demonstrates the usage of add path variable annotation. So here let us type public and then response entity as a return type. So this is generic class. Let us pass book as a type, and let us give a method name something like path variable demo. Alright, next let us annotate this method with @getMapping annotation, and let us pass the URI, let us say /books and then /ID. Alright, next in order to bind the value of this ID to a method argument, we should have a method argument, right? So here int ID. Next we need to bind the value of this URI template variable with this method argument. So in order to do that, we use add path variable annotation. Next within this method, let's have a system.out.println and let us print this ID. Okay, next let's create a book instance over here. Book equal to new book. Alright, and then book dot set ID and then pass ID. And next let's have a return statement, return response entity dot OK and then pass book object. Perfect. And look at here, we got the compilation error. It says create a constructor with no argument. So here go to book class, and here let's quickly create a no argument constructor, public book. Alright, next let's go back to our REST API. Alright, now we have used add path variable annotation to bind the value of this URI template variable to this method argument. Next, let us rerun our Spring Boot application and let us see how this REST API works. So from here, I am going to stop and rerun the Spring Boot application. Well, this is the get REST API, so you can use either browser or a Postman client to test this REST API. So I am going to use Postman client. So here, let's create a new request and then http get, and then the URL is http localhost 8080/API/books followed by the book ID, let us say 1. Okay, next click on send button and we got the response. It contains ID 1. We haven't passed a title description in the URL, that's why title description are null here, and we have passed 1 as a book ID, that's why we got the ID 1 here. Okay, next let's go to our code, and in a console you can see the book ID 1 is printed. Alright, it means the add path variable annotation is working as expected. Next, let us go ahead and let us see how to use multiple URI template variables in the URL. Right now we have only one URI template variable, that is ID, right? So we can have multiple URI template variables, for example ID and then title and then description. Alright, next in order to bind the value of these URI template variables to a method arguments, we have to use add path variable annotation. So here first of all we need to have a method argument, the corresponding method argument like string title and then string description. Perfect. And in order to bind the value of this title URI template variable with this method argument, we have to use add path variable annotation. Next, in order to bind the value of this description URI template variable with this method argument, we have to use add path variable annotation. Next, let us set title description to this book object. So here book dot set title and then pass title and then book dot set description and then pass description. Alright, so this is how we use multiple URI template variables in a URL. Next, let us go and let us rerun our Spring Boot application and let us see how this works. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman as client, and here let us pass multiple values in a URL. For example, here book ID and then followed by the book name, let us say course Java, and then followed by the description, let us say course Java description, and go ahead and click on send button, and there we go. In a response you can see book ID, book title, book description. Alright, so let us go back to our project in IntelliJ IDEA. Now we will see one more use case, like let us say if the URI template variable name and method argument name both are different, then what will happen? So if the URI template variable name and method argument name are different, then we need to pass the URI template variable name to the add path variable annotation. For example, here let us say the URI template variable name is title and the corresponding method argument name is book title. Next, in order to bind the value of this URI template variable to this method argument, we have to use add path variable annotation, right? But look at here, the URI template variable name and the method argument name, both name are different. In this case, we have to pass the name of this URI template variable to this add path variable annotation. For example, here we need to pass URI template variable name here. Otherwise, add path variable annotation won't able to bind the value of this URI template variable to method argument. Okay, perfect. Next, let us say the URI template variable name is book description and the method argument name something like book description. And if we don't pass this URI template variable name to the add path variable annotation, then add path variable annotation won't able to bind the value of this URI template variable to this method argument. Okay, so let me demonstrate this as well. So here let me pass book description. Okay, next let us stop and rerun the Spring Boot application and let us see how this works. So go to Postgres client and here let us make this request again, and you can see internal server error. So let us see what is the issue. So go back to IntelliJ IDEA and here you can see the error, required UI template variable name, book description, and the method parameter type string is not present, and you can see the exception, missing path variable exception. Alright, so it means whenever the UI template variable name and the method argument name both are different, then we have to pass the URI template variable name to the add path variable annotation. Okay, for example, here let me copy this description name and go to add path variable annotation, and here let me pass this URI template variable name here. Okay, so this is how the add path variable annotation works. Now if I stop and rerun the Spring Boot application and if I call this REST API, this should work. Okay, so let me go to Postgres client and let me call this REST API again, and there we go. You can able to see title, description, and there are no errors in a console. Alright, so remember this is a very important point, because in real-time project most of the developer make this kind of mistakes. Okay, so this is how we use add path variable annotation to bind the URI template variable to a respective method argument. Okay, so this is all about add path variable annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into add request param annotation. Well, we use add request param annotation to extract query parameters from the request. Well, sometime client may send a request URL something like this, localhost 800/student/query, and then followed by the query parameters. So you can able to see here key value pair, first name Ramesh, last name Phatare. So this is basically called a query parameters in the URL. Next, look at here the code snippet. This is the REST API that handles this kind of request URLs, and basically the URL contains the query parameters like first name Ramesh, last name Phatare. Next, this is the REST API that extract the query parameters value using add request param annotation. For example, here we use add request param annotation, and then we need to pass the query parameter name, that is first name, and then this add request param annotation will bind the value of this query parameter name to this first name method argument. Okay, next, here also we are using add request param annotation to bind the query parameter value to this last name method argument. So this is how we use add request param annotation to extract the query parameters from the request. Next, let us go ahead and let us see one more example to understand more about add request param annotation. So let's go to IntelliJ IDEA, and here let me quickly create one REST API that demonstrates the usage of add request param annotation. So here public, and then response entity as a return type. So this is generic class. Let us pass book as a type, and let us give a method name as request parent demo. Alright, and let us pass the method argument, let us say string title. So before that, let's have int id. Perfect. Next, within a method, let's have a system.out.println and just print this book id, and then let's have one more system.out.println and let us print the book title. Alright, next let us have a return statement. Before that, let's have a book object, book equal to new book, and then let us set the id, book dot set id, and then pass id. Next, book dot set title, and then pass title. And next, let us have a return statement over here, return response entity dot ok, and then pass book object in a body. Perfect. Next, let us annotate this method with at get mapping annotation, and then let us pass the URI slash books slash query. Okay. Next, let us say a client uses the URL something like http localhost 8080 slash books API books, and then query, and then query parameter, let us say id equal to 1, and then ampersand, and then title equal to core Java. So let us say client uses this kind of URL to make the REST API call. Then we have to bind the value of these query parameters to the method arguments, right? So in order to do that, we use at request param annotation. For example, here let us use at request param annotation, and then we need to pass the query parameter name, that is id and title. So here let us use its name attribute, and let us pass id as a query parameter name. Similarly, go to title field, and here let us use at request param annotation, and then pass query parameter name, that is title. Alright, so this is how we use at request param annotation to extract the query parameters from the URL and bind the corresponding query parameter value to the method arguments. Alright, next let us go ahead and let us rerun our Spring Boot application, and let us see how this at request param annotation works. So from here I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let me copy this URL and let me go back to Postman as client over here, and here let me create a new request. Let us choose http get method and then pass this URL in the URL section, and go ahead and click on send button. It says could not send request, so let me check what is the issue. So you can see the URL http and then colon and then slash and then localhost 8080 slash API slash books slash query, and then these are the query parameters. Next, click on send button, and there we go. You can able to see the response id1 title core Java, and notice here we have passed a book id1 title core Java in a request URL, and that is what reflected in a response. Next, let's go back to our project in IntelliJ IDEA, and if you go to console, you can see the id and title is printed in a console. Alright, it means at request param annotation is successfully extracted the query parameters from the request URL, and it bind the value of these query parameters to corresponding method arguments. Okay, so we can use multiple query parameters in the request URL like this, id, title. Next, we can also use the description as well. For example, here description, and in order to bind the value of this description query parameter name, we use at request param annotation. For example, here let me first give the description core Java description, and next here let's use the corresponding method argument string description, and in order to bind the query parameter value to this method argument, we have to use at request param annotation, and then we need to pass the query parameter name, that is description. Next, here go to book object, and then before return statement just set the description to the book object. So here set description and then pass description. Perfect. Next, let us stop and rerun the Spring Boot application, and let's go to Postgres client, and here let us pass the description in a URL ampersand and then description equal to, let us say, core Java description, something like that. Next, go ahead and click on send button, and there we go. In a response you can see book ID, title, description. Alright, so this is how we use at request param annotation to extract the query parameters from the request URL and bind the value of query parameters to the corresponding method arguments. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this video, let us take a look into add property source and add property sources annotations. Well, add property source annotation is used to provide properties file to Spring environment. Add property sources annotation is used to provide multiple properties file to Spring environment. Well, basically we use these two annotations to provide properties file to Spring environment, and then we can read these properties file from the Spring environment. Next, these annotations is used with add configuration classes. Next, add property source annotation is repeatable, means you can have multiple add property source annotations on configuration class. Next, we can use add value annotation and environment classes to read the property file. Well, basically we use add property source and add property sources annotations to provide properties file to Spring environment, and then we use add value annotation and environment class to read the property file from the Spring environment. Alright, so let me create an example and let me demonstrate all these points. So let's go to our project in IntelliJ IDEA over here. Well, in Spring Boot project we have application.properties file, and Spring Boot by default read this application.properties file automatically, but in real-time project we may have a requirement to read the custom properties file in a Spring applications, right? So in this case we can use add property source annotation to provide the custom properties file to Spring environment, and then we can use add value annotation or environment class to read the property file from the Spring environment. So here, first of all, let me create one custom property file. So go to resources folder and let's create one custom properties file. Let's give name as mail.property. Mail.properties. Within this mail.properties file, we can configure all the mail related properties. Okay. For example, here, let's say gmail.host equal to gmail.com, and then gmail.email equal to ramesh@gmail.com, and then gmail.password equal to secret. Now we have created mail.properties file and we have defined a couple of properties. Next, let's see how to use add property source annotation to provide this mail.properties file to Spring environment. So in order to demonstrate that, so go to base package over here and let's create a new package. So let's give package name as property source, and within a property source let's create a new class. Let's give name as app config, and next let's annotate this app config with add configuration annotation. Well, we use add property source and add property sources annotations with add configuration annotation, right? That's why we have created a configuration class and we have annotated it with add configuration annotation. Next, here we can use add property source annotation. Next, we need to provide the property file name. So here the property file is present in a class path. So here let's have a class path keyword and then followed by the property name, that is mail.properties. Okay, so this is how we can use add property source annotation to provide the custom property file to the Spring environment. Okay, next we can read this property file using add value annotation or environment class. Okay, so in order to do that, here let me create a one new class and let's give a name as property source demo, and let's annotate this class with add component annotation, And next here let me create a couple of properties, private string host, and then private string email, and then private string password. Okay, so basically we are going to read the mail.properties file, right? So if you go to mail.properties file, here we have host, email, password. So these are the properties we are going to read using @value annotation. Okay, so go to property source demo class again, and here let's annotate this host field with @value annotation. And here is the syntax, dollar within a curly braces we need to pass the property key. So go to mail.properties file, the property key is gmail.host. So let me copy this and paste within this @value annotation. Next go to email field, let's annotate this email field with @value annotation, and the syntax is dollar within a curly braces we need to pass the property key. So again go back to mail.properties file, copy this key and paste here. Okay, next let's annotate password field with @value annotation, and then dollar within a curly braces we need to pass the property key. So go back to mail.properties file, copy this key and then paste over here. Now we have used @value annotation to read the properties. Next let's create a getter methods to get the values for these fields. So here right click, generate, and then getter, and select the fields, click on OK. Now we have created getter methods for these private fields. Next let's get this Spring Bean from the Spring IOC container, and then we'll call its getter methods. So in order to demonstrate this, go to main entry point class, and here let me comment out this line of code. So only keep this context object. So within a context object we have a property source demo Spring Bean. So let's get this property source Spring Bean from the application context. So here property source demo equal to context dot get bean, and then pass property source demo dot class. Perfect. Now we have property source demo Spring Bean. Next it has a getter methods, right? So here just put the system.out.println and then call property source demo. It has get host method. Similarly let us print email and password. So system.out.println and then property source demo dot get email, and then sysout property source demo dot get password. Next let us run this application and let us see how this works. So from here I'm going to run this application. Well, we got the exception over here. It says conflicting bean definition exception. Well, there are a lot of app config classes in this project. So here let me quickly rename. So go to property source package. Within that we have app config class. So here let me rename this class name from app config to spring config, and then also rename the file. Perfect. Next go back to main entry point class. Now let's run the application, and there we go. You can able to see we have successfully used @value annotation to read the properties from the mail.properties file, right? So this is how we can use @property source annotation to provide the custom properties file to the Spring environment. Next, @property source annotation is repeatable. It means we can have multiple @property source annotations with configuration class. For example, here let me create one more properties file. So go to resources folder. Within that let's create one more custom properties file. Let's give name as messages.properties, and let's give few properties like app.name equal to, let's give app name something like Spring Boot app, and next property app.description equal to Spring Boot app description, something like that. Next let's go to Spring config class. Here let's annotate this class with one more @property source annotation, and then this properties file is present in a class path. So here is a class path keyword, and then followed by the custom property file name, that is messages.properties. Next, in order to read this file content, we can use @value annotation. So go to property source demo. Here let's create a private field, private string, and then app name, let's annotate this field with @value annotation, and then dollar within a curly braces, just pass the property key, that is app.name. Next, create one more private field, that is private string app description, and then let's annotate this field with @value annotation, and then dollar within a curly braces app.description. Perfect. Next, create a getter methods for these private fields. So here just type get, you will get an intelligence. So just call this get app name. So this will create a getter method for app name field. Next, just type get app description. This will give intelligence to create a getter method for app description field. Perfect. Next, go to main entity point class, and here let's put the system.out.println, and then property source demo dot get app name, and then system.out.println, and then property source demo dot get app description. Perfect. Next, let us run this application, and there we go. You can able to see the app name and app description is printed. So this is how we can use multiple add property source annotations to provide multiple properties file to the Spring environment. Okay, next let us see how to use environment class to read the property file. So go to property source demo class again, and here we have used @value annotation to read the property file. Next, let us see how to use environment class to read the property file. So here what I will do, I will inject environment class. So here make sure that you choose environment interface from org.springframework.core.env package, and let's annotate this field with @auto-void annotation. So this is the field based dependency injection. Next, let's comment out this @value annotation over here. Alright, and go to getter method. So here what we need to do is we need to get the value from the environment object. So here just type environment, and then it has get property method, and then we need to pass the property key. So here the host has a property key gmail.host, so let's pass here. Perfect. Next, go to get email method, and here just call environment object. It has a get property method, and then pass gmail.email as a property key. Next, go to get password method, and here just call environment object. It has a get property method, and then pass property key. So here let me copy this property key gmail.password. Similarly, go to get app name method, and then call environment object. It has get property method, and then pass app.name as a property key, and go to get app description method, and here just call environment object. It has get property method, and then pass app.description as a property key. Okay, perfect. Next, let's go to main entity point class, and let us test this change. So from here I am going to run the application, and there we go. You can able to see the output. The host name is printed, email is printed, password is printed, app name is printed, and description is printed. It means we have successfully used Spring environment object to read the property content. Okay, so this is how you can use either @value annotation or environment object to read the property file content. Okay, perfect. Next, let me demonstrate the usage of add property sources annotation. So go to Spring config class over here. Here let me comment out these two lines of code, and let me annotate this class with add property sources annotation, and then within a curly braces we can pass these two annotations. So here let me copy this annotation, and let me paste it over here, and then comma, and then let me copy this and paste it over here. Okay, so this is how we can use add property sources annotation to provide multiple properties file to the Spring environment. Okay, next, in order to test this change, go to main entity point class. From here let's run the application, and there we go, we got the output. Okay, so this is how we can use add property sources annotation to provide multiple properties file to Spring environment. Okay, I hope you understood how to use add property source and add property source annotation to provide the custom properties file to the Spring environment, and how to read the property file content from the Spring environment using add value annotation and environment object. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into add value annotation. Well, Spring provides add value annotation to assign a default values to variables and method arguments. Well, add value annotation is mostly used to get a value for a specific property key from the properties file. We can read Spring environment variables as well as system variables using add value annotation. Next, let me demonstrate all these points with an example. So let's go to project in IntelliJ IDEA and let's quickly create a new package. Let's call it as value. Within a value package, let's quickly create a Java class. Let's give name as value annotation demo. Alright, let's annotate this class with add component annotation so that Spring container can create a Spring bean for this class automatically. Within this class, let's create a variable. Let's say private string and let's give name as default name. So this is the instance variable. Let's annotate this variable with add value annotation and let's provide a default value. So let's give default value name something like default name. Alright, next let's create a getter method for this instance variable. So here just right click and then generate and then getter, select the field, click on OK. Now we have created default name field and we have annotated this field with add value annotation and we have passed the default value. So in order to test this, let's get the value annotation demo Spring bean from the application context and then we'll call this get default name method. So let's go to main entry point class and go to main method. Within the main method here, let's retrieve value annotation demo Spring bean from the application context. So here context dot get bean method and then pass value annotation demo class type. Perfect. And here let's put the system.out println statement and then call value annotation demo object. It has get default name method and this get default name method returns default name and we have assigned some value to this default name field, right? So this value should be printed in a console. Next, let's go back to main entry point class. From here, let's run the program and notice here the default name is printed. So this default name value we have assigned to this default name field, right? So this is what printed in a console. Alright, so this is how we can use add value annotation to assign a default value to a variable. Next, let us see how to use add value annotation to get a value for a particular property key from the application.properties file. So here, go to resources folder. Here we have application.properties file. Well, by default, Spring Boot will read this application.properties file. We don't have to write a code to read this file. Okay. Next, within this application.properties file, let's configure few key value pair and let's see how to use add value annotation to retrieve a value for a particular key. So here, let's say message or else let's say mail dot host equal to gmail.com and let's say mail dot email equal to javaguides@gmail.com, something like that, and then mail dot password secret. Okay, now let's see how to use add value annotation to get values for these keys. So let's go to value annotation demo class. Here let's create an instance variables private string and then host. Let's annotate this field with add value annotation and here is syntax to get a value for a property key. Within a double quote, within a curly braces, we need to pass the property key. For example, if you go to application.properties file, this is the key, this is the value. So in order to get this value, we have to pass this key to the @value annotation. So let's copy this key, go back to value annotation demo class, go to this field and just paste this key. Okay, next let's create one more instance variable and let's give name as email, and let's annotate this field with @value annotation. And here is syntax: within a double quote, within a curly braces, just pass the property key. So go to application.properties file, copy this key and paste it over here. Similarly, let's create one more instance variable. Let's give name as password. Let's annotate this field with @value annotation. And here is syntax: within a double quote, dollar, within a curly braces, we need to pass the key. So go to application.properties file, copy this key and paste it over here. And here you can see we have a typo, so here we need to provide a dollar. Alright, perfect. Next, let us create a getter methods for these three instance variables so that we can get the value for these three instance variables and we can print to the console. So here just right click and then generate getter and select these fields and click on OK. Alright, perfect. Next, let us test this change. So let's go to main entry point class, go to main method, and here we have already retrieved value annotation demo spring bean from the application context. So here let's put the system.out.println and then value annotation demo object. It has get host method. Next, let's put one more sysout and then value annotation demo object get email and then one more sysout value annotation demo dot get password. Perfect. Next, let us run this application and there we go. You can able to see host gmail.com and then this is the email and this is the password. Alright, so this is how we can use @value annotation to read a value for a property keys from the application.properties file. Well, in real-time project, we use @value annotation a lot to get a value for a property key from the properties file. Next, let us see how to use @value annotation to read the environment variables and system variables. Well, by default, Spring Boot will load the environment variables and system variables. Okay. Next, let us see how to use @value annotation to get a value for a specific environment variable or a system variable. So here, let me create an instance variable private string and let's give a name as Java home. Alright, let's annotate this field with @value annotation and here is the syntax: within a double quote, dollar, within a curly braces, java dot home. Alright, so this key will provide a value as a complete Java home path. Okay, next, here let's create a one more instance variable private string and then let's say home directory. Next, let's annotate this field with @value annotation. Next, here is the syntax: within a double quote, dollar, within a curly braces, just pass the key as a home. So this will give the current home directory and this will give the system variable for a Java home. Okay. Next, let's create a getter method for these two variables over here. So just right click, choose generate and then choose getter, select these two fields, click on OK. Next, go to main point class, go to main method and here let's put one more system.out.println statement and then pass value annotation demo object and then call get Java home and let's put one more system.out.println statement and then print the current home directory. Perfect. Next, let us run this program and there we go. You can able to see in output the Java home path is printed and also the home directory path is also printed. So this is how we can use @value annotation to get a value for environment variables as well as system variables. Alright, so this is all about at value annotation. And in real-time project, most of the time we use at value annotation to get a value for a property key from the properties file. Alright, great. I will see you in the next video.